This is an immersive hands-on Arduino course for beginners. Throughout this course, you'll dive deep into the world of microcontrollers, learning how to create, modify, and optimize Arduino projects from scratch. By the end, you'll have the skills and confidence to bring your innovative ideas to life, using the power and versatility of Arduino.
Hello, my name is Matthew, and I'm going to be your instructor for this Arduino course. Anybody can follow along as this course is beginner friendly, so you don't need to have any prior knowledge in programming and electronics. This course comes in full package, so everything you're going to need to learn about Arduino is fully provided here. Personally, when I was learning about Arduino for the first time, I was jumping from course to course as instructors did not teach me one aspect. So to prevent this, almost everything from electronics, programming, and even physics concepts are going to be fully included in this video. One final thing, when I said anyone can follow along, I mean it, even the ones who don't have a physical Arduino kit. I highly recommend that you get an Arduino kit as it is more engaging, but I will also be using a physical Arduino to teach. But if you don't have one, don't worry. I will show you how to follow along using a simulator. With that in mind, let's start our first section. Before even working on a physical Arduino, the first problem that we run into is there are thousands upon thousands of Arduino kits, and we do not know which one to use to follow along in this course. So, in this course, I'm going to be using an inland starter kit and an inland electronic parts pack. I'm going to leave a link in the description of this video so you guys can check it out for yourselves. Okay, so I'm going to be using an inland starter kit and inland electronic parts pack. But when it comes to these inland starter kits, they're mostly they're available in what? They're only available in the US. So if you're outside of the US, you can get yourself an ELEGOO Uno Super Starter Kit. Okay, you're going to get yourself an ELEGOO Super Starter Kit with an LED matrix. So this kit does not have an LED, a component named LED matrix, which is very important because I'm going to be using it in this video. So you're going to get yourself an ELEGOO Super Starter Kit, and then you're going to get it separately. You're going to get an display matrix, okay? So an LED matrix. Okay, so one final thing is, if let's say you already have an Arduino kit and you want to know all the components that I'm going to be using in this video, I'm going to state them on the screen right now so you can again cross-check on your Arduino kit and on the screen right now if you have the kit, if you have the components that are required. If you don't, you can again separately Google them and try to buy them from Amazon and different stores. So with that in mind, let's move to the next section. Okay, so for those of you who don't have a physical Arduino and want to follow along using a digital Arduino, I'm going to show you how to do that. So what you're going to need to do is go to your browser and then go to Tinkercad and then touch the first link. It's going to be tinkercad.com. Let me just zoom in so you can see it. There we go. And then open it. Okay, so for those of you who are joining or using Tinkercad for the first time, it's going to be asking you to sign up or log in. So we're going to do that. I already used Tinkercad, so I'm just going to log in directly to my account. Afterwards, all you need to do is go to your designs, create one, and then go to circuit. And it should be loading. And once it's done loading, all you need to do is use this tab for components. So you're going to be searching for the components that you need right here and then tapping them and adding them when you do. And there is a code section right here. So basically you can write code to your Arduino and then you can start the simulation. That's all you need to do to follow along using a digital simulator. So with that in mind, let's actually work on our first Arduino project. For our first project, we're going to build a simple circuit that lights up an LED. Let me turn off the light for you guys so you guys can actually see it quite better. Okay. So we're going to check the components that make up the circuit. So we're going to check the breadboard we have here, the resistor we have here, and also the LED. So we're going to check them out separately before assembling them into this one project. So see you in the next section. Before actually talking about breadboards, let's say I want to connect my Arduino and build a simple circuit. Okay, I have my Arduino right here, and before turning it on, I'm going to connect the pin, let's say right here randomly again. Say I want to connect it. I'm struggling a bit right now to hold it. Okay, I did hold it. It's a bit of a struggle. Let's say I connect it to here. It's not even comfortable. Let's say I connect it to here. Okay, then let's say I'm going to use a third wire. I'm going to be building a complex circuit. In this case, my hands are preoccupied, so I cannot really build a more complex circuit, as again, I cannot put a third wire. So this is where breadboards come in and actually solve the problem. Not only that too, but also if I turn on the Arduino and I, as I said again, connected to the pins, I'm going to be zapped. I don't want that to happen. So now, let me bring my breadboard right here. So breadboards come in different sizes and different shapes. So there's a smaller one, and this is the bigger one. I'm going to be using the bigger one to explain what are breadboards and how they work. So if I go real close up here, let me just point my light towards this so you can see it. Okay, so if I go close, really close actually, let me zoom in. I zoom in right now, and if you check this out, is you see wires that run horizontally. Let me again. Okay, there we go. We can see it right now. Wires that go horizontally right here, all of them. You can see that there are wires that are going horizontally, okay? The same goes for this one too. I again bring it up close towards the light. Okay, there we go. They go horizontally. If you check them, right here, if you look at these two wires, right now, they go vertically, okay? The one that are found on the edges, they go vertically. The same with this one that is found on this edge, goes vertically. Okay, so now, let me zoom out right now. This is good. Okay, so it only goes horizontally. So A up to E are connected, okay? So they are connected horizontally, connected horizontally, connected horizontally, connected horizontally, and connected horizontally. It keeps going on all the way to the bottom, okay? The same goes from F, G, H, I, J. They're connected horizontally, 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 and all the way to the bottom, okay? So one important thing is E and F are not connected, okay? There's a gap between them. As you can see right here, there's a big gap between E and F. So one thing is E and F are not connected, okay? So A up to E are connected on their own, but A up to E are not connected to F up to J, okay? So they're not connected. A up to E is not connected to what? F, G, H, I, J, basically. So they're not connected to each other because, as I said again, there's this big gap. Okay, with that in mind, when you look at the ones that are found on the edge, as I said again, if you look at the wires again, they're connected vertically. So all the way from the bottom to the top, they're connected vertically, okay? From the top to the bottom, they're connected vertically. So it goes like this. So go like this, and you have to go vertically all the way, okay? All the way vertically. They're connected. The same goes for the one that is found on the most edge, okay? So these two that are found on the edge, they're connected vertically all the way. Same goes for these ones. So right now, all I have to do to conduct electricity is bring my conducting wire right here, put that right here, and put this right here. And if you again look up close, they're connected because they're in the same row. So if I put this one right here, let's say all the way to the bottom, okay, all the way to the bottom, all the way to the top. Ooh, okay, they're connected, okay, they're connected. The same goes for these ones too, and these ones, and these ones too. Okay, so the same goes for this one. They're connected again horizontally. I just want to recap. Okay, so let's say I want to check this, like scientifically. So I'm going to bring a device called a multimeter. You guys do not need to have it, but it's just again to check. Okay, so let me just bring that right here. It's a bit of tangled right here. Okay, so let me just bring this. The pins are big, so it won't fit in the holes. So what I'm going to be doing is using this conducting wires and just connecting them with the conducting wires, the pins. Okay, so now if you look up close, it's set in the mode of continuity. Okay, this basically means this continuity, and continuity checks if an electric current is going. So for example, let me turn this on. Let me turn on the power. And if I bring these two pins together, it starts to make this beep sound, and not only that too, but also this red bulb lights up. And so does the number change, okay? Okay, so with that in mind, we can know that there's electrical continuity. As I said again, electrical continuity basically means that current can just flow, okay? So with that in mind, let's say I bring one right here. Let me first go up close and show it to you guys. So let me bring connecting wire to 20. Let me bring another connecting wire to 20. Again, connected horizontally, perfectly horizontal. Let me just put that right here. And let me bring these two pins and connect them with the wires. Can you hear that? There is an ominous beep. Okay, that means that, hey, current can flow. Okay, with that in mind, let me just connect this vertically, all the way. Let me go the whole way. Okay, vertically. Say I want to connect them. Let me just bring this pin right here. Connect it right here. Let me just bring this too. And can you hear it? There we go. This basically means is, hey, a current can just flow through, okay? Because they're connected right here, as I said, vertically. So with that in mind, let's move to the next section where we're actually going to discuss about resistors. So see you in the next one. Okay, so in this section, we're going to discuss about resistors. So what are resistors? Resistors are electrical components that are used to limit current. This is going to be important because we don't want to damage other components due to current overflow. Okay, so let's start from this simple diagram, okay? So right here, we've got the positive terminal of the battery. The longer side is the positive terminal, as you can see here. And the shorter side right here is the negative terminal. So current always flows from the positive terminal to the negative terminal. So it's going to flow like this, go through this resistance right here, and then go through our LED, lights up our LED, then goes back to the negative terminal. As I said again, resistors are used to limit current. Why is this important? So if we, let's forget about the resistance existing here for a moment. So let's say we connect it directly to the current, and we put our LED. In this case, we're going to fry our LED because we're going to be using too much current. Okay, so we want to limit the amount of current that goes through because we don't want to damage our LED. That's why we're going to be using resistors. So right now, we're going to use Ohm's law. It's known as V is equals to I times R. V stands for voltage, which is measured in volts. I stands for current, which is measured in amperes. And R stands for resistance, which is measured in ohm. This is ohm. The symbol you see right here, it's OHM, ohm. Okay, so right here, to actually even give you a better and a clear analogy, let me bring my Arduino right here, and let me bring this close enough so that you guys can see the 5V. That 5V means that it's going to output 5 volt. Okay, so that's why I said 5 volt right here. So let me just place it right here, and then current goes, and then we have our resistor. And by the way, if you don't know how resistors look like, they look like this. Let me bring the pack and let me show it to you guys. They look like this. Sometimes you might find a yellow one, but it's okay. Blue or yellow is the same thing. Okay, so we have our resistance right here. Let me place that right here. And we have our precious LED. Let me just place that right here. So right here, when it comes to LEDs, they have a maximum limit of 20 milliamps. So if we go over 20 milliamps, what's going to basically happen is we're going to fry our LED. So we don't want that to happen. How do we prevent it? We use this law. So right here, we have 5 volt that is going to be output by the Arduino. So we're going to say 5V is equals to, this is 20 milliamps is the maximum. The recommended one is 10 to 15 milliamps. Okay, it's 10 to 15 milliamps is recommended, but this is like the full maximum. So let's use 15 milliamps because we don't want to go over the recommended limit. And we have our resistor right here. Okay, so let's divide this. This becomes 5 or 15, and we have milli right here, so it's going to be times 10 to the power of 3. And we've got our ohm. As I said earlier, it's measured in ohm. So in this case, it's going to be 0.3 continuous times 10 to the power of 3. Okay? Ohm. So R is going to basically be 333 ohms. This does not mean we have to exactly give it 333 ohms, but rather we should give it a range of, let's say, 300 to a 400 ohm range, okay, of resistance for this current not to obviously overflow and, as I said again, basically fry our LED. We don't want that again to happen. Okay, so with that in mind, how do we, measure how much ohm resistance is? So we're going to actually check it. So there are two ways to actually do it. The first one is we bring our resistor up close, okay? And what you need is a resistor color code. You can Google it if you don't have it on your kit or you don't have an Arduino, but this is just a resistor color code. So right here, I have it right here. So let me start from the first line. The first line is red. And if you look close enough right here, first line of red means 2. So let me bring my Sharpie right here. Let me write 2 down. You got 2. Now, let's look at my second band right here. It's also red. You can see it. It's also red. The second band of red means 2. So we go 2 right here. Then I have my third one. If you can see closely, it's black. So when we look at it right here, when you look at the third one, it's what? It's 0. Okay? Then we have my fourth line. My fourth line is also black. So I go to the fourth one, and it's a multiplier. So this is basically how much I multiply it to. So in this case, it's black. So it's times 1 ohm. Okay? So when you multiply it, it's 220 ohms. If you look even close enough, there's a fifth band right here that looks brown. This is just tolerance, and we're not going to get into it because it's not really important surrounding this level, okay? So, okay, with that in mind, we have 220 ohms of resistance. So you guys can check your resistor by basically looking at the color codes. Okay, there's also another way to actually do this. So in this case, we're going to go back to using multimeters. So right here, we have our handy multimeter. Let me just untangle it right now. Okay, so let me bring back the resistor that I had here that I calculated to be 220 right here. So let's see if that's actually true, if I want to be dead sure. Okay, so let me just move this paper right here. Okay, so let me turn it on. And right here, what I'm going to basically do is change it to the resistor mode. As you can see, there's ohm right here, so we're changing it to this resistor mode. So if I go to 200 ohm right here, it's going to detect 200 ohm or less. For example, right now, I have 220 ohms that I calculated. If I put it right here, if I again connect it right here, let me just connect it. Can you guys see it? It says a 0.222. Let me change it to 200 ohms right here. If I go 200 ohms, it's not going to detect anything, as you guys can see. Why is that, so you might be asking me? Well, it detects 200 ohms or less, okay? It's not going to detect 200 ohms that are above 200 ohms. It's going to detect 200 ohms and less. It's not going to detect something that is above 200 ohms. In this case, this is 220 ohms, which is above 200 ohms. So it will not detect it. So if I go to 2 kilo ohms, okay? 2 kilo ohms right here. And let me just connect it right here. Now we get a signal of 2.242. Not exactly, but we get 0.242. Let me just bring my paper back. Okay, so 242.242. And as you can see here, it says kilo ohms. So we have to say kilo ohms. When we do the math, this turns out to be 242 ohms, which obviously is not 220 ohms directly, but it's just very close to it. So we can use our multimeter to again check resistance values. It's not going to give you the exact one, but it's going to give you a close one. So you can use resistor color codes right here, or again, you can use your multimeter. It's up to you to decide. Anyways, see you in the next section where we're going to be discussing about LEDs. In this section, we're going to discuss the last component that we're going to need to build our first project. They're going to be LEDs. So if you open your pack, they come in this shape, and they come in all sorts of colors. Right here, we have red, blue, green, yellow. So before actually working with LEDs and putting them in our project and working with them in the circuit, what we're going to basically do is we're going to check the science behind them and have a brief understanding of how they work. Okay, so let me begin right here with something quite more popular. So light bulbs. Light bulbs were obviously invented by Thomas Edison, and let's see how they work. Okay, so right here we have a battery right here, and it supplies current. So what basically happens is current goes through this coil and it heats it up so much so that it starts emitting light. In this case, it is red hot. When we add more volt to this battery, or a higher voltage battery right here that we're using, we're going to supply more current, basically making this coil heat more, and it will obviously going to emit more light. So in this case, it becomes white hot. So what is the problem with light bulbs, and why did we even need to replace them? Well, the problem is, fundamentally speaking, light bulbs are not light generating devices. They are heat generating devices, because the electrical energy that we're going to input, the current, is going to go towards heat. 95% of it is going to go towards heat, while only 5% of it goes towards light. So in this case, we're going to be producing excess heat and we're going to be wasting energy. So we don't want that to happen. That's why we have LEDs. LEDs change electrical energy directly to light energy. Okay, so LED, the long form is light emitting diodes. Light emitting is self-explanatory, as it just says light emitting, it emits light. What is the word diode? Let's check it out right here. So before checking out diodes, LEDs are something that we use day to day. We have LED TVs, LED bulbs, LED stripes that we put inside of our rooms to just decorate and all that. So LEDs are something that we use every single day. Okay, so what are diodes? Diodes are devices made from semiconductors. Okay, so we know conductors and we know insulators. Conductors are what? Conductors are materials that can conduct electricity. For example, we can take this wire. It's a conductor. Okay, so we have insulators too. Insulators are the ones that are incapable of conducting electricity. For example, let's take this pencil that is just made of newspaper. And in the middle, we have semiconductors. So they show the property of conductors and also insulators. So let's check them out. When it comes to semiconductors, they have 4 valence electrons. So let's take, as an example, let's take silicon. It has 14 electrons. When we arrange it, it becomes 2, 8, 4. So it has 4 electrons on the outermost shell. So it's obviously 4 valence electrons right here. So when we align 5 silicon atoms, we have 5 silicon atoms right here. Okay, so when we put them in such a way, they become stable. Let me explain. So at the center, the one with that is marked with the red is the center molecule, and it has 4 valence electrons. The electrons are represented with dots, as you can see here. Okay, so we have another silicon atom right here, another silicon atom, another silicon atom, another silicon atom. Okay, so one important thing that we see right here is the underlined dots right here. These ones are shared electrons. So electrons will be shared between this silicon atom and the central atom, this silicon atom and the central atom, this silicon atom and the central atom, this silicon atom and the central atom. So if we add up the electrons right here, we have 1, 2 right here, 3, 4. And we also have 4 that we already have right here, 4 valence electrons that we have from the beginning. So when we add 4 plus 4, it is 8. So in this case, it's stable. So it doesn't want to receive or give any sort of electrons. So in this case, it's not going to conduct electricity. Why is that so? There will not be free electrons to move, so current cannot flow. Okay, so it shows the property of an insulator right here. So right now, we're going to use a method called doping. And this is the method that actually changes semiconductors and just changes the game for semiconductors and actually makes them behave like conductors. So let me bring this right here so we can check it out right here. So earlier, if you would actually look at it right here, earlier we had 5 silicon atoms. Okay, instead of having 5 silicon atoms, we replace that 1 silicon atom right here. We're going to replace it with an atom that has 5 valence electrons. So it has 5 dots right here. So instead of giving 1 like every silicon atom right here, it gives 2. So we're going to have, instead of 8, we're going to have 9 electrons. We could even count it. 1, 2, 3, 4, 5. We have 5 shared electrons, and we have 4 valence electrons that we already have on silicon atoms. So when we add that up, it becomes 9 electrons. So in this case, it is negatively charged because it has excess amount of electrons right here, and it wants to give those electrons. So it's negatively charged. That's why it's called the N-type, N standing for negative. Okay? So right here, we're going to conduct electricity because we have excess amount of electricity. We have free electricity. We have that 1 electron that wants to what? That wants to move freely. And again, we want to go back to what? To 8 electrons. Okay? We want to be stable. So in this case, what do you want to do? We want to give electrons. So right here, it shows the property of a conductor. We can also use another method. In this case, we're going to give it 3 electrons. So we have 4 silicon atoms right here. The one marked with blue is going to be the 3 electron element. So right here, when we add all this up, we're going to have 7 electrons. We have 1, 2, 3 electrons that are shared, and we have 4 electrons that are again of silicon atom. So when we add that up, it becomes 7 electrons. So this will not contribute towards any shared electrons, this element right here that has 3 electrons. Okay, so in this case, we are positively charged. Why is that so? We have an electron deficiency, and we want to what? Receive electrons because we want to achieve stability with 8 electrons. Okay, so it's called P-type. P obviously standing for positive. Okay, so this is what is going to basically happen. And one thing that we're going to finally need to check is this. Okay, so with that in mind, right here, we have N-types right here that have excess amount of electrons, 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 and electrons right here. And we have the P-type that have holes. So let me discuss the concept of holes and what they are. If you look right here, we have hole. A hole is basically an empty space where an electron should have been. So if there was, let's say, 4 electrons like earlier, like we had right here, exactly right here, we just put the electron. But right now we have is an empty space because we don't have an electron. So basically, holes are just representation of just empty spaces where an electron should have been. Okay, so right here in the N-type, we have electrons over electrons over electrons, while in the P-type, we have holes and holes and holes and holes. Okay, so right here, we connect the positive terminal of the battery as you can see right here, with the N-type and the negative end of the battery with the P-type. In this case, what basically happens is from the electron actually going towards the holes, what's going to basically happen is they're going to start repelling each other. So this one is negatively charged and this one is positively charged, but they start to repel each other. So in this case, current will not flow. Okay, so we connected the positive with the N-type and the negative with the P-type. But right now, when we change the direction of the battery and we connect the negative with the N-type and the positive with the P-type, what basically happens is electron flows from the N-type to the P-type. So these electrons flow from the N-type to the P-type. So in this case, they're flowing from higher energy level to a lower energy level. Okay, so in this case, when electrons are flowing from higher energy level to a lower energy level, they're basically going to be releasing energy. And as you know, the rule of conservation of energy is neither created nor destroyed, but rather taken from one form to another. So when they release that energy, the electrons, they release that energy in the form of light. So when they move from higher energy level to the lower energy level, they'll be losing energy. And that energy that they're going to be releasing is going to be in the form of light. So right now, what basically happens is we directly change electrical energy directly to light energy. So we don't need to have, excess heat and all that like light bulbs did. Okay, so you might be wondering then, what is the P-type of, an LED look like then in real life? Because it matters like what part of the battery that you connect it to. So if you look at your LED right now, let me just bring it up close. To look at it right now, let me get this. Okay, so if you look right now, if you look at your LEDs, the LED legs right here, they're not even. One is longer and one is shorter. Okay, so the longer one, if you look right here, the longer one is the positive and the shorter one is the negative. The longer one is the P-type while the shorter one is the N-type. Okay, so if you look right here, we're going to connect the positive end of the battery right here with the positive, the longer side right here, and the negative part of the battery with the negative terminal. Okay, so we're going to actually check the next section on how to actually assemble our components that we've learned so far. So see you in the next section. So now we're actually going to be in the exciting section of actually building and assembling what we've learned so far. So we have our Arduino right here. We have our resistor, which is again recommended to be 300 to 400 ohms. We have our LED right here. We have a connecting USB right here, where I'm going to be connecting my Arduino to a laptop. And I have my Arduino breadboard right here. Okay. And then I have my connecting wires. Okay, so let me begin by connecting the Arduino with the breadboard. If you have an Arduino Uno, you don't need to connect your Arduino with the breadboard. All you need to do is a hole again. So all you do is, again, connect it directly to a connecting wire. Okay, so second thing I'm going to need to do, we're trying to build a circuit actually. So let me bring the circuit right here. Okay, so we've got our Arduino connected. We want to connect it to the 5 volt. So let me go right here and let's try to connect it to the 5 volt. There's the 5V connected right there to the 5 volt. Okay, let's say put it around 25. Okay, just put it randomly on 25. Then now what we want to happen is we want to connect it to a resistor. Okay, so let me bring my resistor right here. Bring it right here and let me just try to connect it a bit. If you can see it. Okay, so one thing you notice is I connected it across. So as you remember, this row is connected, this row is connected, but these two rows are not connected to each other because they have a gap, as I told you guys earlier. So if I connected it, let's say, in the same row, okay, horizontally in the same row, let me just make this a bit more thin. Let's say connected it this way, okay? If let's say the resistor is not connected properly, sometimes this happens. You have to push it in, okay? And if the resistor is not connected properly, what is going to happen is basically this type of circuit. We have our, again, Arduino right here and directly connected to what? To our LED. So it's going to fry our LED with the one that's happened. Again, so if I connect it abroad though, if I connect it somewhere where it's not connected, again, let me just make this a bit more wide. It's a bit of a hustle to even connect resistors, to be honest. As you guys can see, I connected it abroad is current will flow like this from the 5 volt to the connecting wire right here, goes horizontally, and let's see, it's not connected right here. What is going to basically happen is it's not going to what? Conduct electricity. So the worst case scenario, if you connect it like this, is nothing happens. So the LED does not light up. It's not going to get fried, but it's not going to light up. All you need to do again is connect it properly and you're good to go. So we want to connect it what? When we're connecting resistors, we want to connect it across. If not, we can even connect it vertically, okay? Because again, as I said, they're not connected. So we want this one leg to be on the connected side and one leg to be on the side that's not connected anyway with the circuit. Okay, with that in mind, let me just bring my LED. And before actually doing that, we first need to identify, let me just make this a bit more wide. We need to identify which one is the positive side and the negative side. As I've told you guys earlier, the longer side is the positive, and we want to connect it to the positive terminal. As I said again, the P type, okay? This is the P type. And we want to connect the negative side with the negative terminal, the N type. So we want the longer side to be the direction of the positive. So I have the longer side right here, and I want to connect it right here, as you guys can see. Okay, now finally, we connected our Arduino, current is flowing, we've connected our resistors, we've also connected our LEDs, the positive side and the negative again. So if you look right here, actually, this is the positive side, okay? If you look at it even diagrammatically, it's positive right here, and we have the negative right here, okay? So again, it's going to go all the way right here and to the negative terminal. And how do we get the negative terminal in an Arduino is, let me go all the way, you guys can see it. There's a sign that says GND. You can see it right here. GND stands for negative or ground, okay? So if I put GND right here, it basically means is negative. There's no other meaning towards it, all right? So I want to connect to the negative side of my LED. So all I need to do is touch this, and we're done building our first circuit. So right now, let me finally bring our connecting USB. So let me connect it to my laptop. Okay. Then let me connect my Arduino. There you have it. We have our first up and running LED circuit. Let me turn off the lights so you guys can see it better. So there you have it again. This is a simple circuit. What is going on? Oh, you see resistors that I was talking about earlier? Sometimes they disconnect when we move them again. And what happened was, again, it turned off, but our LEDs, again, were not fried, as I said again, because current cannot flow through. Okay, so with that in mind, see you on the next project. In our previous section, we built a simple circuit that lights up an LED. So let me bring it right here. So if you look close enough, we used our Arduino as a power source, nothing more than that, something that outputs 5 volt. We only used it as something that outputs 5 volt, but also can output a voltage. A battery can. So in this case, we can build the same exact project if we have a 5 volt battery, okay? So instead of using an Arduino as a power source, we can use a battery. Right here, I have a 1.5 volt battery, as is just found commonly inside of the remotes and all the things that we use. So I'm going to use a 1.5 volt. But this means that current is going to be less, okay? So voltage is directly related to current. So I'm going to have less current. Basically, the light is going to be a bit more dim. So to actually demonstrate that, let me turn off the light. Maybe then you can see it. If you cannot, Let me just bring this paper right here and try to overlay it with the paper. Maybe then you can see it. Can you see it? Okay, there we go. And let me just turn it off and turn it on so you can see the difference. Can you notice it? There we go. It's very dim though. You can see it if you was actually in a dark environment. But anyways, this raises the question, why not use batteries instead of Arduino? Because when you look at batteries, they look more reliable, they're cheaper, and again, they're easier, far easier to just move from place to place. So they're more convenient. So when you look at Arduino right here, we have all these things. You really need to be careful with Arduinos. Not only that too, but they're really expensive relative towards a battery. So this raises the question, why Arduino? Why are we using an Arduino? So one thing you guys need to know about Arduino is Arduino acts as a power source, but it's just definitely more than just a power source, all right? So it is a power source. It acts like it, but definitely it is more than just a power source. Even by looking at these pins and looking at all these things that we have right here, you can see that it's just definitely more than a power source. We're only talking about the 5-volt right here. So when you look at all these things that we have right here, it is definitely more than a power source. So what is the purpose of an Arduino? Arduino is used to code our electrical components. For example, let's say I wanted to code this so that it turns on and off every second. So it's going to turn on for a second, then turn off for another second, turn on, turn off, doing it in a loop. Okay, so it's going to turn on for 1 second, turn off for 1 second, turn on for 1 second, turn off for 1 second, and keeps going on in a loop. So how do I do this using a battery? I have to physically come in right here, turn it off, turn it on, count a second, turn it off, count a second, turn it on, count a second, turn it off. And obviously, this is not coding. But with our Arduino, we can set this up. We can set this up so that we can actually code it to actually make it blink. So we're gonna turn it on for 1 second, turn it off for 1 second. We can do this using an Arduino. So Arduino, what does it do? Something important that it does is it lets us code our physical components. I'm sure you use websites and applications and they're coded digitally. So what if you wanted to code our physical components? For example, let's say we're working on a robot or some other projects. This is where Arduino comes in. This is where Arduino comes in and lets us code our physical components. So definitely Arduino acts as a power source, but it acts as an intelligent power source, all right? An intelligent power source that we can code. Okay, so it's definitely more than just a power source. All right, with that in mind, let's check how to actually code our Arduino. So how to actually transfer code to our Arduino. So see you in the next section where you're on my screen and we actually check on how to code using an Arduino. So far, we've learned that Arduino is more than just a power source, and it can do a lot more, especially letting us code our electrical components. So to start coding our Arduino microcontroller, we're going to need a platform to write code on. So in this case, we're going to need a code editor. So it's going to be different depending that you're going to be using a physical Arduino or a digital Arduino on a simulator. For those of you who are using a digital Arduino on a simulator, all you need to do is go to this code right here, this code section right here, and choose your preference. So if you're using blocks, you can use blocks right here. You can change it to block, or if you prefer text, you can use text right here. But I highly suggest that you guys use text, as I'm going to be using text for this course. Okay, so for those of you who have a physical Arduino, all you need to do again is go right here, follow this link, and download the Arduino depending on the operating software that you have right here. So if you have a Windows, you're going to download from here. If you have a Linux, from here, and a Mac, you're going to download from here. So for those of you who don't have Linux, Mac, or Windows, or maybe, for example, you're using a Chromebook, all you can do is go to your Arduino web editor and touch the code online and sign up, and you can use this Arduino web editor. So without downloading anything, you guys can just start coding to your Arduino. That's all you need to do, start writing code to your Arduino. So once you're done downloading the Arduino code editor, it looks something like this. There we go. It looks something like this. It has void setup and void loop. We're going to check what these means, and not only that too, but we're also going to create this blink project that I mentioned earlier of the LED earlier in the next section. Okay, so now what we want to do to write code to Arduino. Let me go to our code editor, and one thing you need to set up is go to our Arduino and choose our board and our communication port. Okay, how do we do it? We go and select the board that we're using. For example, let's say I'm using an Arduino Uno. I go to Arduino Uno and select it. Obviously, I'm using an Arduino Nano, so I'm going to go back to Arduino Nano and select it. So you're going to choose the Arduino board that you have right here. Once you're done with that, you're going to check the communication port that you want to use. Right here, I only have one communication port. So I only have one COM port. So I don't have to stress, and I can just continue and just say OK. But let's say we have maybe two communication ports. Let's say I have another communication port right here underneath, and you do not know which one to use. To know which one to use, all you need to do is basically plug off your Arduino. So I'm going to plug it off. And once I plug it off, it's going to turn off. The communication port is going to be off. So you're going to know which communication port is tied to your Arduino. Okay, there we go. Go back to touch OK. Then I'm going to need to write code. So this is a starter code. This is a code that always exists for every sketch, okay? So this is going to be a code from the complex ones to the easiest project. They're going to contain void setup and a void loop, okay? So what is a void setup? This is where we actually put our setup code, okay? And it's going to run once. Importantly, it's going to run once, okay? So we're going to put our setup code right here, and we're going to only run it once. Okay, when it comes to loop, we're going to put most of our code and our main code right here, and we're going to run it repeatedly. So we're going to run it over and over and over and over and over again. Okay, so let me go right here, and to basically notify that our Arduino what pin we're going to be using, we're going to use this built-in function called pin mode. Okay, we're going to use something called pin mode. All right, there we go. And we're going to tell it what pin we want to use. Right here, I have, again, from 2 to 13. I have digital pin 2 to 13. So I'm just going to choose random number. Let me just choose 7 for now. So we're going to use pin 7. Okay, then once we're done letting our Arduino know which pin we're going to be using, we're going to notify it of how we're going to use it, okay? So we're going to tell it if we're going to use it as an input or we're going to use it as an output, okay? So if we want to use it as an input, we want to what? We want to receive data from the pin, okay? So when we want to use it as an output, what do we want to do? We basically want to send data. In this case, we're going to send what? Electricity. Okay, we're going to send voltage. Okay, so we want to use it as an output in this case. Once we're done with that, for every line, when we finish our code, for every line, we're going to finish it with a semicolon, okay? So one thing to keep in mind is, for all of you, is capitalization does matter. So you cannot write down pin mode, let's say with a small m. If I did that, and let's say I want to verify the code, it's going to show me an error message. So one thing you want to keep in mind is every time capitalization matters in code, okay? So it even matters for this output. Let's say I say output right here with no capitalization, with no proper capitalization, it's going to give me an error. Okay, so capitalization is very important in coding. And let me just run this right now. I don't see any error. Okay, there we go. So I wrote this down properly. So what does this code do? It tells our Arduino that we're going to use pin 7. How do we want to use it? We want to use it as an output. So once we're done notifying our Arduino and we're done setting up our pin, we're going to go to our loop. Okay, so how do we tell Arduino if you want to give 5 volt and 0 volt? We're going to use something called digital write. So right here too, again, specifically, capitalization is very important. So what pin do we want to write? We want to write down pin 7 that we already set up right here. There we go. And once we're done with that, we want to tell it if it's going to be high or low. High means 5 volt, okay? High means 5 volt, 5 volt, all right? You want to keep this in mind. So high just basically means what? 5 volt. Okay, then once we're done with that, what do we want to do when we want to make it blink? We want to what? We want to write down the same code right here. Again, capitalization matters. And put pin 7, and you've guessed it by now, we're going to use low. we're going to use low. So what is it going to do? We're done setting up our code once, so we're going to notify Arduino what pin we're using and how we're going to be using it. Then once we're done with that, it's going to run this code as a loop. It's going to run it repeatedly right here, okay? So it's going to go pin 7, it's going to turn it high. It's going to turn it to what? To 5 volt right here. Turn to 5 volt. And then when we turn it to low, we basically turn it to 0 volt or off, 5 volt or on, okay? That's what we're going to do. So let me just do is verify the code right here in case we have an error. It's done compiling right here properly. And then what we do is upload it, okay? And we're going to upload it to our Arduino. But one thing I forgot to do is to set up our Arduino. So we need to set up our Arduino. So one thing I need to do right here before even setting it up and wiring it, as I told you guys before in the precaution safety section, what I told you guys was to turn off our Arduino. First, we build our circuit and then we turn it on, okay? Okay, so let me bring my red pin right here and attach it to pin 7. Wait, that's pin 2. Pin 7 is right here. Okay, there we go. Put it right here. Put our handy resistor right here. We want to put it at an intersection. There we go. Okay, then we need our LED. I'm going to need to know the big side is obviously the positive. There we go. And put that right here, the positive with the positive side. And then we're going to go back to our GND or negative terminal. Let me go to GND right here. There we go. So I want to check again up close if I'm actually correct or I'm making mistakes right here. So I'm just going to bring it closer to myself and check it for myself. Okay, that seems fine. Nice. Okay, let me check the long side again. Okay, there we go. I'm correct. All right, I'm done checking. Now I can turn on my Arduino. Let me turn it on. Okay. I think it's the resistor right here. Okay, it was the resistor, so let me just touch it again. Okay, there we go. It's working now. But can you notice something? It's not turning on and it's turning off. It's just not blinking. We cannot see any blinking right here. Can you? I cannot. So what is happening? So let's analyze our code. So what we did was set up our code. Everything seems fine right here. Everything seems appropriate. And then what happens is basically, we digital write and we set it to high, then we set it to low, then we set it to high and low. And one thing you notice is it's going to go at a very fast speed. It's going to be really, really fast. Computers are really, really fast. So we cannot notice this with our naked eye. So right here, look at it. It's going to go high, then it's going to go low really fast, then it's going to go high again. It's going to, again, go on a loop, as I said again. So it's going to go high, low, very, very fast that we cannot notice it. So what do we need? We need a delay so we can notice it. So we're going to need a delay. So to do that, we're going to do is use this delay function. Okay, so when I say 1000, it's going to be 1 second. So it's going to capture it in milliseconds. Okay, so we're going to write down how much seconds that you're going to delay it in milliseconds. So we want to delay it right here and put our semicolon after every line. There we go. And we want to put the delay right here again. Delay of 1000. Then there we go with our semicolon. And let's run it again. So let me just verify it right now. Okay, then I'm going to upload it. So it's going to turn off for 1 second and turn on for 1 second. Turn off for 1, on, off, on, and it keeps going on. So let me go on, off, on, off. So we basically build this. Okay, so one thing to keep in mind again is that we use milliseconds. So when I say 1000 milliseconds, it basically means a second. So it's going to receive in milliseconds. Okay, there we go. So we're done with actually building this. So actually in the next one, we're going to check. So in the next section, we're actually going to check a few things about variables. Okay, so I have homework for you guys. So before moving on to the next sections, we're actually going to do these homeworks. Okay, so what we did right now is obviously create this blink again. So we used one pin and create this blink. So what I want you guys to do is create a traffic light. So we have our green color right now. We've got our orange one and we've got our red one. Okay, so you used one pin to set up everything for one LED. So how many pins are you going to be using for 3 LEDs, you're going to be using 3 pins, okay? So you're going to be using 3 digital pins. So you're going to put green in front. So instead of actually the red one, green is going to be right here. Then we're going to have yellow, and then we're going to have red, okay? So we're basically creating a traffic light. So I want this to do is basically, okay? What I want this to do is I want this to delay for 5 seconds and then turn off. So it's going to be on for 5 seconds, okay? Then when this one is off, obviously it's going to turn yellow. For this case, yellow is a shorter one, so I'm going to choose 1 second. And red, I want to make it the same as the green light because that makes sense. So we're going to make this 5 seconds too. Okay, so I want you to create a traffic light, a working traffic light, okay? So you're going to be using 3 pins, creating a resistor right here, using the resistor right here, and then obviously lighting up your LED, then going back to GND, okay? So they're going to be using the same GND. So if I bring, let's say, the second wire, one thing you guys don't know is, let me just bring another wire. Okay, there we go. Another wire. So let's say I have my ground right here of the second LED, of the yellow one, let's say, for example. And what you're going to do is connect it to the same GND, okay? So you're going to connect the same GND, it's okay. But you're going to be using what? Different pins, though. You're not going to be using the same pin. You're going to be using 3 totally different pins. So you might be using D5, D7, D8. It's up to you. So yeah, you're going to be building this project for yourself. So before moving on to the next section, so pause this video and work on it. If you are not sure of how the circuit is supposed to behave, again, you guys can use a digital simulator, okay? Afterwards, I'm actually going to build it with you guys. In case you do not know, you can refer back to the next section where I'm actually going to build it. Okay, so now we're actually going to work on our homework. So I'm not going to bore you guys out trying to build this, as I only need to use 3 different pins and do exactly the same thing. So the necessary information that you guys need is that green is connected to 7. So the green pin right here, the green LED is connected to what? The digital pin 7, okay? So it's connected to what? The digital pin 7. The same goes for yellow. It's connected to digital pin 4, while the red LED is connected to digital pin 9, okay? That's the necessary information that you guys need. So now let's code this. So first, we're going to need to do a pin setup. So we're going to need to go to pin mode and obviously set up our pins. So we want to let Arduino know what pins we're using. So let me just copy this right here. Paste this, and we're using pin 4. So let me write down pin 4 right here. 4, we're using it as an output. Yes, we are. Let me again paste this. And we only have pin 9, so we're going to use pin 9 here too. Nice. And once we're done with that, once we're done setting it up, let me just remove this code right now, because we're not going to be using this. We're going to digital write our pin what? Our pin 7 for green. So we want green to light up first, so I'm going to go for pin 7, then I want to set it to high, then finish it off with a semicolon. Then I'm going to copy this again. Copy this. Then I want what? I want pin 4 to be high. But before actually going to 4, what do I want to do? I want to delay it. Okay? I want to delay it for how many seconds? 5 seconds. So it's going to be 5,000 here. So I'm going to be using milliseconds here. 5,000. Then I want to do what? I want to turn it off. Okay? So I want it to be low. So let me go here. And I've got pin 7 here. Then I want to set it to what? To low. Okay? That's what I want to do. Okay, when it comes towards the yellow LED, what do I want to do? I want to do is the same thing almost, but I want to change the delay to what? To 1 second, don't I? So let me see it right here and set this delay to how many? 1 second or 1,000 milliseconds. And I want to change the pin number again. I want to change it to 4. So go 4, and I'm gonna go 4 again. Okay, this is for what? Let me just write this description down or comment. Yellow. This one is for green, so let me write down green right here. Green. Then I want the red one. It's going to be the same exact thing, but I want to change the pin with the green. Just copy that again. Do that, and I want to change the pin number to what? To 9, okay? All right. So I think I'm done with this one. So let's check if it's actually gonna work. So let me verify this. Okay, seems like it's working. Let me connect my Arduino before uploading it. So let me go here, connect my Arduino, and let's upload the sketch. Okay, it says done uploading, so let's check it out. There we go. There we go, it's working. Nice. That's great and all. But if you look closely again, let me go very close on my camera right now. Like really, really close. Forget about this paper now. Okay. So I want you to very look at this. Let me bring it up close here. So if you look at it right now, can you see how much I stress the GND? Like it really looks really bad. This is, by the way, the GND. All these 3 wires are connected to GND. Okay, so what can I do to fix this? So let me just bring an extra wire right here. Okay, an extra wire. Let me zoom out right now for now. There we go. So I have this extra wire. What I'm gonna do is let me just remove this 3 GND pins for now. Before actually building the circuit, what do I want to do? I want to turn it off. I want to turn my Arduino off. First build, and then we upload, and then we run it. Okay, so got my GND pin right here. Connected. I'm connected to the GND pin. If you cannot see it, I'm connected to the GND pin. All right, now what do I want to do? Okay, so I'm going to use this vertical stripe. Can you see it points to negative? There's a negative and positive right here. I'm just going to use the negative one as this just, again, convention. All right, so I'm connected to this one. So as I said, again, when it comes to breadboards, the edge ones are connected all the way vertically. So I can basically do is what? I can just connect it to this one, the vertical line again. The same for this one. Use this vertical line for the GND pins. And this one for the GND pin, I'm going to use a vertical one. There we go. Now it looks more nice, okay? So let me just, again, turn on my Arduino and run this. Everything should be working normal. Let's just check it out first. Okay, so 5 seconds. There we go. All right, it's working really, really great. Okay, so let's say I have a problem. I have to wait for like 5 seconds, and I just say it's just too long for me. And I just want to reduce this to 3 seconds, okay? So what should I do? I want to change the green and red to 3 seconds. I like the yellow one. It's 1 second. It feels nice. But the red and yellow just feel too long for me. Okay? So what do? I go right here and change 5,000 to 3,000. Not only that, too, I have to go back to red. Then go change it to 3,000 again. Okay. Then I have to upload it. So it's going to work for 3 seconds now. But, okay, let's just check it out. Working. Okay, there we go. It's working. Okay, it's a bit faster now. Let me just count again. 1, 2, 3, and change over. Okay, there we go. It's working pretty fine. All right, but I have to go change it at 2 separate places. So I have to go right here and change this to 3,000. Again, 3 seconds. So I have to go right here again and change this to 3,000. Just think of me having lots and lots and lots of LEDs right here. Let's say I have 5 or 6. I'm going to have to go change it, 6 places. I don't want that to happen. So how do I avoid this type of mistake? So we're going to learn something called variables. All right. So first, before learning about variables, let's talk about this box right here. So I have a box right here, okay? So this box, no label on it. You do not know what is inside until you open it. When you open it, you know what's inside, okay? So it has no label again. It's just empty. But to save us this effort, and let's say I just checked it and labeled it right here and named it microphone box. Okay, so I just gave it a label. So it's going to tell me what is inside before even opening the box. So right now, by just reading this, I can say is, okay, this has some mic equipment inside of here, right? Okay, this has mic equipment before even opening it. All right, so this is the nice thing about variables. So what they do is basically refer to things, all right? So they just basically refer to our data. so we can refer to our data without actually changing anything about our data. Our label does not change anything about our box, all right? It doesn't change anything. All it does is what? All it does is reference to our box what is inside the box. That's just what it tells us. So how do we set up variables here? And we're actually going to see even a second purpose of variables. The first one is to reference things. We're gonna check the second use of variables. So let me go right here. Let's see how you set up variables here. So all you need to do is go right here and use the keyword let, if I'm correct. I don't think you use the keyword let here. So all you need to do is write down a name. So let's say I want this to be delay time. So I just write down delay underscore time. Okay. So I'm going to set this to 3000 and close this. Let me just verify if this is even correct. And it says, no, it's not. Does not name a type. Okay. So right here, all we need to do is go right here and say let delay time. We do that right here. Let does not name a type. So you might be wondering, for those of you who are using JavaScript and all that, we have to tell it what type of data we're putting inside. Right here, we're putting what? We're putting an integer. All right. So we have to let it know the type of data that we're storing. Right. We're going to say is integer. Basically, it's an integer number. So let me just verify this again. Should be working pretty fine now. Can you guys see it? So we have to tell it the type. So when you're using Arduino, you're going to have to tell it the type of variable that we're using. So in this case, it's an integer I'm defining here. And obviously, I'm going to give it a name. So I'm going to call this delay time. Again, this has nothing special on it. So I can just even call it something else that is unrelated to it. I can just say, you know what, it's green. Or I can just say phone. Or I can just say anything. You get me. But I'm going to obviously put delay time because that's what is the use of variables, to give us rightful information of what this is. So even before somebody reading my code, they can understand, they can understand before reading this code is that, oh, this is delay time. This is supposed to be the time that is going to delay inside, obviously, this LEDs. Okay, so I'm going to go say delay time and set it to 3000, all right? So let me just set it to 3000. So I'm going to remove this delay time right here. So I'm going to be using it. How do I use it? I just use it as a normal thing. I'm just going to say delay time. I already defined it. I can use it multiple times. All right. All right. Also for red, I'm going to go right here and use delay time underscore time. All right. Perfect. That's all I need to do. If I verify this right now, I don't get any error. All right. Everything's sounding great. If I upload this, as I said again, a variable does not change a thing about what it's referencing. So I earlier said 3000 here, and basically what it's just doing is delay time is equal to 3000 here. So it's basically putting 3000. The computer is manually putting 3000 here, all right, instead of delay time. That's just what basically it does. So the second usage of variables here is that, you know what, this is a bit too fast for me. This thing is just really fast. This is going 3 seconds and then 1 second and then 3 seconds. This is very fast for me. I just want to make it 4 seconds, all right? So I can just do right here is just change it from one spot. I don't have to go multiple spots to change it. I have to find it once. I can do is just change it from one spot and say, you know what, that's what I want. Let me just verify this. Let me upload this. I want it to be 4 seconds. I want it to be in the middle. I don't want it to be too slow. I don't want it to be too fast, all right? So look at this. I upload this right now. It goes 4 seconds. So let me count this 1, 2, 3, 4. All right, there we go. So it goes for 4 seconds. All right. That's all you need to do when it comes to variables. That's why we use them a lot. All right. So instead of using pin 7 right here, just saying 7, 4, 9. Okay. I can change it again for somebody who does not know what I'm writing down. Before somebody even knows what I'm writing down right here, by just defining these variables, I just save them the time from reading the code. It can also work for yourself when you come back to this code. All right. So I can just say is, you know what, I can call this digital underscore pin equal to, let's say, again, we have 7 right here. So digital pin, let me just say 7 right here. All right. Let me just say digital pin 7 or underscore 7. There we go. Then I can write this down for 4. Write this down for 9. Write 9 here. Write select 4 here. There we go. And obviously replace this digital pins right here. So I'm just repeating 7 right here on pin mode, and also on digital right. I'm repeating it over and over again. Can you guys see the difference right now? So let's say I'm changing a pin. I have to change it at 3 separate places. I don't want that to happen. So all I have to do right now is do exactly the same thing. Write down digital pin 7. It's going to autocomplete it for me. Then go say digital pin 4, and then digital pin what? Digital pin 9. Okay, so I'm just going to replace this again. So one thing you guys need to know is by using Control D or Command D, you can just select the same number over again. So you can select the same thing over again. Say I even selected 7 right now. I even selected the 7 from the digital pin 7 right here. So you need to be careful. So okay, I'm going to do is select this to 7 right here, and I can edit them at the same time. Okay, edit this at the same time. There we go. When it comes to 4, I only have 2 4s right now left. Do this, and again, set this to digital pin 4. And when it comes to 9, I can again use Control D, select 2, then digital pin 9. There we go. It's not supposed to change anything about our code, but it should make it what? A whole lot nicer and clean, all right? So let me verify this again if it's working properly. Okay, everything seems fine. Let me upload it. And let's check if everything is working properly as it should. All right, nice. Okay, that's good. It's working really, really nice. So you guys learned about variables. So again, as I said, one thing you should know about variables is, as I said again, one thing you should know about variables is what? They do not change anything. All they do is what? Reference. Again, like I talked about the box. The label on the box just basically reference what is inside of the box, but nothing more than that, all right? So that's all when it comes to variables. So all they do is just refer data. They just make it easier and cleaner to store data, all right? All right, with that in mind, let's move to the next section. All right, so let's recap what we've done so far. So at first, we began with the 5 volt right here. We began with the 5 volt and we built a simple LED circuit. Afterwards, we used these digital pins right here. And what we did is again build a traffic light. Okay, so what are these pins marked with an A and a number next to them? We're going to check them out in the next few sections. By the way, these are called analog pins. So in the next few sections, we're actually going to see the difference between analog pins and digital pins. Not only that too, but we're going to see their purpose and why they are important in the Arduino world. So see you then. All right, so let me show you guys what I did right here. So what I basically did, all right, is that I set up the basic 5 volt LED circuit. So we have a 5 volt right here connected to the red connecting wire, and then we have a resistor, and we have our LED, and then we go back to the GND with the black wire. That's all I did. That's what we did when we started this course. Okay, so let me go over to my screen right now, and let's start coding. So right here, let me first give this a variable name. So let me say a red pin. All right. Then let me give it a number. Let's say we're using pin 4 right here. Analog pin 4. Let's just say that. Again, I just took it by random. And right here, what we do is, again, as we did for digital pin, what we did was pin mode. All right. Then we put our what? Our pin, which pin it is. And then how do you want to use it? Do you want to use it as an output or as an input? Always put a semicolon at the end of each line. All right, that's what I did right here. But there is a problem right here. So right here, when we're using digital pins, right here, we did was only put the number, right? So let's say I'm using digital pin 4 right here. Let's just say that I'm using digital pin 4. When I'm doing that, what happens? When I'm using digital pin 4, what I did was just put a number right here and set it up like I did for an analog pin. So right here, how do we know the difference between digital and analog pin? So how does Arduino know that we're using digital pin 4 or analog pin 4 right here. Arduino does not know. Okay, so every time to differentiate an analog pin from a digital pin, what we do is put a capital A before it. All right, before the number that we're going to use, we always put a capital A. So it's going to differentiate, and we're going to know actually which pin we're going to be using. So right here, Arduino will not be will not be confused if you want to use the digital pin or the analog pin. Okay, so we're going to do is what? Put a capital A beforehand. All right, so once I'm done setting up the pin mode right here, what I need to do is go here. All right, so what did we do right here? We said digital right, and we set it to what? What do? We put the red pin right here, and then we set it to high when we were using a digital pin. So right here, it makes sense to write what? Analog pin. There's something called analog right. Okay, we do that, and we see a red pin. Okay, the pin that we're going to be using, and then we're going to put a value. So right here, I'm just going to put 255, and I'm going to come back to this and actually explain why did we put 255. So let me just remove this right here, because obviously we're not using a digital pin right here. Let me just remove this, and all right, so let's verify it and let's upload it. Okay. Let me upload it right here. And it's done compiling, it's uploading, and it's done uploading. All right, so let me remove my Arduino from the 5-volt and let me move it towards the digital pin, not digital pin, sorry, I said analog pin 4. Let me just do that. All right, there we go. I moved it to analog pin 4 right here. All right, so right now it's lighting up as how a 5-volt lights it up, and a digital pin lights up the LED. So again, you might be confused on why did we use 255 right here? What is the use of it? And not only that too, but it's a very odd number, you know? Why not 300? Why not 200? Why 255 specifically? Okay, so let's see the science behind it to understand why it is 255. And so the question still remains, why are we using integers? So right here, let me start from something that we're familiar with. We use digital right, and then we set our pin, what pin we're going to be using, and then we set it to either high or either low. Obviously, high means 5-volt, which basically is on. Low means 0-volt, which basically is off. It seems to be working perfectly fine, so why do we need integers to represent this? To represent high. High is represented by what? High is represented by 255. Low is represented by 0. Why do we need integers to represent that? Because this gets the job done perfectly, right? So the problem here is when we're using high and low, the problem that arises is we only have two options. We cannot choose anything more than high or low. Let's say I want to set it to medium. Let's say I want to set it to, well, I want it to output 2.5 volts, literally the medium, the half. What happens? I basically cannot output medium because either I can set it to high or either I can set it to what? To low. So this is where integers come in. They come really, really handy, and they allow us to have intermediate values. So if I wanted to set it to medium, what do I need to do? All I need to do is divide 255 by what? By 2, basically giving me half. So let me just bring a paper right here. Okay. There we go. So let's say I want to do 255. I want the half of it. 255 is what? If you remember, 5-volt. All right. I want to output half of 5-volt. It's going to be 2.5 volt right here. All I need to do is what? I need to try to find X right here, how much I should be writing down, and then do the math. And once I do it, X is going to come approximately to 127.5, which you can round up or round down, which I'm going to round up to almost 128. So what does integer allow us to do? Integers allow us to have intermediate values. What else? Let's say I want to do is what? You know what? I don't want it to be half. I want to do 20% of what? The original high that we had. I want 20% of it. I want 20% of 5-volt. I want to output 20% of 5-volt. So let's do the math right here. What's 5-volt? 5-volt is currently 100%. What is 20%? All I need to do is find the voltage. Do the math right here. Keep on doing the math right here. 20, okay, it's going to be 0. When you do the math, 0.2 times 5 is going to equal to x. When you do the math right here, 0.2 times 5. All right, so basically, what is this? 5 times 2 over 10. When you do the math right here, this is going to be 2 over 2. So we're going to have 1. There we go. 1 is equals to what? X. Basically, we're going to output 1 volt. There we go. So basically, what integers allow us to do is what we can find any value. So we can have any intermediate value between what? Between high and low. So we can have any intermediate value between high and low. Because obviously, if I had, let's say, high right here and low, let's say I write down medium for 2.5 volt, and then I write down another name for it. Obviously, you cannot name every instance. You cannot name every, obviously, value of voltage. So we're going to be using integers, doing the math, and after doing the math, we can do what? We can find our desired value and then output the voltage. So basically, we can what? We can control the amount of voltage that's coming in to our Arduino, coming out of our Arduino. So basically, what happens? Basically, we can create dimmer and what? Brighter light. So we can create intermediate values of light. But one thing I want you guys to keep in mind is, okay, one assumption that you really, really need to know is actually how it works is it doesn't change physically. So as I said again, when we're turning it on, 5 volt, it's basically what? It's on, and 0 volt, it's basically off. So what happens is, let's say we're trying to write down 2.5 volt right here. We're trying to what? We're trying to output 2.5 volt. What Arduino does is, all right, what Arduino does is it turns on for half the time, for half the period of time, and then right here it's 0 volt. Let me just specify it. The one on ground is 0 volt right here. So what happens is what? What happens is it turns on for half the time, turns off for half the time, turns on for half the time, turns off for half the time. It does it really, really, really fast that you cannot notice it. So for us, it's going to appear as what? It's going to appear as dimmer. But what basically is happening is what? It's basically doing high and low, a series of highs and lows for what? It's doing a series of highs and lows for, again, a given amount of period of time. There we go. So that's how we output how much? 2.5 volt. We turn on for half of the time, we turn off for half of the time, we turn on half of the time, turn off half of the time. So basically, we're going to have what? 2.5 volts. Okay? So physically, the same thing is always high and low, series of 5 volts and 0 volts. But using integers allow us to do what? They allow us to what? They allow us to use intermediate values. Alright, so before running the code, let's do a simple recap. So what we did is what? We set red pin to analog pin 4, and we set it as an output right here, our red pin, and we use the analog write command right here, and we set it to a maximum value of 255, which corresponds to 5 volt, right? So let me just upload it right here, and it should light up. It does. Okay, nice. So let me go right here, and let's just say I set it to a value of 40. Just to notice the difference. So let's see if it goes dimmer. And when I do that, you see what happens right here. You see what happens. It does not fully turn on. So even you guys cannot see that it's fully turned on. It's not even turned on at all. Right? I can see that it's not turned on too. So there is an error ongoing here. So one error that I came here to fix is that what I did wrong was right here. I used analog pin 4. So one thing right here, let me go closer, is that you're not supposed to use this analog pins, this A pins for this purpose. Okay? What you're supposed to use is these digital pins right here, these digital pins that are marked with a symbol right here. So let me go closer again for you to see it. Can you see digital pin 9 right there? It has a dot on it, a small dot. See that? Let's compare digital pin 9 to digital pin 8. If you do that, digital pin 9 has a bit of a dot on the very edge, if you look at it. Not only digital pin 9 has it, digital pin 10, digital pin 11, digital pin 6, digital pin 5, and digital pin 3 have the dot sign on them, right? So let me go right here, and I have to connect is this these digital pins that are marked with a dot or a squiggly sign. So for me, it's a dot. But if you go over to my screen right now, let's go over to my screen. If you go to my screen right now, what happens is there's this squiggly sign. I'm just turning on an Arduino, an image of an Arduino Uno. And if you look closely, there's a squiggly sign in front of this digital pins. So what happens again is when you're using Arduino Nano, the board that I'm currently using is an Arduino Nano, we have is what? Dots that mark these unique digital pins. I'm gonna get to using them, alright? But when you use an Arduino Uno, we have a squiggly sign. So it will vary, the sign will vary depending on the board you have, right? So look for, if you're using any other board, look for a unique mark on your digital pins. Okay, so if you look closely here, it says it supports something called PWM, okay? So PWM stands for pulse width modulation. So what basically this means is, let me just explain it in a very, very simple term. All right, so before running the code, let me just make sure that you understand the science behind it. Okay, so it's quite simple. So what does this mean is, let's say I want to turn on my my Arduino to 2.5 volts. I want it to output 2.5 volts. All right, if I wanted to output 2.5 volts, let me just show you how you can do it. So what happens is when, let's say, an Arduino outputs 2.5 volts, what happens is it goes to 5 volt half of the time, and it goes to 0 volt half of the time. It goes to 5 volt half of the time, and it goes to 0 volt half of the time. Let's say I want to turn it on to, let me bring another paper. Let's say I want to turn it on to 1 volt, all right? So let's say I want to turn it on to 1 volt. Let me just turn on. There we go. Let's say I want to turn it on to 1 volt. Okay. How do I do that? All I need to do is just, again, draw the graph of volt versus time. This is time right here. We'll split the time, volt versus time graph. So what happens is it turns on. It's 5 volts right here and 0 volts right here. So what happens is it turns on for a very short period of time. It turns off for a long period of time. You see that? Turns on for a short period of time again, for 5 volt for a very short period of time. Turns on for turns off for what? For a long period of time. Okay? That's just a rough sketch of how 1 volt will look like. When it comes to 2.5 volt, what happens is, again, is what? Half the time it turns on, half the time it turns off. Half the time turns on, half the time it turns off. So we achieve this voltage. How do we do it? We use the two ends, 5 volt and 0 volt, and we fluctuate between them. So we change between them. Okay? That's the science behind it. And one thing I want you guys to know is it happens at a very fast speed that we can't notice it turning on and off. So we don't see it turning off for 5 volt for half of the time and turning off for half the time. It happens at very, very fast speeds. I'm talking milliseconds that our eyes cannot notice the difference. Okay? So for us, it's going to appear as a dimmer light, even though it's turning on and off at very, very fast speed. So let's go to our code and let's write it down to actually see what happens. So let me again plug my Arduino right here. Okay? So right here, let me actually instead of plugging it, what I should do is, let me bring it closer to you guys. So right here, one thing you can notice is we can use those squiggly signed, can you look at it? Those pins again with a squiggly sign on them. So in this case, digital pin 10 has a squiggly sign. Digital pin 9 has a squiggly sign. Let's just use digital pin 9 right here. Okay? So you use one of those pins that have a squiggly sign or a dot in front of them. So digital pin 9, I have to go right here. All right, so I connected it to digital pin 9, and again, it's a simple LED circuit. So let me connect my Arduino board right here. Okay, let's go back to our code. Let me go back to my screen right here. All right, so I'm gonna say is what? Pin 9, okay? Then I set pin right put as output and pin 40, okay? So let me just upload it right here. uploaded it. It's not even fully turning on. Maybe it might be the resistor right here. It's not the resistor. Am I correct with the pin? I think I'm doubting that. Okay, I got it to pin 8. Now I'm correct with the pin. It's pin 9 is right here. Oh, there we go. We have a dimmer light. I don't know, you might notice it or not. So what I'm gonna do is, to notice it is, let's go to my screen and let's write some bit of code so that you guys can actually notice the difference between a value of 40 and a value of 255. So let me just say analog right red pin and set it to 255. Okay, then we're gonna set a delay. Again, delay function lets us put delay for the amount of millisecond. So right here, I'm gonna set it for 1000 milliseconds, which basically means a second, all right? Okay, so we can see the difference. Delay, again, 1000. So let me just run this again. So let me verify this. Everything's running right and smooth. All right, and let me upload it. Okay, all right. Can you see it? It's going brighter and then dimmer, brighter and dimmer, brighter and dimmer. So what I'm gonna do is turn off the light right here so you can see it way better. Okay, let me just turn off both the lights on the spot. You'll see it better now. It's going brighter and dimmer. Obviously, the brighter is 255, while the dimmer is obviously the number 40. Okay, so let me just go back to our light right here. Turn on both lights. So we've seen how pulse width modulation right here works. Okay, so I'm using what? PWM. All right, so I'm using this pit. So one confusion that happens is what I see most often is, all right, what are, again, these pins are the analog pins, the ones that are marked with a D pin and then a number next to them, and that have, again, a dot or a squiggly sign. Are they analog pin or are they digital pin? Because if you, again, look at the code right here, we're using analog, right? So if you look at the code right here, let me just highlight it again. If you use the code right here, we're using what? We're using the command analog right. Oh my God, this is getting annoying. Jesus. Let me just go right here. There we go. Analog right. It's going to analog right. But also, one thing you notice right here is what? It's marked with a D, which makes it a digital pin. So you might be wondering, is this a digital pin or an analog pin? So one thing you need to understand here is the ones that are marked with a dot or a squiggly sign, these special digital pins, I would call them special digital pins. What they are is they're both, okay? So they're digital pins, they're also analog pins. Right here, when we use the analog right command, we use them as what? As an analog pin, okay? So we use them as analog pins. And also one thing you need to keep in mind is we can also use them as digital pins. So let me just turn off all this code right here. If I just say again, not changing the pin right here, I'm gonna say is digital pin, right? Digital right here. And again, when we use this command, we only can say high or low. We cannot put a number here. We're just gonna say high, okay? So let me just upload it right now as it is. Just upload it on the spot. And again, let me connect my Arduino right here. I forgot to connect my Arduino. I can't upload it because I did not connect my Arduino. Let me just upload it right here. It's done compiling, verified the code, and done uploading. Can you see that? It's lighting up. So one thing you need to learn about these digital pins that are marked with a squiggly sign or a dot is we can use them as an analog pin, and we can also use them as what? As digital pins. I want you guys to keep that in mind, all right? So see you in the next section where we're actually going to work. We're going to work with these A pins, with these pins that are exclusively analog pins. You see these pins? They're exclusively analog, all right? So they're only analog pins. So we're going to actually check them out. And for the first time in our lives, we're actually going to use pin mode and set it up as an input. So far we've used pin mode and set it as an input, as you remember here. All right, so we're actually as an output. So we're going to set it up right here and use it as an input in the next section. So see you then. Right, so let's continue and learn about analog pins. All right, so right here we've got these pins right here again. marked. Let me just unplug my Arduino right here. These pins that are marked with an A and that respective number next to them. Okay, these are the analog pins. So let me again focus here. All right, there we go. It's focusing. Let me just go a bit closer. Or maybe even zoom it better. Let's be better. There we go. See those A pins that are marked with a number and an A and the number next to them? Those are called what? Analog pins, okay? Let me just zoom out for now. All right, so I'm gonna be wrecking them. So let me go over to my screen right here. Let me just go over to my screen. And what I'm gonna do here, open this. So let's set up our pin. So right here, I'm just gonna say to pin mode again. Then I'm gonna choose a random pin. I'm gonna choose pin A5. Okay, I'm just gonna put this as what? As an input. Okay, when we're using these A pins, we're gonna use them as an input. So far, we've worked with digital pins and we've worked with pins that are analog and also digital. Those ones that are marked with a squiggly sign or have a dot on them. All right, so far we've used them as a what? As an output. But right now we're gonna use them as what? For the first time, we're gonna use them as an input. We're gonna use some pins, those pins as an input. Okay, so one thing I did wrong right here is I did not use a variable. Again, variables make our life very easy. Why not use them? I'm just gonna say read pin. It will make more sense when I go further through this video. All right. So I'm just gonna say it's read pin. Okay. I'm not gonna use the direct thing. I'm just gonna use a variable again. I'm not gonna use the direct value of it. Okay. So once I'm done setting it up, what do I need to do? I need to use the analog read command. All right, analog. There's something called analog read, as you can see right here. All right, we have what? An analog read command. So far we used what? Analog write. Right, incorrect. We used analog write. We also use digital write. Okay, so for the first time in our lives, instead of writing, we're gonna use what? We're gonna be using analog read. Okay, to read. Okay, so what does analog read do? So basically, so far, what we've been doing was outputting voltages, if you remember. So output voltages. Right now, what we're going to do is we're going to read voltages. We're going to read voltages, all right? Okay, so let's just do that right here. So analog read. And what you're going to put right here on the analog read is the pin that you're going to be reading with, okay? Read pin, okay? All right, that's what we're going to be using to read our pin with. Okay, so let me just turn on my Arduino right here. Plug it in right here, and then let's upload this code. No upload port provided. All right, let me go to my tools, and then let me go to my port right here and select the COM4 port. Now let me upload it. Okay, it's done compiling. It's done uploading, so finished uploading. But how am I supposed to see the result? You know, when we were using output pins, when we were using output, what we did is what? We used LEDs to see the power and the voltage that they had. Remember, right? So we've been using LEDs to do what? To see the voltage. When they turned on, we said was what? It was 5 volt. If it was dimmer, we said it was a lower voltage. So we used LEDs to direct us, to basically tell us and to basically show us that our pins are outputting what? Our pins are outputting voltage, okay? But how do we do it when it's reversed around? So far it was an output, but how do we do it when we're using an input? So to do that, actually, let me just bring something that is common, and I think all of you know of, if you're using computers, is a mouse, okay? So a mouse is a what? Is it an input device or an output device? It's an input device. And basically what we do is we connect it to our computer. Again, we just connect it to our computer. And when we move, we do what? We see something on our screen. What is that? What is the thing that we see on our screen? It's a pointer, okay? So we see a pointer. So an input device, what do we expect now? We expect is what? To see the results to happen on the screen. That's what we expect, okay? So to do that and to actually see something on our screen, we're going to use something called serial monitors, okay? So we're going to use something called what? Serial monitors. So we're going to do a serial.begin, okay? Serial.begin. And in this one, you're going to write your baud rate. So you might be wondering, what is a baud rate? A baud rate is the speed at which, it's basically the speed at which information is transferred. Okay, I want you to think of it like that. Don't go further or don't go deeper, as it mostly does not matter. But to catch it, just for the sake of knowing and for the sake of knowledge, to catch it it's what? It's just the speed at which what? The speed at which information is transferred from your computer to other devices. Okay, that's just the thing you should be thinking of baud rates as. Okay, serial.begin 96,000. I set it as 96,000 as it's the most popular baud rate, all right? It's the most popular one. Okay, so I just started my serial monitor right here. And what I need to do is quite simple. I need to say is serial.print. So I wanted to print something. For example, let's say I wanted to print the number 1, okay? Just say we want to print the number 1 for now. So let me upload it right here, okay? All right, it's done compiling. It's done uploading. And you go to your tab right here where it says serial monitor. I'm going to touch that. Okay. Can you see what's going on? I said 96,000 baud. As you can see, it automatically set it up. Because why? I did something wrong right here. What did I do? I said it says 9,600 baud right here. And I used 96,000 here. I'm supposed to say 9,600. So let me upload it again. You see that? I'm getting an error message right here. So for those of you who don't know, is you can't upload or verify your sketch without removing the serial monitor. So you always have to turn it off before uploading or moving, all right, verifying your code. So I have to always turn it off, and I do that. And let me just upload it right here. There we go, it's done compiling. It's done uploading. So always turn off your serial monitor when you're uploading your code. Let me just upload it right here. Can you see it? It's uploading 1 at very fast speed. Look at it. 1, 1, 1, 1, 1. You can see how fast it is. Look at how even the pointer is moving. It's very fast. Okay? So I just said it's print 1. That's all I'm going to do. It's basically like the print function that we use on Python. Okay? All right, so I wanted to print the value of this. Okay, I just wanted to print the value of this. Let me just do that. Just set it up. And just turn off the semicolon right here. First things first, what should I do? I should what? Turn off the serial monitor. Okay, just turn it off. And you know what? It's going too fast for me. I'm just going to give it a delay. So I want it to delay for what? Let it delay for maybe 500 milliseconds. Okay, so basically half a second. I just wanted to delay for half a second because it's just going too fast for me. Okay, it's done compiling and it's done uploading. So let me go back to my serial monitor right here. And we're receiving, that's very confusing, isn't it? I mean, is this one 50? Because it printed it out at very fast speed. So is this 50 then? Is it 50 here? Or is it 505? Or is this 5,054? Are they together or what? You can't see it until it uploads it right here. Okay, this is very hard to keep up. So what I'm going to do here is turn off the serial monitor right here. Okay, I'm just going to do that. And what I'm going to do right here is say print and add ln at the very end. What this does is basically it prints out everything at a new line. Okay, so it prints it out at a new line. Every print is going to have its own what? Its own single line. All right, so with that in mind, let me just upload it right here. And let's see what happens to the serial monitor. Count for serial port. All right, there you go. It's working actually. All right, you see it. It's just fluctuating, saying 321, receiving 280, 273, 256, 255. Okay, it's okay. Okay, this number does not make mostly sense, does it? I don't think it does. So what I'm going to do is, all right, what I'm going to do is this. So let me just try to do as well. I'm just going to read off of the 5-volt voltage, all right? So what I'm going to do here is I have an analog pin right here. Okay, I have this analog pin. Again, what analog pin am I using for this? I'm going to be using analog pin 5. Let me just bring analog pin 5 right here. I'm just connecting it right here. Okay, analog pin 5. Let me just make sure that I actually connect to analog pin 5 and that I'm not connected to any other pin. Analog pin 5, okay. let me just connect it here. Okay, so let's just again upload this code. It's already uploaded, but I just uploaded it again so that it restarts. All right, then we receive again these weird numbers because I still do not know what are these. Okay, what they are. I still do not know that. So I'm receiving 1023, 986. All right, so we have to make something of these numbers. Okay, so what I'm gonna do right here, okay, is, you know what? This is supposed to read the voltage again. As I told you guys, it's supposed to read the voltage that is coming from what? From our Arduino. So let me go right here. I have my A6 pin right here. Can you see it? I have an A6 pin. I have the 5-volt pin right here. But I am very confused. Should I connect this together or should I not? I am really hesitant about the circuit. Should I connect A6 with the 5-volt? Because if I do, I might short the circuit. If I short the circuit, basically, I might fry my Arduino. You know, so I'm a bit hesitant on connecting them directly. To connecting my pin right here with the 5-volt because I'm not used to doing that. We're used to what? Connecting the 5-volt and then going to a resistance and then going to what? To the GND, right? If I'm correct. So how do I do that then? How do I check? You know, I'm very hesitant about this circuit right here. I don't want to connect the A5 pin directly to the 5-volt pin because I might short the circuit. But I want to do it so that, you know, the answer it gives me is 5-volt. I want to check it. So I'm a bit hesitant on this circuit. So rather than just, you know, doing this and hoping for the best, it's better to do what again? It's better to run a simulator. So I'm just going to go to my screen right here, turn on Chrome, and go to a simulator right here. Okay, that's what I'm going to do. I mean, that makes my life a bit easier. Okay, so again, let me just go right here, and I have it right here. All right, let me just open this so that I can simulate it. All right. Let's just check, you know, what happens here. Does something bad happen? Okay, so I have my analog pin here connected with the digital pin. I want to change that to a 5-volt pin. I want to see what happens with the 5-volt pin. My 5-volt pin is right here. There's my 5-volt pin. Okay, and I have my analog pin. Okay, I have my analog pin. How about instead of connecting it like this, it's better. How about I just connect them directly, you know? Let me just turn both off, and I'm going to do this 5-volt pin connected directly, let's say, to one of the analog pins, in this case, A5. Let me just start the simulation here. Let's see what happens. Nothing happened so far. Nothing happened. Everything seems fine, doesn't it? So far, it seems fine. Nothing is going on. I mean, let me just check my code right here. Is my code good? Put that right down. Did I set A5 to read? I set A3 as a read pin. I just want A5 to be a read pin. I don't need this because I'm using the 5-volt again. I don't need this. I just need my serial, you know, serial dot begin 9600. I already set that up. All I need to do is what? Say analog. I set reader, a variable reader right here. I set it to analog read pin. I don't need that right now. Let me just copy this. Let me just go back. Let's just write it down as if the one that I already wrote down on the Arduino IDE. Okay, so that's what I'm gonna do. So yeah, I think that's my code for now. Let's start my simulation right here. So far, nothing. There's no warning or anything. Okay. All right. What else could possibly happen? All right. So I want to go to my serial monitor right here. Oh, there's a serial monitor right here. All right, I keep getting this value 1023, 1023, 1023, 1023, 1023. Again, so far, my simulator told me that it's fine to connect an Arduino A pin with a what? With a 5-volt pin. Did not say it's correct, you know, to put it together, but like, let's see what happens if I connect an A pin while we're here. Let's just check what happens if I connect maybe a digital pin. All right, digital pin maybe 8. Let me see, digital pin 8 to a 5-volt pin right here. Let's just say I want to connect to a 5-volt pin. What happens? You know, what could possibly happen? Let me just start simulation right here. Maybe let me start that. Before doing that though, let me go on my code and let's just write it to become high. All right, let me just do that. Okay, I received 1023 again. We're gonna get back to that. Okay, But I just want to check again what's going to happen when I connect the digital pin with a 5-volt pin. So I'm just going to pin mode, and what I need to do is set up the digital pin 8, and say what? That's an output. I want to use it as an output. What else do I want to do? One final thing I want to do is what? I want it to be high. So I'm just going to say is what? 8. Set that to what? High. Let's see what happens. Let me just start the simulation. Oof. What happened? It's saying, okay, this one has an error right here. Okay. Let me start right now. I will now. Seems fine. You see that? It seems fine. There's no error coming from my simulator telling me you should not do this or something. It seems fine because it does not make a full circuit. But one thing that's not fine, that's definitely not fine, for example, is connecting the 5-volt pin with the GND pin. Let me just connect it directly, 5-volt and the GND. Let me just start the simulation right here. If I do that, I might not tell you right here, but what happens is basically what? It's basically frying your Arduino LED. So this does not tell me what? It does not tell me if it's fine or not. Okay? It just does not tell me that. It's not warning me about connecting it directly with the 5-volt, with the GND, because it's very dangerous to do that. Because again, what I said is shorting is going to happen, and basically what's going to happen? It's basically going to fry your Arduino. So you see that it's fine, but if I go to another maybe simulator, if you search for another simulator right here, it's going to say it's not right. Anyways, so let's go back to actually what it was. So let me just go back to Control Z, and let me just stop the simulation, and let me just get that 1023 right here, the number 1023. Okay, let me just go back here. Okay, we connected this directly. There we go. Let me go back to my code. Let me just... Okay, so let's start the simulation again. What did I do right here? Oh, I put a semicolon before this. All right, so let me start right now. Okay, seems fine. Let me go to my serial monitor. Okay, it says 1023, 1023, 1023. So I want to explain what this number is. It's like the number that we used at 0 and 255 on the analog write command. We're using 255. So let me just explain this right here. Let me just bring the paper and explain this right here. Okay, so the same thing we did on we basically did on the 255 to 0 value when we were talking about the analog write command. Okay, so look, we have 1, we have 2, 4, 8, 16, again, to the power of 0, to the power of 1, this is to the power of 2, this is to the power of 3, and to the power of 4 is 16, and keeps going on. Okay, we reach a point of 1024. Let me just bring it right here, 1024. This is what? This is what? This is 10 bits, okay? So we stopped at 8 bits right here. This was what? 256, where we basically used for the analog write command. But this extends this, and it can count to what? Up to 1024, okay, to the power of 10. That's why we keep receiving 1023. Why do we keep receiving 1023? We're receiving 5-volt right here because I connected the 5-volt with the what? With the analog pin. So I expect a 5-volt. So 5-volt is what? 1023. Why did we say 1023 instead of 1024? Because we start counting from what? From 0. That's one thing you need to know. So when you start counting from 0, what happens? It becomes 1023. Just like 256 right here, we start counting from 0. It's going to be up to what? 255, right? So 1024 is what? 1024. It can store 1024 items, but it can, because we start counting from 0, it's going to count to what? Count to 1023, okay? So, all right. So right here, we get 1023, basically meaning what? 5-volt. We receive 5-volt, okay? So that's what we basically are receiving. How about if I just remove this 5-volt right here? Okay, let me just remove this 5-volt. Let me stop the simulation right here. All right, let me just remove this 5-volt. I'm not going to connect the 5-volt anymore. So what I'm going to do is I remove the string between the 5-volt and the A5 right here. What I'm going to do is, you know what, I want it to go to GND. I want to connect the GND with the A5. Let's just do that. Okay, so let me start the simulation right here. Okay, let restart simulation. Let me clear this one first. Let me clear the serial monitor. Let me just remove it and open it again. I should be doing that. I should fully remove it. Stop the simulation. Start it again. Let me go back to the serial monitor. Nothing's coming by, as you can see right here. Nothing's coming by. Can you guys see that? Nothing is coming by right here. You're trying to read the pin, but nothing is coming by here. You're trying to use E5. Let me just set clear right here just to clear it up, but nothing seems to be working. So in this case, let me just reload it. I think it's better to do that way when we go through these errors of the serial monitor. When I was using the Arduino, what I could have done is, close the window right here. I'm just gonna do is clear it, and I'm gonna do is close the window right here. I can do that. But sometimes when the simulators again don't work, because they don't fully mimic the physical world, I'm gonna have to reload it because again, it happens. Okay, let me go back to code right here and let's go back to our serial monitor. We keep receiving 0. When you connect to the GND pin, we keep receiving 0, 0, 0, 0, and 0 at like perfect pinpoint accuracy. I'm talking 0, 0, 0, 0, 0. You can see that, right? When it's at 5 volt, we receive 1023. When it's at 0 volt, we receive what? We receive 0. Okay, so 1023 corresponds with what? With 5 volt, when we're reading it. When you're writing, when we're using the analog write command, let me just again, for you to remember, when we're using the analog write command, 5 volt corresponds with what? 5 volt corresponds with 255. The 5 volt right here, when we use analog read, corresponds with what? 1023. I know it might seem a bit odd that we're using, two different, bit systems here. We're extending this to the power of 10, or we're just using to the power of 8 for analog, right? It might be, it might seem weird or stuff, but it's just, again, convention. This is something that Arduino's people who built this decided upon. I don't know why they decided upon this, but as long as I'm concerned, it's going to be, again, 1023 for analog read, and it's going to be 255 for analog write, okay? That's all you need to know. Okay, so now we've worked with what? We've worked with analog pins, but we've not worked with a physical Arduino. We've been using simulators, okay? So let's actually work with a physical Arduino and actually add a bit of a twist to it and make a good project. So I'm going to introduce a new electrical equipment right here called a potentiometer right here. If you look at it, it's blue right here. It's called a potentiometer. It might be different depending on the kit you have, so it might even be black, it might even be long. But one thing you need to look for is 3 legs right here and an adjusting knob. So you have a knob that you can use to adjust, all right? So you have the knob right here that you can turn. That's the 2 things you need to look for in a potentiometer. So it might be different when it comes to yours, when it comes to your kit. So again, check your label, all right? So check the label and check if it's a potentiometer or not. Okay, so what is a potentiometer? Again, before working with the component and stuff, we need to learn the science behind it. So let's check what a potentiometer is. Okay, so we have this simple circuit here and has a potentiometer here, and then it goes back to the negative terminal. This is the positive again. Again, this is the negative. The smaller one is the negative terminal. Okay, so the potentiometer, you can just think of it as what? As a box that has 2 resistors here. Let's call this one R1 and R2, okay? So R1 and R2. So just think of it as what? As a big box that has 2 resistors, okay? So there's going to be what? RT, let's just say it's the total value of resistance here. It's going to be what? Since it's connected in series, it's going to be what? We're going to directly add them up. We're going to add them up directly. So we're going to say R1 plus what? R1 plus R2. Because they're connected what? Directly, okay? So that's all we're going to do. RT is what? R1 plus R2. So what does this let us do? What does a potentiometer let us do? Why is that so that a potentiometer is very important than a, why is it different than a resistor? think of it as a variable resistor. So when you adjust the knob right here, you can change the value of current, the value of volt that comes out of here, okay? So you can adjust it so that what? You can adjust the resistance here. So think of it as a what? As a variable resistor. Okay, so let's say right here, I just put it all the way to the very end, to the very left, okay? I'm just doing that right now. I hit the left, the very end. I can't move it further than this. Let's say I put it right here. What's going to happen is, when I do that, let me just draw it right here. When I'm at the very, very left, R1 is going to have a value of what? RT. RT right here, the total resistance. Okay. And R2 is going to be what? R2 is going to be 0. Again, when I say 0 right here, I've told you guys that there's nothing called as a 0 resistance. It's just theory, okay? So it's very, very small that it's close to 0, but it's definitely not 0, okay? I haven't told you guys that even these connecting wires that are not, they don't serve as a resistor have what? Resistance. So everything has a resistance, even though it's what? It's very, very, very low. Okay, so in theory, it's 0, okay? So with that in mind, what happens when I put it in the middle, when I put the knob in the middle? What's going to happen is what? R1 is going to equal to what? R2. Which is going to be equal to what? It's going to be equal to half of the total resistance. Half of what? Total resistance. Okay. All right. Then what we're going to do is basically go to the very, very right. So what's going to happen? So in this case, what happens is R2 is going to be what? R2 is going to be RT. It's going to be equal to RT, while R1 is going to be what? It's going to equal to what? To 0. Okay? I just want you to keep that in mind. Okay? So right here, let me just turn this notification off. Okay, there we go. So right here, we have this again, voltage out. Again, the voltage is going to be output right here. So we got these. Let me just go closer right here. Focus on these. So you see those two. These are R1 and R2. They're connected to R1 and what? R2. These are the final ones right here. Okay? The first one and the last one, they're connected to what? To R1 and R2. And the middle one is connected to what? The middle one is connected to V out. This is going to be the voltage out. Okay? So, with that in mind, let's just get started. So let me just put this potentiometer right here. Okay? So again, when you put the potentiometer, let me just remove my, let me unplug my Arduino right here. We need to what? We need to put it across. We don't put it together. We don't put the wires together. Again, we just do it what? Across. Let me just put that across right here. Okay. You need to, again, look like it's facing the front. Okay. So with that in mind, what I'm going to do is connect it to a 5 volt. Okay. And we're going to use our analog pins to do what? To read the voltage out of here. Okay. So let me just do that right here. Let me just go on 5V right here. Connect it to the 5V. Okay. Let me just do that. Just go to the 5V right here. Can't see it. All right, there you go. I got it right here. I connected it to the 5V with the black wire. And then what? Let me just connect the third one right here. The third one, the third leg, the last one right here. With the what? With the GND. Let me just connect it with the GND right here. Boom. I did that. And then finally, I'm going to need an analog voltage again. The voltage that I'm going to be reading off of. I'm just going to put it in the middle pin right here for you to see it in the middle pin. Okay. And I'm going to put it at A5. So I already have this code written as I rewrote it earlier. So what I'm going to do is it's already uploaded. So I'm just going to run it. Okay. You guys can look on my screen if you guys remove the code or not, but I already have it. Okay. So let me just upload. It's already uploaded right here. So let me go over to my screen right now and let's open our serial monitor. Go to my serial monitor right here. Let me just make this a bit taller. All right, there we go. Maximize it. It's 1023. It's outputting 1023, 1023, 1023. So let me just adjust it right now. Let me just adjust it a bit. Can you see it's going lower? It's going lower, lower right now. Let me just try to put it in the middle, roughly in the middle. All right, it's going lower right here. It's roughly in the middle, a bit. Okay, it's roughly in the middle right now. I put it straight, so it's roughly in the middle. And then let me just adjust it until it goes to 0. Let me just adjust it all the way down. Let me just do that. You see that? we're changing the what? The voltage value coming out right here. Can you see that? We're going to 0. We don't get a true 0 right here, but we get something that's very close to 0. What is going on is we're getting values like 0 point something, and sometimes it rounds it up to 1, sometimes it rounds it down to what? To 0. Okay, so with that in mind, something that actually can make this more interesting is what? Putting on an LED. So what I'm going to do right here to put on this LED, actually make things interesting. Let me actually move this a bit because this is taking too much space. Let me just, again, move it to the very furthest line right here. That's all I'm going to do. I'm not going to change anything because this is going to take a lot of space. Let me just go and put this as close as I can to the wires. It just takes a lot of space. Okay, I have one space right here. So I'm going to, again, connect the positive terminal of my LED right here to what? To one of the resistors, R1 or R2, whatever you want to pick. I'm just going to connect that. And then what? And then I'm going to connect the negative side of it to what? To the GND. So I'm going to need to do that. Let me just do that. Okay, let me just connect these 2 pins. I'm not connecting the middle pin. I'm connecting the positive, the black one, and what? The red one. Okay, I'm connecting those 2. Let's see what happens when I try to adjust the knob right here. Let me just try to adjust the knob. All right, let me just do that. It doesn't work. Why is that so? One thing I need you to understand, the potentiometer is what? RT is fixed, okay? RT is always fixed. What is changing is always R1 or R2. The value of R1 or R2 is changing, but RT is what? It's always fixed. Okay, so when I'm going through the whole resistance right here, RT is what? It's always fixed. The potentiometer. Right now, my potentiometer is what? 10K ohms, and it's gonna be written on your potentiometer, or at least at the label that of how much resistance it has. Okay, so it's gonna be the total resistance minus 10,000 ohms. Okay, I want you just to know that, but it's gonna be written for you. All right. So with that in mind, if I just again run this over again, it won't work. So what I need to do is what? I need to go to the middle. So let me just do that. How do I do that? I connect the GND again to what? The GND is the red pin, if you remember. Is it the GND is what? The GND is connected to which pin? Let's just remember that. The GND is connected to the red pin, okay? It's confusing me a bit because the red pin is supposed to be connected to 5 volt as a standard. And like the black pin is supposed to be connected to what? The GND. That's a standard again. Again, does not change anything, but it's like a standard between electrical engineers. But I just, I rushed over it and just changed the color. So it got me a bit confused. All right. So let me just connect the positive side to what? The positive side to the middle pin. So I'm just going to connect to the middle one and the negative side of the LED to the what? To the red one. So let me just do that. It's crossing over. I don't want it to touch each other. That would be bad. Don't want that to happen. Okay, there we go. No, let me just go tighter right now. Try to go tighter right here. Right, I think this is the one. All right. So now let's try to adjust it. Okay, let's adjust our knob. Can you see it? It's dimming slowly, slowly, slowly. This looks beautiful, especially when it's going slowly. You see that? We did that. All right, that's beautiful. Now it looks nice. But before finally actually finishing our project, what we're going to do is what? I want to look at the serial monitor right now. It's outputting 231, some value. Let's just change this to what? Let's just change this to something that makes more sense to us. That has something that is what? That is a value to us again. I don't want it to show to between 0 and 1023. I want it to show what? I want it to show 0 to 5 volt. So what I need to do right here, it's quite simple. I need to do some bit of math right here. So what I'm going to do is what? I'm going to say, you know what? Let me just set up a value right here. It's going to say int. I'm going to say calc value because I'm going to what? Calculate it. So I'm just going to say calc value. And it's what? Let me just set it to 0 for now. Okay. Calc value and what? Let me just, okay, there's a delay right here. Let me just go beneath that. And what I need to do is what? Just set up the calc value right here. Calc val is set to what? I'm going to say is what? It's going to be what? It's going to be 5 divided by 1023. You're going to divide that. Then you're going to what? Multiply by what? I'm going to multiply by what? I'm going to multiply by the analog read pin. Wait, I got that wrong. Analog read and I'm gonna say read. Okay, just multiply right here, and I'm just gonna say calc val. Okay, there we go. All right, so what I'm gonna do is upload it right now, and let's see what happens. So let me just upload it right now. Again, my serial monitor, is it off? All right, there we go. Is my serial monitor off? All right, I turned it off right here. All right, I turned it on right now. Just turned it on. Again, make sure that your serial monitor is off every time. Okay, I get 0, 0, 0, 0, 0, 0, 0. Then let me adjust it. Getting zeros? Wait, let me just adjust it the other side. We're getting a 0. Even though this is adjusting, you can see that we're getting definitely more than 0. It's saying 0, 0, 0, 0, 0. So the problem here is, let me show you what I did. The problem here is what? I'm using integers. So right here, it's going to bring what? 5 divided by 1023 is going to give us what? It's going to give us a decimal. So what happens is, it's going to what? It's going to value, it's going to what? It's going to round it down to 0. Because if you just think of it, let me just divide 5 by 1023. Let me just divide 5 by 1023. Let me just bring my calculator right here. Let me just bring my calculator right here. I'm just turning on my calculator. Let me just divide 5 by 1023. 1023. It's almost what? It's almost 0. And it's what? It's rounding it. It's rounding it to what? It's rounding it to 0. So any number multiplied by 0 coming from the analog read, it's going to always read what? It's going to always read 0. So what do we need to do? We need to set it as what? As decimals. So I go right here, and what I'm going to do is set a point next to it, all right? So I'm going to set a point next to it, and you can see 5.0 or just a point next to it. It doesn't really matter. It's up to you. So I'm going to set a point next to it. And one final thing I need to do is what? I need to go to calc val right here. And I'm not going to set it to integers. I'm going to set it to float. Basically, float means what? Basically, float means decimals, all right? So you can just set it up without actually giving it a value. It's up to you. Let me just upload it right now. Okay. And it should be working. Okay, it's done compiling. Okay, it should be done uploading by now. Let me open my serial monitor right here. All right, we're starting to receive real numbers here. Okay, we're receiving 4.7, 4.5 right here, 4.2. We're not receiving full 5 volts. You know, you might be wondering why. If I remove this LED right now, we're almost going to receive 5 volts. You see that? As soon as I remove the LED, we get 5 volts because our LEDs what? Our LED is using up some of the voltage right here. That's why. Okay, so it's using some of the what? The voltage. If I remove it right now, if I remove this LED right now, it's going to be what? Let me just remove it for now. It's going to be giving me 5 volt, 5 volt, 5 volt, 5 volt. Can you see that? As soon as I put it back in though, I think it's right here. As soon as I put it back in, it's going to be giving me 4.8 because what? It's going to be using 0.2 volt right here. Our LED is using what? 0.2 volt of the value. Okay, so let's just adjust it again. Just to check it out. Adjust it more. Adjust it. Again, adjust it almost off right now. And there you have it. And that's it for this project. So I think we built something with a potentiometer. I think it's one of this higher end of projects that are actually nice. So, okay. So I did not change my circuit here. It's the same from the previous one, but we're going to add something called buzzers. So if you look closely right now, let me just bring it close enough. These are called buzzers, and we're going to use them to basically create sound. So we're just going to change electrical energy to what? To sound energy, basically by what? By vibrating it. So again, before working with these buzzers, let's go in depth and try to understand what they do. So let's just have a rough idea of what buzzers are. Okay, so if you look close enough, again, these are called buzzers. If you look close enough, they're not the same thing. If you look at top, they might seem like they're the same thing, but if you look at the bottom, there's a black one right here, okay? And there's a one where you can see the circuit, okay? So let's just go here and try to understand what they are. So the one marked with a black one is a what? It's called an active buzzer, okay? An active buzzer. And the one that does not have any board, any bottom on it, and where you can see the components right here, is what? It's called a passive buzzer, okay? So I want you to understand the difference between these two. So both of them are used to create sounds, but it's going to be different for both of them. So let's go right here and let me just explain what an active buzzer is. Okay, so let me just do that. So an active buzzer, what it basically does is what? It needs DC voltage. It takes DC voltage, and what basically happens is there, if you look inside, if you just pry it up open, there's a cone that vibrates, okay? There's a cone that vibrates back and forth, okay? There's a cone that what? That vibrates back and forth and basically what? Creates sound by vibration. So let's just do that. So I have my, again, circuit from the previous lesson. So what I'm going to do is, I'm not going to touch this one. I'm not going to touch any of these. I'm just going to give it a new space. And one important thing you need to understand is these things, if you look at it, it has a plus sign. Okay? So not only that too, but even there's a difference in what? There's a difference in their what? In the length. Can you see that this one is longer? The plus sign is what? Is longer. Just like what? Just like when we were using what? LEDs. So keep that in mind. Both of them have what? Both of them have a plus sign. Both of them have a plus sign. And the plus sign, what? Leg is longer. Okay, so let's go back to our active buzzer right here. All I need to do is put the plus sign down here. And what I'm going to do is connect it to the 5 volt. So let me just go to 5 volt right here. There's the 5 volt. And I'm just going to connect it to the longer side of it, or basically the positive side. That's all I'm going to do. Okay. And let me bring another wire right here. Let's get another wire. I'm sure this is a very short wire. Let me get a longer one. Let me get a longer wire right here. All of them are short today. I have to go closer, if not. All of them are short. I don't have any longer wires left. I've used all of my longer wires. Okay, so if I have a short one, what I'm going to do is go through this side. Let me just go back to this side. Okay, and let me just take this 5 volt right here and take it. And put it right here. I got the GND, the ground pin. This is I'm gonna connect the negative side to what? To the GND. So let me just do that. That's the GND right here. And it starts to make what? Can you hear that? It starts to make what? A sound directly as I plug it in. So, okay, that's what an active buzzer does. Okay, so let me just bring this one, the passive buzzer. Okay, when I'm using a passive buzzer, one thing that's necessary to do is what? The difference that comes here is I need to use AC. Basically, I need to use what? AC circuit. For this one, I've just directly used what? 5 volt. When you look at the Arduino 5 volt right here, the 5 volt pin, it directly outputs 5 volt DC. Basically what? Direct current. I'm going to come back to this and actually compare and contrast them, but I use what? Direct current. Okay, so for this one, we're going to use AC current, alternative current. Okay, so let me just remove my active buzzer here. This is my active buzzer. Again, the one with the black one. Let me just remove it. Let me just remove the wires that I used for the active buzzer so that it does not get too messy. Let me just do that. Okay, and now what I'm going to do right here, I have again my passive buzzer. Let me just set it up. Let me just unplug my Arduino now. Let me just go back closer so you can actually see it. There's my passive buzzer. I'm just going to put it right there, the same spot. Actually, I need my GND pin connected to here. My GND, cannot see it. All right, there we go. GND pin connected to the negative side for the other leg, which is connected here. And the positive side, I'm going to be using what? Those digital pins that are marked with a what? With a squiggly sign. Those ones that I said that behave both as a digital pin and also as a what? As an analog pin, okay? So we're going to work with those. Let me just put it at digital pin 9, okay? Digital pin 9, because it has what? If you look closely again, it has what? It has a dot sign. Wait, let me just bring it close enough so that it focuses. Let me just actually zoom in more. You see that? It has a dot sign right there. So we're going to use those pins again that I mentioned, that the ones that I used for what? For analog right now. Let me just zoom out. Okay, zoomed out. Okay, so that's what I'm going to do. So let me go over to my screen right now and actually write down some code. So let me just remove this for now, remove this code because I don't need it right now. We can write it down if you need to again. Okay, so what I'm gonna do is what? We're gonna need a digital pin. So I'm gonna say is what? I'm gonna need the digital pin 9. So I'm gonna say what? What is this? Passive buzz. I'm just gonna say passive buzz. It's gonna be what? I'm gonna set it to digital pin 9. Okay. All I need to do is what after it's set it up. I'm gonna say passive buzz. Set it to what? As an output. There we go. Then afterwards, what I need to do, I'm gonna need to do is what? Use the analog write command, and again use passive again buzz, and then what? Then let me just set it to whatever I want to. Let's just say I want to set it to 3. Okay, so let me just set it to 3. Let me just upload this right now. It's done compiling. Oh, we cannot upload it because what? We have not plugged our Arduino. Let me just do that right here. Let me just do that. Let me just remove the paper for now. I'm gonna go with the explanation after we work with it a bit. Okay, let's just upload it. It's done compiling. Okay, it's done uploading. But we can't hear anything, can we? I cannot hear anything. Is everything all right? Let me just again check my pins. Okay, there's still pin 9 is here. There we go. Let me just stop it first. Let me just stop it for a second. You might not hear it as very. You might not hear it as strong as the active buzzer because I set it to what? I set it to 3 because it's gonna be receiving less what? Less electricity. It's gonna be receiving less current. Okay, let me just do that again. Hopefully you can hear it. If not, let me just again increase the value here. Just put 3, so let me just increase it to let's just say 20 for now. Let's just say 20. Let me just again put back what? There's still pin 9 back again to its spot. Now it's louder. Now it's louder. Okay, let's raise it to a higher value. Let's just say 40 or 50. Let me set it to 50. And let's upload it right now. It's done compiling. It's done uploading. Let me put it back right here. Now we can hear it louder. Right, so let's make it actually do something interesting is we do is put what? A delay on it, right? So we're just gonna set it on and off, on and on and off, because it's gonna sound better that way. So let me just say delay right here. Analog, right, what? Passive buzz. Just set it to 0 right here. And give it a delay again. Okay, so one thing I did not do right here is set up what? How much I want to set it to be. So let's just say again, 5 milliseconds. Again, I'm saying 5 milliseconds. And let's upload it. Again, let me just put it back right here. The D button. Can you hear it? Alright, let's just set this maybe to delay 1. Maybe to delay, how about 10? Let's just say you want a longer delay. All right, we've experimented with the passive buzzer and the active buzzer, and one thing the passive buzzer, is capable of is what? We can turn it off and turn it on. Can you see that? You can turn it on and off as we did right here. We turned this to what? To 0. Basically what? Turning it off. At line 14, we basically what? Turn off. We just did is what? Turn off buzzer. That's what we did. Right here, what did we do? We turn on buzzer. But we couldn't do that using what? Using an active buzzer. Why is that so? Why is that so we can't do that using an active buzzer? Why is that so? So the big thing here is when using an active buzzer is what? Why couldn't we do that? Well, it's because what? 5 volt is always what? 5 volt. 5 volt always outputs what? 5 volt. Okay? So 5 volt always outputs what? 5 volt. That's why it cannot, go on and off. That's why we cannot, turn it on, off, turn it on, off, on, off. We cannot do it using a 5 volt, but we can definitely do it using a digital pin. We can definitely do it using a digital pin. Okay, so with that in mind, let me just again actually. So with that in mind, actually, what I'm gonna do is gonna be working with these potentiometers. Before doing that, we're gonna have to go again. We have to go behind the science here. So we're gonna go to the science. So let's do that. Okay. So why does a passive buzzer, require AC circuit, and why does a active buzzer require why does an active buzzer require a DC circuit? A passive buzzer requires AC circuit, and an active buzzer requires a DC circuit. Why is that so? Why is that so? So in a passive buzzer, okay, we use AC circuit. Let me just bring a passive buzzer right here. We use AC circuit because what? Because there's something called a vibration cone. A vibration cone, what it basically does is what? It vibrates to create sound. Okay? So the vibration cone, what? In an AC circuit, what? Goes back and forth, back and forth. So one thing I want you to think of on an AC circuit is what? Let me just bring this right here. I think most likely you've heard the term AC circuit, and you most likely know this graph. It goes up and down, up and down. When you look at a DC circuit, it's what? It's straight. It goes what? It goes one way. This goes what? This goes back and forth. This goes back and forth. Basically what? Basically vibrating. Just think of it. Back and forth at very fast speeds. Basically what? Vibrating. Basically when it vibrates, what happens? It creates sound. Okay? So when you think of direct circuit right here, a DC circuit right here, you might be wondering then, how does an active buzzer work then? Because it receives what? An active buzzer receives what? An active buzzer receives DC circuit. So when it comes towards DC circuit, what happens is, when it comes to an active buzzer, what happens is, the difference in component here is that it uses something called electromagnetic, all right, spectrum. So what it uses is what? EMRs. So what happens is basically, let me just explain this in a simple term, not get into too much detail. So what basically happens is this. Okay, let me just bring a Sharpie right here. What basically happens is this. So you see this, let's just say there's a magnet right here, okay, and there's something it's attracted to right here, okay. There's a magnet here, and there's something it's attracted to. So when it's on, what happens is what? It goes attracted to it. It's attracted to it. It goes right here. When it's off, what happens is what? This magnet is repelled, okay? This magnet repels, okay? So you see that? It goes on and off. So basically what? When it goes on and off at very fast speeds, what happens? When it goes on and off and on and off, what happens? Even using a DC circuit, what happens? What happens is it moves what? Back and forth. The vibration cone moves what? Back and forth, back and forth, back and forth, okay? So that's the whole essential thing. There's a vibration cone and it's moving what? Back and forth to create what? Vibration. Okay, in mind actually, let me just go right here. I have my active buzzer right now. Let me just go over to my active buzzer. What I'm going to do is quite simple. I just want to create something that adjusts the volume. So let's just use a potentiometer right here. So let me just go back to my buzzer. Again, the positive side is right here. So what I'm going to do is, let me just bring my connecting wire. And what I'm going to do is, I'm going to use this middle pin right now, the V out of the potentiometer that we mentioned earlier. I'm just going to use this as my main terminal, okay? Because then I can do what? I can adjust the voltage that comes out. Okay, I'm just going to do that. And I need the GND pin. So obviously I'm just going to take this GND pin from here, and I'm going to put it at what? At the end of the circuit. Let me just do that. Now it's supposed to work. All right. One thing I did not do is what? Right. What did I not do? The black one is supposed to be connected to what? To 5 volt. I think it's connected to 5 volt. Does it connect to 5 volt? All right. So one thing I did is what? I forgot about the potentiometer. It's not what? It has to come from one end the other end. Let me just, again, if necessary, let me just draw the potentiometer again. Just flip the page right now. And as I told you guys, let me just try to draw the circuit here. Okay, we have the battery, 5 volt. We have the potentiometer is what? A box that has what? 2 resistors connected in what? In series. And in the middle, we have what? Something that's going to output our voltage. This one is like the what? The white pin in this case. V output. And we have what? Afterwards, we have our buzzer that needs a positive side. Okay, a buzzer. And then it has a negative side. You just put it with a circle on top. That has a negative side. And then what? We connect it to what? The negative side. Basically, the what? The GND. So one thing that I not do here is what? Connect the R2. The R2 is right here. I did not connect it. I just jumped it. So what I need to do is write like this. So let me go back right here. The V output, let it stay right here. That makes sense, doesn't it? So you know what? I'm just going to put the V output right here. Okay. Then what? I'm going to need another wire to extend it. Just do that. Okay. Alrighty. We're about to extend it. There you go. We extended it. So we extended it on the what? On the white pin. Basically what? The middle. Okay. Alright. So let me just try to adjust it a bit. I don't know if you can hear me, but let me just try to adjust it a bit. Okay. Let me just try to adjust it. Okay, I connected what? The white pin, I extended it to what? To the red pin, if you can see right here. The white pin is the one. The V out is extended to what? The positive side of the what? The positive side of the buzzer. I'm using a what? An active buzzer again. Let me just try to, use it as a turning knob. Basically, use it as a volume adjuster. So what happens is you can barely hear anything at the middle or at the start, and then you can hear something at the what? At the very, very, very end. Okay, when I put it to the very end. Okay, basically when it's what? When it's receiving the maximum voltage, basically almost 5 volt. It's receiving the maximum voltage. You see, it doesn't make any sound when I turn it all the way. So obviously for this case, do we need what? We need a passive buzzer. So let's just try doing that with a passive buzzer. So instead of using what? Instead of using the 5 volt pin again, I need to take it out of the 5 volt pin. The 5 volt pin is connected to what? To this one. And I'm going to be using digital what? Pin 9 instead. Okay? I'm just going to be using digital pin 9. There we go. Then I'm just going to have my passive buzzer here. The positive and the negative side again marked. Okay. Now we should have what? We should have a voice adjustment. So let me, again, what I'm going to do is right now, I'm just going to change it. Hopefully you can hear it now. I'm just going to go silent and let's see the volume change. Can you hear? It's not the smoothest change, but definitely you can notice what? The change in volume when it just changes. All right, let me just go right here and just give it more voltage right now. I'm giving it maximum of 50. Let me just give it 255, which is the maximum value. Let me just give it a maximum value right now. Okay. So now let's just adjust it again from here. Can you hear it? Now it's what? It's basically the potentiometer is what we're using it as an adjuster. All right. So again, potentiometer, we use it as what? As an adjustment, basically as a adjuster for what? For the amount of voltage that comes out. Basically the current, the voltage that comes out. Okay. So we used our buzzers right now. We used the passive buzzer. We have the active buzzer here. We're not using it. We're using the passive buzzer right now. So we made this simple project. Okay. So now we learned about what? We learned about these buzzers and how to make really, really good songs with, really good sounds with. All right. So even then too, if you actually, let me go to my screen right now. Let's make this a bit more interesting than it is. So let me go over to my screen right now. Okay. I don't need all these wires right now. Let me just remove them. I don't need my potentiometer right now. Let me just remove them. Okay. So let me just go to my Chrome right now. And if you go right here, let me just say buzzer Arduino sound code. It'll just go for code. Okay. All right. Let's try to find a good code sound. All right. So there are going to be lots and lots of play a melody using the tone function right here. Let me just try to open this. But what you can do, what I'm going to give you as a homework is what? What I'm going to give you as a homework is try to find these Arduino codes, again, that use a buzzer. You can see that right there. We're using a buzzer right now. Right now, I don't know what buzzer we're using. I don't know if you're connected to a pin or a 5-volt. The image is not the best. All right, let me just go here. Okay, there we go. We're connected to pin 8 and GND. Okay. All right, and there's the code right here. All I need to do is what? Let me just copy the code right here. And it has a library. I need to include that. And we're actually going to see how to even include libraries right now. So let me just copy all of this. Okay, I'm copying all of it. I need to. All right, there we go. No need to repeat melody or whatever. Just copy this right now. Let me just put this. Yeah. Paste this fully. And one thing I need to do is what? Install a library. Okay? There's a board manager. You go right here, and there's a library manager. So let me filter my search. I'm just going to say pitches.h. Okay. This says micro gamer. Just go and try to even run the code before including the right. It says what? There's nothing called pitches.h. Okay? So let me just try to Google it right here. What pitches.h is. There are definitely lots of notes, as you can see right here. Let me just go to pitches.h. There we go. Yeah, we're getting to its GitHub page right now. Pitches.h, and I'm trying to include it as our. There we go. So I'm trying to include it in our library right now. As you can see right now, I'm trying to search for pitches.h. Okay, pitches.h. Just do that. So again, do it yourself. Again, try to go to problems and do it yourself. Okay, let me just install this because it's the only thing that's coming here. Okay, let me just install this and let's try to verify our code even then too, if it actually works. All right, it says there's nothing in this directory, no file in this directory. Okay, pitches.h, there's nothing in this directory. That's what it's basically saying. So what you need to do in this case is basically simple. Okay, so what I do in this case is just go to GitHub or any other documentation and ask them the simple question. Okay, I don't know how to, include libraries in C++ because I'm mainly used it. So, all right, let's just go here. My sketches are encountering the following error. But just don't, it's not enough resident. Okay, reference. Try to read one. Leads me to this link. Right now, this leaves me with this link and it doesn't seem to go any further. Okay, then how do we do it? How do we go and add libraries to our Arduino? Because I used to know this, but over time I think I forgot about it. Alright, pitches.h does not seem to be working. Alright, so let's try to use something that does not have any library. But one thing, I'm going to go over this again, how to use libraries and stuff in the future. Alright, how to install pitches.h audio. Let's just go here. There's an Arduino forum on how to install it. There's an Arduino documentation of what? Installing libraries right here. Pitches.h is a part of, alright, 0 to... Haven't signed on. Alright, so it's telling me to do what? It's part of what? A sketch, not a library. An example of this is official 0.2 digital sketch that comes with the what? With the Arduino IDE. Alright. It's leading me towards this. So again, we're just running to what? We're running towards the problem again. The same problem again. Seems that we can't solve it right now. I'm going to need to solve it later on. Okay, let me just check the installing libraries documentation. Again, I'm trying to do this together with you guys. Is what happens is when it comes to courses is it just seems easy when somebody else does it, and we don't. It doesn't seem that you're going through a problem. We are. Everybody does. Okay. All right. So let me just go to again library manager. Let me just do that. So all right, let me just go to Sketch, include library, and manage libraries. All right, let me just do that. Sketch. There's says include library right now. I'm going to say manage libraries right now. Okay. You should open a tab right now. Just again, go again, just to show you to you guys. Manage libraries. Okay, there we go. Just let me do the same thing. Pitches. When I put pitch, it just shows me pitches. So it does not have a good documentation, because if it did, it's gonna show me basically how to even install it. You see that? Add a .zip library. You can do that. So basically what I need to do is what? Download this pitches.h right now. That's what it's basically telling me to. I have to download this. Basically this code. Download this and run it. So let's just try to find something else that actually does not require me to do what? To use this pitches thing. Okay, so let's just say buzzer Arduino sound code. Again, let's just try to find it. This is part of programming, but you cannot find the things you actually want. Okay. Let me just say code. Let's just say song. Song code. See that? Play Pirates of the Caribbean theme song on Arduino. There are definitely lots and lots of great YouTube videos again to actually make a. There we go. Arduino and a buzzer. Songs for Arduino. Let's just try this one. Alright, there we go. Let's just see the component again. We have the GND and we connected to pin 9 right here. Okay, that makes sense. You have to include the pitches again 9. You have to do that. You keep using this library. Okay, include library, add.zip library. Alright. Alright, there we go. Add a zip library. But we do what? We definitely need pitches.h what? We need to download it. As far as I'm concerned right now, we need to what? Pitches.h. I need to find the library and download the zip. Let me just go to pitches.h right now. I should find the GitHub about it. Alright. There we go, pitches.h. I'm just going to download the zip right now. Let me just do that. I'm just going to call this pitches.h because it just makes more sense. Pitches.h.zip. Let me just call it that. Okay, that should be better. Isn't it better right now? Okay, so let me just do that. Import that. Let's try that. Let me just import it. How do I do that? I go back to this tab. It's showing me how to import it. So, okay, I'm importing the zip library. Sketch, include library, add zip libraries. Let's just do that. So let me go right here. Let's go tools. No, actually, let's go to sketch. And let's say include library. And then add zip libraries. It's not available in the library manager. It's not available in the public library. Pitches.h.zip. Let me just try to do that. It's processing it and it's installed it. So I think my code should be working now. Hopefully it is. Okay, it's done compiling. So hopefully now it's gonna work. Let me just upload it. Okay, it's done compiling, so that's nice. Okay, melody. Can you see that? All right, so we used our library manager right here, but one thing we actually need is what? It does not include what pin I use for this, you know? That's the problem right here. The problem I have right here is what? It does not tell me what pin I'm supposed to use. Does it even set up a pin mode? I don't think it does. Didn't. I think in this case we're gonna be using an active buzzer here because we're not setting up any pin mode and all that for a passive buzzer. So we're just gonna be using what I'm gonna assume we're gonna be using an active buzzer here. That makes more sense. So let me just connect the 5-volt right here. Connect the 5-volt. Let me just put it right here. And we have the GND. Let me just again connect the GND right here. It's a bit harder when you're filming to actually get the right pin. Let me just go over here. GND. Got it. Okay. I think that's how it's supposed to work. Let me just make sure again I got the 5-volt and then not get the wrong pin. I think I did get the wrong pin. Still getting the same thing. Alright, so we're still getting the same thing. What could possibly the problem be right now? I was trying to find another code because this one does not make any sense, does it? At least we imported what? The pitches.hzip. So it should have been actually better. Okay, so this one is horrible. Or maybe I did not read what? I did not read the full documentation. What did it say? I have to connect it to what? It specifically told me what? To connect it to what? Pin 8. Can you see that? It specifically told me to connect to what? To pin 8. So I need to remove this active buzzer again. I did not read the whole thing. That's why I was rushing again to finish this video. That's my problem right now. But again, it happens. I just wanted to show you guys. Okay, actually I did not know anything about adding libraries towards C++ or Arduino, but I just wanted to show you guys the process of learning. Okay, me myself getting into a bit of a trouble right here. Okay, so we need pin 8. It's hard to actually get the pin 8 right now when you're... Here's pin 8. All right, I think it's this one. I think I'm supposed to be doing this. Pin 8. All right. The GND. I uploaded it, right? Just make sure if I uploaded it or not. Just to make sure right now. Okay, it's done compiling. Can you hear it? Let me just upload it again. Okay, that's a nice tone right now. Okay, how about I just want to run this again and again and again and again? It's just running one more time. How about if I run this in the right here and just set it in the loop because I just want to run it again and again and again. That's what I want to do. I want to run it on the loop. Right here, though, before finishing here, I'm just going to just get a delay before, you know, writing the tone over and over again. I'm just going to get a delay of maybe 10 milliseconds. And it's going to make it better. I don't know if it's going to ruin the code. We're just going to see it right now. All right, so this was a bit of a long one right now. I don't think you can see the buzzer right here because again, I just moved it around, but I don't think it matters. Again, I just connected it to what? To pin 8 right here. Okay, connected this one to pin 8, and I connected this one to what? The GND. That's all I did. This is connected to what? To pin 8. As in the image, it's connected to what? To pin 8. It's just my it's because that my wire isn't that long. Here you go. You can hear it again. There we go. So I guess that's it for today. Yeah, so I'll actually see you in the next section. This was a bit of a long one, and really sorry, by the way, for if you guys did not see the pins. I tried to tell you guys where I connected it to and all, but again, this just happened because again, my wire isn't that long, and I have to pull it really hard to actually bring it here. Okay, anyways, see you in the next section. Okay, so in this section, we're going to discuss about photoresistors and thermistors. Okay, so let's bring something that is familiar with you guys. Resistors. Obviously, we use them to do what? To limit the amount of current that is coming in so that it does not basically what? Ruin our components. Okay, so right here, we're going to learn about these special type of resistors. So let me just bring them right here. This is a photoresistor, and a thermistor looks something like this. Let me bring this close enough so that you can see them for yourself. So when you're looking for a photoresistor, what you're going to be looking for is this squiggly lines right here that goes like this, like this, like this. Okay, you're going to be looking for those when you're looking for a photoresistor. And let me just put that next to its name. And when you're looking for a thermistor, you're going to be looking for these round-headed. Again, they can be green, they can come in black, but again, always read your labels to make sure what you have right here. Okay, so always make sure, because they look close to something called ceramic capacitors. Okay, so just keep that in mind. Okay, let me just put this back to its place. Okay, now let me try to explain what these are. Okay, so these are, as I said again, they're types of what? Resistors. They're some sort of type of resistors. They have the ending of ister. Okay, so there are different types of resistor. So when it comes to the photoresistor, one thing you need to understand is it is a type of resistor where the resistance value changes, okay, depending on light. Obviously, the name photo, the beginning of photo, indicates something that has to do with what? With light. Just like how we use photosynthesis. It has to do something with what? With what? With the light. So photoresistors are what? These are types of resistors in which the resistance value changes according to light. This happens so that because we use a special material, all right, on the top. We use a special material which changes its resistance. Again, corresponding to what? Corresponding to light. All right. So one good analogy of this would be something we've worked with in the previous project, which is going to be a potentiometer right here. Let me just bring it closer. The potentiometer we just worked in the past few sections. So potentiometer, what happens? How do we change its resistance? It's a variable resistor, as I said again. How do we change its resistance? We just change the knob. Just like this. And when it comes to a photoresistor, what do? We change the light. We change the value of light. So we change the light again. We go dimmer and brighter. And it's going to change our what? Our resistance. Okay? Just keep that in mind. All right. When it comes to our thermisistors, the name thermi gives it away. It's related to what? Something that has to do with what? With temperature. Okay? Something that has to do with what? With temperature. So when it comes to thermisistors, basically, just like how photoresistors again change their resistance value according to what? According to light. Just like how photoresistors just change their value according to light. These thermisistors, let me just go closer again. These thermisistors change their value according to what? According to temperature. Okay, according to what? According to temperature. Let's just keep that both in mind. Okay, so now let's start, I think, working with our photoresistor here. Let's just keep our thermistor on the side here because they're very familiar. That's why I just chose to teach them together. But let's work with our photoresistor first. Okay, so let me just get this out of the way. Just bring my Arduino here. I have my photoresistor. And what I'm going to do is basically connect a simple 5-volt circuit. So just how we used to use an LED and a resistor, instead of using a resistor, we're going to be using what? We're going to be using a photoresistor this time. Okay, let me just turn off my light here. Let me just turn it off. Turn off my Arduino. Bring the Arduino closer so we can focus on what we're doing right now. Okay, there we go. I'm going to connect the 5 here right here. The 5-volt connected to the 5-volt pin, the red wire. All right, nice. Now what am I gonna do? I'm gonna bring it here, move it to here. Okay, then I'm gonna have my resistance again here. I'm gonna put it across. Okay, When it comes to resistors, again, it does not matter which leg you put it through. Obviously, this matters in LEDs, but when it comes to any type of resistance, it doesn't matter which leg you put through first. Okay, the same comes to the potentiometers. You can put what, the first leg or the last leg. It doesn't really matter. What matters is the middle leg. Obviously, it's going to be the one with the V out. So obviously, the middle leg is the important one that you actually don't want to mess up. But you can just choose between these two. You can just put it in the GND or this other side on the 5 volt. Doesn't really matter. Okay, let me just put that here. Focus on it again. All right, let me get my LED, my handy LED right here. Got my LED. Now I'm going to connect one leg of the photoresistor here to the what? To the LED. Let me just do that. Just focus here so you can see it better. There we go. Now you can see it way better. All right, and then what do I need? My GND. Okay, just bring the black wire here. Again, connect this to the GND. Where's the GND at? It's right here. I just connected the GND pin or the negative terminal. Let me bring this across here. Right, and let's just put it back here to the other side of the LED. Okay, we just did that. Okay, we just did that. But there's something wrong with this circuit. I mean, it seems fine when you look at it because, as far as I'm concerned, what did we do? Let's just recap on it. What did we do? We used our Arduino as a 5 volt output because we connected to the what? To the 5 volt. And then what else did we do? Afterwards, we went to our what? Let me just bring this aside here. What did we do? We brought our resistor here. In this case, it's a variable resistor, and you just indicate it by this symbol. Variable resistor is indicated by this symbol. Basically, changes is what? It's resistors value. It's resistance value changes according to a condition. Okay, in this case, what is going to be? The condition of light. All right, then we have our LED, our handy LED. How do we write that down? We go like this. Then we go back to our negative terminal. One thing I did wrong here is what? This is the negative terminal. The negative terminal is what? The smallest side. So I have to put a negative here. And I have to make this the positive. I have to make it the bigger one. Because, obviously, why? Because the big one's the positive, the bigger line, and the smaller line is what? Negative. Okay, let me just put that. And again, let me just correct this. This goes big, small, and there's a small one here. Just put this to big. All right, there we go. I'm just correcting this. Anyways, what basically happens here is what? We have the 5 volt output, we have our resistor, we have our LED. This seems like a normal, a simple 5 volt circuit. Again, this should be working, and there's nothing wrong with it as far as I'm concerned. It looks perfectly neat. Instead of using our normal resistor right here, we just used some sort of resistance. Instead of using our normal resistor that we have here, instead of using that, we basically did what? Instead of using our normal resistors, we basically used what? A photoresistor, which we said is what? It's a type of what? Is a type of resistor. But the problem that lies here is that this photoresistor, the value changes over what? Over light. So right here, I have a bright environment, all right? I have a bright environment, all right? So how am I supposed to be sure? How am I supposed to be reliant that the photoresistor, doesn't have a small resistance value? Because we said the resistance value changes. How am I supposed to be sure that the resistance value is not very, very small? How am I supposed to be sure, right? Because one thing you need to know about photoresistors right now is as the light increases, okay? As the light increases, the resistance decreases. And then the opposite goes true too. As the light decreases, the resistance on the photoresistors increase. Okay, I want you to keep that in mind. So right here, I'm in a very, very bright environment. I have 2 lights set up just for this course. Okay, so how am I supposed to be sure that, this does not what? This basically does not have a very little amount of resistance value, that what? We're going to have too much current and it's going to fry our LED. How am I supposed to be sure of that? So to be sure, to be exactly sure, in this case, we're going to have to put a backup resistor. Basically, in case if we have a very, very little amount of resistance, in case we have that, we're going to need a resistance that does not change, okay? So what I need is what? What I need is a normal resistor, again, just to back me up in this case. Because if this resistance value just changes to, let's say, a value of, let's say, resistance value goes to what? Goes to very little numbers. Let's see, even 0.002. Okay, I just say 0.002 ohms. Okay, I just say even it goes there. If it goes there, let's just calculate the amount of current that goes here. So current is what? The voltage over resistance. The voltage is what? The voltage is 5. It's going to be divided by 0.002. Okay, there's the current. If I just do that, if I just do the simple math here, and this is going to be 0, multiply this, both of them by 1,000, okay? And it's going to be over 2, 50 over 2 is going to be 25. We're going to be receiving 2,500 amperes. It might not seem, very big. It seems like a big number, but it might not seem, too big because we're not, relatively what? We're not contrasting it with what we know. All right. This is a big number. This is a very, very big number. But to actually put it to the light and to see how big of a number it is, let's just use our normal calculation, right? We have 5 volt. And what is our resistance that we use? 300 what? 330. If I just run this on my computer right here, let me just say 5 divided by 330. It's almost, the current that we receive is almost 0.016 amperes, which is almost how much? If you just put this to light again, how much? Almost 16 milliamps, milliamperes. Can you see it? 16 milliamperes. If the number goes too low, what happens? We receive an excess amount of current. Basically what? It's going to fry our LED, if not even our Arduino. Might even fry our Arduino because of how big of a number it is. Okay? How big of current we're receiving. So, just to make sure again, we're going to need what? A resistor that is not variable, that doesn't change. We need what? A normal resistor. Alright? So in this case, I'm just going to put what? A normal resistance as a backup. Alright, so let me just unplug this and connect my, just bring this here. Let me connect the other leg of the photoresistor right here towards the other leg of the resistor, my normal resistor. All right, there we go. They're connected. Okay, once I'm done connecting them, what do I need? I need my LED again. Always check for the positive side, the longer one, the longer side of it. I found it. I'm just gonna put it here. All right, and I'm gonna need my what? My GND pin. Let me just use my what? My GND to the other side of the LED. Let me just use my GND right here. All right, now it's ready. Now let me just turn it on. Let's do that. Turn it on right here. Okay. Everything seems to be working fine. Everything seems to be working fine right now. It does. Again, we're not going to be coding anything on the Arduino because we're just going to be using what? The 5 volt. So now I want to change what the value of this photoresistor, the value of the resistance. Again, right now I'm using what? 2 bright lights right here. I have one light right here on the left. I have one right to the right. So it's very bright right now. So clearly the resistance value, again, what happens? Let me just bring my here. If the light goes up, the resistance value goes down. So in this case, the resistance goes down. Let's say theoretically it goes down to very, very small number. Let's even say to almost 0. Okay, let's just say 0. So what basically happens here is what? We're going to have our 220 ohm resistor. It's going to be obviously regulating what comes from the photoresistor, because in this case we're using what? We're going to have a very, very small number. Almost close to what? Almost close to 0. Okay, so light is up right here. So the resistance value is down. That's why lots of current is flowing. So what? So our LED is what? Our LED is what? Our LED is brighter. Okay, so let me just try to decrease the light and see the resistance value come up. Basically what? Basically dimming our LED. So let's just do that. So let me just go here, turned off one light, turned off both lights. It's getting dimmer. Let me just go and even turned off the curtains. Let me just fully turn them off. Now we are in a very dark environment, except for the LED that's lighting up right here. The Arduino's built-in LED. Let me just block it for now. Okay, by my hand. You can see how dim it just got. You can barely see the red light right here. The red light right here. I just dimmed it out. Okay. You can see that it's what? It's very, very dim. Let me just turn on the light right now. Both lights. Alright, here we go. You can just see that what? It was dim like a few seconds ago, and now it's bright. Okay, so this is one thing you need to keep in mind when working with what? With photoresistors. One thing we always keep in mind is what? Photoresistors are not always reliant. They're not what? They're not always reliant. Because why? Because again, the resistance value always changes by light. Okay, so where do you think can we use these photoresistors? One of the applications of photoresistors would be what? Especially when we're using street lamps. Basically, they're going to be what? There are going to be times where, again, street lights, again, will turn on and off automatically. Again, no manual configuration. You don't need to turn it on or off. It's going to what? It's going to detect the amount of light that is coming out from the sun. And if it's very, very little, what's going to happen? Again, the resistance value is going to be very high. It's going to record it. And then afterwards, it's going to what? Turn it on. It's going to basically what? It's going to turn it on automatically. So we can use photoresistors for what? For self-turning on and off lights. Okay. So we're going to use them for what? For smart lights. Okay. So we worked with the photoresistor right here. Let's work with a bit on the thermistors that we just mentioned earlier. Okay. Let me just unplug all of this. Take this off. All of it. There we go. There we go. Okay. Just did that. And now let's bring my, right here, my valuable thermistor. And let's try to do the same thing. So again, let's connect it almost to the same circuit. Okay? Let's try to do that. Alright, I have my 5 volt right here. Connected here. Then I've got my thermistor. Again, I can put which leg I want to because nobody's going to force me. Again, because it's not what? It's not important which leg you put it in. Let me just go back here, get this straight. Actually, put it here. Just put it here. Let me get it closer. I'm going to tell you why in a minute. I'm just going to put it closer to the Arduino because I'm going to need this piece right here. Okay, then afterwards, what I want to do is use my normal, again, my normal handy. Again, normal resistor. Why is that so? Because again, the temperature value is going to decide if the resistance goes low or high. Okay, so it's going to be very, very important for me to use what? To use this so that I don't fry my LED. Okay, I did that. Now what I'm going to do is what? Connect it to this edge right here. Let me just get this straight. The Arduino, the normal resistor, okay, is acting. Alright, there we go. Need to connect it like this. I can just unplug my Arduino right here. There we go. Get it closer so you can have a better look of it. And then I have my GND. There we go. Connect the GND to the GND pin. Let me just do that. Alright. Now, what do I need to do? Plug in my Arduino. And you can see it's lighting up a bit. Can you see it? So basically, temperature here is what? We cannot know yet. First thing now we have to do is let me just bring another paper right here and try to explain what is going on. Okay? So let me try to explain what is going on right here. Let me just get this out of the way for now. To the edge. Put my photoresistor right here. Alright. Let's bring my Sharpie right here and try to explain what's going on. So When it comes to thermistor, as we said earlier, what did I say? I said that it's relevant to what? It's going to depend on temperature. Okay, so there's something called NTC and PTC. Okay, so when it came to photoresistors, what did we say? We said directly, if the light is what? If the light goes up, the resistance value goes down. Okay, if the light goes down, the resistance value goes up of the photoresistor. That's what we said for photoresistors. It was what? It was quite direct and straightforward. But when it comes towards thermistors, there's something called NTCs and PTCs. N stands for negative. Okay, N stands for negative. T stands for temperature. Okay, C stands for what? C stands for control coefficients. Right here, coefficient. Okay, again, the P stands for positive. This makes sense right now. Positive temperature. This stands for, again, coefficient. Coefficient. Let me just get that. Okay. So what does this mean? So when it comes to NTCs, right, one thing to keep in mind is when it comes to NTCs is that, okay, when it comes to NTCs and PTCs is what? They're both affected by temperature. Okay. But the difference here is that when it comes to PTCs, what happens is resistance value, it increases by what? By increasing temperature. Okay. So the resistance value increases by what? By the amount of the temperature right here. When it comes to PTC, to the NTCs, it is what? It's opposite. So the resistance value, what? Increases per decreasing temperature. So as soon as temperature starts to decrease, the resistance value, what? Starts to what? Increase. Again, this is what? Due to the material they're made from. They're made from different materials. So again, in this case, the resistance goes up while temperature goes up. In this case, the resistance goes up while temperature goes down. Again, we can put this again. We can put the inverse of this. So the resistance goes what? Down when the temperature goes up. We can say for this one too, the resistance what? Goes down when the temperature what? When the temperature goes down. Okay. So in this case, what? The resistance and temperature have what? Somewhat of a what? They're directly proportional. Basically, they have a what? A straightforward relationship. While in NTCs, what do? They have an opposite. They have an opposite what? They have an opposite relationship. We can say R is what? Indirectly proportional to what? To 1 over T. We can say R is directly proportional to T for what? Her positive what? Temperature coefficient. So that it depends on what? It depends on the thermistor we have here. It can be NTC or it can be PTC. Okay? So, while keeping that in mind, right, one thing I wanted to do here was, you know what, I want to check if the temperature goes high or low. But the problem being here is I have to use something that has big source of heat. And I don't want to get this, what, close to my Arduino because it can ruin my Arduino. I don't want that to happen. That's why I'm just going to be using the light. So I'm going to be using light. I'm going to be using a normal lamp here, and this lamp heats up, especially in the back. It's heated up right now. Oof, that's a lot. It holds a lot of heat here. There's a lot of heat here. There's a lot of heat here, and I want to do is just get it close here so we can see if this one changes or not, if the LED changes or not. Okay, let me just turn off my light. This light, I'm going to need one light only. Let me just remove this for now because we don't need it. And now, I'm just trying to turn again with the light on. What I want to do is again get this so close to the what? The thermistor so that maybe we can see a difference in the what and the LED. Do you see a difference? I can't. Let me just do that. Keep trying to, but I don't see any difference. Barely even see any difference. There might be a difference, but it's going to be very little that we cannot see it in our eyes, both of us. So one thing I want you to keep in mind right now is, okay, one thing I want you to keep in mind, let me turn on my lights right now. For now, just turn this on right here and this one on. One thing I want you to keep in mind is this thermistor does not change very easily. Why is that so? This one specifically, again, check your label. Specifically, this one has 10,000 ohms. So what? It has 10,000 ohms. The resistance is big. So it's going to change for what? For bigger temperature. Okay? So I just want you to keep this in mind. Again, one thing I want you to keep in mind is not about I want you to keep in mind is, all right, right here, this has 10,000 ohm resistor. Just like how the potentiometer has a total combined of 10,000 ohms. Again, it has 10,000 ohms, 10,000 ohms of resistance. This one has a 10,000 ohm of resistance too. Again, I checked the what? I checked the label. The label has it written out because it just says 10,000 ohm next to it. Okay, on the label. Okay, on the paper that I just had my what? My Arduino kit. Just basically says it here, 10,000 ohm. It's gonna go to components right here, and all I need to do is go to components and be like, oh, there we go. They have a thermistor right here. It has what? 10,000 ohm. I have two pieces of what? 10,000 ohm thermistors. Okay, so this is what? 10,000 ohms, which is a very, very big number. So what? So we cannot change the what? We have to change the temperature by very big numbers. I'm talking by very big numbers for us to see a change in what? In the resistance. Because, again, why? Because I said again, either they're related directly or they're related to what? Indirectly. Okay. So one thing to always keep in mind is what? One thing to always keep in mind is what? The resistance is either directly related or indirectly related to temperature. So right here, 10,000 ohms is a very, very big number. So we're going to have to change it by a very, very big number, by very, very big temperature for us to see a difference in what? In the resistance. Basically, we're going to have more current so we can see the light here. So we can see the LED here. Just keep that in mind. That's why I'm going to need to maybe use, if I can, match and sticks or something that is so hot so that, again, this can change in value. But I just don't suggest that you guys do that. If you want to do it, I highly suggest that you guys use a digital, again, those digital Arduinos or simulators, again, because you don't want to get hot stuff near to your, again, electricity. This is not what recommended specifically, especially for kids. So don't do that. As far as you can, don't do that. All right. But one thing you need to keep in mind is what? Thermistors always change in what? They always change according to what? Temperature. Just keep that in mind. All right. This was a bit of a long one. So, see you in the next section, actually. So, see you then. All right. So now let's discuss about temperature sensors. So far we've not discussed about any sort of sensors in this Arduino course. So this is going to be our first sensor that we're actually going to talk about. So let me just bring this closer so you can again see it. So this is a temperature sensor, specifically called the LM35. And you might have a different type of sensor depending on, again, your Arduino kit, the Arduino kit that you have. But first, we're going to see how you're going to know what type of sensor you have. So obviously, the first and the best method to know what type of sensor you have is always, again, reading the manual. Okay, so I'm just going to bring my manual right here, the manual that I got my kit from, and what I'm going to do is search for the components right here. And when you read right here, it says one piece of what? LM35 temperature sensor. Okay, so again, depending on the kit you have, you might have a different type of temperature sensor, but most of them, we're going to check two sensors, so we're going to check most of them. Okay, so even then too, I'm going to show you guys how to actually see what type of sensor you have and adjust accordingly to the sensor you have. Okay, so first things first, what I'm going to do is try to explain what these sensors are. Okay, so let me go right here. The LM right now, specifically what I have is what? the LM sensors, the LM35, okay? The LM35 temperature sensors. But there's also one other common sensor, which is called the DTH. There's like a DTH series, the DTH 11, for example. There's something called the DTH 22, and these are one of the most popular sensor right here. So is this one, but I think this is far more popular. Okay, so we're going to check how the DTH sensors and these LM sensors work. Okay, so if you don't have those type of sensors, I highly suggest that you guys watch a video of the sensor you have first, know the sensor you have, and then check a video, write the sensor's name, and then check the video of, check a YouTube video on it. Okay, that's what I suggest before starting this temperature sensor section. Okay, so now what I'm gonna do is bring the sensor. Okay, let me work with the LM35 right now. And the LM35, one thing you notice is what? You notice it has 3 legs, okay? So you're gonna put it where the text is. There's a, just put this right here. You can see a dot, a black dot right here. Not only that too, but it's rounded. But we're gonna go to the flat side, okay? The flat side of it, where there is a text. We're gonna connect it that way. So the most left leg is gonna be connected to the 5 volt. The middle leg is going to be connected to the analog read volt, okay, some analog volt again. And the right, the very right of this is going to be connected to the GND, okay? So let me just do that. I'm just going to put it right here. Just do that. Try to put it together. Let me just widen this a bit. I need to make this a bit wider. It's not going to fit in across. I wanted to fit it across, so let me just make the legs a bit wider. Let me just bend them so that they fit. Okay, there we go. Thinking how they fit better. Okay, and come on. All right, not the most even one, but at least they fit. Okay, so what I'm gonna do is connect again the 5 volt to the most left leg on the flat side again. Let me just do that. The most left leg is going to be connected to what? It's going to be connected to the right here. Going to be connected to the 5 volt. Okay. Let me just do that right here. Connect the 5 volt. And the middle one, I'm going to be connecting it to what? To one analog pin that I have my choice again. Let me just do that. Find an analog pin. I'm going to be using analog pin maybe 1 today. Or maybe analog pin 2 actually. Let me just use analog pin 2. It's just far a bit closer. I just don't want to stretch the wires. Okay. And then afterwards, what do I want to do? I want to use my GND pin. Let me just do that. Let me just go to my GND right here. Connect that to my GND. The ground. Let me just check if everything's intact. Okay, the GND is right here. Yeah, this is correct. Okay, once I'm done doing that, what I'm going to do is write down the code. So let me go over to my screen right now, and let's write a bit of code, okay? Okay, so let me open my Arduino IDE. Let's write. Open one of this, and let's set up our code. So first things first, we need to set up what our read pin, okay? Read pin is what today? Today's analog pin 2. Not only that too, now what I'm going to do is set it up right here, pin mode, set it up as read pin, and then as what? As an input, okay? Because we're going to be what? Reading from it, okay? Reading. The T's not right. Let me just get that, and afterwards, what do I need to do? Start the serial monitor, because this is where we're going to see what? We're going to see the temperature. Serial.begin. Again, with what baud rate? 9,600 baud rate. There you go. Afterwards, I'm just going to do serial print ln. I'm going to what? I'm going to print a new line right here of what? Maybe the read value. First things first, I need to do what? I need to read. I need to analog read it. So analog read. Right. So obviously this is not making sense. I'm just trying to read the value. But what we're gonna do is first is change the red value to voltage first, and then we're gonna go to check the math and how to change it to Celsius. All right. So let me go to analog read. In this case, it's gonna be analog read with the read pin. This is gonna be what? This is gonna be the red value. It's gonna be the value they're gonna be reading. Just set it like this. All right. And afterwards, what? Then afterwards, we want to say calculated value. Calculated value is what? The read value. You gotta divide it by what? 1023. If I'm correct. Actually, we're gonna multiply it by what? Just do a 5 point right here. Again, you know why I put the point. You can also put 0 right here because it's gonna be a float. I don't want it to round up or down after it's done calculating it, because then it's gonna be a 0. Okay. 5.0 or 1023. I can add a 0 right here or not. It's up to you. Okay. Then once I'm done with this, what I'm going to need to do is go right here. Okay. There's the calculated value. Okay. So to change it to degrees Celsius first, what I'm going to need to do is go to my browser right here. And what I'm going to need you to do is, those people who have an LM35, by the way, are the only ones that are going to be following me in this section. If you have DHT sensors, I'm gonna come back to them and actually show you in the next section. Okay, so for those who only have LM35, we're gonna proceed. If you don't have a DHT or have another type of sensor, again, watch another YouTube video. There are lots of YouTube videos. Again, of any sensor that you really need, you're gonna find lots and lots of resources. But if you're using a DHT, hang on, skip to the next section, and I'm gonna show you how it's done. Okay. So when it comes to the LM35 temperature sensor, we're going to go to its data sheet, all right? I want you to search this for LM and the corresponding number. Right now I have 35, temperature, sensor, and go to data sheet, all right? Let me just do that. And you're going to find some sort of PDF around precision centigrade information and support. I'm just going to go here. Oh, actually the PDF is right here. It says 39 pages here. So let me go here to the PDF. All right. And there's on this PDF right now, the documentation of the LM35. You're going to see is the description and the features it has. It's going to measure to what? It can measure, look at it. Rated for full from negative 55 degrees Celsius to 150 degrees Celsius. This is the temperature range, all right? The range of temperature is from negative 55 to 150 degrees Celsius. So it can go a lot, okay? Again, this is going to be different for the type of LM that you have. I have an LM35. Okay, so once you're done with that, reading this, and by the way, there are lots. I'm talking 69 pages of documentation, but we're not going to get into any of these because they're advanced, all right? And we don't need them in this case. But again, any information that you're going to need, you can find it here in the documentation, in the official documentation of the temperature sensor. Okay, so one thing that you should focus here is right here. You should focus at this one. I have it highlighted. There we go. This one. It says linear plus 10 millivolt per degree Celsius scale factor. So what does it mean? It's saying that the scale factor basically is it's gonna output 10 millivolt per every degree Celsius. All right. So for every degree Celsius that it monitors, again, it's going to sense. It's going to output for analog pin in the middle, the blue pin, the blue wire. It's going to be outputting 10 millivolts. Okay, so it's going to be outputting 10 millivolts. Okay, so right here, let me just bring my paper right here. Paper, and let me bring the Sharpie, and let's try to understand what that means. Let me just put this out of here for now. Okay, so let me just draw a line right here, and let's focus on this line, on this space. Okay, so what does this basically mean? 10 millivolt per degree Celsius. Let me just write this down. It means 10 millivolt per degree Celsius is the scale factor. Okay, I want you to focus at this. What do we want to get? We want to output what? We want to print the temperature. We want to print the temperature. So what does this mean? 10 millivolt means what? Milli stands for 10 to the power of minus 3. So it means 10 times 10 to the power of minus 3 volt per degree Celsius is the scale factor, which means if you multiply this, this becomes 0.01 volt per degree Celsius is what? The scale factor. All right. So what is scale factor? Right here, let me just bring another paper. Okay. Let me just do that. I'm running out of paper right here. Just bring another one. So what does the 0.01 volt per degree Celsius mean? Okay. You said this is what? The scale factor. Again, scale factor is what? Voltage over temperature. You can see their units. What is the unit of volt? Voltage. So what does this mean? Volt over, what's the unit of degree Celsius? Degree Celsius is the unit of what? It's the unit of temperature. Okay. And this means V over T is what? The scale factor. It means voltage over temperature. We're trying to find what? Temperature. Again, keep that in mind. Okay, so temperature is basically what? The scale factor. So let's do a crisscross. Temperature times the scale factor, in this case, is going to be what? The voltage. All right, so we're going to divide both sides by the scale factor. Okay, then temperature is going to be V over SF. Again, what is SF? SF is what? 0.01 volt per degree Celsius. The value is what? Without the unit again, if we just do the unit, it's 0.01. Okay, that's one thing I want you to keep in mind. These two. Temperature is what? Volt over scale factor. And scale factor is what? The value of scale factor is what? 0.01 volt per degree Celsius. Why did we need to change from millivolt to volt? Because, as I said again, let me go over again to my screen. Because our calc value is going to output in what? Our calc value is going to output in volt, not in millivolt. That's why I have to change the standard from millivolt to volt, all right? Because our calc value is going to output in what? In voltage, in V. Okay, so what are we going to do right here? So we're going to need to set up what? We're going to need to set up the scale factor. So what I'm going to say is here, int scale factor. Actually, not int, it's a float. I'm just going to say scale. Let me make this very short. Scale F. It's going to be what? It's going to be set to 0.01. All right. And then I'm going to need what? Temperature. I'm going to say temperature. I'm not going to set it up yet. Then we already have calc value. I do not set up calc value and read value right here. As you can see in my code, I have to set it up right here. I didn't do that. So it's always what? Recommended to set variables first and then what? And then assign them. You can do the opposite way. Again, sometimes you might forget about what? You might forget about setting it up. So I already set up float and temp. So let me just go right here and set up read value. So I'm going to say float, read value. Do I really need to say float or int in this case? Read value is going to give me what? A number between 0 and 1023. It's not going to give me what? A float number. So obviously in this case, I can say float or I can say int. It doesn't really matter, but I can say int right here. It's again makes sense for me to say int. Okay, so you can say int or float, but I'm going to again say float because I'm going to be multiplying this and working with this. So it's suggested that you say float because you don't have to think about it. When you say float, you have to think about it. Let's say in this case, read value outputs 1023. Okay. If it's an integer, it's going to output it as 1023. Okay. If it's a float, it's going to output it as what? It's going to output it as 1023.0, which is exactly the same thing. If it is a float, it's going to output it like that, which is exactly the same thing. So when you say float, you don't have to think about most things. You don't have to think about them. Okay. So you can just say float and just not think about, about it being integer or not. You can just use float for almost everything. Okay. So after using that, what I'm going to need to do is, after I'm done with my read value, okay, I'm going to need float calc value. Now I need the float value because I'm going to be multiplying and dividing. All right, float calc value. Let me just set that up. Okay, once I'm done setting that up, temperature is what? As we said again, temperature is what? Temperature is what? Temperature, let me just go here and point here, voltage over what? Scale factor. So our voltage is what? The value that we're going to be receiving right here over the scale factor. It's going to be S scale underscore F. Okay, so let's print the temperature right here. let's print the temperature. Let's just do that. Let me just first check even if our code is right. It's saying that I'm not put a semicolon. I have to put a semicolon after every what? After every line code. Let me just do that. And okay, it's done compiling. And first thing I need to do is what? Connect my Arduino. I did not do that. Okay. Let me just do that. Let me just bring that right here and connect my Arduino. Just forgot to do that. Okay, now I can upload hopefully. Let me just check if it's connected. It should be showing me my port. Okay, let me just select the port and let's upload it. It's uploading and it's done uploading. Okay, we're receiving numbers very, very fast. So one thing I'm going to do right here is give it a delay. Forgot to give it a delay because it's going very, very fast. I can't even read it. Let me go delay and let's set it for 100 milliseconds. 100 milliseconds will do. Actually, you know what? Let's do 250 because it's going to be really fast. I don't want it to just go really, really fast. I'll just open my serial monitor right here. It's going to open it itself. Okay, let it clear out. Let me just clear this out. Let me just say clear output, and then it should be giving me an output, which is 28. So it's saying that I have what? 28.35 degrees Celsius. By the way, for this, if you are thinking, you know what? Why are we getting 28.35? How am I supposed to change this to Fahrenheit or everything? Why is it specifically in degrees Celsius? Why is that so? Again, let me go to the documentation. It says what? From negative 55 degrees Celsius to 150 degrees Celsius. And the most important part, what? It's saying 10 millivolt per degree Celsius, right? It's saying 10 millivolt per degree Celsius, what? Scale factor. So basically what we're using the unit Celsius. That's why I'm exactly sure that it's using what? Degrees Celsius, all right? So if you want to change it to degree Fahrenheit, all you need to do, by the way, let this be homework for you. So what I want you to do is pause this course right now, pause it right now. And all I wanted you to do is change the degree Celsius to Fahrenheit. We already gave you the degree Celsius right here, which is going to be temp, TMP, temp. I want you to do what? I want you to convert it to Fahrenheit, okay? So pause the video and do it right now. And I'm just going to do it right now. So pause the video. All right, so I think you have done it because I think it's simple. But if you have not done it, what you need to do is first find the formula. What is the formula of what? Temperature, Celsius to Fahrenheit. Fahrenheit formula. Just find that formula right here. All right, there we go. Temperature, degrees Fahrenheit is what? Temperature in degrees Celsius times 9/5. Let me just go over and first what? Assign a variable for Fahrenheit. All right, let me just do that. Let's go right here and let's say, you know what? Float what? Float temperature, and let me just put capital F just to say it's Fahrenheit. Okay, so let me go right here and say temp F is basically what? What did it just say? Let me just go back to my Chrome and try to read the formula right here. It's what? Temperature in degrees Celsius times 9/5. Okay, that's simple. Temperature in degrees Celsius is given by temp right here. Then we're going to multiply by what? By 9. Again, we need to put what? Because we're dividing, what do we need to do? We always need to use a point. 9.0 or again, 9 point. Again, it's up to you. 9 point and put a dot at the very end. Dot. There we go. What else do we need to do? Let me just check that out. And then we're going to add it up by what? By 32. Okay? We need to add it up by 32. Okay, I'm going to add it up by 32. So one thing that is confusing a bit for me is, am I supposed to multiply both of them by 32? I'm sorry, am I supposed to multiply the whole thing by 9/5? Or am I supposed to just multiply temperature by 9/5 and then add 32? So to just check that, let me just go right here actually. Should be giving it to me on actually wait, let me just go to something that was written by hand. So let me go to images. All right, there we go. Now I can clearly see the temperature has to be multiplied by 9/5, not the whole thing. You see that? It's not the whole thing that's going to be multiplied by what? By 9/5. Only the Celsius will be multiplied by what? By 9/5. All right, I just wanted to get that on my mind right there, off my mind. So what I wanted to do right here is serial, again, print it. New line, temperature F. Okay, seems good. Now let's try to upload it. Oh, I forgot to do what? Put a semicolon at the very end. I should have done that. All right, let's just upload it right now. Should be working. It's done compiling. And I think this should be uploading. All right, there we go. Let's go back to our serial monitor right here. Let me just extend it. Ooh, we're receiving lots of values, but obviously it's getting a bit confusing here. We do not know which one is the degree Celsius, and we do not know which one is what. Which one is the degree Fahrenheit. So what we're going to do right here is, you know what? For degree Celsius, let me find degree Celsius right here. It's just temp, degree Celsius. What I want to do is, before this, what I want to do is basically serial dot print, okay, next to it, a string, Celsius. Literally, Celsius. Basically what? Celsius. Let me just say Celsius, C as in indicating Celsius, and I'm going to need a space. Okay, let's say C for Celsius, and I need to do is what? Serial dot print. For what? For Fahrenheit. One thing that is important here to notice is what? It's not print ln, it's print. So basically what happens when you print, by the way? What happens when you print something in the serial monitor? What happens? Let me just go over to here, my screen. Let's say I'm printing 25. Right? 25 is, let's say, the degree Celsius. Let's not focus on the value of the serial monitor. Let's focus here on the writing. Okay? So 25. Let's just say that. What's going to happen here? Well, basically going to happen is what? First, C is going to be printed out. Okay? C. And then what? It's going to be print. What is going to be printed next to it? Temperature is going to be printed next to it. Basically, let's say it's 25 right here. It's going to be printed next to it. That's what I expect. Again, so I'm going to expect this, and what do I expect next? So let's see actually if my code is even correct, because I've never used this before. So let's see even if it's correct. I keep forgetting those semicolons at the very end. It's my bad. I'm just rushing it a bit because I have to go back to the DHT sensors. All right, comfort. All right, there we go. You see that? We're receiving C is 27, Fahrenheit is 83. We're receiving that at a very, very fast speed. You guys can see it fluctuates a bit, but much of the rest is the same. So let's say right now I'm just going to read one of it. Let me just take off this toggle, okay, the automatic toggle. Let me try to read this one. It's saying what? 27.37 degrees Celsius, which is basically what? 81.27 degree what? Fahrenheit. So again, I have another homework for you, and this is again predictable, but I have a simple homework for you, which is going to be that I want you to convert it to what? To degree Kelvin. And I want you to output what? Fahrenheit, Celsius, Kelvin. I want you to output Fahrenheit, Celsius, Kelvin. So pause the video and do that. Okay. So I suppose that you did it yourself, but if you've not, and you want to be, you want to make sure that you did it right, let me just go right here. Well, basically, temperature Fahrenheit is basically temp K. Let me just write that down. What basically temperature Kelvin is just adding 273 at temperature Celsius. That's all you need to do. So let me just define it right here. Temp K is going to be what? It's literally adding 273. It's going to be like temp plus 273. That's all you need to do. All right. That's all you need to do. So all you need to do right here is, again, we want to print it. So we're going to say serial dot print, not ln, only print. And we're going to say K, again, put a colon right here. Finish it with a semicolon and say serial dot print ln, new line. And then we're going to print what? Temp K, capital K. Let me just finish this with a semicolon right there. Okay, and let's upload it. Okay, it's saying there's an upload error. I don't know why. Let me just check it again. Can't open device. Let me just try to run it again. Let me just compile it. Okay, the compiling, there's no problem in compiling. So let me try to upload it. So there's most likely a problem in uploading. Hopefully it's not going to happen again. Okay, it's still uploading. All right. All right, there we go. Let me just clear this up. And it should be running. There we go. You can see C is what? F and then a K. We see a C and an F and a K. A C and an F and a K. A C and an F and a K. That looks beautiful. Let me just go to the bottom again. I just wanted to toggle to the bottom and F itself. But you can see it. We have what? C, F, and K coming simultaneously. All right. So that's all you need to do when it comes towards temperature sensor. I wish that I could bring something colder and hotter right here so we can see the temperature move around. But mostly when it comes to temperature, it doesn't change a lot, okay? And again, I don't want to bring something that's very hot or very cold near my Arduino. That's why. But again, you can check it for yourself using a digital simulator. Try to use a digital simulator, and again, try to toggle around, mess around with these temperature sensors. It's up to you, okay? You can do that, or use, again, be careful when you're doing whatever you're doing. So if you're using something hot or cold, be careful when you're putting it close to the sensor, okay? Be close, especially with the wires, okay? Because they can really just block your view right here. So you need to be close. Again, you need to be what? You need to be cautious of what you're doing. So if you're even thinking of bringing something cold or hot to just, again, check the temperature sensor, be careful about it. Okay, so that's about it for the LM35 sensor. And for those of you who have, again, DHT, we're actually going to see the DHT sensor. So you guys, I might as well skip the DHT sensor because I don't think you're going to be using it if you have an LM35. Okay, so for those of you, again, who watched this section, are going to be using the LM series, the LM35, the LM36, and all these series. Okay, the ones that use the LM. Obviously, what I want you to do is what? I want you to skip the next section because I'm going to be talking about DHT sensors. Okay, so keep that in mind. So see you in the very next section. Okay, so now let's talk about the DHT sensors. Okay, so one thing I want you guys to keep in mind when it comes to these temperature sensors is there's a lot of them. There's the DHT, there's the LM35, there are even different types of, again, sensors that are, again, unknown. Okay, so one thing I want you guys to think about is what? I want you to think of them as Samsung and iPhone. So when you look at them, both of them are phones. They have a lot in common, but they also have their differences. So obviously they look different, again. They have different features, but they do what? Basically the same thing. So they make us, you know, we can use it to what? To call, for example. We can take photos with it. We can use apps with it. Okay, so one thing I want you guys to keep in mind when it comes to temperature sensors is there's a lot of them with different numbers, but they have what? But they are mostly the same, all right? So they have, again, difference in features and, again, difference in, again, how they look and all, and how they're hooked up, again, and how they work. But they're what? They're essentially, nevertheless, they're what? They're the same, more or less the same, okay? So let's work about the DHT sensors. So you're going to be searching up, again, your sensors, again, the equivalent sensor you have, and check for the what? For the connection, okay? Right here, I'm just going to demonstrate using a DHT sensor. So I'm going to go to DHT sensor connection, okay? As what? One of the most popular pins. So right here, as you can see, let me just zoom out so you can see the whole thing. Zoom out, there we go. And as you can see right here, is the most left side is connected to a digital pin right here. So you can use any digital pins right here, okay? And then the middle side is connected to 5 volt, and then the very right side is connected to GND. So one thing I want you guys to keep in mind is what? This thing is going to be using digital read, okay? So it's going to be using digital pins. We're going to be using digital pins, not analog pins for this one, okay? For reading, I think most of you, again, we've been using so far what? We've been using analog pins to read, okay? From the what? From the sensors. But in this case, we're going to be using digital pins. And I'm going to explain in a bit why. Okay. So right here, again, to make, again, our lives way easier, we're going to be using a DHT sensor library, okay? So you're going to be using a DHT sensor library that is by what? By Adafruit, okay? So all we need to do right here to add it is go to our Arduino, go right here, and go to our, again, let me go all right here, and then search for DHT sensor, and try to install the one by Adafruit. There's a lot of DHT sensor libraries, so let me search for DHT and search for Adafruit. There we go. DHT Sensor Library by Adafruit. All I need to do is install it right here from the library manager. And it says that there has a dependency right here, okay? So it needs what? It needs this Adafruit Unified Sensor library to be installed. So if it does not, if you don't install this, the code is not going to work. So let me install it all. There we go. It's both going to install the DHT Sensor library and the Adafruit. There we go. Adafruit Unified. There we go. Unified Sensor installed both of them. Okay. So right here, that's what we can do. But another option is, again, to go to our DHT Sensor library. Again, Google it again by Adafruit, and then you're going to find the first link. All you need to do is Google it. There we go, DHT Sensor library, and search the Arduino link. And then all you need to do is download the version, again, that you want. So if you don't want the newest version, you can download the legacy version. Anyways, once you're done downloading that, all you need to do is add it to go to Arduino, and then go to sketches and go to include library and add it as a zip library. Okay, so with that in mind, we're going to be using Adafruit. So once we're done doing that, we go to sketches again, and we go to include library, and then we go to Adafruit again, DHT Sensor library. We're going to be using the DHT Sensor library. So I'm going to touch that. That's going to include the code for us. So it's going to basically include it in of itself. So we don't even have to write it down ourselves. Okay. So again, for those of you who want to read the documentation, it's available on the Arduino. So again, I highly recommend that you guys read the documentation after this video, so you can use it for more things that actually it's capable of. So I'm just going to be explaining just basic stuff. Okay. So with that in mind, now what we need to do is actually use this, set up this library and try to use it. Okay. So right here, you're going to be using define, hashtag define, and then type. Okay, DHT, what? DHT right here, DHT 11. So you're going to be writing down type and then writing down the DHT, specific DHT model that you have. So just like how we have Samsung S20, S21, when it comes to iPhone, they have iPhone 11, iPhone 12, and all of that. We're going to be writing down the specific model of the DHT pin we have right here. Okay. So once I'm done doing that, I'm going to be defining what pin we're going to be using for sensing it. All right. So right here, let me look to my connection. Let me just search for the connection right here. And it's digital pin 2 that we're using right here. So let me write down digital pin 2. So it's going to be equals to what? 2 basically. And then we write down DHT, HT, and then we're going to basically we're going to give it the sense pin. Okay. Sense pin. And then it's going to be giving it the type of pin that we're going to be using. Okay, so we're telling our DHT library what? We're telling it what type of pin we're using. And then what? We're telling it the sense pin right here is going to be digital pin 2 that we're going to be using it. And then the type of what? The type of DHT sensor that we have. Okay, so once we're done doing that, one thing the DHT sensor is capable of is it can also sense humidity. So we're going to actually use humidity too. So we're going to be setting up humidity right here. I'm going to be setting them as, again, float, because they come out in decimals. So when you hear again in degrees Celsius, we say 29.6 degrees Celsius and everything. So it's going to be again in float. Okay, so set it up in float, and then we're going to write down everything. We're going to be writing them down with with the temperature in Fahrenheit and Kelvin. We're going to be writing them down in 3 forms. All right. Okay. So that's it. Humidity, temperature Celsius, Fahrenheit, and Kelvin. Once we're done doing that, we're going to need to set up our serial monitor, because that's where we're going to be reading our degrees. Okay, so we're going to be reading using our serial monitor. So 9600 as usual. Set it up, and then we're going to begin. So we're going to be telling what? We're going to be telling our DHT sensor library to begin. Okay, then once we're done doing that, we're going to our loop code right here. Okay, and then we're going to set up again the values that we set right here. So we're going to be again assigning them the ones that we just set here. So I'm going to go to humidity and set it to, we're going to say HT that we already began right here. Okay, that we began right here. We're going to be say HT dot read humidity. Okay, read humidity. And we're going to go for temperature Celsius, and we're going to say HT dot what? Read temperature. Okay, read temperature. You can predict this, it says read humidity, and now it's obviously going to be read temperature. Okay, that's what we're going to be basically doing. When it comes to the temperature Fahrenheit and Kelvin, what do? We convert temperature Celsius to what? To Fahrenheit. How do we do that? Obviously, we use the formula. So let me search for a formula right here, Celsius to Fahrenheit formula. There we go. Celsius to Fahrenheit formula is what? Fahrenheit is what? Degrees Celsius times 9/5 plus 32. Okay, so I go to my code right here, and then what? I go to temperature Fahrenheit and say, oh, I want to do is what? I want to use temperature Celsius. I want to multiply it by 9/5 plus added with what? 32. So right here, I did what? I did two mistakes right here, so you guys can actually see it. What is the first mistake right here? The first mistake is what? We're not using decimals. When we're dividing, what do we want to do? We want to use floats. So we need to put a what? A point or a 0.0. Okay, that's what we need to do. We did not do that. That's the first mistake that I did right here. Obviously, if I said 9/5, it's going to be what? I actually did 9/5 right here. What is the value 9/5? It's 1.8, and it's going to round it to what? To an integer right here. It's going to be rounding it to what? To an integer. So it's going to be rounding it to an integer. I don't want it to do that. I want to use it as a float. So I want it to what? I want to what? Set it to float. 9/5. There we go. What other problem do I have here? The other problem that you might not notice right now is that what? Right here, Arduino does not know what? Are we supposed to what? Are we supposed to do this first, this multiplication first, or addition first? It does not know what to do, okay? So we're running into another problem right here. Should it do the addition or the multiplication first? If it does the multiplication first, what happens? Temperature Celsius is going to be multiplied by 9/5, and then finally it's going to be added by 32. But if we do the addition first, what are we saying? We're saying, oh, 9/5, we're going to add it to what? We're going to add it to 32. And then after adding it to 32, what do? We multiply it to the temperature Celsius, okay? So right here, there's going to be some confusion. What do we want to do right here? Let me just, again, look at our code. Let me just look at our formula right here. It's better that way. Where's our formula? Let me just go back. There we go. Can you see it? We want to what? We want to multiply it first and then add it up. Okay, we want to multiply it first right here. You can even see it right here. We want to multiply it first, and then we want to add it up. How do we tell Arduino to do that? Obviously, we need to do is what? We need to put a parentheses, okay? So let me just put a parentheses right here. The parentheses, there we go. Put a parentheses, all of this. So I want Arduino to do what? I want it to do it together. I want it to divide it first, and then I want it to what? I want it to add 32 as a whole. Okay, then how do we go to temperature Kelvin? When it comes to temperature Kelvin, what do we need to do? All we need to do is add 273 from temperature Celsius. That's all we need to do when it comes to Kelvin. It's very, very easy. Okay, once we're done doing that, actually it's better to use what again? It's better to use float numbers. Again, we're using a float number here, so it's technically best to use float numbers here too, okay? Instead of using integers. Okay, then what do we need to do? That's all we need to do. That's all we need to do. So we found the temperature Celsius, Fahrenheit, and Kelvin. We extracted those information already. Okay, so right here, what we need to do is what? All we need to do is print it out. How do we print it out? We see temperature Celsius. Why are we writing the temperature Celsius? You might be asking me, why are we writing it down? Well, we're going to be receiving 3 values simultaneously. So we do not know which one's which. So it's going to act as it's going to act as if it's an indicator. Okay, so temperature Celsius, the string of temperature Celsius that's written down as temperature Celsius is going to what? It's going to tell what? It's going to be written next to what? Or what? It's going to be written to next to the temperature Celsius value right here. So we're going to know which one's which, okay? So when we read the value right here, we're going to have 3 values coming in at once. So we're going to know which one's which. Okay, so I wanted to print temperature Celsius. So I put, again, an enter right here because they're written down. I put a space right here. Why is that I put a space right here? I put a space right here because I'm using what? Serial.print, okay? What happens when you use serial.print? They're going to be written down in a what? In a one line, and it's going to be written down next to each other. Okay, so temperature Celsius is going to be here, and the value after the space is going to be what? The value is going to be displayed. But right here, one thing I want to do is what? I want to add it in a new line afterwards. Okay, I want to add it in a what? In a new line. After it's done doing that, I want it to be in a new line, and then I want it to print again Fahrenheit and then Kelvin. So let me just do that. Print and then set temperature Kelvin. That's all I need to do. It's almost copying code right now. Temperature Kelvin. Actually, wait, let me do temperature Fahrenheit first. because I set it up like that, so it'd be more fair to do it this way. And then write down temperature Fahrenheit. What do I need to do afterwards? Temperature Kelvin. And then print it a new line again. Temperature what? The Kelvin temperature. And then it's best to give it what? A delay after reading it. So you can again give it a delay and set up a delay time right here. Let me set up a delay time. Let's say integer delay time. Let me set it up right here and set it to, let's say, for us to read it, let's say 300 milliseconds. So we can read it properly and put a delay of 300 milliseconds. Okay, that's all we need to do. So right here, again, all of this code again is pre-written for us, and it's already what the library covers everything for us. So all we need to do is not even understand how even the DHT sensors work. So let me go back to that's all we need to do actually. Let me just upload this. Let's see if it compiles properly. Expected what? Expected what? What is this saying? It's saying expected parentheses before these tokens. Oh yeah, I'm not using anything here. Did I do anything wrong? It's saying that I should use maybe it's saying that I should use a semicolon at the end, but I don't think that makes sense. It's gonna even give me an error right here. Anyways, it's going through an error right now because I don't have my Arduino. But for those of you again who have your Arduino and you hooked it up and all, it's gonna be perfectly working fine. All right, so just keep that in mind. Okay, so one thing I want you guys to keep in mind is right now it's going to be working perfectly fine for you guys, for those of you who have a DHT sensor. One thing I want you guys to keep in mind is when you're using DHT sensors is, let me go to my connection right here. And one thing the DHT sensor does is it sends out signals of zeros and ones really, really fast. I'm talking 0, 1, 0, 1s. It's going to be sending out what? Bits of zeros and ones. It's going to be basically saying 0 means what? 0 means off and 1s means on. So it's going to be sending that very, very fast. It's going to be sending it in milliseconds, okay? So it's going to be sending what? A series of zeros and ones, zeros and ones, zeros and ones, zeros and ones. It's going to be sending that, okay? It's going to be sending it through the what? Through the yellow wire right here, which leads to what? Digital pin 2. So it's going to be sending what? Again, it's going to be sending zeros and ones, zeros and ones, and then our Arduino is going to be interpreting that. All right, it's going to be interpreting that. It's going to be interpreting the zeros and ones. Okay, so it's going to either output 0 and 1. So it's going to be interpreting that, and then it's going to what? It's going to again write it down and print it to our what? To our serial monitor. Okay. Obviously, we cannot see we're using zeros and ones. How do we read zeros and ones in Arduino? How do we do that? We use analog read, right? Because analog read lets us use any value from 0 to 1023. So when you're reading something, we use what? We use analog read, okay? But obviously we're using what? We're using a library. So again, it's going to be, the library is going to be the one that's going to be doing the analog read right here, okay? That's one thing I want you guys to keep in mind. So why do we use that digital pins instead of analog pins? So let me go right here, and I think let's go with something more familiar with you guys. So let me go all the way here, and let me try to explain this right here. So when it comes to, if you remember, digital write, what values did it give us? What was the outcome of digital write? It was either high, which basically meant what? It basically meant 5 volt or on, right? When it came, when the other option is what? The other option was what? The other option was, write it down properly, it was low. What did it mean? Digital write low meant what? It meant 0 volt, or basically what? Off. Basically meant off. So there's like 2 outcomes to what? To digital write. Similarly, as we have digital write, and we have digital write right here. We have digital write, and then we have analog write. We have analog write. Okay, we do have both of them. And we also have, as we have analog read too, we're familiar with analog read, we also have something called digital read. Okay, so what does digital read do? Digital read, what it basically does is, you can read the documentation for yourself, but it's gonna what? It's gonna give us what? Information right here. So digital read does is what? It tells us if it's either what? If it's either 0 or 1. It's gonna be telling us if it's either 0 or 1. What does this mean? It's gonna be telling us if it's 0, it means off, or if it's on when it's 1. Okay, so it's going to be telling us that. So it's going to be telling us if it's on or off. On or off. That's what basically digital read does. When it comes to analog read, one thing that, again, why you shouldn't be using analog pins is we have 10 bits of information that is being transferred. 10 bits is a what? It's a bigger number, it's more options, again, it's useful again, but right here it's not, because as I said again, our Arduino, there we go, our DHT sensor always sends zeros and ones, bunches of zeros and ones really fast, okay? So it's going to be either 0 or 1 that's going to be sending, but it's going to be sending it very fast, and then the Arduino is going to be interpreting that, okay? So the number of zeros and ones, again, inside of, again, the full information is going to be affecting, again, it's going to be telling us our temperature. So right here, it's going to be sending out 10 bits of information. So what happens here is, it gives us a value between 0 and 1023. It gives us lots of options. But what happens here? The limitation right here is what? Basically, what happens is what? We only want 0 and 1. We only want what? 0 and 1, because, again, as I said again, our DHT sensors are only going to be using 0 and 1. They're always going to be outputting what? 0 or 1, on or off, okay? So they're not going to be using this rest of the value right here from 1023. Anything from what? They're not going to be using anything from 2 to 1023. Okay, so it's going to be 10 bits of information always being sent out to what? To the Arduino. 10 bits of information being sent out to the Arduino. What is 0 and 10 bits? 0 and 10 bits is what? You have to write it down 10 times. It's basically what? 0, 0, 0, 0, 0, 0, 0. Written down 10 times. What is 1 in 10 bits? 1 is what? 1, 1, 1, 1, 1, 1, 1, 1. Written down 10 times. I have to write it down 10 times. I don't think I wrote it down 10 times. But the important thing is it's going to be written down in 10 bits. Okay? So when it comes to the digital read right here, we only need what? We only receive 0 or 1. So it's going to be sending it in 1 information. When we have 1 bit, what is the 1 bit of 0? It's 0 in of itself. What is the 1 bit of 1? It's 1. What's the 1 bit of 2? It doesn't exist. It can only count up to what? It can only count between 0 and 1. Okay? So that's one thing I want you guys to keep in mind. So right here, it's more efficient because it only sends out what? It sends out little bits of information. It sends out 1 bit. Compared to the what? Compared to the analog. So right here, the analog is going to be sending out 10 bits. Again, and it's going to compound, okay? So it's going to be sending out 0, 0, 0, 0, again, 1, 1, 1. So one thing I want you guys to think about when it comes to bits is like how we have conversations, okay? So 10 bits, what can it do when it comes to 10 bits? 10 bits, again, allow us to what? To access different amount of numbers, lots of numbers. Just think of me saying, hey, how are you? And just think of it as being 10-bit, okay? Hey, how are you is what? 10-bit. And think of hi, it's what? It's just think of it as 1-bit, okay? Which one is faster to say? Hi is faster to say. Why is that so? We're transferring a smaller amount of information, okay? We're transferring what? Smaller amount of information right here. So it's faster. So the problem here is what? The problem with analog read is it transfers 10-bit, okay? It transfers 10-bit. And it's going to be what? It's going to be slower when it's compared to the what? To the digital read. That's why it's preferred to what? To use digital pins when it comes to this, again, DHT sensors. I want you guys to keep that in mind. Yes, you can use analog pins, but it's going to be what? Less accurate. And then also you risk what? You also risk it being slower. But when it comes to the digital pins, we only transfer, again, 1 bit of information, so it's going to be really fast because, our DHT sensor is going to be sending out zeros and ones, and digital read is going to be very fast, again, when it comes to what? When it comes to the digital pins. So just keep that in mind. Anyways, with that in mind, everything should be working perfectly fine for you guys. For those of you who have it, it's going to work perfectly fine, and you can upload the code and you can work with it. Anyways, with that in mind, let's move on to the next section. In this section, we're going to discuss about switches. So this is going to be a very quick and a very short section, but it's going to be an important section because we're going to be discussing one of the most important parts and one of the most common components that we use in an Arduino. Not only in Arduino, but in our lives. Okay, so today we're going to be discussing about switches. Okay, so switches, they look something like this. They have a button right here that you can push. Okay, and we have 4 legs. They come in different sizes. This is a big switch, the same type of switch, and this is the same type of switch, but it's obviously smaller when you do a side-by-side comparison. Okay, so one thing we need to understand about switches is they're fundamentally very easy. They're fundamentally speaking, they're very simple. Okay, so before discussing about, all these switches and stuff, I'm going to get back to this. For doing that, I think it's best if I discuss about current right here, because it makes sense to do so. Because Switches are used to do what? Switches are used to turn on or turn off something. So turn on and turn off a circuit. All right. So let me go right here and let's just again create a simple circuit. Okay, let's do that. This is what? Almost a complete circuit. Why is that so? Why is this a complete circuit? Because the positive terminal goes and it touches what? The negative terminal. It's a complete circuit. How about if it was like this? What happens if it was like this? What happens if there is an opening between what? The circuit right here, between the circuit. What's going to happen? In this case, obviously, what's going to happen? Current is going to flow. By the way, don't connect it direct. Don't connect your obviously positive towards the negative because we have no resistor here. So we're going to fry Arduino. But again, this is just for concept. So current is going to flow. What else is going to happen? Electrons will flow too. If current is flowing, electrons are flowing. Again, currents flow from what position to what position? They flow from the positive to the negative. What about electrons? They flow from the negative to the positive. They have what? Opposite directions. They flow in opposite directions. Okay. So obviously, you know by now that electron flow is what generates current. I just want you to understand that. Just keep that in mind, okay? But what happens here? Let's say electrons are again moving from the negative terminal. Electrons are moving. They're moving. They're moving. They're moving here, they're moving, and they stop here because they cannot cross this boundary. Then what happens here? Electron cannot move the whole way. So basically, what's going to happen? There will be no current flow. So current will not flow because what happens? Because the electron cannot flow from what? From the negative terminal to the positive terminal. So basically, no current flow. Because of why? Because electron can't flow. Because electron can't flow in this circuit. Okay? So that's basically the same concept that we're going to be using in switches. So switches, when we turn them on, they make it so that we can, again, flow. Electricity can flow. Can you see it? Electricity can flow. But when we turn it off, what do we expect? We make it so that electrons cannot flow. Indirectly, will not have what? And will not have any current. Okay, so right here, let me just move this. So let me just bring the switch right here. And one thing you want to look in these switches is, again, let me just focus on the switch right now. Okay, there we go. One thing you want to focus on the switches is there are closed sites. Can you see this? There are closed sites here. There are closed sites here too. And there are ones that are what? They're connected to, even parallelly, they're connected in this direction. Okay? They're connected in this direction. So one thing I always want you to keep in mind is the ones that are facing opposite, the ones that are parallel to each other are always connected. I want you to keep this in mind. They're always connected. Either when you push it or don't, they're always connected. Okay? They're always what? They're always connected. Okay. When it comes towards these ones that are connected by what? They're on the same side. So I want you to see the pins that are attached to what? To the same side. When it comes to those pins, what happens is they are what? I'm just going to put this here. There's a wire. Okay? So there's a wire that's going to move. It's a wire that is what? That moves. Okay? So right here, when you push down, okay, when it comes to these buttons, when you push down, what happens is, I want you to again pay attention, is when you push down, what happens is these wires attach. Basically, when they attach, what happens? Current what? Flows. Okay? Basically, when you don't touch it anymore, by the way, when you just leave it like this, what's going to happen? It's going to be open. Can you see this? So electricity cannot flow from here to here. But as soon as you push it down, what's going to happen? As soon as you push it down, the wire is going to go down. You're going to push the wire down right here. Basically what? Creating what? Creating a complete circuit. In this case, current will flow. Okay, so that's all you need to know to start with these. But one thing I want you to keep in mind is this. Okay, when you look at the smaller push buttons, when you look at them, let's bring them here. When you look at them, it's really hard to distinguish. It's really hard to distinguish which side is which. Am I supposed to put it like this? Like in this way? Let me just actually focus this way better. Let me actually put it like this. It's better that way. All right, there we go. Am I supposed to put this like this? You know, how am I supposed to know which one is connected like this, which one have this type of connection, and which one has this type of connection? Because it's really hard, because they're symmetric. When you look at them, they're symmetric from both directions. They're at the very edge, and you don't know which one's which. So always what you need to look for is what? You need to look for a side that have 2 pins. Let me focus right here. You always want to look for a side that has what? A side that has 2 pins that are connected. So we're going to look at one single side here, and they're what? They're connected to the what? To the same, what? To the same side. All right. So these 2 pins are connected to what? The same side. So you want to look at these. These ones are the ones that are where the switching is going to occur. I want you to keep that in mind. These sides are what? The ones where switching occurs. When you look at these side, when you compare this one with this one, we just bring it open here. Wait, it's not focusing. My bad. Okay, there we go. When we bring this one and this one, okay, these ones, they're parallel. I want you to keep that in mind. Because why? They're opposite. They're not connected to the same side, okay? So the ones that are not connected to the same side, what happens to the ones that are not connected to the same side? The focus is really bad. Oh my, this is really bad focus. All right, what happens to the ones that have that are connected to the opposite side? Okay, I want you to look at the parallel sides. So this side is right here. There's a parallel side right here. So the ones that are connected to parallel sides are connected in this way. They're always connected. Okay, either you push up or push down, they're always connected. Okay, so so when it comes to the ones that are attached to the same side, what happens? They're connected, and the metaphor is connected in a condition. If you push the button, it's connected. If you don't push the button, it's not connected. The ones that are facing the same side. Okay, the same goes for this one too. So I want you guys to, again, to use the side metaphor instead of using the ones that are far apart. Because in this one, everything is, when you look at the small one, let's bring the small switch. When it comes to the small switch, everything is what? Everything is equally distant. Okay, it's a square side, it has a square shape, so everything is going to be what? Equivalently distant. So again, look at the side. So the ones that are connected to what? The ones that are on the same side, the pins that are on the same side have what? They're going to be the ones where switching is going to occur. The ones that are connected parallelly, in the opposite side basically, in parallel sides, are going to be what? Are going to be the ones that are always connected. Either you push up or push down, they're always connected. I think it's going to make more sense when I just bring my Arduino right here. Okay. So let me just bring this right here. Okay. And let me just unplug my Arduino for now. Let's just put this to the side so that you guys can actually reference it. Let's put this to the very edge. Okay. So let me bring my Arduino right here. How am I supposed to connect this? I'm supposed to connect the ones that have the same side again, the pins that are on the same side. Okay, the pins that are on the same side. How do I want to connect them? I want to connect them across. I don't want them to be together. If they are together, obviously what? Switching cannot occur. So I want them to be in what? Opposite what? In opposite. Obviously in opposite rows right here. I want them to be in different rows. Okay, so I'm just gonna push it in as much as I can. I'm gonna put this across too, because it makes more sense to put it across. I'm just gonna try to. All right, there we go. It needs a bit of a push. All right, there we go. Now it's plugged in. All right, so right here, let me just bring my red pin and connect it to a 5-volt. What I'm gonna do is build a simple LED circuit, but in this time, what's gonna happen? I'm gonna be using a switch to turn the LED on and off. Okay. So again, I'm going to put this on the first one, on the first leg. Did that. Now, I'm going to need a resistor. Where am I going to connect the resistor? Because I want switching to occur, I'm going to connect it to the what? To the second leg right here. Second leg's right here. We'll have to disconnect it. Just do that. Alrighty. Okay, there we go. The second leg is connected to the resistor. And then I have my, obviously, LED light. Let me just bring that. Just bring my LED light. There we go. LED light is connected right here to the to the leg of resistor right here. You can see it. And then, obviously, I'm going to need my GND. My ground pin. Let me just get it right here and connect it to the GND. Let me just make sure that I'm connected to the GND. I don't want to get it wrong. There we go, to the GND. Okay, so now what I'll have to do is what? Plug in my Arduino. Let me just do that. Alright. Seems to be working. Okay, the Arduino's on. Let me just check my resistor if it's okay. Okay, let me just push on the button right now and let's see if it's going to turn on or off. Okay, there we go. It's turning on. As you can see, it's turning on. But as soon as I let go, look what happens. I just touched it once. Let me just touch it once. As soon as I let go, it turns off. So one thing you need to understand here is these buttons that I have right now, they're called, where's my Sharpie right here? There we go. There's my Sharpie. All right. They're called push buttons. Push buttons. Okay, push switches basically. They're switches that what? They're push buttons or switches. How about the one that we use? Mostly we use is called a toggle. Toggle switch. Okay. So right here, when it comes to push buttons, the name gives you a push button. I just want you to think of it as a push door. Okay. As soon as you let go of a push door, what happens? It goes back to what? To its original position. Okay. As soon as you let go. All right. When it comes towards the doors we have at home and stuff, if you don't, again, put excess amount of force, what happens is if you just put it in the middle, it's going to stay in the middle. If you just leave it there, if you just, again, push it, and then you leave it at a position, it's going to stay there. It's not going to move in of itself. It's not going to what? Close by itself. Just like how, again, push doors do. Okay? So I want you to keep that in mind. When it comes to push buttons, you always have to push. Okay? For it to what? For it to, right here, let me bring my paper. For it to always what? For it to always connect. You always have to push to what? For it to always put down this wire right here. Okay? This connecting wire right here. So that what? It switches on. Okay, so you always have to push. When it comes to toggle switches, the ones that we have at home, what you have to do is what? You only touch it once and you turn it on. That's it. That's all you need to do. But again, touch it again and what? It's going to turn off. Those are what? Toggle switches. So right here, we're going to be using what? Push switches or push buttons here. Okay, so we have push buttons. So as soon as you let go of, again, as soon as you let go the switch or the button, what happens? It turns off. Okay, there we go. So let me just bring this here and let me try to connect it to the one that is parallel right here. Let me just try to do that. So let me bring my resistor right here. Just pull it out. You've seen that it works. The switching works when we're using what? When we're using the pins that are on the what? The legs that are on the same side. Let me just try to connect the ones that are parallel. Okay, let me just do that. Again, let me just unplug my Arduino because, again, it's better to what? To always unplug your Arduino, work on your, again, physical project, and then plug it back in. Okay, let me just do that. Let me connect my LED to the leg of the resistor. Okay, and I need to connect my what? My GND. Okay, everything seems to be good, and everything should be running by now. Let me plug it. Okay, my resistance is the one that is causing the problem. Let me just go here, push it. Okay, this leg is not pushed. Let me just push it. I have to push it really hard. Okay, I have to push it really hard. Okay, wait, let me just get my resistor. Let me fix my resistor right here. I think it's the resistor that's causing the problem. I think it is. As soon as I push it back in, it's gonna work. Let me just go over here. Push my resistor. Jesus, it keeps bending. The leg keeps bending. Wait, I need to straighten this out first. Let me just straighten it out. All right. Connect it right here. Come on. Is the resistor connected properly? Yeah, I think it is. But okay, the resistor is a bit coiled. I'm gonna have to fix this. Let me just get another resistor. Let me just do that. Okay, there we go. Makes our life way, way easier. Okay, I got another resistor right here. Let me just plug it back in. Plug it here. Plug the other one here. And there we go. I'm not touching it. I'm not pushing it. Switching is not working here. Because why? As I said again, they're always what? They're always connected. They're always connected. Even either I push down right here, it doesn't change the result. See, I'm pushing on the button right now. I'm pushing on the switch, but it doesn't change the result, okay? So one thing you always need to keep in mind is what? The ones that are parallel, again, the ones that are facing parallel to each other are always connected, regardless of them being pushed or not, okay? But when it comes to the, again, the ones that are on the same side, what happens is, again, we have to push to what? To basically connect them. So this is where the switching occurs. All right, let's just do this using the smaller pin right here. Let me just do the smaller one. I have not used that. But before doing that, actually, I have a really good question. Okay, let me just unplug this right now. What I want you to do is I'm going to put this, all right, as you can see, I'm going to put this at this third leg. Right now, they're not parallel. They're more of diagonal. I'm just going to put this one connected to this. Okay, I'm going to be connecting it to what? To this one. The one that is right here. To the leg that is right here. What do you suppose is going to happen? Let me just go right here. What do you suppose is going to happen right here? I mean, I'm connecting this one to what? To this. I'm connecting the first one to this one. They're more of diagonal. All right, I have to adjust my Arduino again because I touched the resistor. There we go. The GND is back here. Let's see what happens. What do you think is going to happen, though? That's the real question. Okay, so I'm just connecting my Arduino. So let me just show you what happens right now. You might be wondering, why is this working as a switch? We just said that, the ones that are on the same side are the only ones that work as a what? Where the switching occurs. So you might be wondering, what is going on? Well, the simple answer is what? As I said again, the first one and the second one, let me just again bring my Arduino closer right here so that I can explain it. Let me point at it using maybe a pen. Okay. These Arduinos are what? These sides are connected, as we said again. The first, let me just take out the wire for now. Let me just push it right here. The first two are always connected. As I said again, the first two are always what? They're always connected. As I said again, they're always what? They're always connected. All right. So they're always connected. So this side is always connected to this side. So this side and this side is going to be what? Directly connected. And what did I say? This side and this side, basically this side and this side, this side and this side, basically this and this, the ones that are on the same side are what? They're connected if you push down. Again, this is where the switching occurs. So they're connected when you push down. So what happens here? This is always directly connected. And then when you push down, this also becomes connected. So you see the electricity moves from here to here, which is always connected. Just again, pull the wires right here. It's always connected from here to here. And then what happens? And then when you switch down, this and this is connected. So indirectly, what happens? This and the resistor, the 5 volt, the red wire again, this and this become what? Indirectly connected. So again, I just want you to keep that in mind. All right. So one final thing is before moving on this section is this is a bit confusing for people. Again, as I said, I don't want them to be confused. So let me just unplug everything. The switch is really hard to get off. All right, there we go. It took me a while. Okay, it's a bit confusing for people, and I even had to do a lot of research before even making this course because it's a bit confusing. Okay, so one thing, again, as I said, is what we're going to always look for sides. Okay, so the same side, we're going to be looking, wait, let me just focus here. The same side, we're going to be looking for the same side. So they're always what? They're always connected to what? They're always connected. Let me just focus again. They're always connected to what? In the condition that we push. This is where the switching occurs again. So I have to connect them in what? I have to put them in a way where the same sides are what? They're in opposite what? They're opposite rows. They're in what? They're in different rows. Okay, let me just do that. Let me just put this in the middle, around here. Connect that, push it again. You have to push, by the way, these buttons, they take a lot of effort and you have to push them. Just make sure that you don't break them. Okay, there we go. Just do it gently. Okay, now I can do is what? Connect my Arduino. What is the, all right, let me just go here actually. Connect the 5-volt right here. Right. Now what do I need to do? My resistor. Let me just bring my handy resistor here. And I need to do is put it what? Across again. I'm going to put it right here, across. And what do I need to check that, you know, obviously the current is moving or not? LEDs. We're going to be using our handy LEDs. And then we're going to be obviously using the GND. We're going to be connecting to the what? To the GND right here. So I need to do, connect this to the what? To the GND. Okay. So now switching should occur. There we go. As soon as we push, again, what happens? As soon as we push, it starts to turn on, but as soon as we let go, it turns off. This is where, again, what happens? The switching occurs. So the same goes for this one too. It's exactly the same thing, all right? The switches are exactly the same push button switches, but the only difference is what? Their size and, again, their leg placement. Okay, so if you always look for the sides again, don't look for the ones that are far again, far and closer. Don't use that reference because this one does not work here because this one is a square. Okay, so there's nothing called far or close because they're equally distanced. All right, so you always have to look for what? For the pins that are on the same side. When they're on the same side, this is where the switching occurs. And when they're what? When they're on the parallel side, this is what? They're always what? They're always connected. Either even you push it up or don't push. So just keep that in mind before moving on. All right, that's all when it comes to switches. So see you in the next section. Okay, so in this section, we're going to discuss about LEDs. We worked with LEDs. We've put lots of LEDs in our project, but we're going to be discussing about a special type of LED. So we've worked with the red LED the most. But we've also worked with what? With the green LED and also the yellow LED. We've been working on the traffic light project, as you remember. Right here, the important thing I want you guys to know is, all right, let's say we have a green LED right here. I have a green LED right here. All right, that's good. What if I want a pink LED? What if I want a purple LED? I have to specifically buy what? An LED that is purple. I have to specifically buy an LED that is pink if I want a pink LED. That creates what? A problem, okay? So how do I get any color that I want in an LED? This is where RGB LEDs come into place, okay? They are called RGB LEDs, and if you want to find them in your kit, one thing you have to look for is that they have 4 legs, okay? They have 4 legs. Let me just focus here. They have 4 legs. Not only that too, but even the third leg right here, the third leg is a bit longer, okay? I'm going to get to why it's longer, but there's a third leg right here that is longer. So we have to look for something that has 4 legs and looks like an LED. It has to be clear, okay? It doesn't have any color, just like how these LEDs used to. It's going to be clear. Okay. So what are these RGB LEDs? Before getting into that, I really want you to understand the science between color. All right. So we have to understand the basics of colors so that we understand how does this RGB LED work. Okay. How does this RGB LED work? Okay. So to do that, let's discuss about something very, very basic. Okay, so I think most of us by now have learned that the 3 primary colors are what? Red, yellow, and blue. If I'm correct. We've learned that the 3 primary colors are what? Red, yellow, and blue. All right. Right here, though, we're not going to be using red, yellow, and blue. So basically, obviously, what does this mean? These 3 primary colors, they can combine to create any color that you want, any color that you think of. Yellow and blue together gives us green. Red and yellow together gives us orange. Red and blue gives us what? Red and blue gives us purple. And even putting less red and putting more blue is going to give us more bluish looking type of purple, and it keeps going on. So the list keeps going on. So we can find any color that we want. From black to white to purple to any color that you're thinking of can be made from what? From the combination of what? These 3 primary colors. Okay. But we can also do it using another color. Instead of yellow, we can also do the same thing by using green, by using red, green, and blue. We can literally create the same thing. When we connect red and green, what do you think happens? when we connect red and green. To be honest, I really do not know. When it comes to red and blue, obviously what happens is it's again purple. When it comes to green and blue, it becomes cyan. I don't know what happens when you connect red and green. I don't remember. I really don't remember. But anyways, the main thing is it exactly does the exact same thing that we just mentioned here. It can create any type of color. It can create any type of color that you're thinking of. Again, with red, green, and blue. They can be what? Primary colors. So you might be wondering, okay, which one are we going to use when we're working with these LED and even with computers? So let me just go over right here. They are known, this red, yellow, blue are known as subtractive colors. Why is that so? So I want you to go, I'm just going to go over to my screen and try to explain it in a simple way. Okay. So I think most of us know what a prism is. Okay. So what does a prism do? It basically what? It basically converts the sunlight, again right here, that comes from the left side, to what? To a rainbow. Okay? So what does it do? It separates light. It separates it into different wavelengths or different colors so that you can see each individual what? Each individual color that makes what? That makes the sunlight right here, the sun. Okay? So one thing I want you to understand here is that it's called subtractive for a reason. What happens is what? It is created by what? By subtracting. So what basically happens what? It's created by what? By subtracting wavelengths of light. So basically what? It's basically created from what? By splitting light. Okay? By splitting light. That's what happens when we're using a prism. Basically, our day-to-day life, when it comes to our day-to-day life, obviously we gain light from what? From the sun. So almost everything that we're going to be using is what? It's going to be red, yellow, and blue, made from these three. All right? Because again, it's going to be separated, and then what happens? And then when it's separated again, we can see colors. All right? Different types of colors. Okay. Then, when it comes to the computer world, though, there is a problem. We use something called RGB. Even the name of this LED right here, it's known as RGB LED. It's known as what? RGB LED. Let me get to why we use RGB instead of RYB in what? In our computers. So the problem here is, instead of separating light, okay, when it comes towards subtractive colors, they have to first gain light and they separate it. So they gain light from the sun. What do? They separate it, okay? They separate it into different wavelengths, or basically different colors of light, okay? When it comes to additive, though, why do we use additive in computers is we don't use the sunlight. That's the problem. Our computers do not use sunlight. Where do they harvest energy? They harvest energy from what? From electricity. Basically, when we charge our phone, when we charge our computer, when we charge, obviously, our devices. So right here, we're changing electrical energy to what? Electrical energy into what? Into light energy. This is very, very important. So we're not what? We're not going to be using a light and then separating it. We're not going to be gaining light from somewhere and then separating it. Obviously, when it comes to our devices, they don't what? We don't use, we don't use sunlight, obviously, to charge our devices. That's why we don't use subtractive color, obviously. So right here, we're going to be using additive colors. Additive colors is literally the opposite of what I said, subtractive. When I say subtractive, what do? We split. So basically, when it comes to RGB, what do? We combine. You see that? We combine these wavelengths of light to create any light we want. So we're going to what? We're going to combine them. That's the very, very important thing. We're going to combine them. And when you combine them, what happens? We're going to be creating every color that we want again. So we can find again, RYB and RGB. The fundamental difference between them is what? Is again, this separating light and this one, what? Adding light. Okay? This what? Blending light. Okay? And it's very, very, again, important. What? In computers, we're going to be using RGB. Okay? All right. So with that in mind, we have to first try to actually work with the LED first. So let's try to understand this LED right now. And we're going to go and understand how the inner parts work. Okay. So when you look at the LED, it has 4 legs. As I said again, one leg is always what? The third leg is always longer than the 3 legs. So the 4th leg right here, let me just bring it right here. Let me just focus it. All right, let it focus. The 4th leg, as we can see right here, let me start from the first one. The most left leg, basically the first one, is what? It's going to be blue, okay? And the second one is going to be green, The third one is going to be connected to the GND pin. And the fourth one is going to be connected to what? It's basically the red light. Okay? That's what I want you to think of them. Okay. So one thing you also need to keep in mind is, okay, this is going to be, let's say, a light compartment right here. There's a blue light compartment and there's a green light compartment right here. Okay. So basically what happens, as I said again, when the red turns on, for example, the red is on and the blue is on, what happens? We get a purple. Okay, because it's again an additive. We have to add up together. We add up lights. Okay, when you add red and blue, what happens? We get purple right here. So let's say it's just basically what? Turning on red LED and the blue LED what? Blue LED, when you turn them on, it's purple. So I want you to think of them as combining 3 LEDs. Combining red, green, blue LEDs into 1 LED. Okay, just think of them as combining 3 LEDs into 1 LED and fitting them in the space. Okay. That's what I want you to think of that. Okay, so it's going to be interesting is actually, let me just put this again across. It's going to be more interesting if we learn as we go. It's better that way. So you guys can actually retain the information. Okay, let me just open this. I need to pry it a bit open because it's not going to fit across. If I don't do that, all right, that's better. All right, I have to just keep track of it. The third leg, let me just again focus on this one. I'm just going to keep it like this. The third leg is going to be here, the G and D. You need to make sure which leg you're putting. Okay, this is the first one is what? The blue, the most left one. The second one is green. The third one is G and D. And the fourth one is what? The fourth one is R. All right, that's how I set it up right now. So you might be wondering, okay, what is all this RGB? How am I supposed to, find yellow? Because right now I've only talked about purple, maybe creating cyan right here, but I've not talked about, finding any color. So let me go over to my screen right now. Let me just do that. And what I want you to Google is, say, color code or color picker. Say color picker. And even Google has this. So all you need to do is basically choose any color you want. In this case, let me just choose green, for example. Let me just say the most green thing. Let me just go to the most green one. Just choose that. This is not the most green. This looks the most green, almost. We cannot see the difference right here. Okay. Okay, this is the most green one because it only has green right here. The green one is the only one that's on. This one is all off. As you can see, this is off, and this is the red one is off. Anyways. So you can just choose any color picker right here and find the value here, and you can understand the value. So you guys do not need to, memorize anything. So you might be wondering, instead of why are we supposed to, call them RGB? Why not just say, we can just say, if you want pink, why not use the keyword pink? If you want, purple, why not use the keyword purple? Doesn't that make more sense? Because it's going to be easier, it's more easier, and you would have to create a whole new system for naming what? For naming lights, Doesn't that make more sense? I mean, it looks like it makes more sense, right? But the problem arises here. The problem arises is we have different combinations of colors. I'm talking millions to millions combination of colors that even provides us in what? When it comes to the amount of colors we can even see. So for example, let's say I want this shade of pink. I call it pink 55. Okay. I just called it pink 55. All right. I just give it a name, pink 55. Then let's say I move it a bit and I want it to be a bit darker. Okay, I have to call this pink 56. Let me just say, okay, let me just call this pink 56. All right, let me go right here, pink 57, pink 58. You can see that when we keep naming it and naming it and naming it, it's going to be what? It's a lot. You can see that, right? You can see that we cannot name millions of what? Millions upon millions of color combinations. Because why? It's going to be infinite. The possibilities are what? The possibilities are a lot. So it's better to what? To have a system and basically what? Direct ourselves. It's like, I just want you to think of just using a simple analogy. Let me just get a paper right here. Okay? Let me just get a paper right here. And let me just explain to you why RGB is important. Why having a system of what? Using naming colors is important. Let's just say, you know what? You have to hold 1 plus 1 is what? 2. Okay? You have to remember this. All you do is remember this. You're not going to go through the math or anything. 1 plus 1 is what? Is 2. We have to catch this in our mind. Okay, 2 2 plus 1 is what? 3. Okay. 4 plus 5 is what? Let's just say 9. What? 10 plus 10 is what? 20. All right. This keeps going. 50 plus 50 is what? 100. Okay. And let me just say 1 plus 3 is what? 4. 1 plus 5 is what? 6. 1 plus 7 is what? 8. So the problem is here what? Let's say I want to understand how to add up to 1,000,000. Let's just say I want to know how to even add up to 100. Let's just say that. All right. I want to catch all the numbers up to 100. Let's say 1 plus 1 is, 2. Okay. 2 plus 1 is 3. I have to hold what? Almost 100 digits to even what? To even count up to 100. Okay. But if I learn the basics of addition, I can even add millions of numbers right here. 1, 2, 3, 4, 5, 6, 7. I can just add this up. It just takes a bit of more time, but I can just technically add it up. I want to add it with 1,000,000 right here. Instead of memorizing it, what do I need to do? All I need to do is add it up. The answer is going to be 2,234,000, obviously 5, 6, 7. So basically what mathematics 2 is also what? Is a system, as you can see right here. And instead of memorizing it, what do? We create a system. So basically once we create a system, it makes what? We can count almost infinitely. Almost infinitely as in, obviously we can't count to infinity, but we can do what? We can do almost anything. That's why instead of, naming it, just think of naming millions upon millions of, again, color combination. Okay? Just think of naming over millions of color combination. We're going to do is what? We're going to create a system of naming it. And then what do we need to do? All we need to do is go to our color picker. And then what? We can choose our specific color. You see that, right? So we can just think of even thousands upon thousands shades of pink right here. So like here, let me just go right here. Okay. What I'm going to do is move it right here. It's right here moved. All right. Let me just wait. It's glitching out. It's glitching out. What happened to my computer? Oh, Jesus, I don't want it to glitch out. All right. Come on. Let me just close this tab. What is wrong with it? Okay, my computer is glitching out for some reason. Let me just turn off Chrome. It just takes a lot upon lot of... okay. Come on. Okay, it's opening other stuff. Oh, my God. What's going on? Let me just ignore my computer for now. And let me just go over to this again. So that's why it's very, very important to do what? It's very, very important to have a system of what? Naming colors, because there's going to be millions upon millions of combinations. Okay? So with that in mind, we're going to be using one of the most popular naming methods, all right? One of the most popular what? Color system methods, okay? The color methods. And this one are RGB. There is something else called hexadecimal, and I think some people might know it if you're familiar with coding and stuff, but we're going to be using RGB today, okay? Because it makes sense, because this is, again, as I said, the LED is an RGB LED. It makes sense for me to obviously talk about RGBs. Okay, so now what I'm going to do is right here, I want you to think of it as I said again, I want you to think of it as if we're connecting. Let me just go put the red right here, the blue on the blue. Let me put the red on the red. Just put the blue right here. Let me put the green right here and the red right here. So remember us, oh wait, let me just put it back here. All right. Remember us doing, obviously, the traffic light LED. What did we do? If you, again, I would really be appreciative if you just, again, go back and check it for yourself. Go back to that section and check it. But what we did is what? We connected one resistor to the what? To the red. And then what? Connected to the what? And then we finished. And then we continued to what? We continued to the green. And then connected a resistor for itself. Again, a resistor for itself. And then we connected another resistor for what? For blue. And then we did what? We finally connected it to the GND. That's what we basically did. So, one thing I want you guys to keep in mind is, just because it's just one LED, don't think that we have to what? We have to use only one resistor. Alright? I just told you guys. I want you to think of what? I want you to think of just us mashing up these three LEDs. These three LEDs into one. Okay? Just think of mashing up these three LEDs into one. And having a fourth leg right here for GND. That's all, I think, what you guys redid, alright? So just think of mashing up again what? This RGB LED. Just mashing it up together. So we're gonna need three resistors here. I want you to keep that in mind. Again, mashing up the red, green, and blue. So right here, don't use one resistor. I think this is something that a common mistake that happens. So please prevent that. So again, always use 3 resistors, because we're going to be lighting up red, green, and blue. I just as I said again, just think of it as 3 mashed up resistors. Okay, so as 3 mashed up LEDs. Okay, so let me have to put this back again. I have to find the longer side again, which is a bit of a hustle. Ooh, it's actually a bit hard. Oh, I found it. All right, there we go. It's like this. The longest side is obviously the ground pin, where the ground pin goes. So let's start working with our LED. Now is the right time, I think, to work with our LEDs. I have to widen this a bit again. I have to widen it so that it goes across. To push it a bit. There we go. All right. Come on. Okay, come on. There we go. Got it. Okay. So let me just go back to my PC, hopefully. Okay. For some reason, it's glitching out. Okay, so sorry, my computer just crashed, but let's continue where we left off. So as I said again, I just want you to think of the RGB LED as 3 LEDs, separate LEDs, combined into one. Okay, that's what I just said. Obviously, it's going to be very similar to the one that we just did to the traffic light course, but instead of using instead of using yellow, we're going to use green here. Okay, so what did we do in the traffic light? We separately did what again? We separately connected 3 digital pins, 3 resistors, and then connected it. So what we're going to do right now is going to set up 3, again, digital pins for each color. So we're going to be setting up 1 digital pin for red, 1 digital pin for green, and 1 digital pin for For blue. Okay, so let's just do that. Okay, forget about the comment that I have here. Okay, I'm just going to get back to this. I just want to remind myself to teach about this along the way. So we're going to get back to this. But right now, I want you to focus on we're going to be creating 3 digital pins. So it's going to be red pin right here. We're going to start with red pin. I'm just going to set it up to 1 digital pin. I'm just going to say 4 today. Again, you can choose whatever you want. And then I'm going to choose the green pin. What is it going to be? Again, 5, 8, any number you like. I'm just going to choose 5. I'm just going to try to make it consecutive. And then we're going to go to blue pin and set it to 6. All right. Then afterwards, what do I need to do? I need to go to pin mode. Then set it up to Then I need to go to pin mode, say red pin, in this case, and set it as output. Once I'm done with that, obviously, what I have to do is copy it. So to do this in an easier way, what I'm going to use is a shortcut, alternate, shift, and then point downwards. I'm going to be using alternate shift, holding it together. Then I'm going to point downwards. So I can copy it again. See it? I'm going to copy it 3 times. Then now what I have to do is change the pin right here. I just changed my language. Let me just change it back to English. There we go. Set it to green pin. And then set this to a blue pin. All right. Then afterwards, what do I need to do? As always, I need to I need to use digital, right? Because I'm working with with a digital pin. Then I'm going to be saying red pin and set it to To a value of high. All right. Again, use alternate shift and again click down, because again, as I said again, it's going to make things easier than copy pasting them, writing them from scratch. So all I need to do right here is change this to green pin, and then what do I need to change this to? I need to change this to blue pin. All right. So we're done setting up the code. So let's start working with our components. Okay. So let me just get this out of the way. Actually, I should let it stay here, to be honest, because it's a bit of a harder concept. So I want it to stay here. So again, you guys can reference this. All you need to focus on the subtractive, focus on the additive, and again, these 3 things. All right. Just want you to focus on these 2 things. Okay. So what I'm going to do right here is I'm going to be using the red one for the red right here. The red is at the 4th. The green one, I'm going to be using a green wire for For green. A blue wire for For the blue color. That's what I'm going to be doing. Green, blue here, green here, and the red here. That's what I'm going to do. And I'm obviously going to use the GND. For the GND, I'm going to use A black wire. Okay. So let's just do that. So let me start with the blue one. It's going to be the one at the very most left. So let me just connect it. Let me get this closer and let me connect it. All right, let it focus. Now let me connect it. There we go. Then what am I going to do right here? I'm going to be connecting it to pin what? Again, let me pin, it's pin number 6. Okay, pin number 6 for me. Pin number 6, there we go. Then I'm going to connect the green one. Let's just do that. Let's connect the green one with the what? With the green wire. So let's go to the green one right here. It's going to be next to the blue one. There we go. Let me just show you guys. There we go. Got it. And then where are we going to put it? Just put this right here. We're going to put it to the digital pin 5. Okay. So where's digital pin 5? It's around here. Let me again make sure that you guys can actually see it. Let me focus here. Digital pin 5. Hopefully focus. There we go. Now you can see it. There we go. Digital pin what? Connect the digital pin 6 and then digital pin 5. Now the one that is left is what? GND. Okay, let me bring my black wire right here. Let's get my black wire and let me connect the GND. There we go. As you can see, connected to the GND. And then now I'm going to connect it to the third leg. There we go. Third leg connected. All right. Then now the fourth one, I'm going to be connecting with what? I'm going to be connecting it to the red. So the red pin is what? It is pin 4. So digital pin 4. Let me go to digital pin 4. Just did that. Just do that. So let me just focus so you can actually see it. I connected to digital pin 4, which leg? The fourth leg. There we go. Focus it right here. The digital pin what? Digital pin 4. All right. Now I can just what? I can just run. So all I need to do is upload it. Let me connect my Arduino. Let me just plug in my Arduino right here. All right. Now I can just run it. So let me upload it. All I need to do is verify the code. It says no board selected. Oh, let me select my board. It says unknown. Let me select it again. Sometimes this happens. I'll have to say it's Arduino Nano. There we go. Got my COM4 serial port. There we go. And now we should be able to verify. And it's done compiling. Now let's upload it. Okay, so let me just turn off the lights so you can see way better. Let me just do that because it looks like a greenish type of light right now. Let me just turn off the light right here. Both lights, actually. Let me just turn this off too, so you can actually see it. It's too bright right now. Let me just try to focus it here. It's a very bright light. You can barely see it. It's trying to give me. Can you see green? Sometimes you can see red. Mostly you can see green. But let me go over to this direction. It's really hard to actually get a lock of this, but it looks somewhat like what? Somewhat like white. Okay? Somewhat like what? Somewhat like white. Whitish type of color. But when you put it here, when you look at it on the screen, it looks like green, but genuinely what I'm getting is what? I'm getting white light right here. By the way, I can look at it. White light somewhat looks like green on the screen right here. Can you see it? You can see dynamic range of what colors right here. I can see a red right now. Can't you see a red right now? Can you see? We have red, green, and blue. When we combine them, it looks like somewhat like what? Somewhat like white. So, one thing I did not do right here is what? By the way, one thing I did not do right here is what? Use resistors. I want you guys to keep it in mind. I did not use a resistor. Well, specifically speaking right here, you don't have to use a resistor, alright? Again, specifically speaking, you don't have to what? Use a resistor, but it's not really stable. When you look at it, it just looks like it's changing color every time. By the way, it's not. What is happening is what? There's a red one, the green, and the blue are what? Lighting up. And when the camera focuses, it focuses only on one color. You get me, right? So when I change it right here, it looks like a reddish. When I change it a bit to another angle, can you see it? You can get a bluer, greenish thingy. Then when I change an angle again, it renders it as another color, but generally what I can see is what? Mostly what I can see is white. But if you look close enough, you can see red, green, and blue. Those red, green, and blue are turned on. Okay? Okay, so let's just keep that in mind. So if we go to my screen again right here, and let's go to our color picker. Let's do that. I have to Google it again because, as I said again, my computer crashed. Color picker. And if you go right here to the very most white, it is what? It's 255, 255, 255. Basically, it's turned on to its maximum and maximum and maximum. Even if you go right here and say the RGB model, just say the RGB model, let me Google it. If you look at it, the intersection of the red, green, and blue, the intersection of all of them is what? It's white. When we turn all of them, what happens? It turns to what? It turns to white. Okay. So the intersection of all is what? It's white. Okay. So let's just get this in mind. Okay. So one thing, again, we've worked with, let me again familiarize RGB for you guys. We actually did what? We actually turned on all of this. It's beautiful. Let me just bring a paper right here, and let's go to the math side of it. As I said again, there's going to be what? A math side towards it. Just like how we, again, use math to, again, systematically what? Add and all instead of what? Memorizing. We're going to have, this involves a bit of what? This involves a bit of numbers. Okay, so let me just remove this paper right here. And if you guys remember, something you guys are, again, familiar with, let me start with something you guys are familiar with. If you guys remember when we were using the analog, I want you to focus here, analog write command, what did we do? We stated the pin right here, what pin we were using, and then we stated a value from what? From 0 to 255, if you remember. Wait, let me get the paper right here. From 0 to what? A number from 0 to 255, an integer from 0 to 255. So, one thing you need to know about RGB is literally what it basically means, okay? When it's written in this format is, okay, the first one represents red. The first value represents the amount of red. And it's going to be from 0 to what? To 255. See that? It's going to be, the green one is also going to be 0 to 255. The third value is going to be a blue, which is going to be 0 to 255. Okay. So if we have, let's say, a color, for example, that is written as RGB, let's say 78, 241, and let's say this one is set to even 0 right here. The 78 is what? The 78 is the value of what? The value of red. 24 is the value of what? It's the value. So 241 is the value of what? It's the value of green. Okay, I want you to keep that in mind. And 0 is the value of what? The value of blue. Okay, so the first value is going to be what? The value of red. The green is going to be what? The second value. And 0 is going to be what? Sorry, blue is going to be what? The third value. Okay, we'll just keep that in mind. So let me go over to my screen right now. And when we see something as 255, 255, 255, what does this mean? It basically means it's turned on to maximum. It's turned on to maximum. When we turn on everything to the maximum, what does it give us? The color white. So again, when we analyze the code, let's just analyze the code right here. We just did what? A digital byte high. What does a digital byte high mean? High means what? High corresponds with what? High corresponds with 255, as we learned again. What does low correspond with? 0 corresponds to what? To 0. Basically, 255 means what? 255 means 5 volt, while low corresponds to 0, which means 0 volt. Okay, so we've just what? Created only white light right here. What we've created is what? White light, but we can create many, many lights by using what? By using the analog write command. Because what? We can set it from a value to 0 to 255. What we did is what? Set only 0 to 255. That's all we could have done. We only can set it to 0 or 255. But now we can set it to any number between 0 and 255. So when we use analog write, we're going to be what? We're going to be unlocking new possibilities. Okay? So what we're going to do right now is we're going to first change the pins that we use again, the digital pins. We're going to be finding those squiggly lined pins again that look like what? They're marked with a D and have a what? A squiggly sign on them. I told you guys that these pins are what? Both analog pins, and they both function as analog pins and as digital pins. So let's try to find those squiggly signed pins and try to use analog write command on them. Okay, so let's just do that. So let me just remove all of it. except for the GND. The GND always stays the same, so I'm just going to keep it there. I'm just going to keep the wires here because I'm going to get back to them. Again, let me just take off this paper for now. And what I'm going to do is go to my screen right here. And we have to remove 4. First, let's remove 4, 5, and then 6. We're going to set them to what? To the digital pins that have what? A squiggly sign. So let's look at one that we have right here. So let me unplug my Arduino right here because it makes no sense to plug it right now. Okay, so let's try to find mine is an Arduino Nano. So we're going to look for what? For a dot on the what? On the digital pins. So let's look closer, and you can see one on digital pin 11. We can see one on digital pin 10, and we can see one on digital pin 9. So let's connect to these 3. Okay, so digital pin 11, 10, and 9 are going to be the ones that I'm going to be using. So let me just do that. Actually, I'm not supposed to be plugging my Arduino. I'm going to plug it. And let's start working with it. Actually, let's first assemble it, and then we can go and write the code. Okay, so digital pin 10, I'm going to be setting it to digital pin 11. It's going to be set to red. I'm just going to do that. As I said again, let me just bring this here so you guys can again remember it. The red is what? At the very last. So I'm going to be setting it to digital pin. Instead of digital pin 11, it's better to set it as digital pin 9 because it's going to be closer. Okay. So I'm just going to set this to what? Digital pin 9. I'm going to change my mind and change it to what? To digital pin 9. Let me just set it to digital pin 9 right here. Set this to digital pin 9. Where am I supposed to connect it? Next to the GND pin to the very right. So let me just do that. There we go. Connected it. Nice. Now what do I need to do? I need to set up green. Let me get my green wire right here. Just find my green wire and put it right here. I need to go to digital pin 10. I'm going to go for digital pin 10 for green. Okay. Then I'm going to go for the blue one, which is going to be the most left one. There we go. And I'm going to set it up for what? Digital pin 11. Oh, the space is very tight. Let me just do that. There we go. You guys can see it right now. Let me just do that. Let me just make sure that you guys can actually see everything. Every setup. And there you have it. Okay. So now, what I'm going to do is let's go over to my screen and let's start writing the code. Okay. So the red pin is what? Set to what? Digital pin 9, while the green pin is set to digital pin 10, if I'm correct. Digital pin 10. There we go. And blue pin is set to digital pin 11. There we go. Now, what do I need to do right here? I'm going to be using them as an output, so this is all correct. I'm not going to change anything here. What else am I going to change here? I'm going to be using what? Analog write instead of digital write. So I'm just going to do that. Down analog write. And I'm going to set the what? The first one, let me just set the red pin to what? To some sort of value. I'm not going to do that right now. Well, I'm going to just set it up. So let me again copy this. Set up green pin. I'm going to set a value later. And we have the blue pin. There we go. So now what I'm going to do is I'm going to go to my color picker right here. Okay. So as you can see, we have the value right here written down on RGB. You can also see other values such as CMYK, HSV, HSL. We're not going to get into them because we're not going to need them right now. But we're going to focus on RGB because this is going to be one of the most popular type of what? Color naming systems. All right. Not a color what? A color system. All right. So I just want to go for something more of yellowish today. I just feel like something yellowish. Let me just go for something yellow. Okay. There we go. I like this color. I want it to be a bit brighter though. Just make it a bit brighter. Actually, but that looks good. I want it to be somewhat greenish though. Let me just go to the greener side of it. Okay, that looks nice. I like it. So what I need to do right here is again, the RGB says that I'm supposed to set it what? 132 for red, 255 for green, and 0 for what? For blue. So let me just do that. Let me go over to my Arduino IDE. It's supposed to be right here. I have to set 132 for the red pin, 132. For the green pin, I'm going to set it to what? 255. And for the blue pin, I can just set it to 0. Okay, so all I need to do is what? Upload this. Everything should be working. No upload port is provided. Why is that so? I did not plug in my Arduino. Let me just do that. Forgot to plug my Arduino right here. All right, now let me try to upload it. Okay, it's done uploading. So let me just turn off the light so you guys can see it way better. Again, turn off the lights. It's really hard actually when there's actually turn on the light. Actually, it's way better with the light. At least it's not gonna be too bright that you cannot see it. It gives me the yellowish. You cannot see it again because of the screen again. It's gonna focus on only one light, but if you look at it, it looks like somewhat yellowish type of green. It doesn't look like the one that looks on the screen like perfectly, but it looks somewhat yellowish type of what? Type of green right here. Some yellowish type of green. If I rotate it to another degree, it looks like yellow. You can see that, right? If I rotate it to a degree, it looks like a yellow. When I rotate it back to another degree, it looks like green. There we go. It looks like a green right here. Okay. So right here, let me just try to make something of a distinct color. Let me just again turn on the light. Let me try to make somewhat of a very distinct color that we don't have. We already have a yellow pin, so let's try to find something that we don't have. Maybe a color that we don't have. Maybe something like cyan, because we don't have a cyan type of color right here. Cyan is one of my favorite colors. I actually like it so much. Okay, so the value of cyan is what? Almost what? 238, 255. But if you go to the closer side, actually it's going to be 255 right here. The most cyan color is going to be 255. There we go. 255. This is cyan. If you want to find, for example, by the way, if you want to find a specific color, okay? If you want to find any specific color, the RGB value of any specific color, all you have to do is what? All you have to do is Google it. So right here, you're going to go right here and say, let's say I want the color pink, okay? So I'm going to say is pink. What I'm going to say is pink RGB value or RGB code. You can say RGB code or value. When you just do that, a pink is going to be right here. The RGB code is what? 255, 192, and 203. All you need to do is go right here. Okay. So I'm going to set the red to 255. Let me just do that. Set it to 255. And this one to 192. All I need to do is set it up to 192 if I'm correct. Let me just look over on 192. 192. And this one to 203. There we go. All I need to do is what? Upload it right now. Let me just do that. It's done compiling. And now it's uploading. It's done uploading. As you can see right here. Let me just turn off the lights if it helps you. It looks somewhat like white right now. Let me just turn off the light so that it can help. Let me just do that. Okay. So again, it was really a hustle. You can see that the color is changing a lot. It's changing from green to right now a red when I tilt it again, and now to a blue. But if I go in the right direction right here, it doesn't look like a pink right here. It looks like a pink right here. Can you see it? A pinkish color. I can see it right here. It looks somewhat like pinkish, by the way. You cannot see it that much because again, we're using camera, but you can see what? Somewhat of a pink when I tilt it. When I tilt it to the right degree, you can see somewhat of a pink. There we go. Somewhat of a pink right here. There we go. We got a pink. That is beautiful. Let's just do that. Can you see it? It's a beautiful one. All right. So, again, you guys can choose any color you want. Google it. Again, any color you know, maybe indigo, cyan, any color you like. Google it, obviously. And yeah, all you have to do is search for the RGB value. And you can, again, do what? You can use your RGB LED and what? And try to create that light for yourself. All right. I think this is it for the next section for this section of the course. But we're going to be working with RGB LEDs and adding up. We're going to take them to the next level by working with the serial monitor on the next section of the project. So see you then. Okay, so let's up this project, as I said again, up a notch. So everything here is going to be the same. The components here are going to be the same. So is going to be the code. So we're going to continue where we left off. Okay. So right here, what I want to do to up this project is use our serial monitor right here, okay? And what do I want to do is, let me actually upload this code right here first because I was working on the pseudocode. I was working on the code previously and I don't want it to interfere with this one. Okay, I think the serial monitor should be printed now. Let me put my serial monitor. It should be like new. All right, there we go. And what do I want to do right here is, okay, what do I want to do right here is I want to enter a message to what? Our serial monitor, okay? So as you can see right here, there's a black bar that says message, enter to send message to Arduino Nano. So basically we can use our serial monitor not only to read, not to only what? Listen or read from our Arduino Nano, but we can use it to write messages to what? To send messages to our Arduino Nano, basically to our Arduino. Okay, so how do we do that? Just write down a message right here. Let's say I said red right here. I can send it to what? To the Arduino. Obviously, right now it makes no sense because obviously we have to what? We have to create a system on which how we're going to receive the message and what Arduino should do when it receives the message. Okay, we don't have to set that code up. Anyways, we can set what messages though? Just like how we have, I want you to think of this, just like how we have digital, let me just write it down properly, digital write and digital read. Just like how we have that when we can write the message to again using our digital pin, and we can read message using our digital pin too. The same goes for analog too. We had what? Analog write and analog read. Now we're gonna have is what? Now we're gonna have a serial what? We've been using what? Serial read. We're reading what? Using our what? Our serial monitor. And now we're gonna be using what? A serial, kind of something like what? A serial write type of thinking. Because we're gonna be what? We're gonna be sending a message by using our what? Our serial monitor. Okay, so what's the idea here? The idea here is that we're gonna set a color name right here. Let's say red. And what I wanted to do is I wanted to change this LED, the RGB LED, as I said again, capable of almost any color, to what? To give me the equivalent color. So when I say red, I want it to turn to red. When I say blue, when I enter blue, I want it to change to blue. When I say pink, I want it to change to pink. When I say purple, I want it to change to purple. Again, I want it to change to what? To the color I already what? That I set right here on the message. Okay, that's the idea of what we're going to be doing. So the question is, how do we even first receive the message from Arduino, and how do we even code it so that what? So that again, it gives me the equivalent color on the RGB LED. Okay, so I'm just remove my serial monitor right now, and we're going to be working a bit on the serial monitor. So one thing we need to do before working with any type of serial monitor is what? We're going to have to always what? Start our serial monitor. So we have to say serial.begin and set it to what? To 9600 right now. And then we're going to be using right here serial.readString. We're going to be using something called what? Serial.readString. Okay, so what I'm going to do right here, we already started our serial monitor right here. Okay, serial.what.readString. Let me just copy it. Okay, serial.readString. There it is. So what does this do? Let's just go to the documentation to check it for ourselves. So what does the serial.readString does for us? So let me just go to serial.readString. And there we go. We have the Arduino documentation of it. There we go. So it says serial.readString reads characters from the serial buffer into a string. The function terminates if it times out. See timeout. So basically, what does it do? From a technical point, they say what? A serial buffer into a string. So basically, what does it do is what? It reads the characters that are what? Are going to be outputted right here. So it's going to be reading the characters that are going to be what? That are going to be written on the message right here. Can you see this? The message part right here. This is the serial buffer. And it's going to be what? It's going to be what? Reading the messages that are coming from here. So we're going to be using what? Serial.readString to what? To read messages that are coming from what? That are coming from our message bar right here, or our serial buffer. Okay, so right here, what we're going to do right here is we're going to need a new value, a new variable. We want to what? Once we get the value, let's say right here I have red. I put red right here. Let's say I put red right here. I want to what? I want to store it because we're going to be using it in our code. So what? So I'm going to be using it later in our code. So what? I want to store it in a what? In a variable. Okay, so let me just do that.
So what do I need right here? I need a variable. So what is it going to be right here? What type of variable is it going to be? Am I going to say integer and say, you know what, this is going to be the current, what, set color. Let me just say set color right here. The set color, is it going to be integer? Is it going to be an integer when I set it up? No. What is it going to be? A string. Okay, a string. Am I correct even how to write it down? I think it's string. Let me just, again, to always check that everything is correct right here, let me just try to compile it, saying that it expected a what? Oh, it expected a semicolon. Let me just compile it. Okay, the capital S is the right one. If I put the small s, well, let's see what happens if I put the small s right here. Okay, there we go. It says an error. I have to say capital S. Capital S is the right way of writing it. Okay, there we go. So you might be wondering, what is a string? Let me just go over this so that it becomes what as simple as possible. Okay, so a string is right here. I'm not going to use my paper actually. I think it's better to use my screen. So right here, what does a string mean? Okay, a string means a normal text. Okay, for example, this is a normal text right here. It says put your setup code here to run once. Okay, but right here, pin mode is what? Pin mode is a what? Let's go right here. Let's use an example of pin mode. What is pin mode right here? Let me just go to pin mode. What is pin mode? Pin mode is a what? It's a command. It's a what? It's a code. Okay? It's a code to be what? Executed. So one thing it wants to identify is what? It wants to differentiate between a normal text and a what? And a what? And a normal what? And a normal code. So it wants to differentiate between what? Code and text. Which one is text and which one is code? Because if we don't do that, we're going to get into what? We're going to get into lots of troubles. Because if I just say right here, instead of, let's say, I'm just saying hello world, it's going to expect, let me just say hello world right here. Okay, let me say hello world. Okay, let me just try to compile this. Let me verify this. Look what happens. Hello was just not declared in the scope. It's trying to find what? It's trying to find a command, a code named hello world. Okay, it's trying to find what? A code named hello world. Obviously, there's nothing called hello world in the Arduino. Obviously, that makes no sense. So what it basically means is what? It does not understand that's a normal text or a code. So to differentiate that, we use what symbol? We use right here, what do you used to call it? A quotation mark. You see that? A quotation mark. So we use quotation marks right here to what? To identify a one that is what? A code and a string. So in strings, we say double mark right here. And let's say hello right here. Hello world. If I say that, it's going to what? Render it as text. It's going to treat it as a what? As a normal text. So it's not going to be giving me an error. So let's see what happens if I just say, you know what? There's a string name. Just say hello world. Okay, I always finish it with a semicolon right here. How about if I upload it right now? Let's see what happens. It's done compiling. You see that? It's done compiling. It's not giving me an error. It's saying is what? This is just a normal text. Don't get into what? Don't get into detail. Just write what? Render it as a normal text. Okay? Don't do anything further than that. It's not a command. It's just basically what it's telling it. So what? It's a normal text. So right here, basically what are they called? They're called strings. Okay? So keep that in mind. Because why? Because I said again, we're going to be working with what? With what? With letters right here. And I wanted to render it as what? It's not going to be rendering what? It's not going to be searching for the what? For the command or for the code red. It's going to be searching for what? It's going to be searching for what? The string red. It's going to make more sense as I go. Okay. So right here, I wanted to what? To read the string. How do we set this? Once it reads the string, I want to set it to what? To a variable again. Because why? I want to what? I want to use it for what? For later purposes. So how do I do that? What I do is I go right here, set color. I say set color. I'm just go right here. See set color. Set to what? Set color is equal to the string red value. So once the value is read right here, as soon as Arduino reads a value, as soon as, let's say I enter a value right here and it reads it, it's going to set it to what? It's going to set it to red right here. Okay, it's going to set it to a value, the string that we just what? That we just read right here. Okay, so what does this mean? So for example, if I set red right here, I just say red and enter it, what is going to happen? Set color. Set color is going to be what? Go right here. Set color is going to be what? Set color is going to be equal to what? It's going to be equal to the string red. Again, what is one thing we have to acknowledge. What is it? What is one thing that we have to acknowledge? This is what? A string. There's what? The quotation mark is right here. Okay? Keep that in mind. Okay. So, with that in mind, now what we want to do is, we set the color. Okay. So let's try to print what we just wrote right here. So to actually see if it's working or not, let's just print it. Okay? Let me just say println and say set color. I just want to print it so that let's even see if it's what? If it's rendering the right thing. Okay. So let me just upload this, but before doing, what should I do? Turn off my serial monitor. That. And now I can upload. It's done compiling and it should be done uploading. Okay, so let's go back to our serial monitor right here. Let me extend it a bit so you can see it better. And let's try to say red right here. Does it print red? There we go. It printed what? It printed red. Can you see that? It printed red. And you can see that it's printing out empty stuff. Can you see that? It's printing out empty. What is going on? You might be wondering, what is going on? Okay, what is going on? You might be wondering, why are we printing out after red? We're printing out something. What are we printing? Some empty spaces, some empty stuffs. Why is that so? Let's see what happens. Again, one thing again you have to keep in mind is what? One thing you have to keep in mind is what? It's going in a loop. So it's going to read it one time, and it's going to be, setting the analog right to, again, all these values. Afterwards, what does it do? It reads the string. In this case, it was red. I already wrote down red. And then it's going to set the color. As I said again, it's going to set the color. So basically I said set color. It's going to print it out. It's going to print the variable set color. And then what happens? And then it runs it again. But this time, after writing what? I did not write it this time. So it's going to start from again. It's going to start from again, as I said. It's going to start again because this goes in a loop again. It's in a void loop. So it's going to start again, do the same thing. But right here, what happens here on the read string? In this case, what did I do? I did not write down red again. I have to write down red at very, very fast speed for me to what? To match up to what? To match up to the Arduino. Right here, what's going on? The read string is what? It's an empty set because I did nothing. It's basically what? It's basically empty because I did not enter anything. So it's going to be giving me those empty spaces right here. It's printing it out. You can see that it's printing out what? Empty spaces. Okay. So I just want you to keep that in mind. Okay. So right here, it's going to be printing out this. We're going to fix this and by using something called serial.available. I'm going to get to it. But now let's focus on just optimizing the read string. We're going to go back and fix this later. Okay. So right here, let me just again forget about the printing. It works. But obviously what happens again? The problem here is what? It's going to print out those empty characters. We're going to fix that on the next one. Okay. So one thing what we want to do afterwards, after we store our set color is what? Our set color is what? We want to compare it. Okay. So how do we do that? So right here, let me write down an if condition. There's the keyword called if. Okay. We have a curly brackets right here. Our condition is written inside here. Okay. Our condition. And then our code is going to be written inside of the curly brackets. Okay. So when it comes towards these if things, if you write them down, let me just write them down right here. If I say if, it has what? A special color. Okay, it's a code, as I said again. We're going to write down our condition, what? In those curly brackets. And then we're going to have our code in the middle of those what's. In the middle of this what? Curly brackets again. Okay, so this what? This squiggly brackets right here. Okay, so in the middle of the, in the middle of the curly brackets. Sorry, I keep saying curly brackets for this one. This is called a parentheses, okay? In the middle of this is going to be the condition. I got that wrong when I said it. But in the middle of the curly brackets is going to be our what? Our code. It's going to be written here. Okay, so one thing I want you guys to keep in mind is let's use a very, very simple analogy so you guys understand this. So I think most of us have obviously had this English lesson about what? If condition tenses, if you remember. So when we learned about condition tenses, what did we say? What did we say? There's a condition, there's if, and there's a condition, and then there's what? And there's what? And there's the result of the condition. So it's like cause and effect. So one good example would be if, okay, if it doesn't rain, I'm going to say I will go outside to play basketball. Basketball. Let's start to analyze this. So, if it doesn't rain, I will go outside to play basketball. What is the condition here? The condition is what? It doesn't rain is what? The condition. This is what? Our condition, okay? This is our condition. And the result of the condition, again, the consequence of the condition will be what? What? I will what? Go outside to play what? Basketball. This is what? This is going to be our action, basically. Action. So there are two things to this condition again. There are going to be what? Two cases to this condition. What is that? What are the two cases? In this case, one case is what? It doesn't rain. So what? I can just go outside and play basketball. But there's another condition too. When this condition is false, basically, when it's what? It's raining, when this condition is not satisfied, it's raining outside, basically, right now. What is going to happen? I'm not going to go outside to play basketball. I'm not going to go outside to play basketball because I don't want to get wet. Okay? I just want you guys to keep that in mind. So, when this condition is what? It can be set to true or what? It can be false. Okay? Both of them will have what? When it's true, it's going to have what? When it's true, it's going to have what? I'm going to go and what? Play basketball. When it's false, in this case, what? It rains. What am I going to do? I'm not going to go and play basketball. So it's going to have what? Two scenarios. When it's what? When it's true or false. When the condition is what? True or false. So it's going to have what? Two, again, cases, as I said again. Okay? So it's going to what? Affect our what? Our action again. It's going to affect our action. This condition is going to affect our action. The condition coming true is going to affect our action. And the condition coming false is going to have what? Another effect in our action. That's one thing I want you guys to keep about. So it's going to be the same thing too when it comes to computers. Okay? So what? There's an if right here, and there's a condition. We have a specific what? We have a specific condition, and then what? When that condition is satisfied, what's going to happen? It's going to specifically what? It's going to what? It's going to execute the code that's here. Okay? When the condition is not satisfied, it's going to what? It's going to skip it. It's going to skip what? The whole what? The whole bracket to the very end. It's going to skip it. The whole what? The whole code right here. You can write hundreds of codes in the middle of this brackets, but it's going to what? It's going to skip it as long as what? The condition is what? Not satisfied. If it's satisfied, it's going to what? It's going to run it. So I just want you guys to keep that in mind. So what are we going to do with this if loop right here? What are we going to do right here? So let me go over right here. Okay. My screen. The condition here is what? If red, right here, if the set color is what? If it's equal to red, okay? If it's equal to red, let's see right here, if it's equal to red, what do I want to do right here? When it's equal to red, what do I want to do? You guys know RGB, so if we want to get the most red color, how do we get the most red color? We do what? We do this analog writes. So let me copy the analog writes, and I'm going to adjust the value again. Let me just remove this, and let's just print this again. And we have, again, analog what? Red pin, 255. Analog right green pin for what? We're going to set this to 0. And the blue pin, we're going to set it to 0 because we only want what? We only want red to be lighting up. Because what we want the color is what? It's red. So again, we can again use our color picker right here if we want to. We can just go to our color picker and say, color RGB value of what? Value of red. When we do that, the RGB value of red is what? 255, 0, 0. There we go. So that's what we basically did. 255, 0, 0. I wanted to do what? Analog write of what? 255, 0, 0. Right? Am I correct? That's what I wanted to do. What if it's not red? So right here, when it's not red, when we want to set another condition, okay, now let me go back to my paper. Actually, let me add another paper, to be honest, because this paper is not enough. There we go. So how do we set another condition? Okay, we're going to be using something called else. Okay, we're going to say if right here. We're going to say if, and we have our condition. Okay, and it's going to be running the code if this is true. Okay. Okay. Then we have something called else. Okay. Else. Else as in what? It's the second option. Else is what? It's more of what? The second option. So if this condition, for example, is satisfied, what is going to happen? It's going to run the code as I said. But what if this condition is not satisfied?
this condition is not satisfied, I want it to run, let's say, a specific code right here. If I wanted to run a specific code right here, okay, instead of just, skipping it as traditionally, what did it do? It had a condition and a code. If it, again, this condition is not satisfied, what did it do? It just skipped it. But let's say I want to, if in this case, this condition is not satisfied, okay? In this case, this condition is not what? It's not satisfied. If in this case it's not satisfied, what I want to do is run another type of code right here. We have code number 2 right here and code number 1. I wanted to write code number 1 if this condition is satisfied. But if it's not, I wanted to run another code, okay? Instead of just skipping it, I wanted to write another code. That's why we're going to be using something called else. So what I want you to think of them is like this. Okay, we had this again sentence right here, which was what? If it doesn't rain, I will go outside to play basketball. Okay? But something else can happen to other than raining. Let's say it gets too hot. I'm talking really, really hot. So if it gets too hot, what happens? If it gets too hot, what happens? I will not go outside and play basketball. So instead of just we're only talking about raining here, which again, it has a wider context, because let's say there's a tornado, let's say outside. If there's a tornado or a hurricane outside, I will not go outside and play basketball. Obviously, I will not go outside and play basketball. So I just want you to keep that in mind. So when you're working with else, what are you doing? We're just adding another condition. Another condition. Basically, what we're saying is if this code is not run, its condition is not satisfied, I'm going to give you another option, which is going to be writing down the second code. Okay. So I just want you to think of it as that. So if this condition is not satisfied, I wanted to do something else. Okay. Instead of just not playing basketball, I wanted to do something else. One of it would be playing maybe board games, okay? So let's say if it rains, in this case, what is going to be? Our condition is going to be false. If it rains, instead of just not playing basketball, what also am I going to do? What also am I going to do is I'm also going to be, let's say, playing board games inside the house, okay? With my friends. Let's just say that. Okay. So with that in mind, okay, you can say what else, okay? Else. And what I wanted to do is I wanted to tell our user right here. I wanted to print out and tell our user, right? Let me just go to serial.print and tell it, hey, color not recognized. I wanted to tell it that we do not recognize what color it's set right here. Okay. I just wanted to tell it, oh, I don't recognize the color that you're saying right here. Okay. All right. That's what I want to do. Okay. So one final thing that we need to learn about if and else is to be exactly fully done is something called, so we learned about if right here. Let's recap. We learned about if, and then we learned about if and else, combining them together. And then we're going to learn about something called if right here. Let me start. It's going to start like if. Just going to add up to it. And there's our condition. Let me just give this, and just separate this condition. Obviously, we have our code in the middle of the brackets. It's going to be code 1. Then we have something called if else. All right, if else, and we have a condition again. We can write down another condition. Okay, we're going to be using code 2 again, right here. And we can even set it up with with else right here. Again, right here, else is it's the final straw. Okay, so here we go. So what does this mean? So this means we have our code 3 right here. When you see else, we have our code 3. We have a third code. There we go. Okay, so what does this mean? So this means if there is a condition, what's going to happen? It's going to be running the first code. If this condition is not satisfied, it's going to go to the second one. We're going to give it another condition, okay? So we're going to give it another condition, and it's going to be running code 2. And the third one is going to be It's going to be running the final straw. It's basically the final straw. It's like the final, like the final thing that you do when you have anything else you don't do, right? You don't do anything when you don't have anything else to do. When you don't have anything else to do, it's like the final straw, okay? It's going to be running our final straw right here. So I want you to keep that in mind. So there's if, again, condition with the code 1, and there's if else, condition, and our code 2, and then else, and then our code, the third code. So I want you to keep that in mind. Okay? So right here, let me just bring my again, our simple example right here, I think it's going to make it way easier. So what does an if else fit right here? So it's basically thinking of it, as I said again, if it doesn't rain, I will go outside to play basketball, right? So in this case, let's say it rains, okay? When this code is not satisfied, it's going to jump this one. And what's going to happen is if else, it's going to go to the if else right here, the second option. It's going to be the second option. It's going to go to our second option and say, okay, it's raining. What else can I do? What else can I do? Okay, I will not go outside. I will not go outside to play basketball. That is true. I will not go outside to play basketball. But what else can I do? I can be on my phone, let's say. Okay, let's say what? I can be on my phone. I just want you to think of it as what? I will be inside of my house and be on my phone. Okay? All right. Then let's say, again, there's another condition where this one cannot be true. Basically, let's say there's no light and my battery's dead, okay? Let's say my phone battery is dead in this case. Let's say my phone battery is dead. As a final straw, what do? I play board games because I have nothing else to do. That's what I want you to think of, okay? So when this condition is not satisfied, there's what? When this condition is not satisfied, we have another condition that we're going to do. But when that condition is again not satisfied, we have a final straw again to do what? To do our last thing, okay? So let's say even we don't have board games. Well, let's say this is going to be another if else, okay? We don't have a board game. What are we going to do? Okay, what we're going to do is maybe sleep because what? We don't have any board game. We don't have anything to do, basically. We don't have anything to do. We're just going to go to sleep, okay? We're just going to take a nap. All right, so that's what I want you to think of them, okay? So one thing you always need to keep in mind when working with these is what? It goes from up to top. The one thing you want to keep in mind is what? It goes from up to top. So again, from up to bottom, up to bottom. So it's going to be reading the if right here. So let's say it reads this one, and this is true. If this is true, what's going to happen is it's not going to read the else one, okay? It's not going to read it. It's not going to read it. It's going to skip it. It's going to what? It's going to skip it. No matter what thing you write in it, it's going to what? It's going to skip it, okay? Keep that in mind. When it comes to this one too, what's going to happen is it's going to read the first condition. If the first condition is satisfied, what are we going to do? Let's say in this condition, for example, if what? It doesn't rain. What do? I just go outside and play basketball. I'm not going to be on my phone. I'm not going to be using board games or anything. I'm going to be what? I'm going to be what? Playing outside. I'm going to be outside and what? Playing basketball. So I want you to keep that in mind. So when this condition is what? Set to true, it's not even going to read the last options. Okay. So it's going to pick from like these options. And the first option is obviously this. If it reads this and this is true, it's going to skip all of this. Okay. So one final thing that you need to keep in mind is you can write down if, let me just bring this here. You can write down if, and then you can write down what? Our condition. Again, the condition. Then our code is going to be written down. If we obviously what? We obviously write it down right here. Then we have if else. Okay. Then again, it's going to have its own condition here. And it's going to have its own code. It's going to be code 2. Then we can also add another if else. The same thing. It's going to run another code with another condition. It has another different condition right here. Code 3. If else. You can keep adding it to what? Till infinity. Okay. You can keep adding this to what? To infinity. Right here. It's like adding, let's say, okay, I don't have, my phone's not here with me. Okay, I'm going to be reading a book. You know what? Instead of reading a book, I'm going to be cooking cooking dinner or something. So what? There's like infinite possibilities. Okay. So you can keep writing down if else to what? Infinitely. And then at the end, what you do is always finish it with the last option. It's going to be an else right here, an else option, and you finish it with a code. So this is what our code 4. It's going to be our code 5. So one thing I want to, again, as I said, is what? Always one of it is going to get picked. So what's going to happen again when this is picked? If the first condition is picked, what's going to happen? If the first condition is picked, what's going to happen is basically what? It's not even going to read all these. If this is true, it's not going to read any of these from else. All of it till else. Everything. It's not going to read anything. It's not going to read all of it. All right. What if the second condition is true? If the second condition is true, what's going to happen? Okay, first it reads the first condition, and this one is false. And the second condition, let's say it reads it, and it's true. In this case, what's going to happen? Anything beneath it is not going to be read. It's going to be what? It's going to be skipped. Anything beneath it is going to what? It's going to be skipped. Okay, it's going to keep going on like that. So I just want you to keep that in mind when working with if conditions. So I think it has been a very longer section of the course because we're learning about new programming again, functionalities and all. So it's going to be a bit, it is a bit longer one. So what I'm going to do is I'm going to stop this right now, right here. And then we're going to see, we're going to take a break and then see you in the next section. Okay, so in the previous section, we discussed about if loops, and now we're actually going to utilize them in our project. So we're going to fully utilize them. Okay, so let me go to my screen right here. And what does this mean? This means is what? If the set color is red, what happens? The analog write command, let's go here, the analog write command is going to set the red bit to 255. Obviously, other ones are going to be set to 0. Basically giving us what? The color red. So let's see what happens when I just do that. So let me just upload it right now. It's uploading. And there's a problem right here. Can you see I did not write down anything on the what? On the Arduino. I did not write down anything. But what happened here? What happened was it turned down to red, which is a bad thing because I'm supposed to what? I'm supposed to go to my serial monitor right here, and then I'm supposed to type red, and then when I enter it, when I send it to the Arduino, then it should have been turning to red, not when I, again, just did not do anything right here, okay? So I did nothing, and what happened was, let me tell you guys, what happened was, I said the color is equals to what? To red. Right here, I said the color is equals to what? Serial.read string, alright? Then afterwards, what did I say? If set color is equal to red, I set it to what? I set it to read, to red. So how do we compare things? So how do we, know the difference between setting up stuff, just as in like this. Let me just bring this here. We'll bring a paper, and I think I'm going to use a math analogy again, because to make things way, way simpler for you guys. So I'm going to bring a paper here. Okay. So, if you remember, if you guys learned about expressions, and then equations. What is the difference right here? When it came to expressions, all we have to say is what 5x plus 7 is like an expression. What is an equation? An equation has the equal sign. Let's say 5x is 7 is equals to maybe here 4. Okay? So right here, what does this do? This means to solve. What does this mean? When we set the equals to here, this means what? Solve for x in this case. What if I said 4 equals 5? 4 equals 5. If I say that, this is going to be what? This is a statement. And what is the statement? Is it true or false? This is definitely what? This is definitely a false statement. Okay? So we use the same sign right here to do what? To solve for x. And what? To even what? To see and compare and contrast. So basically what? We see what? The statement. To see the statement. But when it comes to computers, I said that what? Computers are what? Computers take you literally. And I think all of you know that. That computers, what? They take you literally. So they need to understand the difference between you are solving for x. Basically, they need to understand the difference when it comes to computers right now. They need to understand the difference when you're assigning a variable. Assigning a variable. Assigning a value. Right here. To a what? To a variable. They need to know the difference between you assigning a value and then you comparing a value with another. Comparing values. Comparing two values. So how does a computer know when you're assigning a value and when you're comparing values? Because when we go to line 23 here, what are we trying to do? We're trying to compare the set color variable with what? With the string red. If the string is equal to red, if the answer is equal to red, what are we saying? If it's equal to red, we want it to what? We want it to write what? This code. It wants to run this code. We want it to run this code between line 24 and 26. Okay, that's what we are basically saying. But it cannot know that. So when it comes to assigning values, one thing you need to keep in mind is when it comes to assigning values, you're going to be using the equal sign. Just like how we're using, again, the equal sign in line 21 to what? To set the color. Right here we said set color is equals to what? Serial.readString. To assign variables, you only what? Use what? We use an equal sign. But when we were comparing values, what do? Is we use two equal signs, okay? An equal sign next to an equal sign. When we do that, our Arduino knows that we're comparing values, okay? So we're not assigning values, we're comparing values. Okay, that's one thing I want you to know, okay? So let me just move it right here and let me fix this properly. After what? Right now I'm what? On line 23, I'm doing what? I'm literally comparing what? I'm literally comparing. So what should I be using? I should be using double. There we go. I'm going to be using double equal signs here. And then let's upload it. Okay, I forgot to, again, close my serial monitor. It happens often. All right, let me go again. Should be uploading. Okay, it's done uploading. There we go. Now everything is fine. There we go. It's not lit up right here. Okay. So now what do we think it should do right now? When I say red, we want it to turn to what? We want it to turn to red. So let me just do that right here. Actually, I keep getting color not recognized, color not recognized, color not recognized over and over again. Let's see why is this happening first. Okay, so obviously this is going in a loop right here. Right here, it's a loop, the void loop. So it's going to check for the set color. In this case, I have not set anything. So it's going to be an empty string or almost zero. A zero or an empty string, somewhat like that, because I have not put anything right now. Let's see what happens. And then it's going to be checking for the set color is equals to red. Obviously, it's not equal to red in this case. And then it's going to go what to what? Okay, this is not true. So let me go to this one. Let me go to the else one. Wait, let me go to the else one. It's going to say, let me go to the else one and do what? And run this code again. And then I'm going to start the cycle again because we're in what? In loop. So that's the problem here. So let me remove the else for now because it's quite distracting for now. So let's remove else for now at least. So let me just turn off the serial monitor right here and try to upload it. Okay, it's done compiling and it should be uploading. All right, it's done uploading. So let's see if we're even going to run into errors right now. Okay, so right now when I say red, when I enter red right now, I expect this LED to turn to what? To red. So let me try to do that. I'm just going to touch the enter key right now. And we can't see nothing. Let me try doing it again. We still can't see anything. So in this case, let me try to debug it, all right? So one way to debug it is what? Let me go to my serial right here and say serial.printit. Let's try to print the set color. If there's even a problem with it. So let me just check if the set color is correct. So let me just upload this. But before doing that, again, turn off my serial monitor. Let me just upload this right here. Okay, it's done compiling. Okay, it's done uploading. All right. Now let's try to go to my serial monitor. And now let me try to go to my monitor right here and set the value to red. Okay. Let me just try to do that. Okay. It's not setting to red as you can see right here. What is the problem? Again, what happens? It's just printing out, I think, an empty character. There we go. It's emptying out. Look at it. It's going down and down if you look at the pointer. But it's emptying out what? Printing out empty characters. Why is that so? I don't put anything inside of the message again. I didn't put anything inside of the message. For an instance, I only put what? Red for an instance, and then keeps running and running and running again. So I need to put it where? I need to put this, the print one, I need to put it right here. I want it to print as soon as what? It turns to red. I think it's better that way. But it might not even print it because why is this a bad idea again? Because if obviously this is true, it would have run this. So it always skipped this. This basically means it always skips it. It's saying that set color is not equal to red for some reason. And I need to figure it out myself. So let me try to do is just go over here. It's before the color right here. What I want to do is I wanted to read the string and then, okay, let's try it again. I think it's better that way. Let's try to see it because it's really hard to work from here. Okay, let me just do that. Okay, it's done uploading. So let me try to go right here. Let me just say red. Okay, there we go. There's an instance of red right here. Before it runs through it.
Let me forget about the no line ending right here. Let me focus on the red right here. There we go. Can you see it? The red has a what right here? It has a space. Can you see this? It's like writing it as what? The problem here is like it's right equivalent of writing it as what? As a red, and then maybe you're putting a new line right here. You're giving it a space. It looks like this because it has what? They said again, it has a space next to it. So obviously, this red is not equal to what? It's not equal to what? To the red we have again on the code right here. The red we have here. It's not equal to that. What also could be happening is it could be doing this. It could be saying is, you know what? It prints red in a new line. All right, it prints red in a new line. It prints red in a new line. Either it's a space or it's a new line because I cannot extract that information right now. It can be a red or it can be a what? A new line right here at the end. At the very end, there's a new line. It's creating a new line here. Okay, so let's see if it is a new line or just a space so that we can adjust it to what? We can adjust our red right here, the string that we have to, again, compare it to. So what I'm going to do right here, it's going to be, you know what? If it's a new line, I should print next to it. I should be printing something next to it. So let me just print something next to it. Print, not a new line. Let me just take off the new line right here. Let me just take off the new line from both codes. And if it's a new line, it should basically what? This one should be on its separate line again. So let me just print out maybe then say hello. Okay, hello or hello. There we go. Finish that. So basically, what should happen right now? If it's if it doesn't have any new line or space, what happens? Let's see what's gonna happen. The two scenarios. The first scenario is what? The set color what? Doesn't have any string. So basically, it's gonna appear as what? As red. By the way, for those of you who have a legacy version, it's gonna appear. It's gonna work for you guys. Okay, I'm gonna get back to you guys. So right here, red. Okay, it's gonna appear as red, or we're gonna be receiving what? We're gonna be receiving red with a space, as we saw on the serial monitor. It had a space when I selected on it, and then, or it might be a what? It might be a red, and it has a new line at the very end. It tries to make a what? A new line right here. Just write that. A new line. Okay, that's what it's trying to make. So how do I know if it's a new line or a space? I received the one that had what? Again, a space right here. How do I know it's a space or a new line? Obviously, what I do is, again, put a hello next to it. So if it doesn't have a new line, what's going to happen? There's a space right here. What it should give me? It should give me like red. And right here, say, after the space, say hello. Okay? But if it has a new line, on another line, we're supposed to be receiving what? Hello. On a new line, on a totally new line. So let's see what happens here. Let me just upload this again. So again, we might need to what? We might need to adjust. Again, this makes no sense. As I said again, it makes no sense why Arduino is doing this. But again, we just have to adjust. Okay? All right, there we go. Keep saying hello, hello, hello. Now let me try to say red right here. Look what happens. There's a red right here, and at the very end, look what happens right now. When I even go to the very edge, there's no space right here, but it pushes this to a new line. So what does this mean? This means that what? We're having a red that is attached to a new line. So basically, what does this mean is one thing that we have to know is what? When we're using print, what was it called? Read string, okay? When we're using serial.readString, one thing you always need to keep in mind is what? It prints out strings, okay? And it prints it out in what? Prints it out in a new line, okay? All right, those are the two things you want to know, okay? It prints it out in a string, and it prints it out in what? In a new line. One other thing too, it prints it out in a string. So one other thing I really want to show you guys is, all right, let me just remove this hello right here so that it becomes really easy to teach you guys this one. When I mean that it prints out everything in a string, I'm actually going to show you what I mean by that, okay? So right here, let me just, right here, okay? If I write down 10, and if I print it out, what's going to happen is it's going to give me a version of this. So what I have right here, what I gave Arduino is what? The number, what did I give it? The number 10. I gave it the number. It's a number 10. Wait, let me go back. Gave it the number 10. What did Arduino give me? What Arduino printed, again, what Arduino, again, set serial, sorry, there we go. What color right here? What was my variable? The Arduino set color again. What did it set the variable again to? Is, listen, it set it to a stringed 10. Okay, a 10 inside of a what? Inside of a string. So what does this basically mean? Okay, one thing I want you to understand here is it looks quite the same. Don't you look at it? It doesn't look quite the same, but it does not behave the same. Why is that so? Because if I said right here, if I said 10 right here, let me just say 10 plus 5 and just, write it down and let me just compile it. Okay, I'm not going to upload it, but just compile it right here. I'm not going to have any sort of error. But if I just do a string version 10 right here, okay, a string 10, and try to add it up with 5, if I add it up at 5, it doesn't seem like there's a problem, but if I print it right here, okay, let me just print it, print this, and then a new line. Actually, I should be printing it in a new line. Let me just print this in a new line. Let's see what happens. Let me just verify it, and then let's upload it. Let's see what happens when I add up the string 10 with 5. Okay, so as soon as I open my serial monitor, it says conf where is already connected. Okay, let me just get back here. Let me try to unplug my Arduino. And then let me plug it back in. Okay, now I think it should be working. Let me just try to upload it. Okay, it's done compiling, and I think it should be uploading by now. Okay. So when I go to my serial monitor, I should be getting what? I want to see what happens when we add up 10 and then 5. So let's see what happens when we add up 10 and 5. It's not printing anything. Now, let me just see if it's even capable of printing something. Let me just say, hello, world. Okay? Let's just say that. Let me try to upload it. Take off my serial monitor. And it's done uploading. Okay. It's not, okay, there we go. Give us hello world. There we go. So what I'm going to do is, you know what? I think it's not going to add it up. Let's see 10 right here. And I think it's capable of adding it up. Let me just go right here. And let me just verify it. And this, okay, it's done compiling. Let me just upload it. Hopefully we don't go into an error. Alright, nice. Now let's see what happens. We're still not receiving anything. Can you see it? You're not receiving anything. But basically what happens is we cannot add what? We cannot add, can you see, we cannot add strings to what? To numbers. Have you ever thought of adding up a number to a text? I don't think it's even physically possible, you know? We cannot even do it theoretically. It's not possible, obviously. It's what? Does not obey the law of math. Obviously, we cannot do what? We cannot add a text to what? To a number. So basically, we cannot add a string to what? To a number. But if I say 10 plus 5 right here, 10 plus 5, and let me try to verify it, and let me just try to upload it. There we go. How about now? Let me try to upload it. It's done compiling, and it's uploading. All right, it's done uploading. There you go. It starts to give me what? The number 15. The number 15. The number 15. 10 plus 5 is what? 15. So that's one thing I want you guys to keep in mind. Okay? So when you're working with again, those serial.read strings, what do? Their name even gives us away. What do? They always convert anything. They print out strings. Every time what they do, they always what? When they store values, they what? They put them in strings. And what they do? They print it out in a what? In a new line. Okay? All right. So one thing you need to know before actually, you know, working with this, before actually finishing up is what? We need to make it, so we need to create a new line character. We need a new line character so that it matches what? This one right here, right? Because right here, set color is what? Set color is not only what? We said it's a string. What does it also have? It has a new line. It has a new line. Okay? So it's not going to be equal to, it's not going to be exactly equal to what? To red. Again, if it was a human being, it would have understood, obviously, it would have understood that these things are equal, But when it comes to computers, again, they take it what? They take it literally. So it has to be literally equal. If it's not literally equal, it's not going to take it. If I said red like this with a space is equal to red, it's going to give me the output of what? It's going to give me the output of false. Okay, it's going to say it's false. It's not true. But obviously, if it was a human, what would they say? They would say it is true. Obviously, us, we can account for mistakes. But computers, again, they take it what? Too literally. So with that in mind, how do we represent the new line character is the big question. This one represents a space. Then how do we represent a new line? Well, if you go and Google right here, just Google it right here. If you go to /n, okay, /n Arduino new line. If you just say Arduino new line, it literally starts with a what? With a \n. Can you see it? It says /n. There we go. /n. Okay, that's one thing I want you guys to understand. /n. So what you're going to be using is a backslash. So it's going to be beneath your backspace or above your enter key. So there's a backslash and there's a /. Okay, don't use the one that is what? A /. Use the one that is what? A backslash. Okay, so even though let's say you do not have that character even on a keyboard, let's say for example using an old keyboard and you do not have that character, what you're going to do is just say backslash. Say backslash. If you just find the backslash, all you have to do is copy it from here. There we go. You can do is what? Copy it from here. Again, you guys can see right here, the backslash is right around here. Okay? So even if you cannot find it, all you have to do is what? Copy this and paste it. Okay? Anyways, so you represent it with a backslash and an N. Okay? N stands for what? For new line. Okay? So let me go over here and let's try to upload it. Finally, let's try to upload it. And now I hope everything should be working because we went through lots of errors in this section. So, okay, let's go to our serial monitor right now. And let's see, and let's write down red. And finally, it lights up what? It finally lights up as what? It finally lights up as red. There we go. It finally lights up as red. Okay? So that's one thing. That's a very, very complicated thing. But let me explain to you guys why this is the case, okay? So let me go over right here. So for those of you who are using an Arduino version, older version, by the way, but an older version, those legacy versions that are 1.8, you're not going to go through this error. It's going to work for you perfectly fine, okay? So if you just say red, set color is equals to red, it's going to perfectly work, okay? But after the ones that are using the newest Arduino, right now at the current time of filming, I'm using an Arduino, let me just go right here. The version is at the very top. I'm using 2.1. There we go, 2.1.0. So if you're using something around the 2 series right here, the Arduino 2 point something series, okay, what's going to happen is what? You're going to have to use the new line, okay? You're going to have to use the what? The new line character, okay? So for those of you who had, again, an older version, the legacy version, which is 1.8, you guys only need to do is what? You guys only need to write it down as a normal string. But for those of you, there's what? There's the addition of what? There's the addition of new line every time. So what does this mean, by the way? One other analogy we can use is actually a good example would be print serial.print and serial.what? Serial.println. All right? Println. What did we do when we were using serial.print? This basically means what? It prints it out and it's next to each other. That's what happened. When it comes to println, what it did was it just printed the serial first. It was just a combination of what? It was a combination of basically serial what? .print, and we added what? At the very end, we added the character what? With the backslash right here again. Backslashes are important, not the /, \n. With the what? With the new line character. That's basically it. Serial println was what? Serial print added with what? With the what? With the backslash and what? Character. Basically meaning a what? A new line. Okay? That's all I want you guys to keep in mind. Alright. So, right here we just only added red. So let's add a few more colors. I think this is going to be the most exciting section of the course because we went through a lot of errors before even getting close to here. So let me just remove all these codes that are unnecessary. All right, there we go. Let's just improve our code right here. Okay, So what else can I use right here? What can I say? If else or else if. Again, let me go right here. And what did I say? We used if else, if else, if else, if else again. All right. So how do we write down that in Arduino? Let me just check that out. Say else if Arduino. Let me just go over to an Arduino again. You always have to what? You always have to read documentation. There's if, there's else, and there's what? Else if. Okay? So the naming is different when it comes towards what type of language we're using, but it's an if else, or you can call it an else if. It's again preference. You can call it if else or else if. But you have to write it down as else if when it comes to what? To Arduino. There we go. We have to write it down as what? Else if. I teach this as if else because I use a different language to code, and it's written down as if else in another language. Okay? Another coding language. But right here, we have to write it down as else if. All right. So what I have to do is right here is say, okay, this is not red. What I want it to be is what it is. All right. I want it to what? Let's set up, let's say this time, let's set up, cyan actually. I want to set up cyan. I really want to set up cyan. Obviously give it a new line right here. And then after giving a condition, obviously what do I want to do? Now I want to do the analog, right? Red pin for cyan, I don't know what it is. After first what? Google it. So let me say cyan RGB value. The RGB value of cyan is what? Red of 0, green of 100, and the blue of 100. Okay, so let's just do that. So let me go right here. Red of what? 0. Green of what? 100. Let me just go analog right. Green pin. Let's give it 100 value. And then what? Analog right of what? Green. Sorry, red, blue of what? 100 right here. And let's set it up. Okay, so I want to upload it. Let me just turn off my serial monitor right here. And I think this is good. All right, this is good. Let's go to our serial monitor right here. Okay, we're going to upload it right now. And should be working good. Let me just try to see right now. Let me just see red for now. There we go. How about cyan? There we go. Changes to cyan. Hopefully you guys can see it. Let me just see if you can see it. Somewhat what? Greenish type of blue. Again, if you can see it. Looks beautiful. Then you can add more colors too. You can again add pink. You can add what? Purple. It's up to you again. Add your favorite colors. This is going to be a project. Add 3 or 4 of your favorite colors. And then fully create what I just did right here. Okay? I just want you to do that. That's all you have to do. Okay. So anyways, this was a bit of a longer section, a bit of a bigger project. We finished it. It was a success. So anyways, see you in the next section.
Okay, so let's go to this section. So right now, what we're going to be discussing about today is LED displays. So the 7-segment LED displays. So this is going to be our first time in this course working with some sort of display. Okay, so this display, I think you're familiar with it, as in we use it in digital watches, not only digital watches, but calculators. And even when it comes to, let's say we're going to a gas station to, again, fuel up our car, we can see what? We can see the price per gallon stated by these type of displays, and even the total price being what? Displayed on what? By using these type of displays. So we see them very, very often. So what are their use? Their use is we use them when we want to what? When we want to only get numbers or alpha numerals. These are capable of what? Only displaying alpha numerals and numbers. So for example, we have LCD screen when it comes towards our laptops, our devices and all that. They have a dedicated display. But what if you need a very cheap display that is supposed to only, indicate number or sometimes letter? So in this case, the effective solution is going to be what? Having these cheap LED displays. Again, they are very, very little. Not only that too, but they're very, very cheap. Okay. So when we're using, again, when we don't want these smart LCD displays, to use them on devices that are unnecessary. When they're unnecessary, we use what? We use LED displays. So right here, we're going to be using it. So right here, one thing you need to understand is when it comes to LED displays, right here, when you go over, there's a specific number associated with your specific what? With your specific manufacturer. Basically, the type of what? The type of LED display, 7-segment LED display. So before doing anything, what you first must do is literally go here, okay, Google the name right here. Say right now mine is 5611AS. Okay, you have to go to my, let me just go over to my screen right now. So before running anything, first thing we need to do is Google 5611AS. This is again my number. You Google your own number. 7-segment display data sheet. Okay. Once you do that, go towards the link that has PDF, or you can go over and get the website. Check it for yourself. Okay. So I'm right here, and one of the things you can see what the size. You can see the emitting color. It's going to be red. Some of them are blue, but most of them are red. And it has a common cathode. I'm going to get to this. And it's obviously a single digit. And it gives me all the information I need on what? On this LED display, the 7-segment LED display. Okay. So right here, you might be wondering, why do we call it a 7-segment LED display? So let me just go over right here. And when you just read this, when you just look at the 7 components right here, let me just focus on the 7-segment LED display. When you look at this, when you count this, let me just actually use a pointer. Get my Sharpie right here. When you look at this, when you count this, it has 7 segments counted. If you count it, there's 1, 2, 3, 4. Let me just focus my camera on the LED display. 5, 6, 7. There are 7. Okay, and it also has a decimal point. My one has a decimal point. Yours might not have a decimal point included, but most of them do. Okay, so it's going to vary, as I said, from kit to kit. So again, know your number and read your sheet. Okay, so before moving forward, I just want to declare something called common cathode and common anode. So they come in two, again, they might seem the same, as I said. Looks can be very deceptive. They seem exactly the same, but they function, again, entirely differently. Okay, so there are going to be 2 types of what? LED 7-segment displays. So these are going to be common cathodes and then common anodes. Okay, so right here, let me just go to my documentation, to my screen. When I do that, it says that it's a what? It's a common cathode. Mine is a common cathode. So what does this mean? So let me go right here and try to explain it for you guys with this image. Okay, a common cathode means is that there are different, as you can see, all the segments. The 7 segments are right here. There are 7 segments, and then the decimal point right here. And what basically happens is what? They are connected to what? To a single common cathode. Okay, they're connected to a single what? Cathode. So you can see they're individually right here. They have their own individual pins, as you can see. Let me just go over right here and show you on my camera. They have their own what? Just focus on there we go. They have their own pins. As you can see right here, they have their own pins. Okay? And then what happens is inside, they're connected to what? They're connected to a common cathode. That's why they're called what? Common cathode 7-segment LED displays. Okay? When it comes to the common anode, it's exactly the same thing. Okay? It's exactly the same thing. What happens is what? It's connected to a what? It's connected to a common anode. Okay, this time you might not know what anode and cathode means, but cathode basically means negatively charged. Anode means what? Positively charged. So to actually give you guys a meaningful sentence, what I'm going to do is draw a simple circuit as we usually do. Let me just do that. The longer side is the positive, as we know. The shorter side is the negative. And let me just draw that. Okay, then once I'm done drawing it, there's a positive side and there's the negative side. The positive side is what? The 5 volt. Keep attention. And the negative side is what? Negative side is where? The G and D. Okay, so when we say we have a common cathode, what do we mean? We have a common G and D pin. Okay, So for example, in my case, it's a common cathode. I am going to have what? I'm going to need only one GND because why? They have it all in common. So it's connected together. So again, they're connected together at the very end, and they have what? One common what? One common GND pin. When it comes to the anode, it's going to have what? One connected 5-volt pin. Okay? So I'm going to try to go over both of them, both common anode and both common cathode. So you don't have to go through any other videos. You can just follow along this course. Okay. So let's get started. So let me just bring this right here. Let me just put it. And what I'm going to need you to Google is, right here, go to 7-segment LED display. Write it down, 7-segment LED display. Right here, once you do that, go to your Google Images, okay? And they show you the equivalent what? The equivalent pin. So let me just go over to this one. This one looks better. This one provides a more detailed image. There we go. So what can you see right here? It says GFAB, basically indicating which segment it's gonna what? It's going to light up, okay? So G indicates what? This one. So the first one that is at the very, very left, right here, at the very, very left is what? The very, very left is what? It's G. Then the next one is F. And the ones that are marked with, again, an underscore, a hyphen, you can see right here, are the common grounds, okay? They're the ones that are going to be what? Those are going to be GND, if it's a common cathode, and 5-volt if it's a common anode, okay? I just want you to keep that in mind. And A and B, and there's ED, C, and also DP right here. Okay, so with that in mind, let me just try to light up my common cathode LED. Let me just do that. Let me just bring my LED right here. What do I need? I need resistance right here. By the way, it's recommended that you use 500 to 1000 ohms of resistance, okay? So 500 to 1000 ohms of resistance. The resistance is going to be applied to who? The resistance is going to be applied to every individual pin, okay? Except for the what? For the common anode or for the common cathode, okay? Except for the common cathode and common anode, we're not going to apply the, as I said again, we're not going to apply the resistance, but where we're going to apply it is, we're going to be applying it to every individual what? Segment, okay? Let's just keep that in mind. Okay, so let me just do that and bring this, oh, just threw a resistor. I'll try to find it later. Anyways, so right here, when I go to the screen again, it's going to be my guide. Okay, the G is located at the very, very what? At the very, very left. Let me just again unplug my Arduino so I can get it closer. And all I need to do is what? Connect the G right here. Just go over right here so you can see it. I'm going to connect the G. And then I have a wire. Let me just get a wire right here. Okay. I have a wire right here. Okay. But first, let me connect the common one. What do I have? I'm using what? A common cathode. So it's going to have what? When I'm using a common cathode, it has what? It has a common GND. Let me just connect that. The GND is found in the third leg. So let me just do that. So let me bring a black pin for the GND. Let me bring a black pin right here. Count 1, 2, 3. And here we go. There we go. Connect this to the GND. Let me just do that. And what I'm going to connect it to is a what? I'm going to be connecting it to a pin right here. Let me just connect it to 5-volt for now, just to show you how it works. But I'm going to be connecting it to a pin when we're working with a project. So just to show you how it works, let me just connect it to a 5-volt. There we go. Connected it to a 5-volt. And now, what do I expect? The G to what? To light up. The G is found in the middle. It's the middle segment. It's the middle segment, so I expect this to light up. Okay, the resistor should be intact. I'm using a 1000 ohm resistor. You guys can use anything between 500 and 1000 ohms. And this should be working, hopefully. Okay, can you see that? Can you see that? What's happened? The common cathode is right, but what happened was, what did I do wrong? I got the decimal point light up instead of what? Instead of the G. What did I do wrong? What I did was I flipped it. Okay? What I did was what? I flipped it. I was supposed to put it like this. I was supposed to flip this like this. The decimal should be here, and then put it down like this. First, let me unplug my Arduino, because again, I don't want to get the pins wrong. Right, I think, there we go. That should be it. Excuse me. All right, so now let me just plug back the Arduino. There we go. Now it's working. Let me just turn off the light so you can see it better. There we go. The middle segment is lighting up. Nice. So now let's just go to the ones who have common anode. Let's see how you guys can actually do it. Let me just check that. And in the next section, we're actually going to build a project with it. So let me just go over to my screen again, because I don't have my own. I don't have, let's go to my Tinkercad right here. Specifically, I don't have an anode, a common anode, 7-segment LED display. So I'm going to have to use a digital Arduino. Let me just create that. Okay, it's going good. Now what I'm going to need is an Arduino. Let me get an Arduino. There we go. What else do I need? A breadboard. I can get a small one for now. I'm just trying to light up a single display. And then we're going to go to our project. Okay, and then what do I need? I need a 7-segment. Let me just write it down. 7-segment. There we go, 7-segment. Am I getting anything? Just 7-segment. There we go. 7-segment display. Okay, so I'm going to set it to a common anode right here, so you guys can actually see how it's done. So as I said again, a common anode, what do we have? Let me just bring back the paper. I'm not going to need this anymore. Let me just bring back the paper. Common anode, we're going to have a common 5-volt pin. Okay, so let me just connect the common one right here. So as I said again, we have one thing to always keep in mind, by the way. Let me just go to the image. Do we have the image? Okay, there we go. All we have to do is connect one of these, again, common ports, okay? One of these. We don't have to connect both of them, okay? We don't have to connect one 5-volt and another 5-volt. All we have to do is connect one of them, okay? All you need to do is connect one 5-volt or one 5-volt. When it comes to a common anode, when it comes to a common cathode, what you need to do is connect one common GND, not like 2 GNDs, all right? So you can choose either one and just connect it, okay? All right, so with that in mind, all you need to do is I'm going to connect the 5-volt right here to the third leg. The third one is here, the common. There we go. Once I'm done doing that, I'm going to use a resistance on the GND. Let me just get a resistance. Let me just get a resistor. Resistor. There we go. Got a resistor. What value? 1 kilo ohm, basically meaning 1000 ohm. Let me just rotate it. Let me just rotate it so that it fits me. Let me try to light up a different segment here. Let me just try to light up this one. I don't know what this one is. It's B. Which one is B? Let me just see which one is B. Okay, so I'm going to be lighting up this part. I'm going to be lighting up the right one. The right upper one. The right upper one. Okay, so let me just go here. And I'm going to need I'm going to be using what? I'm not going to be using GND. Don't get that wrong, okay? I'm not going to be using GND. I'm going to be using digital pins. Yes, I can use a GND for now. Let me just try to use a GND for now. Let's see what happens. I've never used the GND with that. Yeah, let me just land it on GND. Let's see what happens, actually. I think it should light up. There we go. It lights up. As you can see, it lights up. So we're going to do again. So right now what we did is, again, light up a common anode and a common cathode. So for those of you, again, we're going to follow along with the common anode. I'm also going to, again, provide you with the course right here. So you guys do not need to, again, go to another YouTube video or another documentation to understand, because I'm going to be covering both common anode and common cathode. Okay, so in the next section, we're actually going to build a project. So see you then. Okay, so what do I want to do for this project? What I want to do for this project is build somewhat of a simple timer. So I want it to count from 9 all the way up to 0. So I want it to go 9, 8, 7, 6, 5, 4, 3, 2, 1, and end it at 0. Okay, so we just want to build somewhat of a personal timer. Okay, so first, how we do that? So first, what do we need to do? We need to plug all the components here. Obviously, we did not plug any components, and then we're going to go over to code. So let's first plug our components, okay? So, again, as I said, the third one is what? The third one is the common ground here. For me, it's a common cathode, so I'm going to be using a common GND, okay? That's all we said. All right, so let me just get this over with. Let me just bring this. There we go. So instead of using normal wires, what I'm going to be using is strapped-on wires that are strapped to each other. So when you look at them, they're strapped to each other. It makes things way easier for me, as all I need to do is connect it continuously, and then what? And then all I have to do is connect it continuously here too. So it's going to be way easier than using, again, normal wires. Okay, than using normal wires. But if you don't have any of these strapped type of wires, the normal wires are perfectly fine. They don't make any difference in terms of conductivity or anything. The only reason I'm using them is I want to introduce new components too. Not only that too, but it makes it way easier, because once I put them right here, let's say I set up the 5 pins that I'm supposed to be connecting here. Once I set up the 5 pins right here, all I need to do is see it relatively from here. So I go brown is first. Okay, brown is here, and and go right here. Brown is here, and then relatively tell the distance from here. I don't have to go the whole way back here just to tell which pin is connected to which pin. So it makes it way easier, especially when connecting when connecting wires that are closely to each other. Right here, I have 5 pins to connect to. Just check it right here. 5 pins, right? I've got 5 pins to connect to right here, and 5 pins from here too. Okay, so let me just get started. So let me just arrange this so that it matches the color. There we go. Right. Seems to... Okay, purple needs to be in the middle right here. All right, there we go. Simple arrangement. Now, you can get started. So let me just start with brown right here. All right. What did I do wrong right here? I forgot to put my resistors first. Resistors do what? They come first, okay? So obviously I have to connect my resistors first, and then I'm going to be connecting my wires. So let me bring my resistors right here. Again, I'm using 1000 ohm resistors. Okay, I have a collection of them, 1000 ohm resistors. But again, you guys can obviously use anything between 500 to 1000. Okay, so it doesn't directly have to be 1000. Okay. So let me just put this here. What I'm going to do is I'm going to move the resistors across. Okay, that's what I'm going to try to do right here. There we go. Try to move it across. Now let's connect the first one right here. Just focus here. There we go. It's connected. Now I keep on bringing resistors first. Let me connect all the resistors, and then I'm gonna continue and connect it to the wires. Let me just do that. Okay, there. You see what I did right here? I connected the second pin, but obviously they ended up in the same row. So all I need to do is, again, widen it a bit, and there we go. Aim for it. Okay, I pushed it a bit. There we go. Come on. It's a bit of a hustle to actually connect them when you have a little amount of space. Okay, so it did connect. Yep, it did connect right here. All right, nice. Now I'm going to bring another resistor. Let me try to find the one that is wider. Let me just widen it up myself. All right. Now the third one, what am I going to do to the third pin? As we said, again, when you look at the diagram, we have 2 common pins. All right, we have 2 common pins. This is the third pin right here. It's going to be the common one. The third pin right here. Just point it to, using my resistor. It's going to be what? The common. The same goes here too. It's going to be the common. So again, when it comes to the common, I'm not going to use any resistance. I'm going to be only using resistance for what? For the separate segments here. All the segments. So let me skip the third one. And go to the fourth one. Okay, you need to be really careful not to connect the wrong pin, the wrong resistor to the wrong place. Everything can go wrong once you plug your Arduino, if you don't be careful. Okay. Wait, slowly. Let me widen this a bit. All right, there we go. Now let me just check it. Okay, when you look at here, I connected 1, 2, I skipped a third. Now the 4th is connected, and the 5th is connected, and all of them are not in the similar. They're not in the same row. I just want to keep that there. I don't want them to be in the same row. Okay. All right, they're not in the same row. Now, I can start using, again, these pins. So let me just do that. Just go here. It's a bit of a hard one. When you're picking it, the breadboard up, it's really hard. All right, there we go. Connecting to the first resistor here. And then the next color is white. Let me go get white. Okay, I need to go here. All right, the third color is silver. Let me get silver. Okay, let me just see that you guys can actually see it. There we go. Can you guys see it? There we go. Connect the third one. And the 4th resistor. The 4th and the final resistor from this side. Alright, connect this one. Obviously, what did I not do right now? I did not connect my GND pins. So let me go over right here. Okay. Let me go over. Where's my GND pin? Let me just bring a separate wire for GND. Okay. I'm just going to bring a separate wire. It would be preferred if I, again, bring a black one because we use black wires to connect GND. Just to maintain the code, if I can, if I have a long black wire. I'm trying to look for one. Okay, there are no long black wires, so I'm just going to use blue. I cannot find it. Right, did. Okay, I think this one is long. Okay, there we go. Found a black long wire. So I'm going to connect the GND. Let me just do that. It's supposed to be 1, 2. It's supposed to be right here. Okay, it's a bit of a hustle again. Let me connect this to the GND. We have a common ground pin. Just connect it to it. Alright. There we go. Connected it to GND. Alright. Now, obviously we have our wires from the other side. Now, I don't have enough space here. As you can see, I only have one row of space right here. I have one column of space. Because I said again, this LED is big. So what I'm going to be doing is, creatively, I think a creative idea is to use a smaller breadboard. So I'm going to be connecting it with the resistor across here, and then I'm going to be using a smaller breadboard and connecting it here. It's better that way. So let me just do that. So let me forget about these wires right now. Just put them right here. Let me just make sure that I have the numbers intact. It has numbers on it, so I'm going to be referencing the numbers right here on the breadboard. Let me just bring it closer so you can see it. There you go. They have numbers. 1, 2, 3. And I want to, again, reference this one. Okay. So let me just do that. Just take off this one for a moment. It's a bit of a hard one. Okay. Connected our first resistor. Then our second resistor. We're not going to be using the common, as I said again. We're going to be using one of the common pins. So as I said again, we have two common pins. And we have two common pins. But we're going to be using only one, okay? So you either can use this one, or you either can use this one. You don't use both of them. So right here, I'm going to skip it. I'm not going to touch any of it. Okay, I already connected the GND from this side, so I don't need to connect it from this side. So the third pin is going to be skipped totally. Okay, now let me go to the fourth one. The fourth line right here. All right, I have to push it a bit. They're a bit hard resistors to put in. Let me first just straighten it out myself. Okay, just make it straight. Let me focus on the resistor for now. Let me bring it closer and actually focus on the resistor. There we go. Now what I'm going to do is straighten it out. Once I'm done straightening it out, I'm just going to do is bend it. Okay, there we go. Bend it. There we go. Now let's focus on putting it back in. Because as I said again, the resistors, they do not fit in properly sometimes. And it can be a bit of a problem. This did not fit the best. I think it's going to cause me problems. But I think it fits. Actually, I think it fits, but it might cause me problems in the after a bit while. So let me just bring my final resistor, connect it. Okay. I'm gonna connect the 5th line to the 5th pin. There we go. Can you see it? I connect the 5th one. I cannot pick it up, as I said again, because the resistors are gonna fall apart. So I'm just gonna move it very, very slowly to the middle, so you guys can see the frame. All right, there we go. Just need to be very careful with it. Okay, now I'm gonna be connecting just blue wires. As you can see, I don't have enough length to go here. So what I'm gonna do is just gonna move this totally. So what I'm gonna do is from purple to blue, there's a difference in, so I have to change my direction. So what I'm gonna do is wrap it more. Can you see this? I'm just gonna separate it. It can be separated. There we go. Slowly. Can you see me? I'm separating it. I don't want to separate it completely. If I do that, then it's gonna be useless. There we go. So that it has more space. I want to move a bit of the resistors. I don't want them to move that much. There we go. We got our first. Then we need our second. What comes after blue? Green. All right. Let's use the green. There we go. Third one is going to be orange. Or actually yellow. Yellow's the next one, not orange. I can see it I can see the colors from here. So it has to be, after green has to be orange. Sorry, yellow. So I'm gonna bring yellow, not orange. See that? Well, that's why it's very useful. It helps me again. Okay, I'm gonna skip the 3rd pin and go to the 4th one. It's very useful because I can just reference it from here. They're attached. So when I'm using a lot of pins, I can just, when they're put next to each other, I can use this type of wires, because they make wiring way much easier. Because if I just wired them with this normal, again, wires, I'm going to come back here, check everything, track back everything like this, and then see where they're connected, and it's going to be a bit of a hustle. Okay, so I connected these 4. I skipped the 3rd one, and I connected the 4th. All right, good. I don't want to move it too much. It's moving a lot. I don't like that. Not a big fan of it moving. The resistors don't seem to be holding them in place because they're weak. Oh, wait, it seems to be moving a lot. Okay, so what I'm going to do is separate the wires again. I think the wires are just having a lot of tension on them. But actually, I can keep it like this, to be honest. Because, yeah, I can keep it like this. If everything is intact, let me just check it. Everything seems to be intact, so I can keep it like this, actually. But I just need to be careful when I move the wires again, when I flip this. We'll just slowly flip it. Ooh, it's moving a lot. Alright, I'm just going to try to flip it. Alright, let me just connect it to some random pin so that it holds together. I'm going to come back and solve this. I'm just going to connect it to some random pins again. Obviously, don't turn your Arduino while you're doing this. It's dangerous. You can just short the circuit right here. I just connected it so that, again, it just moves. Okay, I just connected it randomly. All right, just make sure that your Arduino is not turned on when you do that. Okay, so right here, let me just think of the pins that I'm going to be using. I'm going to be using digital pins, okay? Because I said again, I'm going to be using digital right here. I'm going to be using digital right. So I'm going to be using digital pins. So I'm going to need to use this side. Sorry, this is where my digital pins are. So I'm going to be using the digital pins. So again, slowly. It doesn't seem to be holding the best. Wait. Let me just put these right here so that it doesn't move a lot. I'm not going to be using them, but again, just so that it doesn't move a lot and holds it in place. Okay. There we go. All right. So let me go over to the other side. It's a bit of a hustle. Let's go over to the other side and now try to use these pins. So I connected what? Purple pin. So I need to get my purple pin first. Purple pins, black pins, all of these that are here. I need to first pick them up, hold this together. Okay, so let me start with the black pin. I'm just going to start from digital pin 3. okay? You might be wondering why I'm using digital pin 3 instead of digital pin 1. Why not start with digital pin 1? You might be wondering. Well, the thing is, digital pin 1 and digital pin 0, they're also used in binary. So as most cases as possible, I try to leave them alone. Okay, I don't try to touch them as much as I can. But obviously you can use them for digital pins, but they're also used for binary. So I always, again, reserve them. So I just don't touch them, okay? Because just think of me filling up digital pins 0 and 1, and let's say I want to use binary. Then I'm going to have to arrange the whole thing again, okay? So I just leave them alone most of the time, but they work as a normal digital pin, okay? So again, you guys can actually use them. But it's just, again, not a practice. As much as you can, don't use them. If you have to, though, you can use them. They're perfectly fine to be used. Let me start with digital pin 2. Digital pin 3, sorry. I said digital pin 3. It is hard to even see it. Digital pin 3. There we go. After black, what comes after black? White. Digital pin 4. Then, what comes after white? Gray. I'm trying to get the gray. There we go. And then after gray comes purple. There we go. Then afterwards, after purple comes blue, which is right here. Let me go get it. Then after purple comes green. Let me just make sure that I don't skip anything. There we go. Got yellow. Then at the final one, I have what? I have brown. Obviously, discluding the, again, the GND or the common pins, I have what pins? How many pins to connect? I had 10 pins to connect, and again, disregarding 2 common pins, it's going to be 8 pins. So let me just count this if I'm correct. 1, 2, 3, 4, 5, 6, 7, 8. So I connected 8 pins. Let me just make sure the yellow is connected properly. There we go. And now everything is connected. Again, I just need to be more careful. Okay. Again, I'm using these as a support. They're not connected to anything. Just keep that in mind. Don't want to move them a bit. I have to move them a bit. All right, I'm not going to touch it afterwards. There we go. Let me just bring my Arduino wire. Well, plugged it. Oh, there we go. I'm just getting my Arduino wire. Let me wire up my Arduino. Just bring the wire. Let me just keep it here. Okay. It was a bit of a hustle to, again, even connect it. Okay. So now let's start writing down the pins. Let's start giving them names. Okay. Let's begin. So, go right here. And start giving them names. Okay. So, the first pin that we're going to be giving out name to is pin 3. First things first, again, we need to understand what part is going to be lighting up. Okay, so let me first, I'm going to need what? I'm going to need the diagram. Just get the diagram. I'd say 7-segment LED display. Let's go to images and we should find a diagram that has, there we go. We find a diagram that has what? Their namings. Okay, so let me start from here, the very most left. From here, from this side, it's going to be what? The very most left side is what? It's going to be the black one, the black wire. The black wire is connected to what? To pin number 3. Okay? It's connected to pin number 3. What is it? Decimal point. So what I'm going to say here is integer DP. What is it? It's pin number 3. Integer. What else is there? And keep comparing them. So what I'm going to do is actually, there we go. Divide them into 2 right here so you guys can actually see them. Let me just get the image. Let me just get the image. The full image. Let me just open the image. Open the image. New tab. Let's get the whole image. There we go. All right. So now, what did I connect? The decimal point. Then afterwards is white. Pin white is connected to what? To pin number 4. Which is, what is it? It's C. So all you need to do is what? C is equals to pin number 4. Then integer again. Keep saying that. Then we skipped it. And then we went to what? We went to the silver one, which is going to be D.
So D is set to what? Pin 5. It's going to be easy afterwards. E set to what? Pin 6, because they're set to what? Next to each other. Okay, then afterwards, what I need to do is, we're done with this row. So I need to go to the other one. We need to go to this side. So we're going to need to check this one too. Okay, so the blue starts at the very left. The blue starts from here. As you can see, the blue starts from here. It's connected to the very left. Okay, the next after purple is what? Is blue. So it's going to go after 6, it's going to be 7. So this one is going to be 7. Okay, so the very left, again, you need to keep referencing what? The decimal point is how you're going to be referencing it. Okay, so let's look at the image. So is it going to be what? It's going to be pin what? Segment what? Segment B. It's going to be segment B. What is it set to? Pin 7. So keep going on. And then A set to what? 8. And then afterwards, again, we skip the third one, the common pin. And then we go to F, which is going to be set to pin 9. And again, the final one, G, is set to what? It's set to pin 10. So let's even see if it ends on pin 10 and starts at pin 3. Let me just look at it. It's a bit of a harder one. If you cannot move your Arduino, it's really hard to actually look at it. Okay, we have pin 12, 11. Okay. It's really hard to actually get a hold of these. Let me just look at it. So again, let's see if I made a mistake or not. Let me just move it slowly. It says that I stopped at pin 9, not pin 10. Might have made a mistake here. We connected 4 pins here and 4 pins here. How much should it add up to? I'm supposed to be using what? 8 pins. Okay? How many integers did I set up? 8 integers. I'm correct on this one. Did I start from 3 or 2? Maybe I might have started from 2. Let me just check it. It is connected to pin. Is it connected to pin 3 or pin 2? It's connected to pin 3. I'm checking it and it's connected to pin 3, pin 4, 5, 6, 7, 8, 9. And then it doesn't seem to be connected to pin 10. Did I forget about? Let me just check the number of pins that I connected here. Okay? So I think I made a mistake right here because it's supposed to be extending to pin 10 and it's not touching pin 10. So let me just count the number of pins here. 1, 2, 3, 4, 5, 6, 7. I'm supposed to be connecting 8 pins. So I did a mistake right here. I made a mistake right here. What could it be? I made a simple mistake most likely. So let me just check again. All I need to do is what? Since they're what? Since, as I said again, they're connected pins, it's going to be really easy when I make a mistake. So let me just check it right here. So I connected, I did not connect the green pin because I'm sure I connected, okay, there we go. I connected green pin, but I did not connect green pin. So what did I do? I connected brown pin here instead of green. Ooh, which is so wrong again. Let me just, all I need to do is check it. So let me just check the colors. I connected black and then white and then gray, which makes sense. And then purple, if I'm correct. There we go, connected purple. And then blue and then yellow, blue and then yellow. But I forgot about green in the middle right here. I'm not supposed to be what? Connecting green right here. I'm supposed to be connecting green, not yellow. Oh, I made a mistake right here. That happens. We'll just try to solve it. There we go. Made a simple mistake, but it was easy to solve. Why is that so? I'm using attached pins. That's why they're very, very important. As things get complicated, it's going to be really, really hard to fix them. It would have taken me at least 10 minutes to even find the problem if I was using normal pins. But with just using this pins, I just made it really, really easy. Okay. And then what? After green comes yellow. Now, am I correct again? Did I make another mistake? Okay. Now, it's connected what? How many pins? 1, 2, 3, 4, 5, 6, 7. And then I have an orange pin. Did I connect an orange pin here? Yes, I did, but I connected it to what?
Ooh. Instead of connecting this one, see what I did wrong here? Instead of connecting an orange pin, I connected a brown pin here. The brown is the very, very edge. I'm not supposed to do that again. So I made a mistake here. Let me just solve that. Remove the brown. And what is next to yellow? It's orange. I'm supposed to be connecting orange. I made a mistake. My bad. And there we go. Now I fix it. And now I also connect the orange from this side. Okay. Now everything seems to go. Okay, everything seems to be right. All right, let me just, again, connect these two pins so that they hold the small breadboard together. I'm just going to connect it here so that it does not move a lot. Again, they have no purpose other than holding the breadboard, the red and the brown pin. Okay, so now I think the wiring is right. And now I set up what? Everything, the name is right. It extends to what? To 10, from 2 to 10. So everything seems to be correct. So I said 2, I meant 3. 3 to 10. So everything seems to be right. So now, let me go over to my code. And now let me just go to pin mode. And set everything up. Pin mode. Set everything up. So we have decimal point. Set it to what? Set it to output. All right. Keep copying this. Alternate shift down. Keep copying it. And then I can do what? I can change the names. So I'm going to start with C, D, E. Let me just go C. And then there's D. And then there's what? There's E. And then there's B. Just go to B. And then there's what? And then there's A. And then there's F. And then there's G. Okay, let me just remove the final one. Let me just count the pins. They're supposed to be 8. 1, 2, let me just count it. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pins, okay. Good. Now what do I need to do? To light up everything, I'm gonna need to do is what? Use digital right. Okay? And set my pin right here. Let me just start again. The decimal pin. And set it to high. Once I'm done with that, to light every component right now, what do I need to do? Again, I'm going to need to write the digital right. I'm going to need to copy it. It's going to be second, 2, 3, 4, 5, 6, 7, 8. Okay. Now, where do I go? Now let me write them down. C, D, E, C, D, E, and then after E there's B, A, F, and then finally G. There we go. So now let's just upload it. Well, before I need to upload it though, what do I need to do? I need to wire up my Arduino. So I'm gonna move this again slowly. It's gonna be a bit of a hustle because if things go wrong right now and the resistors go wrong, it's gonna be really, really sad. Because the amount of what wiring it took. Gonna attach both and slowly move it again. You need to be gentle, very, very gentle, because this resistors again can just pop out. Really, just push it a bit. Okay. Now let's just try to turn on our Arduino. Okay, now let's just verify our sketch. Let's do that. Verify my sketch. Hopefully everything's good. Okay, it's good. Now what? Now I can compile it. It's compiling. And now it's done uploading. Okay. Can you see it? It's not fully lit up. I just need to move this a bit. Okay? I'm just going to move it a bit so you can see it. The wires. There we go. Let me just focus on them. Let me just turn off the one light right here so you can focus at it. Not everything is turned on. Why is that so? Just the resistors again. Let me just, if I touch one resistor right here, look at it. If I just touch one resistor, lights up. It's because the resistors are not connected properly. Okay? So let me just, again, push the resistors a bit. There we go. Push this one in. This one is pushed in properly. Everything seems to be intact here. All right. Okay, let me just check the other resistors right now. Oh, there we go. Can you see it? The second resistor is not connected properly. Slowly. We need to go slow. Just push it. Okay, there we go. How about this one? The G pin, I think, is the very left one because I put it at the very edge. It's not lighting up. Okay, this pin. Right, there we go. Let's push this. It's a bit of a hustle. Let me try to push in this one. And what is not lighting up? What segment is not lighting up right now? Okay, this segment is because of this resistor. Okay, this resistor seems to be working fine. How about this resistor? Okay, both of them. Okay, I see. So again, wiring it up is a big problem in of itself, especially with these resistors. They don't hold in place, and I find it really hard. Can you see that? Okay, so they're not holding in place. So what I'm going to do is, again, fix the resistors. This resistor, let me just see if this is even correct, because not all of them are on. Just, again, so you can see that not all of them are on. So for those of you who are using a digital Arduino, it's going to be really easy for you guys. It's going to be way easier than here. Again, due to the limitation we have, again, in components, we're going to have to find a way to work around it. Okay, everything seems to be working fine, but the middle pin right here. Let me just check what is even the name of the pin. Let's check the name of the pin. Okay, so let me go to my Chrome. The middle pin is the G pin. Okay, where is the G pin? Which one is connected to the middle pin? How am I supposed to know that? Let me again check the image. G is supposed to be around here. Okay, G is around here. G is at the very edge. The very edge, but the resistor at the very edge is not working, basically. Let me just check if even if it's wired up correctly. I just need to remove this. It's not doing much of a thing. Slowly. Okay, let me just again straighten out the resistor. Hopefully you can see it. Let me just bring my light on. Make a focus on the resistor. The focus is bad. I'm just gonna straighten out my resistor. I'm just focused on the LED right now. Okay, straighten it out. There we go. Now I'm gonna have to carefully put it back in. Just again, a hustle. Let's do that. Oh, I see the problem here too. I did not push it in. Let me just push in my LED. Just push it in first. There we go. Now it's pushed in. Our LED is pushed in. Only what? Only one line is not. Only one line is missed right here. I can turn off my light so you can see it better. Only one line is not appearing. What is it? It's the line F, which is going to be next to what? Next to G. So the resistor next to G is not lighting up properly. Let me just check why it's not lighting up properly. I'm just turning on my light right here. It's a bit of a hustle, as I said again. Ooh, I see what the problem is. There we go. Push it in and then slowly let go. Slowly let go. Let me just turn off both lights so we can see what we did right here. It looks beautiful. Okay. Turn it off. And turn it off. Let me just turn off the other one. There we go. Now everything is lighting up, including the what? The decimal point. Alright, nice. Okay. Let me just go right here and do exactly what I just did. I'm going to light up 2-3 pins on the common anode. I'm using a common cathode, so I'm going to show you guys how to do it in a common anode, just in case you do not know. Okay? So let me just go right here. This is a common anode, as I said. So just turn this off. Let me just take this off. Let me delete this first. Where's the delete button? There we go. Let me just first create it, and then there we go. Delete this.
delete the resistor. So basically what you do is what? We have a common what? We have a common, this is a common anode. So what do? We have a common what? We have a common 5 volt. So what I'm going to do right here is connect the 5 volt right here, the common 5 volt to the third pin. Again, I can use the one that is at the bottom right here, or I can use the one at the top. It's up to me. There we go. Now once I'm done connecting the 5 volt, I'm just give it a color right here so that it's easier to track again. Okay, just change the color right here to red. There we go. The 5 volt. And now I'm going to start connecting what? I'm going to start connecting using resistors. So let me just connect let me slide up 1, 2, 3 segments, and then I'm sure that you can do the rest of it. Okay, I'm sure that you can light up the rest of it. So let me just go right here. It has a resistance of 1 kilo ohms. Okay, basically 1,000 ohms. And now let me just rotate it. Just rotate it right now. Okay. So you might be wondering how to turn it on using a digital pin. All we did was what? Use the 5 volt and the ground pin. So I'm just going to show you guys how to use a digital pin and just light it up. Okay. You can get another resistor here. Let me just light up this part too. Okay. Just rotate it. Right. There we go. Let me start writing code for this. So before doing that, actually, I need to what? I need to connect the wires. So I'm going to connect this wire right here to digital pin 3. Let me start from pin 3. Just give this another color. Let me start with the orange. There we go. And let's give this another color too. First, connect this to digital pin 4. There we go. Give it another color so you can see it way better. I'm just going to zoom in so you can see the circuit way better. Okay. There you go. That's the circuit that I'm going to be using. You can pause the video and check it for yourself. Okay. All right. Now let me just go to the code. So what you need to do is basically the opposite when it comes to what? When it comes to the common what? The common cathode. Okay. So I'm going to go to text. Yeah, I'm going to use text. So what I'm going to do is, let me just again set up variables. I want you to do it yourself for those who have common anode. I'm sure you guys can do it. Just have to follow the same step, but there's going to be a difference. I'm just going to show you the difference here. Okay. That's basically what you need to do. Let me just bring the 7 segment, where is it? The 7 segment image. I'm going to be connecting B right here. Just see it. It's going to be, let me just take off the code for now. I'm going to be connecting B, and from underneath here, I'm going to be connecting what? I'm going to be connecting the decimal point. Okay, let me connect the decimal point and B. Where is B? B is around here. So I'm going to be lighting this and this up. Okay. So let me go to our code. Then what? Let me just turn off all this code right here. I don't want that. So I'm gonna say B. What pin is it? It's pin 3. Let's connect the digital pin 3. And what do we have? Decimal point. It's gonna be connected to what? To what? The digital pin 4. Then what I need you to do is what? Right here, set it up as we did normally. Set it up. Pin mode. Set B to what? The output. Just get the capitalization right. Pin mode. Set the decimal point 2 to what? To output. Output. There we go. And all you need to do right here is, instead of using digital right again, we're going to be using digital right and setting it to high. What you're going to be setting it to is low. Okay, we're going to be setting it to what? To low. Basically almost acting like a what? It's going to act like a GND pin. Okay, so I'm going to do decimal point and setting it to low. Let me set it again. So let me just start the simulation right here. And let's just move our code. And there you go. B and decimal point is what? They're activated. So what I want you to do again, to light up everything, is what? Again, connect all these components yourself, just like how I did using my common cathode. Again, connect it. And then write every code. Obviously, for common anode, you're going to be using what? You're going to be setting it to low. Okay? That's all you need to do. Instead of high, you're going to be setting it to what? To low. Okay. So just keep that in mind. So now what I did is what? What I did is set it up to what? To light up everything. So to even make a timer right now, let me go over to my Arduino IDE. Let me go to my Arduino IDE. There we go. So now what do I need to do? I want to set it to what? I want it to count from 9, then go to 8, then go to 7, 6, 5, 4, 3, 2, 1, and then finally going to what? To 0. Okay? That's what I wanted to do. So again, I turned all of this just to check that everything is connected. I turned off everything to high just to see that they're connected. And now they're successfully connected because everything is on. I just wanted to check if everything is on so that does not cause me problems later on. Okay. Oh, I just turned off the pin mode. Sorry. I was supposed to delete the high ones. I accidentally cut this. Sorry, I just put it back. I want to do is what? Take off the digital rights, not the pin mode. Pin mode I needed. Oh, it's a bit of hardware. There we go. There we go. Now, for 9, what do we need to light up? For 9, we need to light up what? So let me start from here. I just copied this, okay? Okay, I want you to do is what? Before cutting this, okay? I want you to copy it again, that I set it all of it to high. I want you to copy it, and I turn it off right here. What I want you to do is for 9, what segments do we want to light up? So let me go over right here. We want to light up what? We want to light up, where is 9? There we go. For 9, we're going to need to light up what? A, B, G, C, and D. A, B, G, C, and D. So what I'm going to do right here is bring a paper. I think it's going to make it way easier. Let's first write it down. I think it's better that way. So I'm just bring a paper right here. I need some paper. Just go get it. There we go. All right, there we go. Found the paper right here. Let me go get my Sharpie. Where's the Sharpie? There you go. Found my Sharpie. I don't want to push this a lot, so let me just slowly move it because I need that space. Oh my God, it's very, 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 very hard. Just moved it a bit, and the pin B just turned off. There we go. Just push it back in. Okay, there we go. Okay, so for 9, what do I need? What do I need to turn on for 9? Let me just keep writing this. For 9, what do I need to turn on? I need to turn on A, B, G, C, D. So I need to turn on A, B, G, C, and D. Let me just make sure again, A, B, G, C, D. All right. For 8, what do I need to turn on? For 8, I need to turn on everything. Everything from what? From A to G. I'm going to need to turn on all of it. I can add the decimal point, but I don't need to. All right. So for 7 right here, what do I need to turn on? I need to turn on A, B, C. A, B, C. Yeah, A, B, C. For 7, then 6. Let me write the numbers down first. It's easier that way. 1. Then end it to 0. Okay, for 6, what do I need to turn on? A, F, G. Let me first go A, F, J, A, F, G, and then E, C, D. E, C, D. Basically turn on everything except for B. Then go to number 5. What do I need to turn on? I need to turn on A, F, G, A, F, G, A, F, G, and then C, D. Just write that down, C, D. For number 4, what do I need to turn on? For number 4, I need to turn on F, G, B. Just write that down, F, G, B, and then I need to turn on what? C. That's what I need to turn on, C. Then for number 3, I did not write down number 3 properly. There we go. For number 3, what do I need to turn on? A, B, G, A, B, G, and then C and D. Let me just check it again. A, B, G, C, and D. Yeah. C and D. For number 2, what do I need to turn on? I need to turn on A, B, G, E, A, B, basically G, and then an E. A, B, G, E, and then finally a D. Okay, for number 1, what do I need to turn on? I think number 1 is the easiest one. I can either turn on BC or FE. I'm just going to go to BC. I'm going to choose BC. There you go. And then finally for number 0, what do I need to turn on? Everything except for G. Let me just write that down. Everything.
everything except for G. Okay, there we go. Okay, so that's all I need to turn on. So let me start turning this on. Okay, so let's go back again to our Arduino code, Arduino IDE, and now let's start. Let me just write here number 9. For number 9, what do I need to turn on? Again, I'm going to copy paste this again. What I'm going to need to turn on is what? The decimal point. I can remove the decimal point. I don't need to turn it on. I can remove the decimal point. Okay. What do I need to turn on? A, B, G, and C and D. So I'm going to leave C. I'm going to leave D. I'm not going to leave E. I'm going to leave B and A. That's it. That's all I need to turn on, except for what? G. Okay, there we go. So I'm going to remove F and G. There we go. So this is for what? For number 9. How about for number 8? Just write down number 8. Number 8. For number 8, what do I need to turn on? Again, paste this first. And then I'm going to need to remove decimal point. And then I'm going to turn on everything from A to G. So I'm not going to touch anything. Everything's from A to G is already ready. There we go. And then for number 7, okay, what do I need to turn on for number 7? A, B, and then C. Okay? A, B, and then C. Okay, for number 7. Let me go to my clipboard right here. Control V. Just go here and just say Windows and V. Just go to my clipboard. I forgot about this. I accidentally, there we go. Again, copy this again and just turn it off. I can paste it. There we go. So now what? I'm going to turn off decimal point. And then what do I need to turn off? Everything except for ABC. Okay, so I'm going to turn this off, turn this off, turn this off, and this off. So let me just check how my code goes until here. Let me just check it. So let's just try to upload it. It's compiling. And then it's done uploading. What did I do wrong right here? It doesn't even look like any number right here. It doesn't even look like a number. Looks like a 6, an inverted 9 from my perspective. For you guys, it most likely looks like 6, which is way wrong. Just so wrong right here. There is a problem now. Okay. So what I need to do right here is what? Give it a delay. I forgot a delay. Oh, so let me just give a variable right here. Let me say delay time. I'm going to set it to second. I want it every second, so I want it to decrease every second. So I'm going to give it a delay between every number. That's what I need to do. So let's see how it progresses. So delay time. Just give that. Keep writing delay time for every number. Delay. I'm going to give it a delay of what? Delay time. Delay time. There we go. End it with a semicolon at the very end. Put a semicolon. And then finally, give this to a delay time. Delay of what? A delay time. Delay time. There we go. Delay time. And then let's set it up. Okay. Now let's see what happens. I gave all of them a delay time. Let's just see what happens again. Let me just try to go again. That seems so wrong, doesn't it? It seems so wrong. What could we have possibly done wrong? Let me try to again turn on everything first. Okay, so let me just try to go right here. And then at the very end, I want to do is turn on everything. Let me just try to do that. So what did I do wrong here? I do not know. Let's turn this off. What did I do wrong? Oh, I forgot the curly bracket right here at the very end of our loop code. What did I do wrong? Let me just turn off this one. Just put it down here. What did I do wrong? I think everything seems fine. So let me just see if everything's even coiled up properly. So if everything is even what? It's even, the resistors might be a problem. So let me just check if the resistors are the problem here. Let me try to find my, there we go. Finally, I'm going to set it to all of it to high so we can actually see it ourselves.
Is it the resistors that are making a problem right here again? Or are they the, is it our code? Let me just check. Might be our resistors. Let me just turn off the light so you can see way better. Okay, when I finally turned it to what? Off it to high, everything seems fine. What could we have done wrong then? Okay, we don't even see 9 at first. Did we see 9 first? Number 9, did we see 9 properly? So we got C, D, B, A, and G. Let me give the delay time. Let's give it more time. Let me see. 3 seconds. Every 3 seconds. Why is that so? Because I want to see where the error arises, okay? Where the error starts. So let me look here. Even the 9 is not correct. And then I changed the number. Okay. So what could I have done wrong here is what? What I believe we could have done wrong here is naming it while we're naming the variables. So, again, I made a mistake. It happens, as I said again. But right now, I can, again, check it what? Relatively. That's the best part of it. You can check it what? Relatively. So let me go over here, and let me bring my diagram. Again, I went through another mistake. Again, it happens. But right here, there's a black wire. The black is connected to what? To pin 2. What does the black indicate? The black indicates what? Decimal point, right? Yeah, the black is the one that's connected to the closest one. If I'm correct. Yes, the resistor goes here, and then it's connected to this one. So it's connected to the closest one. So the black goes what? To the what? To the decimal point. Am I correct? It goes to the what? To the decimal point. All right, let's connect decimal point. What did I give it? It's pin what? It's pin what? It's the first pin. It's pin what? We start from pin 3. So this should be correct. Okay? This should be correct. And then let's go to the white one. The white one seems to be connected to the other one. Let me just, again, keep checking on the wires. Just going to keep on doing that. Okay. I see the problem. I think I see the problem right here. Okay. No, actually, I don't. Everything seems correct. All right. Oh, yeah, everything seems to be correct. The first is connected to here. The second is there. The third is there. The silver one. The silver is next to the purple, which makes sense. Did I get anything wrong? Let me just put it side by side again. Just put this side by side. Okay, that's all I need to do. I'm going to need to set it up side by side. And there's pin E and there's pin D. What could be our problem? Okay, set pin E to what? Set it up by number, decimal point, and then C, and then D, and then E, and then, wait, after E, I set to E. Okay, there we go, I'm correct. I set it to E. And then I start to the other side. What could be the problem right here? What could be the problem? So I want this to finally light up as what? As a 9. So one problem that I did, one problem there is, let me show you one problem there is, right here, is what? One problem that there is that I keep forgetting to do what? I keep to give it low. Right here, what happens is, look, C and D are already set to high, okay? When we're going to number 9, C, D, B, A are set to high, as I said. They're going to be set to high. And then when it comes to number 7, and again, G is set to high too, okay? Wait, is G supposed to be set to high? It's not. I forgot about G right here. Let me fix G up. So, let's fix G up. And then C, okay, all of it are set to high. Okay, C, D, B, A are set to high. And then what happens here is what? We only want A to G to be set to high. No problem, okay? Everything what is set to high. That makes sense. But the problem starts here. What is the problem right here? Can you see the problem? C, and then B, and then A. Can you see it? C, B, A are the only ones that are supposed to be set to high. But we already set everything up to high. Can you see it? We set everything to what? To high. This is where the problem starts, okay? So we set everything already up to high. And then we only want to set this to what? To high. So we have to what? Technically, what do we have to do? We have to turn everything low before what? Moving into the next one. Because right here, I set everything from A to G to what? To high already. And then when I go right here, from C, B, and A, I only want them to be set to high. Other ones, they're going to be set to what? To low. Well, what I want right here is what? What happens is what? Quite the opposite. Okay? So what happens is quite the opposite. So everything's already set to high, and when I try to set this high again, it doesn't make any difference. That's what's happened. Okay? So I need to do is what? I need to go over to my code right here. Again, hopefully I have everything intact. Let me just get this right. Paste this. Oh wait, let me go to my clipboard again. There we go. Got everything right. Instead of removing them, what I'm going to be doing is what? I'm going to be setting them to what? To low. Okay, the ones that I don't want, I'm going to be setting them to what? To low. A, B, G, C, D. So we need C, we need D, we need what? We need what? We need E. We don't need E, so what do? I set it to low, okay? Because it's going to affect the next number that we're going to what? We're going to be touching. So we're going to set this again to high or low. We cannot just remove it. Okay, so this was already set to high. Okay, A is supposed to be set to high. We're not going to be using F, so we're going to be setting it to low. And then, how about G? Okay, G is supposed to be set to high too. All right, so we're not going to touch it. So let's try to upload it right now. Let's even see if we can even see 9 as a number. So let's just try to open it. We cannot see what? Okay, you see that? For the first seconds, what happens is what? You don't see the whole thing light up. We see 1, 2, 3, 4 LED segments light up. How many LED segments should be lighting up? 1, 2, 3, 4, 5. Let me just check my code again. 5 segments should be set to high. 1, 2, 3, 4, and 5. What could be the problem? I generally don't know what the problem is. So I think what I'm going to do right here is, instead of wasting time, is I'm going to try to figure out the problem out myself. And then I'm going to come back here and try to solve it for you.
Okay, so I was about to re-record the whole section, but I made what I made was a very simple. I made 2 very simple mistakes. The first one being is that the resistors right here are touching. So let me just move it right here. And these 2 resistors were touching each other. All right. So basically what happened was, when these 2 resistors touch each other, they started to what? They started basically to fuse, as if they were just acting as one resistor. So basically it was not working on its own. Okay, these 2 resistors. That was the problem that I just made. So there's a good chance that the code is working for you. So right here, that's the first mistake right here. Okay. And the second mistake here is, when we're using 9, okay, we need to also turn on F. Okay, we also need to turn on what? F. All right. That's just one thing you have to keep in mind. Let me just show you guys where F is. There we go. We need to turn on F, which is supposed to be around here. Okay, so with that in mind, what I should be doing right here is what? Set this to high. That's our first mistake. Solved it. I untangled the resistor right here. I untangled them myself. Okay, so it should be working properly right now. I just separated them. And one thing we need to finally do is what? We need to finally write down the whole code of this. Obviously, I did not do that for this one. Let me just do that. Let me go here. Let me just copy actually number 8, because all of it is set to high. So it's going to be easy. We need to copy the whole thing, not just part by part. Let me just do that, copy that, just paste it here. Wait, I took it off. I deleted number 8. Let me just leave it there. Copy that, and then I'm going to paste it here. Supposed to remove number 7 here. All right, there we go. This should be paste. There we go. Number 7, paste. Let me just give it a space right here. Just so you can, again, have more space. There we go. Now what I need to do is, right here, is what? What is supposed to be set to high? A, B, C. So other than A, B, C, everything's supposed to be set to low. Just keep on doing that. Let me turn on caps lock. And there we go. Low. A, B, C are supposed to be set to high, so I'm going to leave this one and this one to low. And then finally G to low. So now let's just check and upload it. Okay, should be compiling. And it's working perfectly fine now. Okay. And it's working perfectly fine. It counts to 7. That's good. It goes back to 9, 8, 7. Let me just change your angle so you guys can actually see it from the right spot. Let me just do that. There we go. Let me just put it right here. There we go. Let me turn off phone light so you can see it way better. Now you can see it from a good angle. Now it's going 9, 8, 7. Okay, the delay time is big, so let me just change it to, it's set to, let me just check it, 3000 milliseconds, basically 3 seconds. I'm going to set it to what? 1000 milliseconds. Basically what? A second. Okay, so what we're going to do right now is write down the whole number. So let me just write down, we're on number what? Number 6. Number 6. What do we need to do for number 6? Again, I'm just going to paste this code right here. For number 6, A, F, G, E, C, D need to be turned on. So basically B needs to be turned off. What else? Yeah, basically B needs to be turned off. That's, I think, all that is supposed to be turned off. There we go. So B needs to be what? Turned off. So B set to low for number 6. All right. Now, once we're done with that, I'm just going to set this up to what? Number 5. Paste the code again. So for this case, 1 needs to be turned off, B, and then E. B and E needs to be turned off. Low. And then for E2, it's going to go low. Let me just check it again. A, B. Okay, A. Okay, B is going to be turned off because it's not here. Then there's C, there's D. E needs to be turned off. And then F. And then there's G. So I'm not going to touch that. So let's just check it out right now. Actually, let's upload it. Let me write till that time. Let me just write down number 4. Okay, it's going 7, 6, 5. Okay, let's write down. There we go. Okay, I went to number 5. Now let's write down number 4. That's all we need to do. Let me just write down number 4. All right, go to digital. Oh, I just need to do is paste the code again. 1 needs to be turned off right now. A needs to be turned off. Let me just turn off A first. Turn off A. No, I need to turn on caps lock. There we go. Turn A off. How about B? B needs to be turned on. C needs to be turned on. D needs to be turned off. Let's go to D and turn it off. Okay, how about E? In this case, E needs to be turned off too. Let's go to E. How about F? F needs to be turned on. And then G needs to be turned on. So I'm going to leave it like that. Okay. And then again, keep on doing this for number 3. Paste that. And what needs to be turned on for C? Okay, A, B, G, and C, D. Okay, so basically E needs to be turned off. Okay, D is turned on. E and F needs to be turned off. So let's go to E and F and turn them off. Low and F to low. Okay. Afterwards, let me go to number 2. Number 2. Paste that. For number 2, 1 needs to be turned off, C, and then what? D needs to be turned on, so E, then F. Okay, so basically what? C and F needs to be turned off. So let's go to C and F and turn them off. Let me turn them to what? To low. Okay. F needs to be turned low. Again, for those of you who are using a cathode pin, you're going to be exactly doing what the opposite of what I'm doing. If you want to turn off something, obviously what you got to do is what? You're going to set it to high. When you want to turn off something. When you want to turn on something, you set it to what? To low. I think you guys know that. All right. Let me just keep that in mind. And let's move to number 1. Number 1. It's number 2 right here. Number 1. Paste that. And what do I need to do? For number 1, only B and C need to be turned on. So most of it is going to be what? To low. Okay, B and C need to be turned on. Just go here. How about E? Low. B and C. Okay, I'm going to leave B. I'm going to go to A. Turn that low. And F. And G. What is left? Only zeros left. So let me write down number 0. Number 0. And paste that. 1 needs to be turned off for number 0. Everything is on except for what? Except for G. So only G is going to be what? Set to low. One final thing I want to do on number 0 is I want to add the decimal point because we've not been using it. So I want to add the decimal points. And what I'm going to do is a decimal point and set it to what? To high. Okay. So if I'm setting this to high, what do I need to do? As soon as this is set to high, after it goes to 1 round, it's going to keep it high because I've never mentioned decimal point here. So what do I need to do? I think I wrote it down myself, but what you need to do is what? You need to set it to low. Okay? You need to set what? The decimal point to low. If I just don't do that right here, and let me just upload it. I just removed it for now. Let's see what happens. Okay. So 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, the decimal point, you see that? The decimal point after another round, once I set it to high, Again, on number 0, when it reaches number 0, I set the decimal point to high. It's gonna what? Continue on being high as long as I don't write the code to what? To keep it on low. So I have to write down the code to keep it on low. I cannot just what? Neglect it. Okay, so let me just do that. And let's upload it right now. Okay. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, the decimal point, and then the decimal point turns off. There we go. Now we created our own timer. Okay, so this is as far as we go on the LED. I think we're done with this one, so see you in the next section. Okay, so in this section, we're going to discuss about 4-digit 7-segment LED displays. So far we've worked with a normal 7-segment LED display, but now we're going to work with one that has a 4 digits. Okay, so one thing that you notice right here that is off a bit is when you look at the 4-digit 7-segment LED display is that it only has, as you can see right here, it has 6 pins. Right here, it has 6 pins. So totally it has only 12 pins. Okay, when you look at here, when we think of 7 segments again, how many pins do we have for each segment right here? We had almost what? We have 8 segments, so we have 8 pins for segments, and then we had 2 pins for the common. As you can see right here, we have 5 pins and 5 pins, so totally we have 10 pins. So how much pins did we expect right here? We expected how many pins? We had 8 pins, again, 8 segments here. So we're going to be expecting how many pins? We're going to be expecting 8 times 4, which is going to be 32. And then we expected 2 common pins, which is going to add it up to a total of, what, 34. But, obviously, our Arduino only has how many digital pins? Let me just unplug my Arduino so you can see it closely. If you look at my Arduino Nano right here, it has around 13 digital pins. It goes to digital pin number 12 right here. And then there's digital pin number 13 at the very edge. Can you see that? Even let's say we're trying to use our analog pins, we only have how many pins? We only have 7 analog pins here. Okay? So right here, even if we add it up, we're not going to have enough space for 34 pins. So right here, they use a very, very simple, yet a very genius way of designing it in such a way that it only needs 12 pins, basically 2 more than just our normal, 7-segment LED display. So let's see how this works. Okay, let me just plug my, again, 7-segment LED display. It's very familiar to the LED display we have here, okay? The 4-digit one is very, very familiar to this one. Let me put it actually on the other side so it can actually be better. There we go. The focus isn't good. Wait, let me fix up the focus. Make it around here. There we go. Now it's better. So, now, the question is, what are these? What are these pins again? What are these pins? What do they represent? So let me go over to my screen right now so you can see it for yourselves. And when you look right here, there is what? There is D4, A, F, D3, D2, B, E, D, DP, C, G, and D1. So one thing that, again, you're familiar with are those A to G pins. So you're familiar with the segments A, F, B, E, D, DP, C, and G. But you're not familiar with these ones that are marked with the green, the D1, the D2, the D3, and the D4. So D1, D2, D3, D4 basically means is, right, I want you to keep this in mind, is D1 represents digit 1, D2 represents digit 2, and obviously digit D3 represents digit 3, and D4 represents digit 4. Okay, so the question is, what are these? These are, I want you to think of them, these D pins again, these digit pins, I want you to think of them as the common pins, okay? I want you to think of them as what? As the common pins, okay? So, again, right here, if it's a common anode and common cathode, they exist here too. We obviously had a common anode and common cathode when it came to the what? When it came to the 7-segment LED display, they are also exist here too. So they can be a common anode. When it comes to 4-digit one, they can be common anode or common cathode. Okay. So when it comes to D, again, these D pins, they act as a what? As a common pin. So when you want to turn on something, what basically happens is what? Let's say we want to turn on A on digit 4. If you want to turn on A on digit 4,
what do we do is we do what? We turn A, for example, let's say I'm using a common cathode for now. I'm using a common cathode. My pin is a common cathode. Okay. My 4-digit LED segment display is a common cathode. So I'm going to be using common cathodes as an example. So what should I do right here? A needs to be turned on to what? A needs to be turned on to high. Okay. The pin that is connected to, it's going to be turned to high. And then D4 is going to be what? Connected to the what? It's going to be connected to low. Basically acting as a what? As a ground. Basically, it's going to act as a 5-volt. And then there's a resistor right here on the segment, as every time we did, using the 7-segment LED display, the 1-digit 7-segment LED display. What we did was what? We always connected the resistors to the what? To the segment. We're still going to carry this rule, okay? So we're going to be connecting the resistor to the A pin. And then what we're going to do is what? We're going to turn on, again, we're going to use the D4 as a what? As a GND common pin. And what happens is what? We're going to turn on A. Where is A supposed to be? Let me just Google the 7-segment LED display. There's an image of where A should be. Okay, there we go. The A is right here. The A is right here at the top. So basically, we're going to turn on this part. This part. That is what we're going to turn on this segment. It's going to be at the digit 4. And what? It's going to be A. Okay. So let's try to, first things first, let's try to understand, how to connect these things. Okay. So let me just try to exactly do what I did right here. Okay. So right here, mine is a bit different again with the number. Okay. You're always going to check the number right here. Let me just unplug it for now. You're always going to check the number and then search for the data sheet. Okay. You're going to search the number right here. You're going to write the number and then say LED matrix and then what? And then search the data sheet again to just see this layout of how yours is going to be, because it's going to be different from the display to another. So from kit to kit, it's going to be different. So again, always keep that in mind. Okay. So right here, I already made myself a documentation right here. Okay. I'm going to show you guys how to actually make it. If you guys do not find the data sheet online, sometimes there might be cases where you don't find the data sheet online. I tried to Google mine. I put my number right here. I put my number right here and Googled for it, and then I could not find it. So what I basically had to do was write a documentation, a data sheet myself. So I'm going to show you how it's done. But for now, let's try to, again, focus on how these, again, 4-segment LED displays work. Okay, so right here, let me just get it as close as possible to the Arduino. Let's put it right here. Okay, so let me bring one resistor here. Let's just bring a resistor. Let's bring another wire right here. Mine is a common cathode. So what is the common pin right here? The common pin for me is what? The common pin is going to be those D pins. Let's say I want to light up digital pin number 1 here. I want to light up digital pin number 1. Okay, what do? I go to the very edge again. I kind of forgot to put the dot here. I only put 888 here. Let me put the dots here. Forgot the decimal point. There we go. Fixed it up right now. Okay, so what do? I literally put right here. This is going to turn on digital pin 1, as you can see. Sorry, I said it's going to turn on the digit number 1, the first digit, basically. And I want to turn on A in this one. So let me just go right here. But before connecting to a segment, what do? I always use my resistor. Let me just get my resistor right here. A 1000 ohm resistor. We're going to be using the same resistance when we were using in the 7-segment LED displays. Basically, this ones that have 1 digit. Okay, so let me just do that. Just try to turn on A. This should be easy. Okay, there we go. Moved it across. Let me just bring it closer so you can see it. Again, I connected this one right here. Oh, I think I jumped one. No, I jumped one. Actually, I'm not correct. There we go. Now it should be at A. As you can see, I connected it to A. All right, everything seems to be working nice now. And then I connect this one to the red. So obviously, what do I connect this one to? I'm going to be connecting this one to what? To the 5-volt, while I'm going to be connecting my common pin because it's a cathode. Again, it's a cathode. Since it's a common cathode, what am I going to be connecting it to? I'm going to be connecting it to GND. Let me just do that. Okay. Seems to have been connected. Let me just push it in. Just need to push it in a bit. And now let's try to light up our Arduino with that.
let's see what happens here. Okay, let me just touch my resistors. I'm not sure if the resistor is causing the problem right here. It's not lighting up. Let me just try to push it the whole way in. Nothing is lighting up right now. We're going through an error. Let's just see what happened right here. Again, let me just check my pins. Let's unplug my Arduino first. Let's check our pins. We've been connected into 5 volt. Alright, I connected the 5 volt to this one. Alright, nice. The GND. I connected the GND to this one, which is good. Let me just make sure. This is what? Digit 1. As you can see right here, this is digit 1. Let me just check if I connected it to the first digit. Yes, that makes sense. I connected to what? To a GND. Can you see it? I connected it to GND. And then afterwards, what did I do? And then, okay, I connected the resistor right here to an A. Connected the resistor right here to what? To an A. The A pin. So basically, what should have been lighting up? This one should be lighting up. This segment should be lighting up. This one right here should be lighting up. Okay. So everything I think should be working fine. Oh, there we go. Everything is fine. Now it's lighting up. Let me just turn off one light so we can see it better. Okay. And lower the light a bit. Let me give it a different color right here. There we go. And now I think you can see it way better. Let me try to focus at it. There we go. Now it's lighting up. Okay. So we just did that. But right now, the big problem again being here is, okay, I turned this one on. Let's say I want to turn on digit number 2. I want to work with digit number 2 now. I just wanted this to be on and I want to work with digit number 2. Okay, digit number 2 is what is again, as I'm using a common cathode, it's going to be connected to the GND. All right, where's the digit number 2 right here? Digit number 2 is after A. I'm going to have to jump, okay, a step, an F, and then go to D2. Let me just do that. So all I need to do is what? Go to D2 right here. What else I should do is what? I should be connecting it to what? To a resistor or not? I shouldn't be. Why is that so? I'm working with a what? With the common pin. When it comes to common pins, we don't connect it to resistors. But when it comes to individual segments, we connect it to what? We connect it to, again, resistors. So, okay, let me just skip one and go right here. Just did that. Can you see it? Let me just focus here. There we go. Skipped it. And now, where do I go? I go to the GND. Basically, I'm going to share this GND with this. Okay. There we go. As soon as I do that, can you see that? Let's try to, there we go. Get my resistor. Can you see it? One thing you notice is, okay, it seems to be working fine. Now let me just try to connect I want to turn on F2. I just want to turn on F, okay? There is a problem that's occurring, but let's just again go and let's connect it to F right now, and then we're going to talk about the problem of doing this. I'm just connected to an F right now. Okay, how do I connect it to an F? I'm going to need, again, a resistor right now because I'm lighting up what? An individual segment. All right, so I'm going to what? I'm going to need to connect it to an F. So where is it? It's around the middle. I have to go between these two. Yep, it's going to be a bit of a hard one. It's going to be a bit of a hardship to do, actually. All right, there we go. Connected it to an F, and then I'm going to need a wire. I'm going to need a long wire, actually, this time. I'm going to get the white wire. It's very long. There we go. What am I going to be connecting it to? To 5 volt, because I'm using a common cathode again. The individual segments will be connected to what? They'll be connected to the 5 volt. Let me just do that. They should be connected to the 5 volt. Just the resistors. Let me just check both the resistors. All right, there we go. Just touch the resistance right here. Can you see a problem with carrying? It's not consistent, as you can see it. It's not really consistent. What is the problem here? The first problem is, okay, the first problem being, let me just take off this one. Just take it off for now, so you can see it. The first problem was, there's not what? There's not enough power to turn on all these displays, okay? That is the first problem, okay? So as I said again, these, again, when we were putting our resistors, they were intended to what? They were intended for what? For one segment LED displays. They were intended for one segment what? LED displays. So basically we turned on, at maximum we turned on 8 segments here. Remember? At maximum we turned on 8 segments. Just think of them lighting up what? 8 LEDs here. But right now, we have how many segments? We have around 8 right here. 8. Basically, we have 32 segments. How are we going to light up 32 segments? Because it's going to require a lot of power. It's going to require more voltage than 5 volt, okay? So one thing we could have seen right here is when I put the F pin right here, when I tried to connect the F pin, everything blacked out. What happened basically was it did not have enough power to light up all of them. Okay, it did not have enough power to light up what? All of these segments again. Okay, that's one thing I just want you to keep in mind. It had no enough power to what? To light up two different digits. Okay, so right now, another problem is it starts copying the same thing. Can you see it? If I just put right here, A right here, it's going to light up both. Let's say I want to turn on 1. Let's say I want to represent the digit 1, 2. The problem here is what? Okay, I need to turn on this and this for number 1, and I'm going to need to turn on another type of what? Another type of segments for number 2. But right here, what happens is what? It copies the same segment. So when I light it up in this manner, what happens is what? It lights up what? It copies the same thing. It copies the same thing. So it's going to be what? It's going to be very, very horrible. You don't want it to be exactly the same. As I said again, let's say I want to turn on 1 right here, and once I want to turn on 2. They're going to be a problem right here. Let's say I turn on 2. Okay, I'm just going to add up these segments right here. Just fine. But when I want to turn on 1, what happens is what? I have to turn off this one. Okay, I have to turn off this one. So basically what happens is what? If I turn off this one, it's going to turn off from this one too. So they start what? Copying each other, which is going to be bad. Okay, so this is where the problem arises. Okay, this is problem number 1. The problem number 1 being what? It copies the same thing. And the second thing you can see is, if you focus again, is the what? The division of power is not very, very consistent. Look at it. Let me just turn off the light. Can you see it? One is very, very bright right here, and this one is very dim. Now just think of trying to light up 32 different segments here, which is going to be what? Almost impossible. It just even tapped out when we tried to connect it to an F. As you could have seen in the when I tried to connect to F right here, the F pin, what happened? It just tapped out. It couldn't do it. Basically, all of it turned off. Okay, so this is the second problem that we have here. Okay, so how are we supposed to light it up then? Well, one thing that you need to keep in mind is we are always supposed to light up. Let me just actually take off all of this. We're supposed to light up what? We're supposed to light up only 1 digit at a time. So we only can light up 1 digit at a time. So right here, if you look, let me go again to the image right here. If you go to the image right here, what you can see is what? A, F, B, all these segments are what? They're common to what? They're common to the D pins. The D pins are the ones that are specific right here. We have D1, we have D2, we have D3, we have D4. They're specific. While A, F, B, again, E, D, decimal point, C, and G, those segments right here, they're what? They're common. They're common to all of them. Okay? So one thing you can do is what? We can light up everything here from all the segments, but we can do it what? We're limited to what? We're limited to what? We're limited to 1 digit at a time. Okay? We're limited to what? To 1 digit at a time. So right here, when we do that, again, when we just think of, again, using the 1 digit LED matrix, it's going to work perfectly fine when we're using 1 digit. I just want you to think of them as what? As like 4, again, these 4 what? These 4 1 segment LED displays connected together, okay? Systematically, so that they have 12 pins. So I just want you to think of them as what? As 4, again, 4 1 digit 7 segment LED displays. Okay. So right here, again, if it was specific, if we had specific, if we had specific segments for all of them, it would be like A1, there will be A1. We'll have a different pin for A1. We're going to have A2. We're going to have A3. We're going to have A4. So basically, we're going to have a lot of pins, obviously. We cannot work with all these pins. So another problem arises while using this method too. The problem is, okay, I want you to keep this in mind. The problem is, okay, 1 digit at a time. Okay, 1 digit at a time. Okay, it works perfectly fine when we use 1 digit at a time. Let me to prove this again, let me just connect 3 pins using let's use digit 3 right here. And let's try to connect again, just 3 or 4 segments right here. Let me just do that so you guys can understand it. All right, let me just unplug this. Where's my digit number 3 right here? Digit number 3 is here. Let me just focus here. Digit number 3 is here. So it's going to be the one at the very edge. The one close next to the very edge. There we go. Let me just push. Let me first push this one so that it doesn't move a lot. There we go. But it's still visible. There we go. I'm lighting up what? A digit, so I don't need to use my resistor. I'm just going to connect it directly to what? I'm using a common cathode, as I said again. So I'm going to be connecting it to GND. The D pins are going to be connected to what? To the GND. I just want you to think of the digital pins, the D pins, the digit pins as what? I just want you to think of them as common pins. Again, they're marked with what? They're marked with the number of their respective digit that they light up. Okay, there we go. Connected it to what? I'm supposed to connect to GND. There we go. Connected it to the GND right now. Let me just focus here so you can see it way better. There we go. And now, what do I need to do? Let me just light up again one segment right here. I don't care that much, so okay, I'm just gonna light up B because it's close to it's very close to the digit number 3. All right, there we go. Now I'm just gonna need my wire. Let me just wire this up. Let me get my wire right here. Then I'm going to be connecting it to the 5 volt. I've got my resistance. All right, my resistance is check. Does it light up B? I think it lights up B. There we go. Let me just try to light up another one too, just for the sake of it. Let me bring another resistor. Let me just light up somewhere that is here. Just go right here. Can you see it? Hopefully you can. There we go. There we go. Should be around here. I'm going to connect this to 5 volt. Let me just light up 2. Why? I think 2 proves the point, so I don't need to light up more than 2. There we go. Okay, I need to push in the resistor. I'm just pushing this display and the resistor. Can you see it? Let me again turn off the light. When we again use one digit at a time, what happens is what? Can you see it? It lights up properly. There's no what? There's no when you see the power, division of power right there was uneven. Right here, it's even. Okay, as you see it right here, it's even. And then 2, I don't need to copy. It's not copying the same thing. But it raises again another problem. The problem with this method is using one digit at a time because it's intended to be used at what? As one digit at a time. So what happens here is the problem most people I think about right now is another problem is what? If we use one digit at a time, it destroys the purpose of what? It destroys the purpose of having a 4-digit LED display. Because right here, let's say we want to turn on, 1, 2, 3, 4 right here. I just touched the resistor. Okay, let's say we want to turn on 1, 2, 3, and 4 right here. We want to turn on 1, 2, 3, 4. We can't do that. If you're using what? If we're only using one digit at a time, basically what happens is what? What basically happens is what? We cannot turn on all of them at once. Well, one thing I want you guys to keep in mind is, okay, one thing I want you to keep in mind is that these things are very, very fast. I'm talking about these LEDs, our microcontrollers, computers are very, very fast. Okay, so let's say we want to turn on 1. What do we go? We go to digital pin 1, and then we turn on, again, 2 segments. We're going to turn on these 2 segments. Okay, we want to turn on, let's say 1. Okay, we want to turn on that. And let's say we go to digital, again, we're going to go to digital 2. We're going to turn this off. After we're done with it, we're going to turn it off. And digital pin 2, we're going to go to D2, connect D2 right here. And then we're going to light up all these segments. Again, the one that marks a 2. We're going to go right here and light up all these segments, right? So you might think that it's going to go really slow. We're going to see 1 right here, and then we're going to see 2. But it's going to happen very, very fast, okay? I'm talking in milliseconds. It's going to happen very, very fast in milliseconds that we're not going to notice 1 turning off, okay? We're not going to notice 1 turning off and then switching to 2. 1 turning off right here and then Arduino going here and lighting up 2. It's going to happen so fast that we're going to what? We're going to keep seeing 1 and then we're also going to keep what? Seeing 2 right here, okay? For our eyes, it's not what? It's not visible for us. So that's one thing I want you guys to keep in mind. We're going to be lighting up 1 digit at a time, but it's going to happen very, very fast that our eyes cannot what? Our eyes cannot notice it, okay? Our eyes cannot notice it so that what? So that we can basically what? Turn on all of these at once. So we can turn on all of these at once. So technically speaking, we're not turning all of these at once. We're turning this on. we're turning this off. Once we're done with this, we go to this one. And then once we're done with this, we go to this one. Once we're done with this, we go to this one. But it happens very, very, very fast that our eyes cannot notice what? This turning off, okay? These turning off, okay? The others turning off. It's going to happen very fast that all of them, for us, it's going to appear that all of them are what? All of them are on, and they're what? They're displaying what? They're displaying numbers, okay? That's one thing I want you guys to keep in mind. Okay, so right here, one final thing before moving on is, again, the problem here is what? Let me just turn on the lights. The problem I encountered myself was, okay, the problem I encountered myself was I could not find the documentation on my specified type of what? On my specified type of four-digit 7-segment LED displays. Okay, I could not find the specific data sheet. Okay, if you look at the image right now, when you look at the image, it's very, very different from my what? It's very, very different from the one that I have here. Almost everything's the same when it comes to segments right here. A, F, B, E, D, D, P, C, and G are the same, but the layout of the what? The digits is very different. Digit 1 right here is located at the very, very left for me, left top, while digit 4, in the image is digit 4. So again, how do we find, which digit is which, and how do we label them and write this down for ourselves? Because sometimes you might not find what? If you have a less popular type of code right here, you're not going to find what? You're not going to find your LED display data sheet. There's a lower chance of it because I did not find it myself. I've been looking around for like a good 20 minutes, 30 minutes, but I could not find any data sheet on my specified type of 4-digit 7-segment LED displays. So right here, what I did is, first things first, I wanted to know if it's a common anode or a common cathode. Okay, how do I know that? Let me just again begin from, let me just turn all of this off. Okay, let me just do that. How do I know that? How do I know that? Okay, how do I know that? What I did is what? Okay, I just assumed that's what? This is going to be the digit pin right here. And let me just assume this is the digit pin. Okay, I just again assume this is what? This is going to be a digit pin. I just started with this. And I started connecting it to what? I just assumed, again, you're gonna be doing it with trial and error, okay? You're gonna be using a method of what? Trial and error until we get one segment, okay? So right here, let me just again use this as a what? As a digital pin right here. I'm gonna be using it as a D pin. As a what? I'm just gonna assume this is a common cathode. So if this is a D pin, what is it gonna be? It's gonna be connected to GND. Connect to GND. All right, I'm gonna assume the other one, the next that is right there, as a segment again. So you're going to keep on trying until, again, you find the right one. Until you find one segment lights up. Okay? Let me just again assume this is a common, actually, you know what? This is a common cathode, but let me just assume this is a common anode for now. So to make things very easier for other people who have a common anode. So let me just show them right here. I'm going to be connecting this to the what? If it's a common anode, I'm going to be connecting to 5 volt. Let me just do that. And let me bring another pin. Again, I have my resistor. I'm just assuming this is what? This is a segment next to it. It's a segment. I'm just assuming that. Again, this is assumption until we basically what? Until we find when it's right. Always one thing you have to always keep in mind is what? We always have to light up again our what? We always have to use resistors, because if we try to connect one without any resistor, what's going to happen is when we're trying to find out which one's which, we're going to basically what? Fry our LEDs, our segments right here. We don't want to do that again. Okay, so just keep that in mind. Okay, it doesn't turn on. Okay, what I'm going to do is I'm going to be moving. I'm going to start moving, okay? I'm going to be starting to move my resistor to the other pins. I'm not going to change the common pin again. I'm just going to keep it like that. For now, I'm just assuming this is a D pin. Okay, I'm just going to keep doing it. Let me go to the other one right here. Let me focus actually here. There we go. I'm just going to keep doing it. It's not lighting up. Again, pushed it. Let me just push it again. Let's push it so you can see it. There we go. It's not lighting up. I'm just going to keep on moving the resistor again, one at a time to the next pin. Try to connect the other one. It's not lighting up. Okay, let me try the other one. Let me try a whole row before actually concluding, okay? So let me try at least one of these 6 pins before actually concluding. So, okay, let me just try to connect this one to the resistor. It's supposed to be here. Okay, it's not lighting up. So what could I possibly see right here? Either I did not connect it to a right digital pin right here. So, okay, I do not know if I connected it to what? To a normal D pin. I'm just going to assume this, again, a segment again. I'm just going to keep doing this until we find what? A correct answer. So let me just keep touching this again, changing it. Keep changing it. Okay, I reached the resistor point, so I'm not going to touch that. Again, there is a probability of finding it. Let me go to the other side right now. Now we have to find again, one of those digital pins are supposed to be here. One of them is supposed to be what? Digital pins right here. Just keep doing it. Keep doing it. It's not lighting up. Nothing is lighting up right here. Keep doing it. All right, I reached my end of this side. So basically what could happen is what? I reversed it. Basically it's a what? It could be a common what? A common cathode instead of what? A common anode right here. I tried it as a what? As a common anode. Okay. It's not a common what? It's not a common anode. So let me try a common cathode. So let me just reverse it. So right here, what do I need to do is again, set the D pins are supposed to be set to what? They're supposed to be set to GND. Let me just do that. Again, I'm going to be assuming this is what? I'm going to be assuming. Let me start actually from right here. Keep on. Let me just start from here. Because I know this is the D pin. I don't want to start from here. I just want to show you guys how you do it. Right now, since I already wrote it down again, I wrote down the documentation. All right, let me again go here, right here. Let me just again put a segment right here. And let me connect it to a what? To the 5 volt. Segment to the 5 volt. Segment to the 5 volt. Okay. Let me again push it a bit in so we can see it. There we go. Nothing is lighting up. Okay, maybe I have to move this again here. Let's see if it lights up. Where's the 5 volt? Did I get the GND right? I don't think I got the GND right. Wait. All right, there we go. Oh, I did not even connect this one to the proper resistor. I'm supposed to connect the same row. There we go. Can you see it? Oh, now it's lighting up. If I put it right here, it doesn't light up. But if I just put it here, it lights up. Okay, let's try to not find this one again. Let me just go over right here and let's try to find it again. Let me just try to what? My objective here is to at least try to find what? Try to light up one segment. That's my only objective here. As soon as I do that, it's going to be easy. Oh, what did I do wrong here? Let's keep on pushing it. Again, I'm just going to make sure the resistance is again intact. Ooh, now it's lighting up. So let me just say, okay, this light up. Let me just say, okay, this lit up. So how do I extract the information right here? Okay, this one that is right here. Okay, there's something right here. I'm just gonna again check it. It's the one at the very, very left. Okay, I'm just gonna draw this diagram right here before labeling it. Okay, let's just say I'm labeling it right now. Okay, wait, let me just hide this for now. Let me just hide this for now. There we go. Let me just draw this diagram again that looks like this and it shows the pins. So right here, it's lighting up a what? It's lighting up at the what? At the 4th digit. So what does this mean? This is the one at the very, very, again, at the very, very right. So this one is supposed to be what? This is supposed to be digital what? Sorry, I said digital. I meant digit number what? It's going to be digit number 4. It's the 4th digit. Okay, it's digit 4. All right, so this is what? This is going to be D4. That is right here. It's going to be what? I hooked it up to here. It's D4. What other information can we also extract? It's a common anode or a common cathode? It's a common cathode. Because why? The D pins are what? They're connected to what? To the GND. Okay? So they're what? They're basically what? They're basically common what? Common cathodes. Okay, we extracted this information. What else can we extract here? Can you see the segment right here? Let me go over to my image right here, to my screen, and when you look right here, A is at the very top. So what does this mean? The segment we connected right here. Okay, the segment we connected right here is what? The segment we connected right here is what? It's going to be what? It's A. So this is what, if you let's say, go here. Let me just go over here. There we go. The one that we connected right here is A. When you look at the resistance right here, the leg of the resistance is touching A. Can you see it? It's touching A. There we go. A. Oh, I just moved the resistance again. That's the resistance that, oh, there we go. I moved the resistance. There we go. A. So I also discovered a pin right here, a digital pin. Let me just go over to it. It's around here. I think so. It's around here. There we go. Now what is this? This is what? Now we can just, again, look where it's located right here. What we connected right here. And then we can say, what is this again? Let me just move this to the top. Can we see it? It's the one at the very, very what? At the very edge. What is this then? It's appearing on digit 1. So basically it's what? It's D1 right here. When it comes to the white one, again, the white wire. It's going to be connected to what? To D1. Okay, what is this again? A. So we can keep finding them again by doing what? By lighting up other segments. That's all you need to do. So let's say we're trying to find another segment. What do? Right here, we're going to move our resistance right here. And when it does not light up, what does it mean? When it does not light up, it's probably what? It's probably a D pin. So we're not going to touch that. So we're going to leave it again. We're going to light up all the segments. So basically, it's just trial and error until you find one segment. As soon as one segment lights up, you can extract lots of information. From here, I can extract what? This is A. Okay, this is A. From here, from the red wire, I can say the pin right here is A. What else is it? It's on the first digit. So it's what? So it's going to be what? The digit number 1 is going to be here. What else can I extract right here? I can say it's a common anode or a common cathode. So again, you keep doing that and find all the pins, okay? And name all of them. That's all you need to do. So with that in mind, we're going to actually work on a project in the next section. And we're actually going to wire up all of this, which is going to be a lot of it. So we're going to wire up 12. So anyways, we're going to see you in the next section. We're actually going to work on a project with this one. Okay, so we're gonna build as a timer, okay? Just like how we did using the 1-segment LED display right here, 7-segment LED display with the one that has 1 digit. Just like how we did that, we're gonna be building a timer, and it's also gonna be including a buzzer, okay? It's gonna have a buzzer right here, an active buzzer, and it's gonna actually ring after what the timer hits 0. Okay, so just to save you guys time, I did all the wiring up that was necessary again. So I did every wiring up and wrote down all of them as variables. So let me just again get this closer so you can have a good look at it and where it's going. So let me just make a simple again. Let me just explain it simply. These are A and F. Let me just again bring this closer. How am I supposed to do that? It's actually hard. Let me just bring the camera down this time. It makes more sense to do that. There we go. Let me just bring it way closer here. All right. So these two, as you can see, the black and the silver, again, when you look at them, they're connected to what? To A and F. They're connected to resistors right here. One resistor leading to A and the second resistor leading to what? Leading to F. Okay. That's all I did. Then afterwards, what I did was, I put this again, as you can see it right here. Can you see this, the silver one? The silver one is supposed to be D1, okay? It's D1, and afterwards, these two colors right here, the purple and the blue, respectively, are D2 and D3. And finally, I set a resistor for, again, B, because it's a segment again, and then used the green color, okay? Then, afterwards, what I did was, I went to the other side, because I did not have space in this side, too. As you can see, I don't have space on this side, so I just used another small breadboard just to go through it, just like how I did using the 1-digit 7-segment LED display. So what I did was, again, connect, these pins, these pins in order right here. We start from yellow again. The next color is yellow, as you can see on the stripe, and then connected them respectively. So yellow represents E, then orange represents D, obviously then red represents DP, and then the brown represents C. And then right here, because I run out of wires right here again, we're connecting lots of pins. Because I run out of wires, what I did was I used a single white wire right here. Specifically a single white wire right here, as you can see it. And this is connected to what? It's connected to G, okay? And one final thing is, obviously, we have D4 right here that I'm not going to use. Let me go back right here. Obviously, I don't have to put a resistor on this, so I put it right here and connected it to what? Pin 13. Okay, can you see pin 13 is at the very, very other side. Let me just give this, let me change the color. So better. Change it to, there we go, I think this is better. There we go, D13. Alright, D13 is right here. There's still pin, 13? Again, you can see it from another angle. There we go, there's still pin 13. So that's what I did. I connected them, and separately, I run out of digital pins right here. Okay? So one thing I want you to keep in mind, let me just put this in its normal angle. Okay, there we go. So one thing I did right here is what? After I was done with setting up the 4-digit LED matrix, LED segments right here, what I did was what? I set up a different circuit, a big black one. I used an analog pin because I ran out of digital pin right here, I used an analog pin, okay? I used what? I used an analog pin, and then I used a diode, okay? A diode, again, as I said, is supposed to change what? It's supposed to change AC circuit to DC circuit, alright? And then I used my active buzzer. Active buzzer, as I always told you guys, it needs 5 volt DC. It receives what? 5 volt DC, direct current. And basically, let me just explain the science before we go behind it. What does a diode do? It basically can convert AC to DC. Let me just show you how it does. Let me just bring the paper right here. Let's go over the science before, we keep walking and focus on the 4-digit display, because it's going to be the main one right here. It's the main component here. Basically, when we use a diode, if you remember, AC circuit goes both sides. It goes both sides, okay? When it comes to DC circuit, it only goes what? One way, okay? It's straight. It goes one way. When it comes to a diode, if you remember, I told you guys, even when we were using these LEDs, let me just bring an LED right here. I think an LED would be a great example because they're diodes too. They're literally what? Light emitting diodes. They're diodes, but they what? They emit light. That's their like special property, but they're just diodes. They're the same thing. Okay? So when it came towards these, again, diodes, they were present like this, if you remember. And then we, again, presented them in the circuit. So this is what? The positive side, and this was what? The negative side. Okay? Is it the positive and the negative? I think I actually switched it up. There we go. It's this side. It's positive and negative here. Anyways, the main thing here is what? The main thing here is if we connect it to the positive, again, we connect the positive to the 5 volt and the negative to the GND, it worked. But if we switch the direction, what happened? It did not work. So basically what happens in diodes? In diodes, currents only flow in what? Currents only flow in one direction. As I told you guys, currents only flow in what? In only one direction. So that's basically what it's doing. When we receive, again, inputs from analog pins and digital pins, they're always what? As I said, again, they're always AC. So to just change it to 5 volt DC, what does a diode do? Diode only receives what? Half of what the AC is sending. It's going to be receiving half of it. So basically it's going in both directions. It's going to receive only the one direction. And it's going to what? It's not going to receive the other one. It's going to be dull. And then keep on doing this. So basically over time it looks something like this. If you just, again, lower it down, if let's just say we tune it down, it's going to be almost as if we're getting what? We're getting DC circuit. Okay? It's just as if we're getting DC circuit. That's one thing I want you guys to keep in mind, okay? When we're working with this, a diode. Let me just show you guys what a diode looks like. This is called a rectifier diode. Again, read your labels and try to find some sort of diode, okay? This is a rectifier diode right here, okay? Basically does what? Changes what? It's used for what? Basically to change AC circuit to what? To DC circuit, okay? Again, the side, again, you have to understand the side, okay? How you set it up is, again, important because a diode, if I just, again, change the direction right here and put it like this, if I put the, there we go. If I put the, again, silver mark right here with the positive sign, okay, with the positive sign, what's going to happen is what? It's going to basically what? It's not going to connect. It's basically going to be silent. But if I obviously change the direction right now, if I change the direction, it's supposed to be like this. If I change the direction like this, it's going to work perfectly fine. Okay, just keep that in mind. Let me just put it back to its spot though. 1, 2, ruin it. Oh, I think I bended it a bit. I don't think it's on the positive side of the... Okay, there we go. The positives here. All right. There we go. Connected it. Obviously, if I don't hear anything, I just set it up wrong. Again, we can know from just, again, listening to it. If we don't receive anything, then basically what I did is what? What I did is change the direction. Okay. Let me get this out of the way. And the GND, if you can see right here, the GND, let me just make sure you can see it. The GND is, again, extended by this. It goes the whole way here. And then what happens? It goes what? To this side. And then it goes to the other side of the what? The active buzzer. Okay. So now let's focus back on the, again, 4-segment LED display. So everything before, obviously, we start, what you want to do is what? We want to check if everything's hooked up properly, especially the resistors again. There might be cases where, again, the resistors are not connected properly. Basically, we have to push them in. So let's just see if they're connected properly. So let me go over here to my code. Let me just do that. I
have another code. I want, not this one. I think it's this one. No, it's definitely not this one. How about this one? I think it's this one. There we go. Okay, let me just remove this code. I don't need this. I'm going to go back to this. We're going to be including libraries, so we're going to get back to this. But we want to do is check everything. So again, I just set up the pins again, gave them the name, and then connected them to their what? To their, again, the pins that we had to use again, to the respective pins. One thing you notice here is I, again, recommend that you don't use digital pin 1 and pin 2, because again, they're used for what? For binary. But this time I was using digital pin 1. Why is that so? Because I don't have any space. As you can see, I did not have any space. I finished what? Until 13. I used every pin until 13. I only have up to 13, and I used every digital pin that I had. Okay? So that's why I used 2. Again, you can use them, but most cases when you don't need to, don't use them. Okay. So, again, we're going to start here. And then, again, I set up everything. D1, D2, D3, D4. And then I set up a delay time, set it to 100 milliseconds. We're going to get to it. And then obviously I have to set everything to what? To an output. Just like how we did in the 1-digit 7-segment LED display. Just did the exactly same thing. And I set every segment to high so we can see it, including the decimal point. And then obviously what do? We're going to, again, using a common cathode. So in this case, we want the GND. So the one we want to light up right now, we're going to set it to what? As a GND, we're going to set it to low. So we want it to act like a GND. So we're going to set this to what? To low. Basically to have what? To make a complete circuit. As soon as we turn this, all of it to high, and then we turn this to low, we basically made what? We create a 5-volt to ground type of circuit, a complete circuit. Okay, now I'm going to set every other to what? To high. Let's see if I don't set this to high. Let's see what happens if I don't set this to high. Let me just comment this out. Let's comment actually the second digit too. Let's comment everything and let's just focus on this one. Let me just do that. Let me just comment everything and focus on the first one. Okay, and I'm going to get back to them. Comment it out. Comment it out. Now only this one should be working. Then I said what? I set this to low, but let's just say I forgot about writing these again. I just only focused on D1 right here and forgot about these. Let's see what happens. Okay, should be done compiling and now should be uploading. Can you see it? Almost all of them are lighting up, as you can see, but obviously there's a problem right now. The problem is it's not consistent. I mean, let me just turn off the light so you can see it way better. Some of them, again, what light up bright, and the other ones are just dim. When you look at them, other ones are just dim. I don't think you might notice it in the camera, but when you look at it in real life, it's just for example, the 4-digit right here is very, very dim. Okay? And obviously they represent what? The same character over and over again. Right now, I just wrote down 8. I wanted to write down 8, and they represent the same character. I wanted to have this. This is not lighting up. Okay, this is not lighting up. I think it's this one. There we go. Let me add that segment. The G, which one's not lighting up right now? Right now, the middle is not lighting up. Let's just see what even segment here is. The segment is G. What pin is it? Pin 12. G is attached to pin 12. Where is G? G's here. Okay, G's right here. So should be around here. Okay, there we go. It's a bit of a hustle to even connect them. There's a lot of pain even in connecting these. Okay, there we go. Now everything's lighting up. But as you can see, everything lights up. So obviously, what should we do right here? Should set everything what? Everything by default is what? Everything by default is set to low, as we know it. Every pin by default is set to low. We want to set them to high so that they don't what? They basically don't what? They basically don't display right here. Let me just set that to high. Now only the first digit should be working. There we go. The first digit is displaying really, really bright. Nice. It's going nice right here. So actually, for you guys to even see it, let me just change the angle again. I'll just keep on changing the angle so you can see it. There we go. I think this is better. Yeah, that is better. You can't even see this one too. You can see the... There we go. That's better. Now, obviously, let me just put back the code that I just commented out. Okay, let me just put that back. There we go. And now let's just upload it. So basically what happens is what? We set this to low again. Then we set this to all of it to high. So basically what? Digital pin 1 only displays. And then we're going to set it for what? The delay time is set to 100 milliseconds. After 100 milliseconds, what's going to happen is what? We're going to set this, again, all of it to high, the other digital pins. I'm not going to write the same thing over again because I already set it to high. And I want to keep it that way, okay? Because I want to check what everything is working perfectly fine.
That's why I'm not gonna, write this again, because I'm gonna be setting all of these to high. So they're already set to high, so I'm not gonna touch them. That's what I want, okay? Obviously, if I want to write down something and stuff, I'm gonna turn it off. But now I'm just using it for testing purposes, okay? So set this to low for the second digit, and set it to what? To high, and give it a delay time. And then do the same thing, except for digital digit 3. Again, digit 3, we're gonna do that for low. We're gonna set it to low, and then obviously give it a delay time, and then all of it to high, and then finally we're gonna put what? Digit 4 to low, basically turning on digit 4. Okay, and then having a delay time right here. Let me just upload this, and let's see what happens. All right, can you see it? It's scanning. Can you see it? It's going 8888888. I gave it a delay of 100 milliseconds, okay? That's how it's working. Let me just set this to, again, to a very small number. Let's say 5 milliseconds right now, and let me just upload it. When I do that, let's see what happens. When I do 5, look at it. It goes so fast, it scans so fast, it just switches from one digit to another digit so fast that we cannot see it. So we can just see is what? We can see is that all LEDs are what? Turned on. For us, for our eyes, what we can see is what? All LEDs are what? Turned on. Obviously, that's not the case. What it's doing is scanning it really, really, really fast. Just like how we did it when we put it to 100 milliseconds, you can just see the effect. You can see the effect when you put it to 100 milliseconds, scanning it really, really, really fast. Look at it. Look at how it does it really fast, really fast, really fast. Let me just put it to 20 so you can see it. Even, let's go, let it go even faster than it is. Let's go even 5 times faster. And look at it. It's flickering. Can you see it? How fast it's going? It's just flickering. We cannot see it. We can see it's going so fast. But when you set it to 5 right now, when we just set it to, again, 5, which is 4 times faster than 20, when we just do that, look what happens right here. We don't see any interruption. We just see all of them light up. For our eyes, we only see what? It's all of it is lighting up. Because again, our eyes cannot what? They cannot comprehend that type of speed. Okay. That's all that there is. So everything is hooked up properly and as it should be. Okay. With that in mind right now, what we're going to do is to make this project interesting is we're going to be using a library. Not only that too, if you remember, when we were working with the, let me just turn on the light. When we were working with the, again, 1-digit 7-segment LED display, just focus on it. When we were working with it, what we basically did was what? If you remember, what we basically did is what? We just used 9, 8, 7, 6, 5, 4, 3, 2, 1 to just set a timer, to just basically make a timer. We just did was what? Count up to 9. Obviously, this LED segment can count up to what? It can only count up to 9. But when we go to the 4-digit one, obviously it can count up to what? It can count up to 9,999. So just think of writing down and setting up all these numbers. Just think of setting up 9,999, going to 9,998. Just think of even setting up all of that, It's a lot, obviously. So in this case, it's just way easier to use libraries. So they make our lives way, way, way easier. Okay, so let me just go over to my screen again, and what I'm going to do is, let me just go over to my code. I already wrote the code. So again, we don't waste time, and we can focus on actually reading the code and understanding the code. Okay, so again, I don't want to waste time by typing it. Okay, there we go. There's the code. All right, there's the code. So one library that we're going to be using is, you're going to go to your library manager and search for servseg. Okay, servseg. It's literally the servseg is literally the library that we're going to be using. Okay, it's not showing it. Oh, savseg. Sorry, I misspelled it. Savseg. There we go. Install it right here. You can install it again. If you don't find it on the library manager, again, you can go to what? You can say savseg library. And then afterwards, searching for savseg, look at it, go to the Arduino page, and then you can install it as a zip right here. You can install it as a zip. And then you can again add it to what? You can add it to your sketch. Basically, I think you guys know how to do it because I've shown you guys, but even if you don't, after you're done doing that, what you do after installing it is you say include libraries and add.zip library. Okay? That's all you need to do. But again, you can just download it from here. It's going to be easy. Again, let me just remove it for now so that I can install it. As you can see, all you have to do is just tap the install button. And once you're done, there you go. We're just done. That's all we need to do. There we go. Okay, so The SafeSeg library just helps us, again, work with LED matrices, all right? So it's going to help us is what? It's going to be working with LED segments right here. So it's going to make our lives way, way, way easier. Oh, I think it's displaying 999. I'm just going to fix that up. There we go. Okay, it's going to make our lives way easier. As I said again, using libraries, we're just going to what? We're going to focus on actually work on our project and actually understanding lots and lots of concepts, because there are going to be lots of concepts here. Okay, so what I did again is here, and my code, let me just, actually, I can turn off the light. No, let me just keep it on. It's just reflecting at me. Let me just put it down. There we go. Okay, so when it comes to the code, all I did is, again, set up every segment right here with its respective pin, and then again, put, again, the digits right here, set it up, and I set up a delay time of 5 milliseconds. That's all I did right here. What did we set up? Okay. Wait, this is not supposed to be this is not the, well, this is the one that I turned on, all of the segments. Where's that other one? There we go. I want the other one. I want this one. There we go. There we go. All I did is, again, set up what? I set up every digit again, and again, gave it its variable, gave it a variable name. And then what I did here is user input. Basically, what this program does, let me just show you the program running. Let me just upload it first, so you can see how the program works, okay? So it compiles my sketch. Okay, it's done compiling. Now it should be done uploading. Okay, so let me show you what happens, again, once you're done building the course. What is supposed to happen? So again, we can set a timer for seconds. Maximum is what? 9,999. 9,999. So again, we're going to set a timer in what? In seconds, okay? So I'm going to set a timer for, let's say, 10 seconds. I'm going to enter it, okay? After I'm done entering it, it starts counting to 10, goes 8, 7, 6, and you can see 5. It's going 4, 3, 2, 1. And the buzzer should be ringing. The buzzer isn't that loud. Let me try it again. Let me try 1 second again. Did I flip it? Maybe I should flip it. I should flip my diode, because you cannot hear anything. Maybe I, again, put the wrong direction on the diode, because it can happen, as I said. Let me just get the positive. Get the positive of this. All right. The positive, there we go, that's the positive. I think it's the opposite direction, so we're not hearing anything from the buzzer. I'm going to say 2 seconds now, 2 milliseconds. We're totally not going to hear anything. Okay, I'm using an active buzzer. Okay, there we go. And let me just check the polarity of the active buzzer. The positive is supposed to be here. Let me just change the direction here too. I think it's the direction. Right. The positive's here, the negative should be right around here. Okay, the positive's connected, the negative is connected, the negative terminal, basically the GND. Okay, and then this is going to be connected to analog pin 4. I set it up as analog pin 4. Let me just check it out. Bus pin is set to, as you can see, analog pin 4. Let me try to upload this code again. Maybe it should be the uploading. Let me turn off my serial monitor first, though. Let me first turn off my serial monitor before uploading it. Okay, it's done compiling. Okay, it should be uploading. All right, there we go. Let me just again set it for 3 seconds. Counts to 3, 2, 1. Okay, I think the problem is, let me just go over to try to find analog, right? Okay, let me just set this to 5 milliseconds. This one to 255, yes. Basically 5 volt, 255 is 5 volt, yeah. And it turns off after 5 seconds of what? 5 seconds of playing a timer. Let me just do that. Again, turn off my serial monitor fast before it's done uploading. There we go. Let me go back to this code. Let me go up. Now let me go to my serial monitor. Let's set it 3. Should be working. Come on. Can you hear it? Ooh. I think you can hear something, but it's not the best. Okay, I think it's because this one is not connected properly. I think one of them is not connected properly. You know what? So what I'm going to do right here is, again, search for analog write command. Let me just turn off this analog write. Let me just, when it turns it off, this is basically turning off your what? It's basically going to turn this off. After 5 seconds, it's going to turn off what? Our buzzer. So let me just turn that off and let me try to wire it up properly. I think it's the wiring that's causing the problem. Let me upload this code first. And then let's try to, again, use the timer. Let's just do that. Done compiling, uploading, and it should be done uploading. Okay, let me set this to 3. Okay, now we can hear it continuously. This is correcting the analog pin 4. You can hear something, can't you? Can you hear it? So what happened again? What did I say right here? I said that when we're using what? When we're using diodes, what happens is what? We hear it half the time, basically. Okay, we hear it half the time because, again, when it comes to each circuit, it goes back and forth. So it's going to only work what? In one direction. Let's say the back one works. Okay, let's say the back one works. The fourth one doesn't work. Okay, so basically we're going to hear it for what? For half the time. Okay, so we're basically hearing it as what? Can you hear it? It's not like the normal active buzzer sound, but it's creating a sound. Why is that? So just think of it as if you're using a delay of what? 5 milliseconds and then what? Giving it an off, okay? Just turning it off, on, off, keeping off doing it what? For over what? Half of the period of time, okay? Just think of doing that. It's basically that, okay? Because it's turned off for what? For half of the time. As I said again, when it goes to the other direction, when the current reverses in the other direction, it's not gonna go to what? To the buzzer. Why is that so? Because we have a what? We have a diode, okay? Let me just focus here. There we go. It is working. Okay, so now let's focus on something else. Let me just turn off the serial. Let me just actually upload it again. Let me first turn this on. So that turns it off after 5 seconds. Basically like how a timer just turns off after a while. It's going to turn off after 5 seconds, okay? That's the code right here. Let me just go all the way up. And let's start actually analyzing the code because it does work. Okay. I know it might seem a lot of code, but I'm just going to explain to you what I just did. Most of it is copy-paste, so don't get intimidated by the amount of code that there is here. Okay. So, user input is what? User input is basically the amount that we're going to be receiving from what? From a user right here. I'm going to save it. So, for example, the number we're going to be receiving here. If it's a 30, it's going to be what? User input is going to be what? Set to what? The 30 right here. Okay? It's basically that, okay? This code is useless right here, so I just removed it. And there's bus pin right here, which is going to be set to A4. Again, I'm going to be using this obviously for my buzzer. Makes sense. And then I'm going to set there a delay time of 5 milliseconds, okay? Then I'm going to what? I'm going to include the SafeSeg library right now. The one that I, again, installed in the library manager. I'm just going to include it right here. And right here, it says is what? SafeSeg right here. Again, the capitalization matters, okay? Again, you can read the documentation for yourself. You can just say, you can Google it yourself, say SafeSeg documentation right here. I already Googled it, SafeSeg library documentation, and you can go to the GitHub right here and actually read what the SafeSeg is capable of, okay? So you can read it for yourself. But I already read the documentation myself, and I'm going to be what? I'm just going to be using it for this purpose, all right? I just want you guys to know that. Let me just go to there we go. So it's basically what? It's basically asking SafeSeg right here to set up an object or a list called SafeSeg, okay? It's going to be creating a SafeSeg called list. And we're going to be using this a lot. Like, look at here. I'm going to be using SafeSeg.begin, SafeSeg.setBrightness,
sevseg. There's an even sevseg.refresh right here, set number, refresh display. So basically it's going to contain the commands of the sevseg library. Okay, it's basically like how Arduino sets up, how Arduino's like, hey, Arduino sets up serial monitor. Okay, it sets up the object called serial right here, a serial. Just like how we, obviously, this is automatic, by the way. Just like how we use serial and say .begin, we say serial.println right here. Arduino is basically it's like Arduino setting it to serial. I just want you to think of it as like that equivalent, alright? But obviously, Arduino does it Arduino does it automatically. We don't have to touch anything. But when it comes to libraries, we have to do it ourselves, okay? We have to do it manually, okay? We're just setting up sevseg. Just think of it as a folder named sevseg, and it has a lot of files again, okay? Lots of files right now, okay? I just want you to think of it like that. Okay, so again, we're gonna save this as a byte. Again, as you remember, we were talking about bytes when we were changing it to binary, saying 8-bit, 10-bit, and we were checking that. So basically, a byte is literally a single byte is 8 bits, okay? So basically, it's like 8 bits of information. And we also saw how 8 bits of information literally correspond with, when we're working with 0 up to 255 for when we're using analog write command, if you remember. Okay, so we're using a byte. Okay, so we're going to be setting this to a byte again. Okay, and we're going to tell this, and we're going to set this as number of digits. Basically, for example, in our case, we have 4 digits. Okay. We have 4 digits. It's going to be corresponding to 2, 1, and 8. If you go to your documentation right here, it just tells you right here, should be around, where is it? I actually saw, there we go. Supports up to 1 to 8 digit displays, okay? I want you to understand that. So basically what I did is the number of digits that is on my on my 7-segment LED display. In this case, I'm using I'm using a 4-digit 7-segment LED display. That's why I'm going to set it to 4. And then afterwards, what I'm going to do is write this down again, digit pins. And then what do? I set it in order, okay? I set the digit pins. What are the digit pins? They're D1. I already defined them here. They're D1, D2, D3, and D4, okay? One thing I want you guys to understand here is order matters, okay? You're going to first put D1, and then you're going to put D2, and then D3, and then D4, okay? You cannot jumble it up and then expect the library to understand which one's which, okay? It's never going to understand that. So again, one thing I want you guys to understand is D1, D2, and D3, and D4 are supposed to be set in an order, okay? The same goes for segments right here. When we set segment pins, okay? It's going to be set in an order. Why is that so it's important to be in order? As I said again, there are lots and lots of models of 7-segment LED displays, okay? There are lots of models of them. Right here, mine has a different number, which is 420 something. And I didn't even find the documentation regarding my type, okay? So there are going to be lots of them that are manufactured by different companies, okay? They're going to be different. Where the pins are, the pin placements are going to be they're going to be different from segment to segment, okay? That's why it needs to know which is which, okay? So you need to figure it out yourself, as I said again. You're going to figure it out yourself, and then you're going to define it here, and then you're going to put it in an order, okay? You're going to put an order of A, B, C, D, E, F, G, in alphabetical order, and then finally put your decimal point. All right. Then afterwards, we're going to put the type of, the type of data we're going to store in this variable. In this case, it says bool. I'm going to teach you guys what that means, okay? Then it says resistors on segments. Are we using resistors on our segments? Yes, we are. So we set it to true. True basically meaning what? Yes, we are. Okay. What does a Boolean mean? So a Boolean basically means true or false. Okay. It holds 2 values, true or false. So true basically means I want you to think of them as being asked as a question. When you're asked a question, for example, are you hungry? You're going to say yes or no. It's a yes or no question. Okay? You're going to say yes if you're hungry. You're going to say yes. And if you're not hungry, you're going to say what? No. If you're full, you're going to say what? You're going to say what? No. Okay? That's basically it. But obviously different in in computers. Basically, you're asking our computer, do you have resistors on your segments? That's literally what sevseg is asking us. And we're setting it to what? We're saying yes, we do. We're setting it to what? To true. Okay? So this is basically Booleans. Okay? So even if you Google it for yourselves and say Boolean values, this is, again, basic computer, and I think that most of you don't have prior programming knowledge. Okay? So right here represents a truth value. That is obviously true or false. Okay?
That's literally what it is. So to express booleans, again, they're data types, just like how we have numbers and, strings and all that. There's something called booleans. Again, they're data types, okay? I don't want you to get into detail right here. They're data types, and then we're going to represent it by what? By using the word BOOL, okay? That's one thing you should keep in mind. All right, then afterwards, we tell it the hardware configuration. Is yours common cathode or is yours common anode? Obviously, for those of you who have a common anode, you're going to be what? You're going to remove this and say common anode. There we go. It's going to finish it by itself. It has autofill, so you can just finish it by yourself. Again, capitalization everywhere matters. So again, make sure that you write it down in capital letters. Let me just put this back to common cathode because mine is common cathode. Again, if you have a common anode, it's going to set it up to what? Common anode. Okay. Then as soon as what? We're done doing that, what we do is we set up our what? We begin. Just like how we begin our serial monitor, we're going to begin giving our CFSEC the information. We just set it right here. What did we do right here? We just set up the information in what? In variables. That's all we did. Right now, what are we going to do? We're going to what? We're going to give this information. We're going to hand it over to what? To CFSEC, okay? We're going to give it its hardware configuration right here, which is going to be common cathode. We're going to give it the number of digits again, which is literally 4 for our case. And we're going to set our digit pins again. We're going to give it our digit pins, the list of digit pins right here, okay? Segment pins too, and then resistors on segments. One thing I want you guys to keep in mind right here is what? When we put these squared rates right here, okay? When we put them, okay, one thing I want you to understand is we're just saying is we have a list, okay? This means is what? We have a list. We're going to be setting up a list, okay? So we're basically doing what? We're just setting up a list. We're just setting up a list of what? A list of digit pins right here. So basically this does is what? It just tells our Arduino, hey, we're about to what? We're about to use lists in our code, okay? That's all it's basically telling it. Okay. And afterwards, once we're done again giving this information, handing this information to CFSEC, what do? We set the brightness right here, okay? And I read the documentation and it should be around 0 to 200, okay? It lights up from 0 to 200. The value is going to be 0 to 200 right here. But when it comes to 200, we're going to see something like flickering, right? Just like how when we were using, let me just bring this right here, and we set this to 20, when we set the delay time to 20. And we tried to turn on everything, and just set this to 20. And just like how we turn on everything, we're going to see some flickering, don't we? Let me just compile and just upload it. Okay, I have the serial monitor open on this one. That's why. There we go. Now it should be working. Okay, it's compiling, and now it should be uploading. It's like how when we're trying to do that, it flickers a lot. Can you see it? It's flickering a lot. Can you see it, right? It flickers a lot. Basically, that's what's happening right here. Basically, it's telling us right here to use a brightness between, I want you to do right here is listen. Right here, when we set it from 0 to 100, it's going to be perfectly bright. But when we set it to something above 100, for example, between 100 and 200, flickering again might occur, okay? So to prevent this, I'm just going to set it to a value between 0 and 100. Right now, I just set it to 90. You can set it to 100 if you want to. But again, most cases, don't use 100 to 200 value, okay? Because it flickers a lot. From my experience, not only that too, but it's also written in the documentation, okay? Then afterwards, we finally, start our serial monitor right here. Start our serial monitor. Okay, then, after we're done setting up our code right now, what do? Now, we're going to ask the question, hey, set a timer for what? Set a timer for seconds, and the maximum is what? Let me actually set right here. Should put a comma right here. Makes more sense to put a comma. Set a timer for seconds. The maximum is what? The maximum is what? 9,999. Obviously, the maximum is what? 9,999. I'm just saying that. Okay, let's just say again, a user wants to use our Arduino and set a timer. Let's just say that we're just again creating a product that is like a timer or something for again users, a simple digital timer. Let's just say we're creating that for a user. Okay, so we're gonna ask it set a timer for seconds. The maximum is what? The maximum is 9,999. Okay, I'm just again printing the string out, and then look what happens here. There's a while code right here. There's a code right here that you guys don't understand. So what I'm gonna do right here, okay, just to make again our lives way simpler, let me just get out of the sketch right here and try to explain it. Let me just open a new sketch and try to explain it inside of a new sketch. I think it's gonna make it way easier. Okay, let this load. Give it some time. Okay, it's taking a bit of a while. There we go, it's loading. And let me just show you what I mean by what this loop does right here. What does even this code mean? Okay, so first things first is we're going to be setting up our serial monitor, okay? Serial.begin. I just want you to follow along. I don't want you to code this. Okay, I just want you to follow and just give me your attention. Okay, then afterwards, what I want you to do right here is we're gonna write down while, and then we go here, and then right here set something called, we're gonna be using the serial again, and we're gonna say available, okay? And we're gonna set this to 0. We're not gonna set this to 0, we're gonna compare it to 0 right here. And let me just try to explain this code for you. But before that, let me try to print something without it. So let me just comment this out. Basically, let me just leave this out for now. And let me just try to print something. Let's see the problem that there is, and let's see the problem it solves for us, okay? Let's see what this code solves for us, okay? So let me just, again, try to print what? Let's say, let me just try to ask it a question right here. Hi, how are you? Okay, I'm just trying to ask it a question right here. Let me set a semicolon right now, and let's see what happens, okay? Let me upload this, and it should be done uploading. It's compiling, and it should be done uploading by now. Okay, it's done uploading. So let's see what happens here. So let me just turn on the serial monitor and just go close to it. And you see that it's printing out the same thing, hi, how are you, multiple times, again and again and again. Can you see it? Just printing it out, again, infinitely. So it's just going through a loop, again, printing it, again, printing it, again, printing it. So just think of just being in a conversation and somebody asks you a question. What do? You go silent and what? Wait for a response, don't you? You go silent and you wait for a response. Basically, Arduino is what? Arduino is basically asking us the question over and over again. And just think of somebody doing that in real life. That would be really, really awkward and really weird. Really? So anyways, how do we stop Arduino, from telling us, from again, how do we tell Arduino to tell it to shut up right now? Just, hey, Arduino, I just want you to shut up until I give you a response. How do we do that? So obviously we're going to be using the while loop right here, okay? And we're going to be saying serial.available, okay? There we go. Equal to what? Equal to 0. And then when we set it to here again, what does it show right here? Basically, now it's going to ask me one time right here, okay? So I'm just, again, remove the serial monitor when uploading it. There we go. It asks the same thing. There we go. Still uploading. So right now, what does it do? Stops asking me the question. It just basically stops asking the question. Just asks once and then waits for my response. Can you see that? It waits for me to enter a message right here. Let's say I'm doing fine. And just send it over. Okay? So it waits for me until what? Until I'm done giving it a response right here. Okay? That's what it does. So again, serial.available checks what? Checks the amount of information that is coming through here. So basically the amount of information that is being sent by our serial monitor right here. In this case, if we're not sending anything, it's going to be equal to what? It's going to be equal to what? It's going to be equal to 0. If we don't send anything, it's going to be equal to 0. As soon as I send something, though, it's not going to be equal to 0 right here. Let me just do that. As soon as I do that, this will no longer be true. So this while loop is no longer going to be true. Okay? There we go. Now it keeps asking me the same question. Why is that so? Because it's no longer what? Equal to 0 again. The amount of information that is being sent by the message again, by the serial monitor is what? Is no longer to 0. I'm sending some sort of information. Specifically right now, I'm sending what? I'm sending a string. Okay. So right here, what does it do? A while loop does again. A while loop does is, again, while is basically, as I said again, while hungry. We can use this metaphor again. While hungry, eat. Okay. So I want you to think of them as what? While loop, I just want you to think of them as what? It's gonna keep on running the same thing and same thing over and over again until what? This condition is false. The condition that is here is what is set to false. Okay. So let's say while we're hungry, what do? We keep on eating. We keep on eating. We keep on eating. But as soon as we're no longer hungry, basically we're full. What happens? We stop eating. Okay. So we stop this. Specifically what? In this case, what does it mean? We're going to skip the code that is in between the curly brackets right here, the curly braces right here. So we're going to be what? We're going to be skipping the code between it. Until what? Until that condition, the condition that we set here is what? It's false. So in this case, it is true until what? Until I give it a message right here. As soon as I give it a message though, it's false. Right here, there's nothing here. So basically, what am I telling it is basically wait. Wait for my response. Don't run any code, just wait for my response. I'm just going to keep on what? Running this on a loop again and again and again. Waiting for what? For my response, okay? So it's going to be waiting for my response, and as soon as I respond to it, it starts to what? It starts to actually give me what? Starts to actually what? Starts to actually run the code that is below here, okay? Starts to run the code that is found below the the while again, the while loop. Okay, the while loop is going to keep running over and over again. It's not going to read the code that's beneath it. Okay, it's not going to be reading the code that's beneath it. What is it going to do? It's going to be reading again the while loop over and over and over again until what? Until I get a response. As soon as I do, it's going to go beneath and read the code that I wrote down beneath the while loop. Okay, so once you just keep that in mind, let me just go to our Arduino right here. There we go. Let's go back to our, actually go back to our code right here, to our while loop code. Okay, just go here. Where is it? There we go. Okay, afterwards, what do? We take the user input right here, and then it's set to what? Serial.parseInt. So what does serial.parseInt mean? So we start from something you guys know and you guys learned about in the previous few sections. So one thing you guys learned about is what? We learned about, again, setting up strings right here. So we set up a string right here, and then what did we do? Let me just give it a name, user feed. Okay, for now, let's give it a name. Let me set it up. And then what did it do? Right here, I'm going to do is, I'm going to say user feed dot what? User feed. I'm going to say is user feed. I'm going to set it to, sorry, I have to set it to something. It's a variable. I have to set it to something. I'm going to set it to serial.read string, right? Read string. Basically, what does this mean? Basically, what? It's going to read what? The value that is going to come from here. What do I expect it to be? I expect it to be what? A string. It's written right here. I want it to be a string. So if I display a value right here, let me just say, I am fine to the serial monitor. But before doing that, I have to upload it. Let me just actually upload it first. Let me upload it, and then I can just run it. Okay, it's done compiling, and it should be uploading now. Okay, it's done uploading. There we go. Now let's go to our serial monitor. There we go. And what do I say? I am fine. Okay, let me just say I am fine. Right here. There we go. If you just let me just print out user feed right now. I think it's better to print out user feed so we can see it ourselves. Let me say print ln and say I want to print out the user feed. After what? After we set it up. Okay, there we go. Let me just upload it. Let me close my serial monitor till that time. All right. Everything should be going good now. It's done uploading. Now, let's check what happens here. Okay, let me just say I am fine. Okay, it prints out I am fine. There we go. Prints out what? I am fine. Nice. So, what does this mean? Again, this is again used for what? For strings, reading strings. So if you remember, what did it do? It always what? Created a new line always. At the very end, it created a new line for what? For our responses, if you remember. Created a new line, so I can just say serial.print, and again, it's going to print it out in a new line, if you remember. Not only that too, but importantly right now, what does it do? It also sets it to what? To a string. So even if I, let's say, give a value of 10 right here, if I say 10 and just enter it over here, it's going to give me what? Even though it looks the same thing right here, it seems like the same thing. It's giving me what? It's giving me this. What Arduino is outputting is what? It's outputting 10. What I want is what? The number 10. It's giving me the text 10 right here, okay? You might not see from the serial monitor. I mean, from the serial monitor, you just assume that, oh, it's just 10. No difference here. But obviously, what is it doing? It's giving me the what? The string 10, okay? It's not giving me what? The number 10. Obviously, with that case, we cannot what? We cannot, multiply strings. We cannot add up strings. They don't have the properties of what? Numbers. Okay, it's going to treat it as a what? As a text. Arduino is going to treat our 10 as a what? As a text when we put it inside of a string. It's going to be thinking of it as what? As a text containing what? As the text containing number 10. So it's not going to be able to multiply it, to add it. And this property is very, very important because we're going to go here. Let me just go show you guys right here. Even in our sketch right here, we're going to be using something called setNumber from what? From our sevseg library, okay? So we're going to be using setNumber. So again, when setNumber, obviously the name is self-explanatory. We expect a what? We're going to be setting a number right here, okay? So we're going to be expecting what? A number. If we put a string right here, we're going to be what? We're going to be confusing our sevseg what? Library, okay? We're going to be getting a bunch of errors. Okay, so right here, just to make sure that, we're receiving number 10 and we want to even give out numbers is how do we tell Arduino that we're going to give it numbers instead of strings? How are we going to tell it that we're going to be giving it numbers is literally using parseInt, okay? ParseInt. It contains the name int, the integers. It indicates what? Integers, okay? So we're telling Arduino what? We're going to be giving it integers, okay? In the message board, we're going to be giving it what? We're going to be giving it integers. And most importantly, I want you to store it as what? I want you to store it in the variable as a what? As an integer. I want you to store it as a string. I want you to store it as what? I want you to store it as a number. Okay, that's what we're telling Arduino. So it expects a number. Not only does it expect a number, but it also what? It also is going to be outputting it, and again, it's setting our variable to a what? To a number. Okay, so right here, let me just say right here and parse int. I'm just going to say 10 right here, and then it's going to give me. Can you see it? I just gave it 10 right here. It just gave me 10. Obviously, I just said print right here and not print ln. I said print right here. So it just gave me 10 and then ask the question again because obviously what? Because again, it's running on a loop. So it's going to be asking me the same question once it's done going through the loop. Okay. So the main important thing here is what? When it comes to parse int, it's what? We're going to be receiving integers on the message board. That's where we're telling what? Arduino. Okay. So we're going to be telling Arduino we're going to be receiving 10. Not only that too, but what? We're going to store it at what? As a number. I want to specifically store it as what? As a number. I don't want you to store it as a string. That's what we're telling Arduino. Or obviously there's something called parse int and there's something else called parse float. Basically parse float is literally the same thing as parse int except it's for what? It's for float numbers. Basically what? Decimals. Okay. So let me just go back to parse int. That's one thing I want you guys to know. Okay. So even actually, we said that we use the while serial.available again, this loop right here. We use it again to what? For Arduino not to ask us the same question. But it's actually important too in another aspect. Okay. Let me just remove the question right now. Again, let me just show you why it's important too. Let me just go right here. Let me just dice it out again. Let me just take it out right now. And let's see. Let me just upload it. Let me just try to set up a variable right here. Okay. Let's see what happens. Okay. Okay, it should be done uploading by now. There we go. And when we put on the serial monitor, let me just, again, if you cannot see it right now, but it keeps on outputting 0, 0, 0, 0, 0. Can you see it? But let me just, again, give it a value right here. Let me just say 22, okay? It's going to output 22, and then it's going to go back to 0, 0, 0, 0. What's going on, you might be wondering? Obviously, the problem here is what? The problem here is what? Arduino starts reading this code, and for now, what did we set in our message bar? We did not set anything. When we don't set anything, what happens? It's equal to what? It's equal to 0. So basically what? It's going to output 0. Can you see it? It's going to be outputting 0 and it's going to be printing it. You see that, right? So what does it prevent to? This while.serial.available again code prevents to. It's going to wait for us to what? For our message before what? Setting up our variable. So it's important not only in asking the question, for the question not to be repeated again and again and again, but it's also important in what? It's also important for us to what? To set up our variables, okay? So it's just going to set it up to what? It's going to be setting our variable before we give it a response. It's going to prevent that, okay? So just keep that in mind. Okay, so let me just go over back to our main code right here, and let's try to read the other part of it. So right here, what I'm asking it is user input is what? Less than or equal to 9,999, because we cannot display anything beyond what? 4 digits, as I said again. And this symbol right here, and then what it tells us is what? User input must be greater than 0. As you remember what? It goes down. It goes, let's say if we have 20 right here, we start our timer from 20. It's going to go 20, 19, 18. It's going to go all the way to what? Let's say it goes to 5, 4, 3, 2, 1, 0. It's going to keep on decreasing. So -1, -2. I don't want it to go to what? I don't want it to go to negative numbers and 0 because obviously time obviously cannot be negative. Okay, so I don't want it to go to what? To negative numbers. That's why I always want to check before running any code. I want to make sure that the user input is what? Has to be greater than 0 because we're going to be what? We're going to be decreasing 1 as soon as we go. Anyways, one thing you always want to make sure is what? It's less than 9,999 and then what? Less than or equal to 9,999 and then greater than 0. Okay, then, okay, this symbol right here, let me start from the symbol right here. I think you guys know obviously the if statement. The symbol right here basically means less than equals to. If you just go over here and let me just go over here right now and let's go to less than or equal to the sign. If you look at the sign of it, I think most of you are familiar with this in math. We use this sign, this symbol right here, but we don't have this symbol in our keyboard. Okay, so when we're coding, we write it down is, okay, how do we write it down? We write it down as what? We put our first, less than or equal to whatever it is, less than or greater than, we put it first, and then we put the equal sign, okay? We put the equal sign at the end, okay? So for something like greater than, let me just try to write down greater than. If you want to write down greater than or equal to, we just put the greater sign right here, and then we put the equal sign at the very end, okay? Just want you guys to keep that in mind. Okay, and what does this mean? This basically means like the keyword end, okay? It just basically means end, okay? So right here, what does this mean is, okay, if the user input is less than equal to 999 and user input is greater than 0, it's gonna what? It's gonna run this code. Basically, if one of them is false, what happens if one of them is false? You know, let's say the user input is let's say it's less than what? It's less than 0 right here, okay? Let's say it's even 0 or negative number. And this is going to be true. User input is going to be what? Less than negative, it's going to be less than or equal to 9,099 because it's going to be a negative number, okay? This is going to be true. But in this case, what happens? In this case, it's going to be what? It's going to be false. It's not greater than 0. A negative number is not what? Greater than 0. So it's going to check what? Both of them are true. So if only both of them are true, it's going to happen what? It's going to what? It's going to be running this condition. It's going to be running this code, okay? This condition is going to be true if only both of them are true. And we're using AND. Okay, that's how we express the logical term AND. We just say, we put double what? We put the double AND signs right here, and that's it. Okay, just want you to keep that in mind. When it comes to OR, obviously, when it comes to OR, let me just actually go back here. When it comes to OR, we use this sign, okay? We use this sign. It's found, again, above your enter key, and you just use shift, and then you just, again, touch it. Okay, so what does this do? This basically means OR, okay? And when it comes to OR, one of the conditions are true. If one of the conditions are true, it's going to be true. So it's basically asking if user input is less than or equal to 9,999, either this is true or this is true. If one of them is true, it's going to run the code. This condition is going to be true. This statement is going to be what? This statement is going to be true, okay? I want you to keep in mind this statement is going to be what? It's going to be true. So it's going to want what? It's going to only want one true value, okay? When it comes to the end, everything must be true. Everything must be true for the whole condition to be true, okay? All right. Just keep that in mind. Okay. Now, let me just go right here. And again, right here, we're going to be running the while loop, okay? So it's going to be going until this loop, until what? Until this condition turns out to be false. So we're going to be checking again if this is greater than 0. Okay. Just checks for 0. And then what happens? It's going to set a number. Basically, what it's doing is what? We're telling what? We're telling SEVSEG, hey, I want you to what? I want you to what? To display this number, okay? Send numbers, basically, I want you to display this number. Basically, what is this? The user input. Basically, what the user just inputted. Okay, once you're done doing that, what I want you to do is I want you to display it, okay? Okay, so let me just, there's a bit of a code that is repeated over and over again. This code is repeated over like 200 times, okay? This code, like this specific code right here, these 2 lines, they're repeated again over 200 times. So you might be wondering, why did we write this over 200 times? So let me just explain this to you. So right here, what people would have suggested was, okay, I want you to do a SEVSEG. I want you to what? I want you to refresh the display. So let me just explain what refreshing displays mean. Refreshing display basically means when you're scanning again, if you remember, when we're using a 4-digit, segment display, what happens? We only turn on what? 1 digit at a time. So it's gonna what? It's gonna keep on scanning. Basically what? It's gonna keep on running the same thing again and again and again. Very, very fast. That we don't see it in our what? We don't see it by our naked eyes. Okay? Basically, that's what's going on. So we're telling what? We're telling SEVSEG, I want you to physically what? I want you to physically refresh the display, okay? I want you to do what? I want you to do exactly what? Refresh the display again and again. Let's say, for example, we put a number, for example, this time is 20. How do we display 20? On the 3rd digit, what do we do? On the 3rd digit, we put a what? We put a 2. And then on the 4th digit, we put a what? On the 4th digit, on the display, we put a what? We put a 0, okay? So I wanted to what? I wanted to basically refresh the display. I wanted to go from 2, 0. I want to go 2, 0, 2, 0 again and again. Because we can, again, as I said again, we can only turn on one digit at a time. So it's going to do it very fast. So SEVSEG is going to automatically what? It's going to, again, when you tell it again, it's going to what? It's going to refresh it again and again, okay? So most people would have suggested just let's forget about the code that's beneath here, okay? So beneath the comment right here. So what most people would have suggested was refresh the display and then, okay, you know what? We have to set a delay for what? For 1 second. Why is that so? Basically represents what? After 1 second, we just wanted to what? We're basically what? Representing 1 second of delay right here. 1 second. And then we're going to do what? We're going to decrease it, okay? That's what's basically what, most people would suggest right here. We're going to be telling what? Refresh the display and then delay it for a second so that it counts what? It counts a second, okay? It counts a second on the timer And then what? It can, again, we can keep on what? We can keep on decreasing the user input value. Okay? The problem arises here. So, okay, let me just think that Arduino is, again, reading this code. So it's going to go right here. And let's say the user input is what? Less than or equal to 9,099? Yes, it is. Let's say I just put 20 right here, okay? And is 20 greater than 0? Yes, it is. So it's going to read this code. And then it's what? It's going to be set the number to what? It's going to be setting the number to 20. And then what? It's going to be refreshing the display. And the problem arises here. It's going to read this in an instance. It's going to read this in in milliseconds, okay? It's going to refresh the display in milliseconds. And then it's going to be delaying, okay? Physically, it's going to be delaying for what? For 1 second. So it's going to turn off the display and delay for what? For a second. So let's just say this, again, takes the Arduino 5 milliseconds to read. Let's just say it takes it definitely less than that, but let me just say it takes it only 5 milliseconds to read this, okay? How about this? It's going to be spending, okay? It's going to be what? It's going to be turned on for 5 milliseconds, and then what happens is what? For 955 milliseconds, it's just going to be off, okay? It's going to be what? It's going to be delayed, okay? It's just going to be delayed. It's not going to be on, okay? We're not going to be refreshing the display. As I said again, it's going to be just delayed. It's not going to be reading any code for what? For 1 second. That's what's going to be going on, okay? So, what is the right way of doing things? Okay, what's the right way of doing things? Then, the right way of doing things is, let me just remove this code again. The right way of doing things is, okay, we're going to put our seg, we're going to be refreshing it, and then we're going to be delaying it for 5 milliseconds, because we cannot notice 5 milliseconds. When I put everything, as I said again, let me just put this right here. Where is it? There we go. When we set the delay time here to 5, and we, again, uploaded the code. Let me just upload it. Okay, there we go. It failed to upload. Okay, I see why it failed to upload. Let me turn off my serial monitor right here. There we go. Let me just upload this. Forget about the errors right now. Okay, I should be done compiling and uploading. If I just upload this right now, can you see it? It's going to go so fast that we cannot see what? We cannot see it change from one digit to another digit, change from one digit to another digit and another digit. Again, we cannot see it because it's going to what? Very fast. 5 milliseconds is just so fast for our eyes. Okay? So what I did was, let me go back to my, again, normal code right here. Okay? What I'm going to do for my normal code right here. And then what do I do is I keep on refreshing the display and I keep on delaying it by 5 milliseconds, okay? I keep on delaying it by what? By 5 milliseconds. There we go. So I keep on refreshing the display and doing it how many times? 200 times. Okay, this code is, again, written over and over again. So it's written like over 200 times, okay? If you go all the way up to, I think, line 400 or something, you can see the end of it. But anyways, it was written 200 times. So obviously, the simple question is what's 200 times 5? 200 times 5 is what? 200 times 5 is 1,000 milliseconds. Basically what? Basically a second. Okay? That's one thing I want you guys to keep in mind. So right here, I just keep on refreshing the display and then do what? Do a delay of 5 seconds. Refreshing the display, do it what? Do a delay of 5 seconds. And keep on doing this over again, 200 times. So how do we do this? Obviously, again, you write down, what I did was what? I obviously wrote down this code right here, and then I started to what? Copy paste it until, again, to the point of where it reaches 200. Again, you don't have to, again, paste it 200 times. I think you guys know how to, paste this 200 times really easily. Obviously, what you do is what? You write it down, and then you, again, paste it until it's 10, and then you copy the whole 10, and then you do what? After you copy the whole 10, you paste it how many times? 20 times. So basically, you just count up to 20, and then it's what? It's 200, okay? So you obviously don't have to paste it up 200 times. Okay, don't have to paste the same to these two lines 200 times. There's an easier way to do it. Okay, so right now, let's go here. There we go. It ends here. And then once I'm done again, displaying again my what? I'm done displaying the user input for how much? For a second, for a total of 1 second again. This adds up to a second, as I told you guys. Once I'm done doing that, I want to do is what? I want to minus 1 from the current value. So right now, I said it was 20, right? So it's going to what? Minus 20. It's going to be 20 right here. 20 minus 1 is what? It's going to be 19. And it's going to set it to what? To the user input. It's going to set it to what? To the user input. The new user input is going to be what? It's going to be the old user input right here minus 1. Okay? So it's going to be what? If it was 20 right here, it would have been what? It is the new user input is going to be what? It's going to be 19. After we're done with that, it's going to what? It's going to refresh the display again. All right? And then what I wanted to do again is keep on running this while code. Okay? We do not finish the while code right here. This is a code for another one. But it's going to keep on running this while loop again. It's going to keep on running this loop over and over again until we reach what? Until we reach 0. Let me just go all the way up. There we go. It's going to keep on writing this over and over and over until what? Until we reach 0. As soon as we reach 0, it's going to be 0 is greater than 0. Is that a true statement or a false statement? Is 0 greater than 0? No, it's a false statement. And as soon as it hits 0, what happens is what? Again, all of this code, all of this, that is multiple lines again, until the end of the curly bracket is going to be what? It's going to be skipped. And then as soon as we reach 0, what happens is what? As soon as we reach 0, we're going to have what? An analog, right? Basically what? We're going to turn on our what? Bus pin for 5 seconds, and then we're going to turn it off, okay? So it's going to be ringing for 5 seconds, and then we're going to turn it off, okay? Then afterwards, what happens here? Sevsec.blank. What does it do? Sevsec.blank, what it does is basically, it turns off every what? It turns off the display, okay? So basically, if it was displaying anything, and if you just put .blank at the end, basically does what? It's just going to clear out the display, okay? It's going to be turning off everything from the display. Okay, so right here, we're done with that, and we're left with is only else. So it's just the if-else statement right here. Okay, if you want to see, by the way, the end of the curly brackets right here, you have the rectangle right here, right? You have to find the other rectangle, the one that is what? The one that is highlighted by a rectangle right here. So this one is highlighted by a rectangle. Let me just find the other one that is highlighted by a rectangle right now. Let me just go all the way up. And as soon as I do that, there we go. Can you see it? It's what? It's mapped with a what? It's highlighted with a rectangle right here. So basically what? It's basically the curly bracket of what? The if statement right here. So we're saying if it's 9,099, and again, if it's greater than or equal to 9,999, and if it's what? If it's greater than 0, I want you to run this code. But if it's not, there's the else right here. The else, you just go all the way down because it takes a long while. There we go. If it's not, if it's not be in this range, what am I going to say? I'm going to say his maximum number is 9,999. I'm going to tell the user, please try again. So let me just run this code right now. Let's just upload it. Okay. All we need to do is upload it right now. And now it should be working like magic. Okay. And it's done uploading. And now it should be working. There we go. Now let me just say 10 seconds. Should be counting to 10. Actually, I can turn off the lights too. It's nice. 4 goes to 3, 2, 1. And there we go. The buzzer rings for what? For 5 seconds. And then what? It basically turns off. So there you have it. This is a timer again. Made from what? From 4 segment LED displays using the what? The Sevsec again library. Anyways, this is one of the finer end of the projects, to be honest, and this is personally my favorite project from the whole course. This is one of the hardest sections, and actually one of the what? One of the most rewarding and one of the best, again, one of the best project of the section of this course. So anyways, see you in the next section. In this section, we're going to be discussing about LED matrices. So you're going to be looking for, again, these dot-looking type of pins right here that have around 8 pins here. Okay, they have 8 pins here, and they have 8 pins here. So we're going to be looking for something like that. Okay, so one thing I want you guys to keep in mind is, while we're also working with the 4-segment right here, so sorry, the 4-digit 7-segment LED display, one thing that obviously we had was the number right here. So it varied again. The positions of the pins varied again according to the number. One thing I want you guys to keep in mind is, again, there's going to be a specific number associated with your what? With your LED matrix right here. And then that number again is going to what? It's going to be literally dictating which pin is which pin. So first on, let's just see what LED matrices are even capable of. So if you've seen a LED matrix, it might look like something you've not seen before, something that is completely new. But if you, again, let me just go over to my screen, and I think most of you are very, very familiar with these type of ads, and most of us see this type of, these scrolling type of red LEDs. You've seen lots of these LED ads that scroll, okay? I think most of you have seen, again, these, again, red scrolling LED ads, and they're basically the same thing. Obviously, the ones that are on the ads are obviously bigger, and they're more capable, but they operate on the what? On the basics of this. Okay, this is just that it's a very, very small one. Okay, all right. So right here, why do we use LED matrices first things first, rather than these 4-digit 7-segment LED displays? Because we use this display again to display what? We display numbers within any number that we wanted from 0 to 9. But obviously, when you try to display something other than a number, for example, an alphabet, we start running through errors. Okay, so right here, let me just try to display small a. What should I even be turning on? It's impossible to what? It's impossible to what? To turn on small a. For example, here what? To basically display a small letter A. Okay, but using an LED matrix, what? We're capable of, again, we're capable of what? We're capable of displaying any type of alphabet, alright? Small letter, capital letter, any number, and even small types of images. Basically, we cannot display a sophisticated image using this, but we can display simple images. For example, a smiley face, a frowny face, and other than that. So we're going to display a little bit of what? Smiley again. We can display what? Simple images. Okay? So LED matrices are more capable than what? They're more capable than our 4-digit, again, 7-segment LED display. We use this again when we want to what? We want to only display what? Numbers. Obviously, they're no match to our, again, LCD screen that we have on our phones and tablets and laptops, but they're way cheap. And again, they're going to show you the text when you need them. So, okay. So they're very cheap and again, very, very useful. All right. So now let me just show you how an LED matrix works. So before even, using it in our project, what we're going to do is check how LED matrices work. Okay. So let me go over to my presentation right here. So, right here is what? They're marked. Every pin is marked with a what? With column 1, column 2, column 3, all the way up to 8. Okay? The same goes for rows. They're what? They're marked from row 1 to row 8. And one thing I want you guys to understand is row is what? From left to right, extended from left to right, while columns extend from what? From up to down. Okay? So, if you go inside of an LED matrix, what you're going to be seeing is what? You're going to be seeing lots and lots of wires. Let me just show you a wire right here. This is basically the inside of what? An LED matrix. You can see what? You can see multiple lines here. The ones that, again, extend. The wires that extend from left to right are what? They're rows, okay? So they're going to be these lines again. So I just want you to think of them as a grid, okay? They're going to be basically what? A grid. A grid of what? A grid of literally wires, okay? So you can see this, again, they go to the corresponding number rows, go from left to right. And then there's columns, marked with a what? Marked with a black color. The black line is what? Columns, and the red line is rows. Okay. So, how do we turn on a specific what? A specific dot. Basically, a specific LED inside of this LED matrix. How do we do that? Basically, what we do is, okay, we turn on R5. We set it to what? We set it to high, okay? We're going to be setting up, let's say, for example, we're going to be setting up R5 to high, row 5 to high. And then what we're going to do is what? Set column 3 to low. When we do that, guess what happens? I want you to take a guess which LED segment lights up. Is it this one specifically? Or even the whole row lights up here? The whole row lights up? What happens? Okay, I just want you to take a guess. For those of you who guess that the whole row will light up, you're wrong. Because what happens here is what? The 5 volt is going to be connected, for example, let's say to this LED right here, the LED segment that's here. But the problem is what? It's not a complete circuit. A complete circuit always has what? It has what? The positive terminal and the negative terminal. Okay? So in this case, it has the 5 volt again, but it does not have what? A negative terminal. So specifically here, it's not going to light up. The same goes for this one, for these ones that are here. But when it comes to the one that is again located at row 5 and column 3, what happens is what? What happens is what? It lights up. Because why? We have the 5 volt coming in from row 5, and we have the ground pin, the negative terminal, coming from what? From the column 3. So specifically right here, it's gonna what? It's going to light up. There we go. It's going to light up. Okay. That's one thing I want you to keep in mind. Alright, so let's just move forward right here, and let's try to draw an L, okay? Let's try to draw a simple L. One thing I want you guys to actually keep in mind when trying to draw these simple L's is, what do we need to turn on? We need to turn on R2, okay? We need to set R3 to high. We need to set R4 to high, okay? Then we need to set R5 to high. And then when it comes to the columns, what happens? we turned on C3 to what? We turned it on to low. So basically what? We created a full circuit for these 4 LEDs. And then we set C4 to low, and then C5 to low. I think most of you would suggest me to do what? To do this, to get what? An L. But there is a problem here, okay? And this is literally what? This is the result that we expect. But what actually happens is, it's gonna light up like this. Why is that so? Right here, unintentionally, we lit up what? Column 4. And row 2, row 3, and row 4 are already set to what? They're already set to high. Because of what? We're again talking about what? Column 3. But we already set column 4 to low. So basically, when they intersect right here, basically what? We're gonna have a full circuit. So, when you have a full circuit, what happens? In this case, it's gonna what? It's gonna light up. So these LEDs are gonna start to light up. And the same goes for what? C5. So it was more of like the problem that we had when we were working with the 4-digit 7-segment LED displays. You remember? We did was what? We tried to turn on everything right here. We tried to turn on 4 of the digits right here. When we tried to do that, it started what? Started copying the first digit, and the first digit started copying the second one, and the second one copied the third one, and the third one copied the fourth one, basically giving us the same thing. So for example, if I, let's say, turn on 7 right here and try to turn on all of these 4 digits at once, what are we going to be getting? We're going to be getting 7, 7, 7, 7. Okay, that's what basically is happening. So if you look right here again, what happened is what? The column 4 what? Started to copy column 3. That's what's going on. Column 4 copied column 3, and column again 5 copied column 3. Can you see that? What happens is, there we go. It started to copy it, and basically they're literally what? They're literally the same right now. Column 3, column 4, and column 5 light up the same. Okay? So, how do we prevent this? We do exactly what we just did when it came to what? When it came to the 4-digit 7-segment LED display. What did we do? We only displayed 1 digit at a time, and then we switched from 1 digit to another digit, right? So for example, right here, I displayed 8, and then what did I do? I moved to what? I moved to here, and then displayed another number. For example, let's say 2. And then after I'm done with that, I displayed what? Let's say 3 right here. And then once I'm done with this, I displayed 4. But again, one thing obviously Arduino did so good is what? It was very, very fast. The Arduino was very, very fast at scanning, and again, turning off the first digit, going to the second digit. It was so fast that for our eyes, we can see all of them is on. So basically what? We cannot see Arduino physically doing what? Arduino turning off the first digit and going to the second digit. It was that fast. So we're going to be doing exactly the same thing here. So what we're going to be doing is what? Okay, we don't want, again, column 4 and column 5 to copy what? Column 3. So what do? We only turn on column 3 right here. Okay, one part of the L. We're trying to, again, write down capital letter L. What we're going to do is what? We're going to set up R2 up to R5 to high, and then we're going to set column 3 to low. So we're going to basically have what? This line. Once we do have that, we're going to what? We're going to automatically what? We're going to turn off what? Column 3. Okay, we're going to be what? We're going to be turning all of them off. Okay, so we're going to be turning this to what? We're going to be turning column 3 to high. And then what? Row 2 up to row 5 are going to be what? Row 2 up to row 5 are going to be set to low. Then afterwards, what do? Then afterwards, we what? We focus on what? We're going to be turning on row 5. And then we're going to be turning off what? We're going to be setting this to low. And we're going to be setting this to low. Column 4 and column 5. So basically, we have what? We have an L. Obviously, we cannot see it right now as if I'm just doing it separately. But if I even try to use this on the presentation, let me try to actually toggle between it very fast so you can see it. Okay. So you can see somewhat of an L right here. Obviously, I'm not doing it as fast as the Arduino. When the Arduino does it, it's going to be so seamlessly fast that we're not going to be noticing it. But even right here, you can notice a flickering L. Okay, you can notice a flickering L. So basically, Arduino is going to do it really, really fast. And what? So that we cannot notice it. Okay, one thing again I want you guys to keep in mind right here is what? The difference in the model. There were lots of, again, difference in models when it came to the 4-segment LED displays, the 4-digit 7-segment LED displays. Obviously, the pin placement is going to be what? Different according to what? According to the number you have. Again, what I want you to do is what? Find the corresponding number in your LED matrix. I want you to find the corresponding number and then do what? and then Google the data sheet. If you don't have your data sheet, you're going to be doing exactly what I just did for the what? For the 4-digit 7-segment LED display. We're going to keep on trying to turn on one segment right here, one light. As soon as we do, we're going to be extracting what? We're going to be extracting information right here. Let's say this one lights up in this case, okay? Let's say this one lights up. I'm going to say this is going to be what? Row 6, and it's going to be column 3. And I'm going to be, again, talking about the corresponding, again, pins that I, again, attached. And obviously, what do I need to do afterwards? I can extract information and create a data sheet myself. Okay? But one thing I want you guys to keep in mind is, okay, right here, I can just say this is row and column. Okay? I can just flip it again and say this is row or column. I can just say this is, again, this is row, this is column. I can just say this is what? This is row, this is column. So one thing I want you to get to always, keep in mind is, okay, I want you to put the one that has a number right here. It is faded. What happened to mine was it has faded, so I just put a black sign on it. Okay, so to just indicate which direction is which. So one thing I want you to always keep in mind is the pinheads are supposed to be like this. When they're on the opposite, okay? And again, the one that has a number, it's going to be placed like this. It's going to be, again, placed what? Like this. And then you can write down your pins, okay? So I want you to write down your pins like this. So this is going to be what? When you talk about row 1 like this, row 2 like this, you're going to be keep on talking them like how? You're going to be placing them like this. This is very, very important, okay? If you just do that, you're going to be interchanging. If you just, let's say, not use this one where the pinheads are like up and top and bottom, and if you just place them left to the right, when you place them left and right, what happens is what? The row is like this, and then what? We just interchange the row and the column. They basically what? They basically switch. Okay? So just keep that in mind. So always keep them from top to bottom, okay? When you're working with them. Okay. So with that being said, before we actually work in our first project, let me just try to light up one LED segment right here. Okay? So I get my LED again. And because the LED takes a lot of space, I'm going to be using a separate breadboard right here to make my life way easier. Let me just connect that breadboard to the LED first. Hopefully you can see it. There we go. Connect it in such a way. And then connect this right here, around here. Okay, I'm going to need my resistor right here. Obviously, I need my resistor. I just want you to think of them as what? As LEDs. If I just connected an LED directly to what? 5 volt and the GND, what happens to it? It's gonna what? It's gonna be fried. If I brought my normal LEDs right here, if I had one, there we go. If I brought my normal LEDs right here and just again connected 5 volt and GND, what happens? It's gonna what? It's gonna be fried. So I want you to think of them as what? As LEDs right here. We have 64 dots right here. I just want you to think of them as 64 LEDs, okay? So right here, what I'm gonna do is put a resistor right here. There's a documentation right here. X indicates, okay, X indicates row. Y indicates column. It's just my documentation, my version of the documentation. So let's say I want to turn on X6. Okay, I'm going to be connecting it to what? I'm going to be connecting it to the positive, while Y is going to be connected to the negative. Okay, so let me just do that. X6, which one is going to be X6? X6 is going to be the one that is marked with a what? That has a number for you. Most likely has a number. Mine has faded, so I just put a black sign on it. So right here, let me just put it back again. I just removed it so I can show it to you guys. Let me put my resistance right here. Let me just make sure that it goes across because I don't want it to touch the other LED pins right here. And then just do that. Okay, that seems good enough for me. Then afterwards, what do? I need my GND. I need to connect to one of the columns right here. Let me just go to column Y5 right here. Let me just go to Y5. Why not? Let me just do that. Let me bring 2 wires. Let me bring a red wire. Let me connect the red wire. Let me just focus it right here. Let me connect the red wire right here. The red wire to the 5 volt. Alright. 5 volt right here. Connected it to 5 volt. And then I'm going to be connecting my GND. There's my GND. My handy GNDs here. There we go. And I'm going to be connecting it to the pin next to the very, very left. Okay. I cannot see it from this angle. Let me just... It's very hard to see from this angle. Oh, wait. when I push it in. Just tap there we go. Now it should be lighting up. There we go. Let me just turn off the light. Turn off all the lights so you can see it. There we go, it's lighting up. Nice. There we go, it's lighting up. Let me just turn on the light back again. Let me just do that. There we go. And one thing I want you guys to keep in mind is, what is this again? Let's count all the way again to rows. If I count all the way, row 3, row 4, row 5, it's going to be row 6. Again, it's connected to what? To X6, which means what? X represents row, as I said. So basically what? X6 is what? Row 6. Okay. It's connected to what? Column 5. All right, let me go to column. Read it from up to bottom. 1, 2, 3, 4, and 5. Basically, this is what? Y5. There we go. So it's connected to what? Column 5 and what? Row 6. There we go. Sliding up. But one thing I'm going to tell you guys is, all right, one thing is, this is how we're conventionally used to what? Lighting up our LEDs. We first put what? We first put our resistance and then put what? The 5 volt and then the GND. But we can also do what? We can also do it another way. We're going to be putting our resistor, instead of placing it on the GND right here. Let me just unplug my Arduino. Instead of what? Using the resistor on the 5 volt, we can use it at the GND. Okay? So, let me just do that. It's really hard to focus and film at the same time. Wiring it up is really the biggest problem when it comes to these LED displays. Wiring it up is literally 90% of the problem in my experience. Okay, there we go. The resistor should be connected to the same. Okay, there we go. I think it is. All right. Let me just do that. And there's our handy GND connected to that one. And the resistor is going to be what? To the GND. Instead of what? Instead of being to the 5 volt. Let me put the 5 volt back to its place. The 5 volt should be at X6, so it should be at the one at the very, very start. There we go. The very start. Let me just go here. And now let me just plug in my Arduino. Alright. Should be working. Okay, it's not lighting up completely. Let me just make sure even the resistance is... Okay, there we go. The resistance is the problem. There we go. The resistance is the problem. But you can also... Wait, let me just... The resistance just keeps on... It's not put on properly. Let me just take it off, I guess. It's not doing well. Let me get another resistor. Let me get another resistor right here. It is really hard to actually connect these pins and see at the same time. It's really hard. There we go. Now it's even lighting up really, really good. I don't think you might see it. It's lighting up even way brighter than it used to. Can you see that? It's lighting up really, really good. The last time I tried to light it up, what happened when I connected the 5 volt? When I connected, let me just turn on the light so you can see it better. When I connected the 5 volt to the resistor, it wasn't lighting up that good. I couldn't even see it myself. It wasn't lighting up that good. The problem isn't with the... One thing I want you guys to keep in mind is it's way preferable to do what? It's way preferable when it comes to LED matrices. It's preferable to do what? To go to what? To use our 5 volt directly and then limit the resistance when it comes to the what? To the ground pin. Basically to the what? Basically to the what? To the column, okay? That's one thing I want you guys to just keep in mind. So, again, you can wire it up as you like. You can wire it up again, put it to the what? You can connect it to, you can connect the resistor to the what? To the 5 volt. But it's again recommended that you connect it to the what? You connect it to the GND, okay? Because it's gonna have what? It's gonna have more consistent lighting and it's gonna be more brighter, especially when you're lighting up lots of LED matrices at once. Anyways, this is it for the section where we're actually gonna be again checking what LED matrices are and just introducing it. But we're gonna work on a final project before again moving on from our LED matrices. So see you in the next section where we're actually going to work on a project involving LED matrices. Okay, so I wired up the LED matrix as you can see here. So let me just try to explain what I did right here. So I just, again, wired it up earlier because it takes a lot of time to wire it up, because there's like 8 pins from the top and 8 pins from the bottom. So total of 16 pins. So it's going to be it's going to be a big effort to do what? To actually connect the LED matrix again to our Arduino. Okay. So right here again, this is my, let me just bring this bit back so you can see it. This is basically my documentation on the documentation I made on my LED matrix. Okay, so right here is this is row 4 connected to the black one. Just go right here so you can see it. Connected to the black one, and then the white one. I keep connecting this again with the parallel wires that are here. Okay, I'm just going to be connecting it, the wires that are next to each other. So I keep connecting it all the way up to here, and then connected starting from digital pin 2. Okay, so I keep doing that, and then once I'm done with that, there's going to be 2 pins left here, these 2 pins right here, these 2 wires left here, and I start from here. And again, what do? I keep going on again. I keep going on. Obviously the wire ends at 10. I connected 8 here, then I connected 2. There's a total of 10 wires here. Okay, so what happens is I start using the normal wires, as I said again. So I run out of it, so I use my normal wires and keep adding it up until digital pin 13. After digital pin 13, we run into a problem. What is that problem? We have 16 pins here, okay? We have 16 pins. And right here, how many pins do we have right here in the Arduino digital pins? We have around, how much? Maximum of what? Maximum of 13 in my Arduino Nano. Specifically in my Arduino Nano, there's specifically the maximum is 13 digital pins. Okay? So we run into this problem. So what do? I try to use the analog pins afterwards. So I start to use the analog pins, I think, starting from A2. Let me check. Yeah, starting from A2, I start to use the analog pins. Okay? Connected them. Again, it's going to be different. Again, how you wire it up again is going to be different from person to person, depending on the model of the model of LED matrix you have. Obviously, they look the same, but obviously the number again is going to it's going to affect where every other pin is going to be. So every column right here is going to be my column 1 is going to be here, right here at the very edge. But for somebody else, it might be somewhere around here or even somewhere around here. So obviously the placement of pins and the placement of columns and rows and the pins is going to be different depending on on the number you have, the model of the model of the LED matrix. Okay? So I just want you to keep this in mind. So again, this I made is again specifically for me. How do we know that? I already showed you guys. What you need to do is keep on wiring it up until 1 lights up. As soon as 1 lights up, what happens? As soon as 1 lights up, we can extract 2 information from it. We can extract the row and the column. Okay? Okay. So with that in mind, okay, let me go over to my code. And to even check that everything is wired up properly, what do? We're going to need to turn on every LED matrix right here. We're going to need to turn on every column and every row just to see that everything is wired up. Sometimes, again, what happens is the resistors, again, they might be attached together. Sometimes they're not put in properly. And sometimes we run into physical errors. So sometimes it might confuse us where the error is occurring. So your code might run perfectly. And then again, you might have a problem when you're working with the LED matrix. It happened to me when I was working with the 4-digit 7-segment LED display. Okay, so with that in mind, how do I turn on everything? So let me first again, I defined them earlier right here, so I don't waste your time trying to do that. So I defined them right here. Basically, when you use the keyword #define, it's basically like using variables. Instead of here, they're going to be They're going to be set to constants. Variables are they change from time to time. Again, you can add them up. You can You can change them. But when it comes to When it comes to constants, they're always constant. I just want you to think, let's say the constant of gravity is what? We're going to say #define. Okay? I'm going to say #define for work anywhere. #define, we're going to be saying gravity. Gravity is a constant. What is it? It's 9.8. 9.8 meters per second. So we're going to be defining constants, okay? So it's exactly going to do the same thing as The same thing as variables, but it's going to be It's going to be set to constant. It's not going to be You cannot change the value once you set it, okay? All right. So I just set this up. Again, I defined the row 1 up to 8 and again, pin they're connected to, and then column to Column 1 up to 8. I just rolled them down. Okay. So right here, what do I need to do is I need to go to pin mode and then Start giving them
output. Say they're output. I want to use them as what? As output. Okay? Let me just keep doing that. Let me keep on pasting it until, and then go to row 2, and then row 3, row 4, row 5, row 6, 7, and then finally 8. I'm going to be doing the same thing when it comes towards what? When it comes towards, oh wait, I'm not correct here. When it comes the same to the what to, when it comes to the columns too. Let me set all of them to what? To output. That's what I want to do. I'm going to be using all of them as an output. Okay, so let me paste this again. Keep on pasting it. And I think this should be 8. Let me go 2 right here. 3, 4, 5, 6, 7, and then 8. There we go. Now afterwards, what do I want to do? Turn all of them on. As you remember, we're going to be setting what? The rows to high and the columns to low to light up what? To light up even a segment of the LED matrix, if you remember. So to even light up everything, I need to set all rows to high. But one thing I want you guys to, again, pay attention here is we used analog pins and also what? We also used digital pins. So depending on the pin that I have, I'm supposed to be saying what? Analog right for analog pins. And for those who have, again, a digital pin, I'm going to be saying what? Digital right. Okay? So I just want you to keep that in mind. So let me just say digital right here. Oh, I just changed my language. Let me just, there we go. Let me just turn this caps lock off. There we go, digital right. Then let's just check which rows receive digital right. So all of them seems to be receiving digital right, except for row 5 and row 8. So except for row 5 and row 8, I'm going to be saying digital right. I'm going to be starting from row 1, and setting this to high. And let's keep just pasting it a bit. There we go. And now for row 1, we're going to say row 2, 3, 4. We're going to skip 5. We're going to be using analog right for 5. Then we're going to go 6, 7. We're not going to be even writing down what? 8. 8 is going to be using analog right. So let me go here and say analog right. And then if I set this, let's say set it to row 5 right here. And then I cannot use high. When I use analog right, I'm supposed to be writing down a value, which is going to be an integer between 0 and 255. Obviously, high means what? 255. So I'm just going to be setting it to 255 right now. And then once I'm done doing that, what do? I'm going to be also copying the same thing for row 8. Row 8. Set that to high. Obviously, right now, oh, I'm supposed to say 255. I set high instead of 255. My bad. So after this, obviously, our job is not done. Now we should set what? The columns to what? We should be setting them to low, or basically GND. Okay? So column, most of them seem to be using, yeah, only 2 of them don't use it. And this time they're what? Column 3 and column 5. Okay? So, okay, for columns, what am I going to say? Digital right. Most of them are going to be using digital pins, again. It's because I run out of them that we're going to be using analog rights. So if you guys have an analog pin that, again, your Arduino, again, your type of model that has more than 16 pins, I suggest that you use only digital pins, okay? Mine does not have it, so I'm going to be using analog pins too, because mine is a bit small. Okay, so let me just set column 1 to low. Set that to low. Let me focus on the numbers here. One number. Okay, there we go. Column 1, 2. Okay, column 3 and 5 are not going to be what? They're going to be using analog right? So except for them, 3 and 5, I'm going to be using everything. So let me go to column right now. Let me go column 2. 3 is not going to be using it, so I'm going to be skipping 3 and going to 4. And also 5, we're not going to be what? We're going to be using analog right? And then 7, and then 8. Let me just remove this code. All right, there we go. Now I'm going to be writing down analog. Let me turn off caps lock. Analog right. Column. We're going to be starting from column 3 and then setting it to what? To 0. 0 corresponds with what? With low. All right, and then copy this and then do the same thing for what? Column 5. There we go. And now I think everything should light up. Let's just upload the code right now. It's done compiling and it should be done uploading. Can you see it? Almost everything is lighting up. Let me just turn off the light for you guys so you can even see it better and change the angle here. It's not the best of angles. There we go. Let me just move it a bit. There we go. You can see that row what? Column what? Column 1, 2, 3. Column 5 is not lighting up. So basically I've touched the resistor or something.
most of the cases, again, resistors. They're not put in properly. So let me just check my documentation right here to understand which one is causing me some problem right here. Okay, so column 5 should be around, it's not here. Okay, it's here. There we go. Column 5 is here. So the resistor that is at the very front right here. Let me just turn on the light so you can see it. There's a resistor at the very, very beginning. There we go, at the very, very beginning. Let me just turn that on. There we go. So just touch it a bit. Don't touch the other ones. There we go, just touch it a bit. Let me turn off the light so you can see it better now. Now everything is lit up. There we go. Now everything is lit up. Okay. So everything seems to be connected properly. So every column and every row was connected properly. Okay, that's good. Now, let's try to, again, do something interesting with it. So obviously, let's try to do a project with it. So right here, what we're going to do is, okay, I'm going to be having, I've tried to actually search for libraries, okay? I've searched for LED matrix libraries. Just like how we had the SafeSeg library for the segment LED displays, the 7-segment LED displays, I try to find LED matrix libraries. And when I did that, what I found was most of them require something called a MAX72XX chip. Basically, it's not going to be your typical LED matrix. It's going to have some add up to it, all right? So it's not going to be exactly the LED matrix that we're using right here, okay? So it's limited to to the models that are the models that are popular. Mine is a bit of a less known model, okay? Not only that too, but it's going to include its own chip. So it's not going to it's not going to include the traditional LED matrix when I look at most of the libraries, okay? So what I did was, let me just go over to the code right here. Let me go over to the code right here. There's a code right here that is preset, okay? I don't want you to focus too much on this, what all of this is, but there's a preset code right here that I'm going to be leaving down in the link below, in the description below. So again, you guys can see it, and you guys, again, can use it for yourself. So you can, again, get the sketch for yourself, okay? So let's just analyze the code, though. I'm not going to be just giving you the code, okay? I'm just going to let you analyze, too, what you need to analyze. Okay, so let me focus right here. So let's start with, it's going to be defining, again, your row. So again, with your corresponding row, for example, it's at pin 5 right here. If you set it to pin 5, you're going to say pin 5. Mine is set to pin 6, so I'm not going to touch it. You're going to be defining your rows and columns and what pin they're connected to, okay? Okay, then afterwards, what you're going to be doing is defining the rows. And this one, again, is going to be written itself. It's going to be preset, again, when you, again, when you check the code in the link below. So don't focus too much on this, but what this does is basically it's an object, okay? I just want to go over it. So this is an object that's, again, contains what? This is a list that contains what? It's a list that contains what? Row 1, row 2, row 3, row 4, row 5, row 6, row 7, and row 8. At what? At a list, at a single list, okay? So it's just listing what rows we have here. Basically, the ones that are right here, okay? All right, the variables that are right here. Let me just skip this right now. I'm going to get back to this, okay? And right here, what is very, very important for you guys is, okay, what is very, very important right here is, again, we're going to be setting the pin mode to what? To all of them to output. What? All of them to what? To an output. That's one thing I want you guys to do, okay? Then afterwards, okay, I don't want you to focus on these two codes, okay? They're going to be pre-written again on the code. I don't want you to focus on them. They're a bit more complicated again, so don't focus on them, okay? Just leave them alone as they are, okay? We're just going to be using them as a library, okay? When we use libraries, again, we don't look at in most cases, we don't look at the behind code of how the library works, okay? We don't do that. What we do is we use the library, what it provides us, okay? So like that, again, we didn't find the library, so what I did is again, this is all set up for you guys. So again, don't focus on these, okay? They're, again, beyond your scope, okay? Don't focus on these. They're going to be written down for you guys. But I want you to focus is right here. I want you to focus on this. To understand this, what we're first going to do, I think for you guys to better understand this, is let me go right here. And I want you guys to search for an LED matrix. Okay, LED matrix right here, and I want you to search when you come to LED matrix editor. Okay, add editor and search for it. And then go to the link right here. And then you have your own digital LED matrix. Okay, so what I want you to do is right here.
Okay, what I want you to do is what? It's way better to draw it right here. So let's say I'm trying to draw L like we did last time. So I just showed you guys the science of drawing an L. So let's say we want to draw an L. So the problem here arises is what? We're gonna have to what? We're gonna have to first what? We're gonna have to first turn it on before what? Visualizing, okay? So even to see an L right here, what should I do? I should visualize it myself before what? Before actually what? Before actually turning it on myself, alright? So the problem here is what? The problem here is what? We cannot visualize it. We cannot visualize the what? How to draw this in dots. Okay, we cannot visualize how to draw this in dots before what? Before putting it in our what? In our physical, again, LED matrix. So what this allows us is what? We can visualize how an L is supposed to look like. So we can first do is, okay, so what I need to do is like this. Then I can know what? Okay, I need to turn on column 3 and row 3 again. And I'm going to turn on row 4, row 5, row 6. And then after I'm done with that, what I'm going to be doing is, okay, I'm going to be turning this off. I'm going to be giving it a delay time, maybe a 5 milliseconds, okay? Not 5 seconds, 5 milliseconds. And then I'm going to be running this code right here. Okay, so I'm going to turn on row 6. And then I'm going to be turning what? Column 5 and column 4 and column 5 to what? To low. Okay? So I can visualize it. So before even writing it down again in dots, it allows you to what? To visualize it. And the best part about this is what? The best part about this is that once you, let's say, okay, I wrote down L, okay? Let me just write down L or something. Let me write down capital L. Let me just write it down. The best part about this is, okay, what you're going to be saying is inserting it. After you insert it, okay? After you insert the code right here, and you can see it right here, okay? And after you insert it, what you need to do, let me just actually delete this. I don't need this one. Let me just delete this one. There we go. Once you have, again, this, L again. What's the best part is, as soon as you just go right here, the code is written for you. Obviously, you cannot understand what this is, but as soon as you just touch as byte arrays, it's going to change it for bytes, for bits of data, okay, as a byte. Once you do that, you can get this code right here. So you can just copy this, and then what you can just basically do is paste it, okay, to your code. Basically, directly without yourself doing it again, without yourself saying, okay, I have to turn on 3, and then what, 2 to low, and then keep on doing this and this, and this is gonna what, involve a series of steps, okay? Just not to do that, what you need to do is what? What you need to do is only use this in what? In bits. So first things first, let me try to show you guys what this means. So let me just analyze one of these codes for you guys. So I think it's better that way. Okay, so right here, let me start right here. Let me start all the way to the top. Okay, there we go. We have A right here. Can you see A? Can you see A? Okay, let me start with B actually. A is a bit of the code is not right because I was messing around with it. I remember that. So I'm gonna fix it though on the description code. I'm gonna be fixing it on the final code. But right here, let's see B right here, okay? I think B is something interesting to analyze. So what does it do? It says B, okay, byte. It's set to byte. A byte is what? A byte is basically 8 bits. Just like how we were using again, the number from 0 to 1024. If you remember, numbers from 1024. Basically, these numbers from 0 to 1024, they were what? They were 8 bits, okay? So basically, for example, 1024 in 8 bits or in a byte is basically what? 11111, written down 8 times, okay? When it comes to 0, what was it? It was 0 written down 8 times. And obviously, 0 to 1024, again, the values again are going to be converted, okay? That's basically what it is. Okay, so again, we've discussed earlier, we've discussed about what binary. So this is basically binary, okay? Okay, so what you do is B, and what do they have is right here is a B. They use a B or a small b right here to define what? We're telling our Arduino, we're not just setting down random numbers. We're setting down what? We're sending information in what? We're sending information in bytes, okay? We're sending our information in bytes. I want Arduino to know that. So you can use what? 0B with a small b, or you can use capital B right here, okay? Then, what do you do? Right here, this defines every column, okay? This defines every column. So this is going to be for row 1, okay? This is the first one in our list. This is the first one in our list, so it's going to be what? Row 1, okay? This is going to be row 2. This is going to be row 3, row 4, row 5, row 6, row 7, and then finally row 8, okay? So right here, what we're telling is, okay, I want you to turn on what?
I want you to turn on row 1. I want you to turn off what? Row 1. I don't want to use what? When you set it to 0, it's basically off. I don't want to use what? Column 1. I don't want to use column 1. For row 1, we're setting this up, okay? This is, again, the whole thing is what? The whole code right here, again, the whole thing is for row 1. Okay, I want you to keep that in mind. So every bits of zeros and ones is what? Every bits of 0 and 1 is what? Every bits of 0 and 1 is columns, okay? So right here, I'm saying is for row 1, I want you to do, for row 1 is, I want you to what? I want you to turn off what? Column 1. Basically what? Basically, I don't want it to light up, okay? I don't want it to light up, okay? When it comes to what? Column 2, column 3, column 4, and column 5, I want you to turn it on. Okay, basically what? It's gonna light up. I want you to light up what? Column 3, column 4, column 2, column 3, column 4, and column 5. When it comes to column 6, 7, and 8, I want you to turn it what? To turn it off. Basically what? I don't want you to light it up. Okay? That's what it's basically saying. Okay? So right here, I want you to do is what? I want you to turn on what? I want you to turn on column 2, 3, 4, 5. Let's try to do that ourselves right here on the editor so we can see it ourselves. So let's try to turn on, let me just clear this. Let's try to turn on column 2, 3, 4, and 5. Okay, for row 1. So let's go back to our code right here so that we can understand what this is, okay? There we go. We, again, define 2, 3, 4, and 5. All right. Then afterwards, for row 2, what I want you to do is I want you to turn off what? Column 1, and then turn on what? Column 2. Let's turn on column 2 right here. Column 2 is turned on. On row 2, we're going to be turning on column 2. Let's visualize what's going to happen. Let me go back to my Arduino right here. No, it's the other code. Let me go back to the other code. There we go. And then I want you to turn off what? This is column 3, 4. I want you to turn it off. And then finally, I want you to turn on column what? Column 5. Let me just count it. Let me just see if I'm correct. 1, 2, 3, 4. Yes. So I want you to turn on column 5. Let's just do that. Let's go back here and turn on column 5. There's 5. And then let's go back to our Arduino code. We're just going to analyze it again just to see how it works. And then I want you to turn on what? Column 2 and column 5. Column 2 and column 5. The same thing as we did right here. I want you to turn on column 2 and column 5, okay? For row 3, I want you to turn on column 2 and column 5. All right, I just did that right there. Let's go back to our Arduino. Then afterwards, for row 4, I want you to do is what? I want you to turn on column 2, 3, 4. Okay, column 2, 3, 4. Let's just keep that in our head. 2, 3, 4. 2, 3, 4. There we go. And then what do I want you to do right here? Let me read it. Okay, we read what? Row 1, row 2, row 3, row 4. We're on row 5 right now. Let me just check it again. Yes, we're on row 5. There we go. Row 5 is here. Okay. Now what? I want you to turn on column 2 and then what? Column 2 and column 5 again. Okay, I want you to turn on column 2 and column 5 just like how we did for row 2 and row 3. Okay, so let me just do that. Column 2 and column 5. Column 2 is supposed to be here. And column 5 is here. There we go. And let's go back here. And then afterwards, what I want you to do, column 2 and column what? Is it column 6? We counted. This is column 2, 3, 4, 5, and then yeah, column 6. So I want you to turn on what? Column 2 and column 6. Okay, let's just do that right here. Column 2 and column 6 for row 6. Column 2 and column 6. All right. It's looking something like an R right now. Let's finish it up. So hopefully it's going to appear as B. There we go. I want you to do is what? The same thing. If I'm correct. It looks exactly the same. Let me just check it. Yep. I want you to do the same thing. Let me just check it again. Column 2. This is column 2 and this is column 6. So I want you to turn on column 2 and column 6. Okay. Let's just go to column 2 and column 6. Column 2 and column 6. There we go. And then when it comes to the row 8, let me go to the row 8 right here. The final row. I want you to do what? I want you to turn on column 2, 3, 4, 5, 6. So let me just do that. I want you to turn column 2, 3, 4, 2, 3, 4, 5, 6. And there we go. We have what? We have somewhat of a B right here. This is basically what's going to draw if I tell it to draw B. So what you need to do again to draw something is, okay, we have the information again. Preset for you, I have the information. Preset for you, I have B right here, C, D, everything from A to Z. From A to capital Z, I have it written for you guys, okay? From A to capital Z is written for you guys, okay? Then what I want you to do right here, okay, is
You're going to say draw screen, and then you tell it, I want to draw a B. Let's see what happens right here. Let me just upload this. It's compiling, and it should be done uploading. That's all you need to do. I want you to do is what? Use the function draw screen and put what? Again, what you want to draw right here. As soon as you set it at bytes right here, once you set it to a byte, what I want you to do is use it, okay? There we go. Draw screen B. Can you see it? Let me just check if you can see it. Let me turn off the light for you guys. Let me bring this closer. Actually, bring this closer. I don't want to touch the wires. They're very, very fragile. I was about to push them away for you guys, but they're very fragile because I can just ruin the whole thing. And I don't want to, again, connect 16 pins. It's going to be a lot of work. Let me just go from this angle so you can see it. There we go. I want you to focus on this. There we go. It's drawing out the B that we just drew on the what? On the matrix editor. Basically on our what? Digital matrix. So let me just zoom this back. Okay, that's good. All right. So right here we draw B. And I already said this for you guys. So again, you can draw what? D, E, anything you want. Let me just upload D right here. I want to draw D. Let me draw a D right here. There we go. We have D drawn out for you guys. So almost every letter is, again, I already preset it. So what I want to do here is, again, we can use this to do what? We can use this to, again, set up what? Not only letters, we can also use it to even do what? Simple drawing. So what I'm going to be doing is I'm going to be drawing a simple face right here. I'm going to be trying to draw at least I'm going to be trying to draw a face right here. Let me go to L right here and let me delete it. I don't need it anymore. I don't need it. Let me just delete it and let me just reset everything. And once I'm done doing that, let me just try to draw a smiley face. Not the best drawer, but okay, let me just go right here and let me start like this. I think it's better that way. Let me just keep on trying. All right, let me go like this. And then let me just try to do exactly the same thing here. It's a bit of a struggle because I don't know how to, I'm not the best drawer right here. Okay. I mean, it's not bad. It looks like a good circle. Not the best one, but I think it gets the job done. Okay, let me put 2 right here, eyes. And then let me just try to draw a smiley face on it. Let me just try to do that. There we go. We have what? A smiley what? We have a smiley face right here. We have a smiley face. So let me do is insert it right here, okay? Once you just insert it, the code is already written for you guys. So again, lighting up all of these individual bits of dots would be really hard because you're going to have to do what? A lot of work just to even light this up, just to know which one's which. And if you mess up at one spot, you have to go back, check everything. Again, you have to do almost how many? We used around, let's say half of it right here. We used, let's say roughly, I would say, maybe 2/5 of it, 2/5 of the 64, again, dots that we have here, 64 bits of what? Bits of, again, lights that we have here. And basically, if you just, again, try to do it physically, again, set this to high, set it to low, and doing all of that, it would be a lot of work, okay? So, we're just going to be using this, and you're going to be extracting this information right here, okay? That's all you need to do. Once I insert it, the information that's out going to be right here. It's already going to give me the code right here. Again, make sure it's written down in bytes and byte erasers. This is, again, selected. Just make sure that this is selected. Let me just copy that. Let me only get the code right here. Copy that. Okay. Let me just copy that and let me go right here. Oh, not this one. Let me go right here. There we go. And what I need to do is what? I add it as a byte. Okay. As a byte of information. So I'm just going to say byte and I'm going to say, let me call it smiley because it's a smiley face. So let me just call it smiley. And then again, I'm going to need to again use again my brackets right here just to indicate it's a list. And then afterwards I can paste it. There we go. Let me just again, I don't want it to be spaced out. So let me just give it space right here. Let me just make sure that again, it can take up a whole line. This is valid. But again, from an aesthetic point of view, every row right here is taking a line up. So it doesn't look that good. Let me just again, without touching anything, just remove the extra bits of again spaces right here. Let me just remove them. Okay, I think this is good. Okay, I have to remove this one that is here. Remove the extra bits of again. There we go, the extra bits of spaces that we had here. Now this looks better. And let me just upload it right here. Let me just upload the code. Oh, I forgot to give it a semicolon at the end. I defined it right here, smiley. It should be working. It's done compiling. And now what? It should be done uploading. Okay, let me go to draw screen, and I want to draw what? Smiley. Smiley. Let me try to draw smiley right here. It's done compiling. Okay, now it should be uploading, and there we go. We have a smiley face. Can you see it? Let me just turn off the other light. Not the best lighting, but I just want to make sure that you see it for yourselves. Let me bring it closer so you can see it. There we go. We have a smiley face right here. So again, it's up to what? It's up to your imagination again to do these things. So you basically can do what? You basically can do, well, obviously you cannot do everything, but you can do lots and lots of things. It opens possibilities that were no longer possible in what? That were not possible using a 7-segment LED display. So what I'm going to be giving you guys to do is what? Right here, again, I have the preset code. What I want you to do right here is, okay, I did not add every alphabet. I added every alphabet, like every capital letter from A to Z. As you can see right here, add it up and just set it up right here for you guys. But one thing I did not do is I did not finish. There we go. Where is it? I did not finish writing down every small letter, okay? I have A right here, but I did not finish writing down everything. We have A, B, C, D, E, and I stopped at J. Okay, what I want you to do is add up to it, okay? I want you to add it up all the way up to small z. Okay, I want you to add up all the way up to small z. And one important thing I want you guys to do is, okay, again, one thing I want you guys to do is, don't focus so much on this code, but what I want you to do is write down a word with it. How do we do that? How do we write down a word? What I want you to do is, we want to write down a word. How do we display a word? Okay, how do we display a word? I want you to think of it. So again, I want you to pause this video, think of it for like at least a minute or two, and then come back this video where I'm just going to show you again how we just do it, because we've learned this so far and it's going to be very, very simple. Okay, so I'm just going to be waiting, and hopefully now you have, again, resumed the video, and then hopefully you got it right. Obviously, to write down words, they're what? They're just a bunch of what? They're just a bunch of letters. So what do we need to do? Let's say I want to say the word Arduino. Okay, how do I do that? I say draw screen A, and then I give it what? A delay time of what? A few seconds right here, 20, maybe 200 milliseconds. I want to draw it for A, and then what? I want to give it a delay of what? Maybe a delay of a bit while, and then give it some delay right here. And then what? Leave a delay of some bit right here. Let me say 20 milliseconds. And then I want you to draw screen D right here. Draw screen. And then B. I already wrote down capital B, so I can say, oh, I said B instead of R. R. After A is R. Let me actually give it a draw screen of what? A draw screen of B. Okay, let me set this B right here. No, sorry. Draw screen. I said draw screen again. I meant the delay time. Sorry. Delay time of what? A delay time of, let's say, 20 milliseconds. What is better if I do it right here? If I give it a variable, say delay time, and give it a variable. So let me select both of them and just say delay time. Delay time. What also did I do wrong right here? The code right here is not supposed to be set to delay time. It's supposed to be set to delay. I said delay time instead of delay. My bad. There we go. Now let me just define this here. Let me just define it maybe down here. Let me just define it right here. Say integer delay time. Let's set it to 100 milliseconds. Now let's try to upload this. See what happens. Let me just try to upload these two again. Sentences right here. There's 2 letters. It goes too fast for me. Okay, let me just give it a bigger delay time. Let's say 1 second. Okay, let's say 1 second. See what happens. Done compiling. Can you see what's going on? It's basically turning on. It's doing the draw screen thingy. And then what? It's going to be delaying physically for what? For a second. And then it's going to be drawing again R for a very, very short while. And then again, it's going to have a delay of what? 1 second. Where it's going to be what? When it's on the delay, it's going to be what? Turned off. Okay, so what I want you to do again, I'm not going to do it myself, but your homework is going to be, okay, to find a way to delay it in such a way that, again, you don't do what? It doesn't turn off. Okay, how do we delay it in such a way that it doesn't turn off? So I want it to turn off for what? For at least what? For maybe a second, okay? I want it to be on for a second, Then I want it to switch to R. Not obviously, again, it appears for a second right here. It appears for like a millisecond right here. And then what? It turns off for a second. And then it goes to the other R. And then it turns off for a second. So I don't want that to happen. So I just want it to be on until we switch to a what? Until we switch to a delay. So this is going to be your homework for this section. So again, I'm going to go to the next section and fix it myself, but I want you again to try to do it yourself. So before you guys again check out how I do it, I want you to try again. I want you to try hard and then to do what? And try to again solve it for yourselves, okay? Okay. So now let's analyze our code right here. Draw a screen, and then it does it again for milliseconds. And then it delays physically, where it's going to be turned off. It's going to be delayed for a second right here. And then basically what? It's physically turned off. And then the draw screens are, and then it's physically turned off for a second. So best thing actually to do right now is, let me just remove all of this code because it's not working. Let me just remove it. And let's go back where we were just drawing a specific letter. What happened here? For example, right now I'm just draw screening what? A. What happens? It draw screens A, but it goes inside of a what? If you remember the loop function in the Arduino, what happens? It keeps running over and over and over again. It's basically a loop, just how it says it's going to be going over and over again. Again, if you remember, our setup code is here what? It's set up once. When we go to our setup right here, our void setup, okay? When it comes to void setup, what do? We only have what? We only run it one time, okay? When it comes to the loop, we keep running it multiple times. That's why when we draw screen, let's say, for example, only A, with no delay time on it, we can see A just being drawn right here. There we go. A is literally what? It's drawn on the screen. Again, it's going to do what? It's going to draw screen A for an instance, and then it's going to keep on doing it inside of the loop again and again and again and again and again. So obviously it's going to be too fast for our eyes. Okay, so now, the question is going to be what? The question is going to be, how do we create our own loop? Because when it's inside of a loop, it does what? It literally what? Lights up. So how do we create our own loop? How do we do it? We use the while keyword. Okay? So what I'm going to be doing right now is I'm going to be trying to maneuver it in a different way, a bit of a different way. But what I'm going to be doing is I'm going to be setting up an integer right here. Integer and call it I. Okay, let's set it up, and I want to set it to 0. Okay, then what I want Arduino to do right here is I want it to do is, as long as I is less than 300, I want you to continuously what? Draw A. That's what I'm saying. As long as I is less than 300, I want you to do what? I want you to draw it. Okay, I want you to put what? Draw screen A. Keep on doing that. Okay, that's what I'm telling my Arduino to do. Okay, then what should I do right here? It's going to be an infinite loop. If I do this, what is going to happen? I is always going to be less than 300 if you remember, because I set it to what? I set it to 0. So I want this to end at some point. How do I do that? Then I'm going to say I keep adding 1, okay? Keep adding 1 every time while I does what? While I keep adding 1 on I every time. That's what I want them to do at the end of the loop. Okay, then it's gonna what? It's gonna end after what? Running this loop 300 times. It's gonna run this loop around actually 299 times, not 300, 299. If I want it to run 300 times, I'm just gonna set it equal to right here. And then now it's gonna run through this loop 300 times. Okay, before what? It's gonna be drawing screen A 300 times before what? Before moving on to the other code. So let me just try to even upload this. Okay, we're running into an error. Okay, I see where the error is occurring. So right here, I set integer to I, and then right here too, what did I do? I used I as a byte. I already set it as a byte again. So the problem is, why do we have 2 I's? Variables are unique. They're supposed to be unique. That's what Arduino is telling me. So let me again set I maybe to, let me call it counter, because we're going to be using it to count. So counter seems like a good name. Let me go right here and set every I to counter. Okay, there we go. And let's check it out now. All right, can you see it? It turns on for like a bit while. We can see it visibly, and then it fully turns off. So let's see what's going on here. Okay, so what's going on here is it reads the counter, and then again, it runs through this code 300 times. So basically draw screens A 300 times. So it gives us enough time to what? To see it. Obviously, we can see it. But afterwards, what happens? Counter keeps adding up to 300. Once it reaches 300, what happens? Again, what happens? Once it reaches 300, what happens is basically counter. Let's print counter at the end. So let's see what counter is going to be at the end. So let me go to serial.print ln, and let me just say counter at the very end, because I want to see what counter is going to be up to. All right, I think this is good. Now, what are we going to do? Obviously, we have to what? We have to start our serial monitor. Let me just do that. Let me go to my setup code right here at the very end. Start our serial monitor at the baud rate of 9,600. Give it a semicolon at the end, and let's run this. Let's upload it right now. It's done compiling, and it should be uploading by now. All right, now let's open our serial monitor, and it's finally gonna open it for us. All right, come on. 301. Can you see it? The value is coming out here, saying what? 301. 301. It's printing out 301. So what happens is what? 301 is what? Less than or equal to 300. So it's not gonna run this code another time. Can you see that? It's gonna be what? It's gonna be counter 300. What's going to happen is when it reaches 300, here, okay, let's go right here. When counter is set to 300, this is going to be true. And then what is it going to do? It's going to draw screen A as usual. And then it's going to be counter is equals to 300 plus 1. What is that going to be? It's going to be setting it to 301. Now, when it comes back and tries to do the loop again, 301 is less than or equal to 300. That's a what? That's a false statement. So it's going to be skipping this at all. It's not going to touch it again anymore. And then what's going to happen is what? It's going to keep printing the counter. Right now, it's the value of the counter, 301. Okay? All right? So right here, it's very important at the very end of the code that we what? At the very end of the code, we set it to what? We set the counter back to what? Back to 0, to its initial value. Okay. We only printed A. So what's better is let's create a loop again. Counter is less than or equal to what? What are we going to put right here? As soon as it passes through 300, the value is going to be what? 301. So I want it to be less than or equal to 600 right here. That makes more sense to do. Then I want to do basically the same thing. Draw screen what for me? R. I wanted to draw screen R. And then I wanted the counter to keep adding up again so that it's not stuck in a what? An infinite loop. I don't want it to be stuck in an infinite loop while it keeps running R. Again, infinite amount of time, because it's always going to be true in that case. And as long as we don't add what? Counter is equals to counter plus what? Okay. And then finally, what we want to do, we want to set it back to 0. Okay. As soon as it runs through this, what is going to be the value? As soon as it's done running through this loop, the counter is going to be what? 600. As soon as, let's say it goes to 600 right now, it's going to be what? 600 is less than or equal to 600. It's going to be true. It's going to be drawing R. And then the counter is going to be set to 600 plus 1. What is 600 plus 1? It's going to be set to 601. So again, we want to set it back to 0 so that this loop again keeps going on. So let's check it out. It should be an A and then an R. It should be going between A and R. There we go. It's going between A and R. A, there we go. And then it's going to R. Nice. Now let's keep adding on, again, the other letters for Arduino. We need D. So let me just keep on copying. This is better that way. Let me copy the while loop once. Let me keep the counter is equal to 0 at the very end so I don't touch it. Paste it. And then now I'm going to go to 900. And now I'm going to go for what? For R. There we go. D. Let me say capital D. And the counter plus 1. I'm not going to touch that. And then I can keep on pasting this code. Just keep on pasting it. It was 900. Let me add 300 on 900. It'll be 1,200. And then I want to draw screen what? After D, I want to draw U. U. Okay, there we go. Seems nice. Let me paste that again. And 1,000 is going to be 1,500. Then I have an I for the Arduino. And paste that again. 1,500 and add 300 on it. It's going to be 1,800. And then it's going to be Arduino. Okay, come on. There we go. I hate the documentation sometimes. Can't touch it by using your pointer. Anyways, N, and then we have an O. Arduino. Okay, I have to set this to what value? 1,000, not 1,000 actually, 2,100. There we go. Let's check what happens. And we have, again, it's going to set this back to 0 at the end. That's good. Now it should be displaying Arduino. There we go. And there you have it. Obviously, one thing I want you guys to keep in mind is, it's going to keep doing it on loop, that's nice. But one thing I want you guys to keep in mind is, again, this is what, we're not using time directly. We're not using delay time. We're not using any type of what? Time. We're indirectly using what? What I want you to analyze is, one thing we're using is what? We're using Arduino's processing speed, okay? Again, it's going to be running through this code how many times? 300 times. So let's say we have a very, very fast Arduino. Mine is an Arduino Nano. Let's say we have a faster Arduino. I'm talking a significantly faster one. It's going to be running through this code really, really fast. So basically, it's going to feel like how we just saw it for like, again, a bit, and then it turns off, okay? So that's what's going to happen. So again, it's going to be variant on the Arduino model you have and how fast it is, okay? So I want you to, again, adjust it using what? As it's slower or faster, I want you to adjust it for what? For the number right here. How do we make this way easier then? For ourselves, give it a variable, right? It's better to give it a what? A variable. What I'm going to need to do right here is say, okay, delay time. I was saying delay time right here. You know what? I can use this because I'm no longer using delay time here. So I'm going to be setting delay time. And what I'm going to be doing is I want to set it to 300. You know what? Let me set it to 200 because I feel like 300 is very long. Let me set this to 200. And again, what I'm going to be doing is, okay, delay time is going to say delay time right here. Nice. Then I'm going to be saying delay time times what? Times 2. That's basically what it is. Delay time times 3. Again, this was, again, I just set it to 200 right now because I wanted to go shorter. Okay, that's what I wanted to do. But obviously, let me just set it back to 300 so you can understand it. Delay time times, and if it's up, delay time is what? 300. And delay time times 200 is what? 600. There we go. That we put earlier 600 right here. And then delay time times 3 is what? 900. We literally put 900 right here. Delay time times 4 is literally 12, what? 1200. Okay, so it's 1200. So that's what I'm going to keep on doing. So it's just times. You can again use a variable instead of, because we're going to be using this in multiple places. It's going to be easier to do what? It's going to be easier to use a variable so that, again, if you want to change anything, we can change it only at one place and it's going to affect the whole thing. Let me see, delay time times 7 right here. And then we have delay time times 8. There we go. And we set the counter to 0. And one thing I want to do right now is I want to set the delay time right here to what? To 200 so that it goes faster, okay? I don't want it to run the code 300 times. I want it to go 200 times. Let's see if it goes faster now. Okay, there we go. It's better right now. It's better. Arduino. Okay, the U is a bit longer. And oh, there we go. Let's see if I can set it to faster. You know what? Let me just set this to 50. I set it to 500. Sorry, 50. There we go. Let's upload it. Let's see what happens now. There we go. Now it goes really fast. Arduino. There we go. Nice. So again, one thing I want you guys to keep in mind is we're not using delay time directly. We're using what? We're relying on our processing speed, okay? We're relying on Arduino's processing speed. We're just saying that, you know, take 50, it's going to take a long time right here so that we can see it. So we can see what? We can see A being drawn. But let's say Arduino's, again, like every computer, like every phone, from here to here, they get what? They get faster, they get better, they get upgraded and all. So maybe this might take, again, a while to write down for now for this model of Arduino. But in the very future, what's going to happen? It's going to be so fast that it's going to be running it so fast. For example, right here, it's going to be almost as if you're running it, giving it a delay time of, let's say, 5 milliseconds, okay? That's how fast it's going to be. It's going to be like running this at 5 milliseconds because, again, the processing speed is going to improve. So it's going to be basically like that. See that? It's going to be so fast that obviously right now we cannot read this because, again, it's very fast for us. Okay? So that's one thing I want you guys to keep in mind. So for example, let's say we're using this for, let's say we're producing something, okay? We're using this for production or something. For a production basis, obviously it's not going to be reliable. It's not future-proof because, as I said again, it's going to be running into problems. But obviously this is just, again, a home project, so it doesn't really matter that much. But again, I just want you guys to keep that in mind, okay? So anyways, with that in mind, let's finish this section.
Well, there you have it. You've completed this Arduino course, and I hope you've enjoyed the journey as much as I have. Before we say goodbye, remember that finishing this course is just the beginning of your Arduino adventure. The world of Arduino is vast, and there are countless number of components, projects, and problems waiting for you to be solved with the skills you've gained here. If you find this video helpful and inspiring, please consider giving it a thumbs up. That's a way of boosting the content so it can reach more learners like you. And don't forget to subscribe to FreeCodeCamp to join a community of fellow programming enthusiasts. Plus, it really helps the YouTube algorithm. With that in mind, if you want to check more courses made by me, you can check my personal channel in the link below. I don't want to keep you for too long. Thank you for tuning in, and I hope to see you again soon.